Welcome to Simplilearn's AI course. AI or artificial intelligence is when machines learn to think and make decisions like humans. You have seen it in things like virtual assistants, Netflix recommendations, and self-driving cars. AI is high in demand in 2024 with industries like healthcare and tech using it to improve efficiency, making AI professionals highly sought after. In this course, we will learn about neural networks, deep learning, and recurrent neural networks, the building blocks of AI. We will also cover the exciting career opportunities in AI and help you prepare for job interviews by teaching you the key concepts and problem-solving skills needed in the field. Let's start with this AI journey together and open the door to high-paying job opportunities. Before we commence, if you want to enhance your career in AI, here's some quick info for you. Check out Simplilearn's postgraduate program in AI and machine learning with Purdue University and IBM. This program is perfect for aspiring AI enthusiasts and professionals looking to switch careers. Gain expertise in generative AI, prompt engineering, ChatGPT, explainable AI, machine learning algorithms, and more. A year of experience is preferred. Hurry and enroll now. Find the course link in the description and pinned comments. So let's get started.
Picture this, a machine that could organize your cupboard just as you like it, or serve every member of the house a customized cup of coffee. Makes your day easier, doesn't it? These are the products of artificial intelligence. But why use the term artificial intelligence? Well, these machines are artificially incorporated with human-like intelligence to perform tasks as we do. This intelligence is built using complex algorithms and mathematical functions. But AI may not be as obvious as in the previous examples. In fact, AI is used in smartphones, cars, social media feeds, video games, banking, surveillance, and many other aspects of our daily life. The real question is, what does an AI do at its core? Here is a robot we built in our lab, which is now dropped onto a field. In spite of a variation in lighting, landscape, and dimensions of the field, the AI robot must perform as expected. This ability to react appropriately to a new situation is called generalized learning. The robot is now at a crossroad, one that is paved and the other rocky. The robot must determine which path to take based on the circumstances. This portrays the robot's reasoning ability. After a short stroll, the robot now encounters a stream that it cannot swim across. Using the plank provided as an input, the robot is able to cross this stream. So, our robot uses the given input and finds the solution for a problem. This is problem solving. These three capabilities make the robot artificially intelligent. In short, AI provides machines with the capability to adapt, reason, and provide solutions. Well, now that we know what AI is, let's have a look at the two broad categories an AI is classified into. Weak AI, also called narrow AI, focuses solely on one task. For example, AlphaGo is a maestro of the game Go, but you can't expect it to be even remotely good at chess. This makes AlphaGo a weak AI. You might say Alexa is definitely not a weak AI, since it can perform multiple tasks. Well, that's not really true. When you ask Alexa to play Despacito, it picks up the keywords play and Despacito, and runs a program it is trained to. Alexa cannot respond to a question it isn't trained to answer. For instance, try asking Alexa the status of traffic from work to home. Alexa cannot provide you this information, as she is not trained to. And that brings us to our second category of AI, strong AI. Now, this is much like the robots that only exist in fiction as of now. Ultron from Avengers is an ideal example of a strong AI. That's because it's self-aware and eventually even develops emotions. This makes the AI's response unpredictable. You must be wondering, well, how is artificial intelligence different from machine learning and deep learning? We saw what AI is. Machine learning is a technique to achieve AI, and deep learning, in turn, is a subset of machine learning. Machine learning provides a machine with the capability to learn from data and experience through algorithms. Deep learning does this learning through ways inspired by the human brain. This means through deep learning, data and patterns can be better perceived. Ray Kurzweil, a well-known futurist, predicts that by the year 2045, we would have robots as smart as humans. This is called the point of singularity. Well, that's not all. In fact, Elon Musk predicts that the human mind and body will be enhanced by AI implants, which would make us partly cyborgs. So, here's a question for you. Which of the below AI projects don't exist yet? A. An AI robot with citizenship. B. A robot with a muscular skeletal system. C. AI that can read its owner's emotions. D. AI that develops emotions over time. Give it a thought and leave your answers in the comment section below. 3 lucky winners will receive Amazon gift vouchers. Since the human brain is still a mystery, it's no surprise that AI too has a lot of unventured domains. For now, AI is built to work with humans and make our tasks easier. However, with the maturation of technology, we can only wait and watch what the future of AI holds for us. Well, that is artificial intelligence for you in short. Do not forget to leave your answer to the quiz in the comment section below.
AI will pretty much touch everything we do. It's more likely to be correct and grounded in reality. Talk to the AI about how to do better. It's a very deep philosophical conversation. Yeah. It's a bit above my pay grade.
I'm going to say something, and it's going to sound completely opposite of what people feel. You probably recall, over the course of the last 10 years, 15 years, almost everybody who sits on a stage like this would tell you it is vital that your children learn computer science. Everybody should learn how to program. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program. And that the programming language is human. Everybody in the world is now a programmer. This is the miracle.
Artificial intelligence or AI, from its humble beginnings in 1950s, AI has evolved from the simple problem solving and symbolic reasoning to the advanced machine learning and deep learning techniques that power some of the most innovative applications we see today. So AI is not just a buzzword. It is a revolutionary force reshaping industries, enhancing daily life, and creating unmatched opportunities across various sectors. AI is changing numerous fields. In healthcare, it aids in early disease diagnosis and personalized treatment plans. In finance, it transforms money management with the robo-advisors and fraud detection system. The automotive industry is seeing the rise of autonomous vehicles that navigate traffic and recognize obstacles, while retail and e-commerce benefit from personalized shopping experience and optimized supply chain management. So one of the most exciting developments in the AI is the rise of advanced AI tools like ChatGPT 4o, Google Gemini, and generative AI models. So these tools represent the pinnacle of conversational AI, capable of understanding and generating human-like text with remarkable accuracy. ChatGPT 4o can assist in writing, brainstorming ideas, and even tutoring, make it a valuable resource for students, professionals, and creatives. Similarly, Google Gemini takes AI integration to the next level, enhancing search capabilities, providing insightful responses, and integrating seamlessly into our digital lives. Generative AI is a subset of AI, is also making views by creating new content from scratch. Tools like DALL-E, which generates images from textual description, and GPT-3, which can write coherent and creative text, are just the beginnings. So these technologies are changing fields like art, design, and content creation, enabling the generation of unique and personal outputs that were previously unimaginable. So beyond specific industries, AI applications extend to everyday's life. Voice-activated assistants like Siri and Alexa and smart home devices learn our preferences and adjust our environments accordingly. So AI is embedded in the technology we use daily, making our lives more convenient, connected, and efficient. So join us as we explore the future of AI, examining the breakthroughs, the challenges, and the endless possibilities that lies ahead. So whether you are a tech enthusiast, a professional in the field, or simply curious about what's next. So this video will provide you with a comprehensive look at how AI is shaping our world and what we can expect in the years to come. So before we move forward, as we know, ChatGPT, Gemini, Generative AI tools is an AI based. And if you want to learn how these cool AI develop and want to create your own,
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
so try Simplilearn's postgraduate programs in AI and machine learning from Purdue University in collaboration with IBM. So this course teaches in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. So don't forget to check out the course link from the description box below and the pinned comment. So without any further ado, let's get started. So how AI will impact the future? The first is enhanced business automation. AI is transforming business automation with 55% of organizations adopting AI technology, chatbots, and digital assistant handle customer interaction and basic employee inquiries, speeding up decision making. The second thing is job disruption. Automation may displace job, with a one-third to takes potentially automated, while roles like securities are at risk. Demand for machine learning specialists is rising. AI is more likely to augment skilled and creative positions, emphasizing the need for upskilling. Data privacy issues. Training AI models requires large dataset, raising privacy concern. The FTC is investigating OpenAI for potential violation, and the Biden-Harris administration introduced an AI bill of rights to promote data transparency. The fourth one is increased regulation. AI impact on intellectual property and ethical concern is leading to increased regulation. Lawsuits and government guidelines on responsible AI use could reshape the industry. Climate change concern. AI optimize supply chains and reduce emission, but the energy needed for the AI models may increase carbon emission, potentially negating environmental benefits. So understanding these impacts help us to prepare for AI's future challenges and opportunities. So now let's see what industries will AI impact the most. The first one is manufacturing. AI enhances manufacturing with robotic arm and predictive sensors, improving tasks like assembly and equipment and maintenance. The second is healthcare. AI changes healthcare by quickly identifying diseases, streamlining drug discovery, and monitoring patients through virtual nursing assistant. The third one, finance. AI helps bank and financial institutions detect fraud, conduct audits, and assess loan applications, while traders use AI for risk assessment and smart investment decisions. The fourth one, education. AI personalizes education by digitizing textbook, detecting plagiarism, and analyzing student emotions to tailor learning experience. The fifth one, customer service. AI-powered chatbots and virtual assistant provide data-driven insights, enhancing customer service interaction. So these industries are experiencing significant changes due to AI, driving innovation and efficiency across various sectors. So now let's move forward and see some risks and dangers of AI. So AI offers many benefits but also poses significant risks. The first one, job loss. From 2023 to 2028, 44% of worker skills will be disrupted. Without upskilling, AI could lead to higher unemployment and fewer opportunities for marginalized groups. The second one is human biases. AI often reflects the biases of its trainers, such as facial recognition favoring lighter skin tones. Unchecked biases can perpetuate social inequalities. The third one, deepfakes and misinformation. Deepfakes blur reality, spreading misinformation with dangerous consequences. They can be used for political propaganda, financial fraud, and compromising reputation. The fourth one, data privacy. AI training on public data risks breaches that expose a personal information. A 2024 Cisco survey found 48% of businesses use non-public information in AI tools, with 69% concerned about intellectual property and legal rights. Breaches could expose millions of consumers' data. The fifth one, automated weapons. AI in automated weapons fails to distinguish between soldier and civilian, posing severe threats. Misuse could lead endanger large population. Understanding these risks is crucial for responsible AI development and the use. So as we explore the future of AI, it's clear that impact will be profound and far-reaching. AI will change industries, enhance efficiency, and drive innovation. However, it also brings significant challenges, including job displacement, biases, privacy concern, misinformation, and the ethical implication of automated weapons. So to harness AI potential responsibly, we must invest in upskilling our workforce, address biases in AI system, protect data, privacy, and develop regulations that ensure ethical AI use. What is deep learning? Deep learning is a subset of machine learning, which itself is a branch of artificial intelligence. Unlike traditional machine learning models, which require manual feature extraction, deep learning models automatically discovers representation from raw data. So this is made possible through neural networks, particularly deep neural networks, which consist of multiple layers of interconnected nodes. So these neural networks are inspired by the structure and the function of human brain. Each layer in the network transforms the input data into more abstract and composite representation. For instance, in image recognition, the initial layer might detect simple features like edges and textures, while the deeper layer recognizes more complex structure like shapes and objects. So one of the key advantages of deep learning is its ability to handle large amount of unstructured data, such as images, audios, and text, making it extremely powerful for various applications. So stay tuned as we delve deeper into how these neural networks are trained, the types of deep learning models, and some exciting applications that are shaping our future. Types of deep learning. Deep learning AI can be applied supervised, unsupervised, and reinforcement machine learning using various methods for each. The first one, supervised machine learning. In supervised learning, the neural network learns to make prediction or classify that data using labeled datasets. Both input features and target variables are provided, and the network learns by minimizing the error between its prediction and the actual targets. A process called backpropagation. CNN and RNN are the common deep learning algorithms used for tasks like image classification, sentiment analysis, and language translation. The second one, unsupervised machine learning. In unsupervised machine learning, the neural network discovers patterns or clusters in unlabeled datasets without target variables. It identifies hidden pattern or relationship within the data. Algorithms like autoencoders and generative models are used for tasks such as clustering, dimensionality reduction, and anomaly detection. The third one, reinforcement machine learning. In this, an agent learns to make decisions in an environment to maximize a reward signal. The agent takes action, observes the records, and learns policies to maximize cumulative rewards over time. Deep reinforcement learning algorithms like deep Q networks and deep deterministic polygradient are used for tasks such as robotics and gameplay. Moving forward, let's see what are the artificial neural networks. Artificial neural networks, ANNs, inspired by the structure and the function of human neurons, consist of interconnected layers of artificial neurals or units. The input layer receives data from the external resources and it passes to one or more hidden layers. Each neuron in these layers computes a weighted sum of inputs and transfers the result to the next layer. During training, the weight of these connections are adjusted to optimize the network's performance. A fully connected artificial neural network includes an input layer or more hidden layers and an output layer. Each neuron in a hidden layer receives input from the previous layer and sends its output to the next layer. So this process continues until the final output layer produces a network response. So moving forward, let's see types of neural networks. So deep learning models can automatically learn features from data, making them ideal to tasks like image recognition, speech recognition, and natural language processing. So the most common architecture in deep learnings are the first one, feed-forward neural network, FNNs. So these are the simplest type of neural network where information flows linearly from the input to the output. They are widely used for tasks such as image classification, speech recognition, and natural language processing, NLP. The second one, convolutional neural network, designed specifically for image and video recognition. CNNs automatically learn features from images, making them ideal for image classification, object detection, and image segmentation. The third one, recurrent neural networks, RNNs, are specialized for processing sequential data time series and natural language. They maintain an internal state to capture information from previous input, making them suitable for tasks such as speech recognition, NLP, and language translation. So now let's move forward and see some deep learning application. The first one is autonomous vehicle. Deep learning is changing the development of self-driving car. Algorithms like CNNs process data from sensors and cameras to detect objects, recognize traffic signs, and make driving decisions in real time, enhancing safety and efficiency on the road. The second one is healthcare diagnostic. Deep learning models are being used to analyze medical images such as X-rays, MRIs, and CT scans with high accuracy. They help in early detection and diagnosis of diseases like cancer, improving treatment outcomes and saving lives. The third one is NLP. Recent advancement in NLP powered by deep learning models like Transformer, ChatGPT have led to more sophisticated and human-like text generation, translation, and sentiment analysis. So applications include virtual assistant, chatbots, and automated customer service. The fourth one, deepfake technology. So deep learning techniques are used to create highly realistic synthetic media known as deepfakes. While this technology has entertainment and creative application, it also raises ethical concern regarding misinformation and digital manipulation. The fifth one, predictive maintenance. In industries like manufacturing and aviation, deep learning models predict equipment failures before they occur by analyzing sensor data. Their proactive approach reduces downtime, lowers maintenance cost, and improves operational efficiency. So now let's move forward and see some advantages and disadvantages of deep learning. So first one is high computational requirements. So deep learning requires significant data and computational resources for training, whereas advantage is high accuracy, achieves state-of-the-art performance in tasks like image recognition and natural language processing. Whereas deep learning needs large labeled datasets, often require extensive labeled dataset for training, which can be costly and time-consuming together. So second advantage of deep learning is automated feature engineering. Automatically discovers and learns relevant features from data without manual intervention. The third disadvantage is overfitting. So deep learning can overfit to training data, leading to poor performance on new unseen data. Whereas the third deep learning advantage is scalability. So deep learning can handle large complex datasets and learn from massive amount of data. So in conclusion, deep learning is a transformative leap in AI, mimicking human neural networks. It has changed healthcare, finance, autonomous vehicles, and NLP.
So let's talk about, is AI is a good career or not? You have probably heard a lot about artificial intelligence or AI. It's everywhere and it's shaking up industries all over the world. But here's the big question. Is AI a good career choice? Yes, absolutely, it is. Take Elon Musk for example. We all know him as the guy behind Tesla and SpaceX. But did you know he also co-founded OpenAI? Even Elon's diving into AI, and that just shows how massive this field is becoming. And guess what? AI isn't just for tech geniuses, there's room for everyone. Let's talk about numbers. AI jobs are growing like crazy, up to 32% in recent years. And the pay is pretty sweet, with roles offering over $100,000 a year. So whether you're into engineering, research, or even the ethical side of the things, AI has something for you. Plus, the skills you pick up in AI can be used in all sorts of industries, making it a super flexible career choice. Now, AI is a big field and there are tons of different jobs you can go for. Let's break down some of the key roles. First up, we have machine learning engineers. These folks are like the backbone of AI. They build models that can analyze huge amounts of data in real time. If you've got a background in data science or software engineering, this could be your thing. The average salary is around $131,000 in the US. Then there's data scientists, the detectives of the AI world. They dig into data to find patterns that help businesses make smart decisions. If you're good with programming and stats, this is a great option. And you can make about $105,000 a year. Next, we've got business intelligence developers. They are the ones to process and analyze data to spot trends that guide business strategies. If you enjoy working with data and have a background in computer science, this role might be for you. The average salary here is around $87,000 per year. Then we've got research scientists. These are the ones pushing AI to new heights by asking innovative questions and exploring new possibilities. It's a bit more academic, often needing advanced degrees, but it's super rewarding with salaries around $100,000. Next up, we have big data engineers and architects. These are the folks who make sure all the different parts of business's technology talk to each other smoothly. They work with tools like Hadoop and Spark, and they need strong programming and data visualization skills. And get this, the average salary is one of the highest in AI, around $151,000 a year. Then we have AI software engineer. These engineers build the software that powers AI application. They need to be really good at coding and have a solid understanding of both software engineering and AI. If you enjoy developing software and want to be a part of the AI revolution, this could be your role. The average salary is around $108,000. Now, if you're more into designing systems, you might want to look at becoming a software architect. These guys design and maintain entire AI system, making sure everything is scalable and efficient. With expertise in AI and cloud platforms, software architects can earn hefty salary about $150,000 a year. Let's not forget about the data analyst. They have been around for a while, but their role has evolved big time with AI. Now they prepare data for machine learning models and create super insightful reports. If you're skilled in SQL, Python, and data visualization tools like Tableau, this could be a great fit for you. The average salary is around $65,000, but it can go much higher in tech companies. Another exciting role is robotics engineer. These engineers design and maintain AI-powered robots, from factory robots to robots that help in healthcare. They usually need advanced degrees in engineering and strong skills in AI, machine learning, and IoT, Internet of Things. The average salary of a robotics engineer is around $87,000. With experience, it can go up to even more. Last but not the least, we have got NLP engineers. NLP stands for Natural Language Processing, and these engineers specialize in teaching machines to understand human language. Think voice assistants like Siri or Alexa to get into this role. You'll need a background in computational linguistics and programming skills. The average salary of an NLP engineer is around $78,000, and it can go even higher as you gain more experience. So you can see the world of AI is full of exciting opportunities. Whether you're into coding, designing systems, working with data, or even building robots, there's a role for you in this fastest growing field. So what skills do you actually need to learn to land an entry-level AI position? First off, you need to have a good understanding of AI and machine learning concepts. You will need programming skills like Python, Java, R, and knowing your way around tools like TensorFlow and PyTorch will help you give an edge too. And do not forget about SQL, Pandas, and big technologies like Hadoop and Spark, which are super valuable. Plus, experience with AWS and Google Cloud is often required. So, which industries are hiring AI professionals? AI professionals are in high demand across a wide range of industries. Here are some of the top sectors that hire AI talent. Technology. Companies like Microsoft, Apple, Google, and Facebook are leading the charge in AI innovation. Consulting. Firms like PwC, KPMG, and Accenture are looking for AI experts to help businesses transform. Then we have healthcare. Organizations are using AI to revolutionize patient with treatment. Then we have got retail. Giants like Walmart and Amazon leverage AI to improve customer experiences. Then we have got media. Companies like Warner and Bloomberg are using AI to analyze and predict trends in this media industry. AI is not just the future, it's the present. With right skills and determination, you can carve out a rewarding career in this exciting field. Whether you're drawn to technical challenges or strategic possibilities, there's a role in AI that's perfect for you. So start building your skills, stay curious, and get ready to be a part of the AI revolution.
Imagine harnessing the power of artificial intelligence to kickstart your own digital business. AI has unlocked endless possibilities, making it easier than ever to create and sell digital products online. From generating captivating art to crafting engaging text, AI tools are your gateway to effortlessly producing a wide range of digital products that can elevate your business or even be sold for profit. The beauty of AI lies in the accessibility. No need to be a tech expert to dive in. In this thrilling article, we will explore the diverse digital products you can create with AI, reveal the best tools at your disposal, and guide you through the process step by step. Get ready to unleash your creativity and see how AI can transform your entrepreneurial aspirations into reality.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
If you're really interested in elevating your career to new heights, Simplilearn's Artificial Intelligence Engineer program in collaboration with IBM is the perfect choice. This comprehensive course offers in-depth training in AI, machine learning, NLP, deep learning, and generative AI, ensuring you gain the essential skills to thrive in the AI industry. With live interactive sessions led by industry experts, hands-on projects using real-world tools, and access to exclusive IBM masterclasses and certifications, this program is designed to set you apart in the competitive AI landscape. Don't miss the opportunity to become a certified AI engineer and unlock the door to exciting career opportunities. The course link is mentioned in the description box and pinned comment. So, let us understand what are digital products. Whenever we hear the term digital products, we generally think of images, arts, or files that can be downloaded. While these are the majority of the products we can find online, the definition of digital products is much broader. Digital products include paintings, illustrations, graphic designs, photographs, or other forms of visual and multimedia content, and other web-based services. And these are intangible items that are created, sold, and distributed online. Unlike physical goods, digital products exist in a digital format, meaning they don't require inventory, shipping, or storage. Examples of digital products like software, ebooks, online courses, memberships, digital music, and other web-based services. Now let us understand why sell digital products. Selling digital products using AI offers numerous advantages that can significantly enhance your business's efficiency, creativity, and profitability. AI is a game changer for selling digital products online. Whether it's generating stunning artwork, composing music, or writing compelling text, AI expands your creative possibilities, allowing you to produce high-quality digital products quickly. Leveraging AI reduces the need for extensive human resources, cutting down on costs associated with hiring designers, writers, or developers. AI can even analyze customer data to help create personal digital products that are catered to specific audiences. This targeted approach increases the likelihood of sales and customer satisfaction as the products are tailored to meet individual needs and preferences. AI constantly evolves, providing you with cutting-edge tools and techniques to stay ahead in the market. By integrating AI in your digital product business, you position yourself as an innovative leader offering products that stand out with competition. In short, selling digital products using artificial intelligence enables you to tap into the enhanced creativity, efficiency, and scalability while keeping costs low and maintaining a high level of personalization and innovation. It's a smart, future-focused approach to building a successful digital product business. Now let us understand where to sell digital products exactly. Sell your digital products in multiple online sales channels to increase their reach and expose more people to your brand. Starting an online store to list your digital products, promoting your brand, and publish the content that appeals to your audience. Try promoting your digital products in social media and set up social media storefronts so that users can check when they scroll. Most importantly, initially use an e-commerce platform which already has a bunch of perks like huge audience, easy setup, and so much more. For example, Etsy, Gumroad, and Shopify. Now let us understand the top 5 digital products to sell online. The first product is generating guides. There are some famous shops in Etsy that have guides for everything, including the real estate guides, Airbnb cleaning checklists, cooking guides, and so much more templates. Basically, they have good templates with attractive fonts. With the help of AI, you can make it personalized depending on your interest. For example, you can ask the ChatGPT all the things an individual needs to know on Airbnb cleaning and make a good guide of it. Here, 75% of the work is done by AI, and you yourself need to copy the template to Canva or Word and ultimately make it look good. The next product is logo design. Let me tell you, one doesn't need to be a graphic designer to design logos, as Midjourney has the ability to create logos for almost everything. Pick up the list from the ChatGPT on which business you can create logos for, and you're halfway there. Finally, you need to utilize your idea and write your prompt in the Midjourney, and the result will shock you for sure. It is one of the most profitable business among all, but you need to understand the language of AI, Midjourney, and a bit of Photoshop. The next product is business cards. This is one of the top selling cards online as it is demanded by most businesses. Basically, it's a card carrying information regarding the type of businesses, their landmarks and contact details, etc. You need to go to the Midjourney to tell it your exact card design and pick up a design and put it in Canva to make it personalized and usable. The next product is resume templates. Without any doubt, this product is booming in the market. With the advantage of AI, it can be one of the most profitable businesses overall. Professionals are continuously searching for better resumes that create impressions and even cross the application tracking system and finally get hired. You just need to tell ChatGPT to create a particular type of resume with necessary sections. You can just write a prompt in Midjourney to create great-looking resumes that are unique, and you are done. Using both the things together, you can just start the most profitable business. The next product is product mockups. Product mockup is a broad market including frame mockups, t-shirt mockups, pillow mockups, etc. The hero product is the mug mockup, which are actually best for gifting purpose. In the modern era, people are a fan of personalized products, and this field actually fans the desires. You need to be back on Midjourney and simply ask to show some simple mugs with white background and Photoshop it to make it personalized. It's a great idea to start the business as it's a trending market and can earn a lot. Now let us understand how to create and sell digital products. After you have basic knowledge about what digital products are and what products to sell, the next step is to know how to create and sell them. So let us understand the step-by-step guide to create and sell digital products. The first point is identifying a product. Begin by identifying a digital product that's in demand. Kate's research led her to gallery wall art. Kate identified a potential product by conducting market research on Etsy, a popular online platform for selling homemade goods. She spotted a demand for a specific type of product, gallery wall art sets, bundles of printable art images. She analyzed the listings using the Adobe Chrome extension to estimate the potential revenue and total sales. Seeing the demand for this type of product and its high earning potential, Kate decided to utilize AI technology to simplify the creation process. Follow the same process and you can identify the real diamond pretty soon. The next point is the website to generate designs. Use websites like Midjourney to generate designs, images, text, anything and everything in just a few steps. Midjourney uses text prompts to generate the search. The next point is download the design. After you select a particular type of design of the product, download it in your system for further process. The next point is use of AI tool. ChatGPT is the next wonder of AI. Use that wonder to make the product personalized and gain all the knowledge if you are making any type of guides. The next comes use of photo editor. For selling digital products online, one of the skills you need to master is the use of photo editors like Photoshop, Canva, etc. The better you can use, the better your product will look. Having intermediate knowledge of photo editors will be great to start with. The final step is listing the product. After everything is done, give life to your product by listing it on a website like Etsy, Gumroad, etc. and you are good to go. Now let us understand the tips to sell digital products. Before you start a business, understand your target audience. Knowing your target audience will help you create products that meet your needs and preferences, which can lead to more sales. The next comes identifying profitable digital products. It will help you go a long way. Choose products that are doing well in the market like logos, wedding cards, resumes, and more. Use Google ChatGPT to gain information and have a research on websites like Etsy, Gumroad to see the business. The best sellers use the great marketing strategies. You too need to do that. AI can help you market your digital products. You can use AI-powered chatbots to answer customers' inquiries and send automatic generated mail marketing campaigns and create an audience. The last but not the least, the most important step is to have a competitor analysis. Research on competitors' products, their pricing strategies, their audience, etc. can help you a lot in formulating your marketing. To make $1,000 a month with digital products using AI, you must create valuable products that solve your customers' problems and market them effectively. Pricing your products correctly, creating an automated sales funnel, and scaling up your business and all are critical components of a successful digital product business. With this, we have come to the end of the video. Hope you have liked it. For any queries, do comment and one of our experts will definitely help you out.
The term generative AI has emerged seemingly out of nowhere in recent months, with a notable surge in interest according to Google Trends even within the past year. The spike in curiosity can be attributed to the introduction of generative models such as DALL-E 2, BARD, and ChatGPT. However, what does generative AI entail? As a part of our introductory series on generative AI, this video will provide a comprehensive overview of a subject starting from the basics. The explanation will cater to all levels of familiarity, ensuring that viewers gain a better understanding of how this technology operates and its growing integration to our daily lives. Generative AI is, after all, a tool that is based on artificial intelligence. A professional who seeks to switch careers with AI by learning from the experts. What is generative AI? Generative AI is a form of artificial intelligence possesses the capability to generate a wide range of content including text, visual, audio, and synthetic data. The recent excitement surrounding generative AI stems from the user-friendly interfaces that allow users to effortlessly create high-quality text, graphics, and video within a second. Now moving forward, let's see how does generative AI works. Generative AI begins a prompt which can take form of text, image, video, design, audio, musical notes, or any input that AI system can process. Various AI algorithms that generate new content in response to the given prompt. This content can range from essay and problem solution to realistic created using images or audio of a person. In the early stages of generative AI, utilizing the technology involves submitting data through an API or a complex process. Developers need to acquaint themselves with a specialized tool and writing application using programming language like Python. Some of the recent and fully operational generative AIs are Google Bard, DALL-E, OpenAI ChatGPT, Microsoft Bing, and many more. So now let's discuss ChatGPT, DALL-E, and Bard, which are the most popular generative AI interfaces. So first is DALL-E 2, which was developed using OpenAI GPT implementation in 2021. Exemplify a multimodal AI application. It has been trained on a vast dataset of images and their corresponding textual description. DALL-E is capable of establishing connection between various media forms such as vision, text, audio. It specifically links the meaning of words to visual elements. OpenAI introduced an enhanced version called DALL-E 2 in 2022, which empowers users to generate imagery in multiple styles based on their prompts. And the next one is ChatGPT. In November 2022, ChatGPT, an AI-powered chatbot built on OpenAI GPT 3.5 implementation, gained immense popularity worldwide. OpenAI enabled users to interact with and fine-tune the chatbot's text response through a chat interface with interactive feedback, unlike earlier versions of GPT that was solely accessible via an API. ChatGPT brought a more interactive experience. On March 14, 2023, OpenAI released GPT-4. ChatGPT integrates the conversational history with the user, making a genuine dialogue. Microsoft, impressed by the success of new ChatGPT interface, announced a substantial investment in OpenAI and integrated a version of GPT into its Bing search engine. And the next one is Bard, Google Bard. Google was also an earlier forerunner in advancing transformer AI techniques for language processing, protein analysis, and other content types. It made some of these models open source for researchers but were not made available through a public interface. In response to Microsoft integration of GPT into Bing, Google hurriedly launched a public-facing chatbot named Google Bard. Bard's debut was met by an error when the language model incorrectly claimed that the Webb telescope was the first to discover a planet in a foreign solar system. As a consequence, Google's stock price suffered a significant decline. Meanwhile, Microsoft implementation of ChatGPT and GPT-powered system also faced criticism for producing inaccurate results and displaying erratic behavior in their early iteration. So, moving forward, let's see what are the use cases of generative AI. Generative AI has broad applicability and can be employed across a wide range of use cases to generate diverse forms of content. Recent advancements like GPT have made this technology more accessible and customizable for various applications. Some notable use cases for generative AI are as follows. Chatbot implementation. Generative AI can be utilized to develop chatbots for customer service and technical support, enhancing interaction with users and providing efficient assistance. The second one is language dubbing enhancement. In the realm of movies and educational content, generative AI can contribute to improving dubbing in different languages, ensuring accurate and high quality translation. And the third one is content writing. Generative AI can assist in writing email responses, dating profiles, resumes, and term papers, offering valuable support and generating customized content tailored to specific requirements. And the fourth one is art generation. Leveraging generative AI, artists can create photorealistic artwork in various styles, enabling the exploration of new artistic expression and enhancing creativity. The fifth one is product demonstration videos. Generative AI can enhance product demonstration video, making them more engaging, visually appealing, and effective in showcasing product features and benefits. So generative AI versatility allows it to employed in many other applications, making it a valuable tool for content creation and enhancing user experience across diverse domains. So after seeing use cases of generative AI, let's see what are the benefits of generative AI. So generative AI offers extensive application across various business domains, simplifying the interpretation and comprehension of existing content while also enabling the automated creation of a new content. Developers are actively exploring ways to leverage generative AI in order to enhance the optimize existing workflows and even to reshape workflows entirely to harness the potential of technology fully. Implementing generative AI can bring numerous benefits, including automated content creation. Generative AI can automate the manual process of writing content, saving time and effort by generating text or other form of content. The next one is efficient email response. Responding to emails can be made more efficient with generative AI, reducing the effort required and improving response time. And the third one is enhanced technical support. Generative AI can improve responses to specific technical queries, providing accurate and helpful information to users or customers. And the fourth one is realistic person generation. By leveraging generative AI, it becomes possible to create realistic representation of people, enabling applications like virtual characters or avatars. And the fifth one is coherent information summarization. Generative AI can summarize complex information into a coherent narrative, distilling key points and making it easier to understand and communicate complex concepts. The implementation of generative AI offers a range of potential benefits, streamlining process and enhancing content creation in various areas of business operation. So after seeing advantages of generative AI, let's move forward and see what are the limitations of generative AI. Early implementation of generative AI serve as vivid examples highlighting the numerous limitations associated with this technology. Several challenges arise from the specific approaches employed to implement various use cases. For instance, while a summary of a complex topic may be more reader-friendly than explanation incorporating multiple supporting sources, the ease of readability comes at the expense of transparent identifying the information sources. So the first one is, when implementing or utilizing a generative AI application, it is important to consider the following limitation. I repeat, the first one is Lack of source identification. Generative AI does not always provide clear identification of content source, making it difficult to trace and verify origin of the information. The second one is assessment of bias. Assessing the bias of original sources used generative AI can be challenging, as it may be difficult to determine the underlying perspective or agenda of the data utilized in the training process. The third one is difficulty in identifying inaccurate information. Generative AI can generate realistic content, making identifying inaccuracy or falsehoods within the generated output harder. And the fourth one is adaptability to a new circumstances. Understanding how to fine-tune generative AI for a new circumstances or specific context can be complex, requiring careful consideration and expertise to achieve desired result. And the fifth one is glossing over bias, prejudice, and hatred. Generative AI results may amplify or perpetuate biases, prejudices, or hateful content present in the training data, requiring vigilant scrutiny to prevent such issues. So awareness of these limitations is crucial when the implementing of utilizing generative AI, as it helps users and developers critically evaluate and mitigate potential risks and challenges associated with the technology. So, future of generative AI. Furthermore, advances in AI development platforms will contribute to the accelerated progress of research and development in the realm of generative AI. The development will encompass various domains such as text, images, videos, 3D content, drugs, supply chains, logistics, and business processes. While the current standalone tools are impressive, the true transformative impact generative AI will realize while these capabilities are seemingly integrated into the existing tools with regular use.
Today, we'll take you through the exciting roadmap of becoming an AI engineer. If our content piques your interest and helps fuel your curiosity, don't forget to subscribe to our channel. Hit that bell icon so you never miss an update. Now let's embark on this AI journey together. As artificial intelligence continues to revolutionize various industries, AI engineers stand at the forefront of this technological wave. These professionals are essential in crafting intelligent systems that address complex business challenges. AI projects often stumble due to poor planning, subpar architecture, or scalability issues. AI engineers play a crucial role in overcoming these hurdles by merging cutting-edge AI technologies with strategic business insights. So in this video, we'll guide you through the essentials of becoming an AI engineer. Let's start with the basics. What does an AI engineer do? An AI engineer builds AI models using machine learning algorithms and deep learning neural networks. These models are pivotal in generating business insights that influence organizational decision making. From developing applications that leverage sentiment analysis for contextual advertising to creating systems for visual recognition and language translation, the scope of an AI engineer's work is vast and impactful. So to succeed as an AI engineer, you need a blend of technical prowess and soft skills. So now let's break down this 8-month plan. Month 1, Computer Science Fundamentals and Beginners Python. So before we delve into AI, it's crucial to establish a strong foundation in computer science. This month, you should focus on the following topics. Data representation. Understanding bits and bytes, how text and numbers are stored, and the binary number system is foundational for everything in computing. This knowledge helps in comprehending how computers interpret and process data. Now next comes computer networks. Learn the basics of computer networks, including IP addresses and internet routing protocols. It's essential to understand how data travels across networks using UDP, TCP, and HTTP, which form the backbone of the internet and the World Wide Web. Next comes programming basics. Begin with the basics of programming like variables, strings, numbers, conditionals, loops, and algorithm basics. These fundamentals will allow you to write and understand simple programs. Simultaneously, you'll also start with Python, the preferred language for AI. So learn about variables, numbers, strings, lists, dictionaries, sets, tuples, and control structures like if conditionals and for loops. And then move on to functions and modules. Understand how to create functions, including lambda functions, and work with modules by using pip install to add functionality to your projects. Next comes file handling and exceptions. You should also practice reading from and writing to files, as well as handling exceptions to make your programs more robust. Finally, grasp the basics of classes and objects, which are crucial for writing organized and efficient code. So this comprehensive overview sets the stage for more complex programming tasks that you'll encounter in the following months. Now in month 2, you'll move on to data structure algorithms and advanced Python. So building on the foundations from month 1, we'll now delve into data structure and algorithm. So familiarize yourself with the concept of big O notation to understand the efficiency of different algorithms and data structures. Learn about arrays, linked lists, hash tables, stacks, queues, trees, and graphs. Mastering these structures will allow you to store and manipulate data effectively. Now next comes algorithms. You should explore algorithms such as binary search, bubble sort, quick sort, merge sort, and recursion. These are essential for optimizing your code, and parallelly you'll advance your Python skills. So you can dive into inheritance, generators, iterations, list comprehensions, decorators, multi-threading, and multiprocessing. These topics will enable you to write more efficient and scalable code. So this month's learning prepares you to handle complex data operations and enhance your coding efficiency. Now in month 3, you'll move on to version control, SQL, and data manipulation. So in the third month, the focus shifts to collaboration and data management. Number 1, version control. So understand the importance of version control systems, especially Git and GitHub. So learn basic commands such as add, commit, and push. You should also learn how to handle branches, reword changes, and understand concepts like head, diff, and merge. So these skills are invaluable for tracking changes and collaborating with other developers. Next, pull requests. Master the art of creating and managing pull requests to contribute to collaborative projects. Next, we'll dive into SQL for managing databases. So first, we'll start with SQL basics. So learn about relational databases and how to perform basic queries. And then you'll move on to advanced queries. Understand complex query techniques such as CTEs, subqueries, and window functions. And then comes joins and database management. So study different types of joins like left, right, inner, and full join. You should also learn how to create databases, manage indexes, and write stored procedures. Additionally, you will use NumPy and Pandas for data manipulation and learn basic data visualization techniques. This comprehensive skill set will be crucial as you move into more advanced data science topics. So now in month 4, you'll deal with maths and statistics for AI. So mathematics and statistics are the backbone of AI, and this month is dedicated to these critical subjects. So first, learn about descriptive versus inferential statistics, continuous versus discrete data, nominal versus ordinal data, measures of central tendency like mean, median, mode, and measures of dispersion like variance and standard deviation. After that, understand the basis of probability and delve into normal distribution, correlation, and covariance. After which, you should move on to advanced concepts. So you can study the central limit theorem, hypothesis testing, p-values, confidence intervals, and so on. In parallel, you should also study linear algebra and calculus. So in linear algebra, learn about vectors, matrices, eigenvalues, and eigenvectors. And in calculus, cover the basics of integral and differential calculus. So this mathematical foundation is essential for developing and understanding AI models, setting you up for success as you transition into machine learning. Now in month 5 comes exploratory data analysis, which is EDA and machine learning. So with a solid foundation in math and statistics, you are now ready to delve into machine learning. Number 1, pre-processing. Learn how to handle NA values, treat outliers, perform data normalization, and conduct feature engineering. You should also understand encoding techniques such as one-hot and label encoding. You'll also explore supervised and unsupervised learning with a focus on regression and classification, and learn about linear models like linear and logistical regression and non-linear models like decision tree, random forest, etc. And then understand how to evaluate models using metrics such as mean squared error, mean absolute error, MAPE for regression and accuracy, precision recall, etc. Then comes hyperparameter tuning. Learn about techniques like grid search CV and random search CV for optimizing your models. After which you'll move on to unsupervised learning. Here you can study clustering techniques like K-means and hierarchical clustering and delve into dimensionality reduction with PCA. So this month's focus on EDA and model building will prepare you for more complex AI applications. Transitioning to the next phase, you will begin to work on deploying these models and real-world scenarios. So in month 6 comes MLOps and machine learning projects. So this month we'll cover the operational aspects of machine learning and work on practical projects. So in MLOps basics, learn about APIs, particularly using Fast API for Python and server development. Understand DevOps fundamentals including CI/CD pipelines and containerization with Docker and Kubernetes. You should also gain familiarity with at least one cloud platform like AWS or Azure. Now in month 7 comes deep learning. So in this month, we delve into the world of deep learning. So number 1 comes neural network. So learn about neural networks, including forward and backward propagation, and build multi-layer perceptrons. After which we'll move on to advanced architectures. So here explore convolutional neural networks, which are CNNs, for image data, and sequence models like RNNs and LSTMs. So this deep learning knowledge will be crucial as we move into specialized areas of AI in the final month. Now in the final month, the 8th month, comes NLP or computer vision. So the final month, you have the option to specialize in either natural language processing, NLP, or computer vision. So first we'll reveal NLP track. So here you should learn about regex, text representation methods like count vectorizer, TF-IDF, Bow, word-to-vec, embeddings, and text classification with naive Bayes. And familiarize yourself with the fundamentals of libraries like Spacy and NLTK and work on end-to-end NLP project. And talking about computer vision track, focus on basic image processing techniques like filtering, edge detection, image scaling, and rotation. Utilize libraries like OpenCV and build upon the CNN knowledge from the previous month. Practice data preprocessing and augmentation. So by the end of this month, you should have a solid foundation in your chosen specialization ready to embark on your AI engineering career. So in conclusion, adopting AI is more than just a trend. It's a strategic move that can transform your organization's approach to machine learning. So do check out our professional certificate course in AI and machine learning, which is designed to equip you with the skills needed to excel in this dynamic field. Through live classes led by industry experts, masterclasses from IIT Kanpur faculty, and hands-on projects, you'll gain a competitive edge in AI. To enroll in this program, candidates should have a bachelor's degree with a 50% or higher average, preferably 2 or more years of work experience and foundational knowledge in programming and mathematics. Check out the course link in the description box below. So that's all for today's video on becoming an AI engineer. We hope you found this guide valuable and informative.
So now let's see steps to get an AI engineer job. So to thrive in this field, developing a comprehensive skill set is crucial, while encompasses many specialized areas. So here are some certain core skills that are essential across most roles. So here is you can build these skills. First one is technical skills. So AI roles heavily rely on technical expertise, particularly in programming, data handling, or working with AI specific tools, or you can say the cloud specific tools. So here are some key areas to focus on. The first one is the programming languages. So proficiency in general purpose programming language like Python and R is the fundamental. Python in particular is widely used in AI for simplicity and robust libraries such as TensorFlow and PyTorch, which are crucial for machine learning and deep learning tasks. The second one is database management. So understanding how to manage and manipulate large datasets is essential in AI. Familiarity with database management systems like Apache Cassandra, Couchbase, and DynamoDB will allow you to store, retrieve, and process data efficiently. The third one, data analysis and statistics. Strong skills in data analysis are must. Tools like MATLAB, Excel, and Pandas are invaluable for statistical analysis, data manipulation, and visualization of trends in data, which are critical for developing AI models. The fourth one, cloud AI platform. Knowing of cloud-based AI platforms such as Microsoft Azure AI, Google Cloud AI, and IBM Watson is increasingly important. So these platforms provide pre-built models, tools, and infrastructure that can accelerate AI development and deployment. The second one is industry knowledge. While technical skills from the backbone of your AI expertise, understanding the industry context is equally important. For example, knowing how AI integrates with digital marketing goals and strategies can be a significant advantage if you are working in or targeting industries like e-commerce or advertising. So industry-specific knowledge allows you to apply AI solutions more effectively and communicate their value to stakeholders. The third one, workplace or soft skills. In addition to technical, industry-specific skills, developing workplace skills, or you can say soft skills, is essential for success in AI roles or any roles. So these soft skills often honed through experience include, the first one is communication. Clearly articulating complex AI concept to non-technical stakeholders is crucial. Whether you are explaining how machine learning model works or presenting data-driven insight, effective communication ensure that your work is understood and valued. Second one is collaboration. AI projects often require teamwork across diverse fields, including data science, software development, and other things. The third one is analytical thinking. AI is fundamentally about problem solving. You will need strong analytical thinking skills to approach challenges logically, break them down into manageable parts, and develop innovative solutions. The fourth one, problem solving. AI projects frequently involve unexpected challenges, whether it's a technical bug or an unforeseen data issue. Strong problem solving will help you navigate these hurdles and keep projects on track. So building these skills can be achieved through various methods, including self-study, online courses, boot camps, or formal education. Additionally, working on real projects, contributing to open source AI initiatives, and seeking mentorship can provide practical experience and further enhance your expertise. So next thing is learn advanced topics. So as you advance in your machine learning journey, it is important to delve into more advanced topics. These areas will deepen your understanding and help you tackle complex problems. So some key topics to focus are, the first one is deep learning and neural network. The second thing is ensemble learning techniques. The third thing is generative models and adversarial learning. The fourth one is recommendation system and collaborative filtering. The fifth one is time series analysis and forecasting. So now let's move forward and see some machine learning projects. So working on real world projects to apply your knowledge, focus on data collection and preparation, capstone project in image recognition and NLP, predictive modeling and anomaly detection, practical experience, key to solidifying your skills. So now let's move forward and see what is the next skill. That is earn a certification. So if you are already hold an undergraduate degree in a field of related to AI, enrolling in a specialized course to enhance your technical skills can be highly beneficial. Even if you don't have a degree, earning certification can show potential employers that you are committed to your career goals and actively investing in your professional development. So you can unleash your career potential with our artificial intelligence and machine learning courses, tailored for diverse industries and roles at top global firms. Our program features key tools, enhance your AI knowledge and business acumen, join the job market and become sought-after professional. The next thing is continuous learning and exploration. So stay updated with the latest development by following industry leaders, engaging in online communities and working on personal projects. Pursue advanced learning through courses and certification to keep your skills sharp. So now let's move forward and see some AI career opportunities with salary. So the job market for machine learning professionals is booming. The average annual salary for AI engineers can vary based on location, experience and company. So here are some roles like machine learning engineer, data scientist, NLP engineer, computer vision and AI ML researcher. So now let's see how much they earn. So the first one is ML engineer. So machine learning engineers earn $153,000 in US and 11 lakh in India per annum. The second one is data scientist. The data scientists earn $150,000 in US and 12 lakh per annum in India. The third one is NLP engineer. They earn $107,000 in US and 7 lakh in India per annum. Fourth one is computer vision engineer, CV engineer. They earn around $126,000 in US and 6,50,000 in India. The last one is AI ML researcher. They earn $130,000 in US and in India they earn around 9 lakh per annum. So note that these figures can vary on website to website and changes frequently. So now last step is start applying for entry-level jobs. When you feel confident in your training, begin researching and applying for jobs. Many entry-level AI positions like software engineer or developer roles are often labeled as entry-level or junior in the job description. Jobs that require less than 3 years of experience are usually suitable for those just starting out. If you need additional support in your job research, consider applying for internship, taking on freelance project, or participating in hackathons to further hone your skills. So these opportunities not only provide valuable feedback on your work, but also help you build connection that could benefit your career in the future. So with this, we have come to the end of this video. If you have any question or doubt, please feel free to ask in the comment section below. Our team of experts will help you as soon as possible. Artificial intelligence or AI is transforming our world, making things faster and more efficient. But what happens when AI makes mistakes? When AI is biased, it can have serious consequences for companies and people's lives. Imagine missing out on a job, being wrongly identified in a photo, or being unfairly treated, all because a computer program made a bad decision. These mistakes don't just harm individuals, they can affect entire communities without realizing it. So AI bias is also called algorithmic bias. Happens when AI systems unintentionally favor one group over another. Take healthcare. For example, if the data used to train an AI system doesn't include enough women or people from minority groups, the system might not work as well for them. This can lead to incorrect medical prediction, like giving black patients less accurate results than white patients. In job hiring, AI can unintentionally promote certain stereotypes, like when job ads use terms like ninja, which may attract more men than women, even though the term isn't a requirement for the job. Even in creative areas like image generation, AI can reinforce biases. When asked to create picture of CEOs, AI systems often show mostly white men, leaving out women and people of color. In law enforcement, AI tools sometimes rely on biased data, which can unfairly target minority communities. So in this video, we will explore some well-known examples of AI bias and how these mistakes are impacting people and society, from healthcare to hiring and even criminal justice. AI bias is something we need to understand and fix. So let's dive in and learn how these biases happen and what can be done to stop them.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we start, here is a quick info for you. Dive into the future of AI with our Generative AI and Machine Learning course in collaboration with ENICT, Academy IIT Guwahati. Learn tools like ChatGPT, OpenAI, Hugging Face, Python, and more. Join masterclass led by IITG faculty, engage in hands-on project, and earn executive alumni status. So find the course link from the description box below and the pinned comment. So without any further ado, let's get started. So what is AI bias? AI bias, also called machine learning bias, happens when human biases affect the data used to train AI system, causing unfair or inaccurate results. When AI bias isn't fixed, it can hurt a business success and prevent some people from fully participating in the economy or society. Biases makes AI less accurate, which reduce its effectiveness. Businesses may struggle to benefit from systems that give unfair results, and scandals from AI bias can lead to loss of trust, especially among groups like people of color, women, people with disabilities, and the LGBTQ community. AI models often learn from the data that reflects society biases. This can lead to unfair treatment of marginalized groups in the areas like hiring, policing, and credit scoring. As the Wall Street Journal notes, businesses still find it challenging to address these widespread biases as the AI use grows. So moving forward, let's see some sources of AI bias. Distorted outcomes can negatively affect both organization and society as a whole. So here are some common forms of AI bias. The first one is algorithm bias. If the problem or question is not well defined or the feedback provided to the machine learning algorithm is inadequate, the result may be inaccurate or misleading. The second one is cognitive bias. Since AI systems rely on a human input, they can be affected by unconscious human biases, which may influence either the dataset or the model's behavior. The third one, confirmation bias. This occurs when the AI overly depends on existing beliefs or trends in the data, reinforcing prior biases and failing to detect new patterns or trends. The fourth one, execution bias. When important data is omitted from the dataset, often due to the developer overlooking new or crucial factors, this type of bias arises. The fifth one, measurement biases. So this bias stems from incomplete data, such as when a dataset fails to represent the entire population. For instance, if a college analyzes only graduates to determine success factors, it would overlook reasons why others drop out. So moving forward, let's see how to avoid bias. So here are checklists of 6 process steps that can keep AI programs free of bias. The first one is choose the right model. Ensure diverse stakeholders select training data in supervised model and integrate bias detection tools in unsupervised models. The second one, use accurate data. Train AI with complete balanced data that reflects the true demographics. The third one, build a diverse team. A varied team helps spot bias, including innovators, creators, implementers, and end users. The next one, watch data processing. Bias can appear during any phase of processing, so stay vigilant throughout. The fifth one, monitor regularly. So continuously test models and have independent assessment to detect and fix biases. And the last one, check infrastructure. Ensure technological tools and sensors are functioning properly to avoid hidden biases. So conclusion is, AI biases poses serious challenges by amplifying existing societal biases, affecting individuals and businesses. From healthcare to hiring, AI system can unintentionally reinforce stereotypes and inequalities. Imagine this, you are using a calculator app on your phone, and it gives you an answer to be a complex math problem faster than you can blink. Pretty standard, right? But what if instead of just crunching numbers, that app could actually think through the problem, breaking it down like a human would, considering the best approach, and even explaining why it made certain decisions? Sound futuristic, doesn't it? Well, we are not too far from that reality. Today, we are diving into OpenAI's latest project, codenamed Strawberry, a new AI model that pushing the boundaries of reasoning and problem solving. So in this video, we will break down what makes Strawberry special, how it works, and why it could change the game for AI systems moving forward. So first off, what exactly is Strawberry? According to recent report, OpenAI is preparing to release this new AI model in the next 2 weeks or in the couple of weeks. And it's set to improve on things like reasoning and problem solving. Previously known as Q or Q star, this model is designed to be much better at thinking through problems compared to what we have seen from previous versions.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we start, here is a quick info for you. If you want to learn AI and ML from the industry experts, try Simplilearn's postgraduate program in AI and machine learning from Purdue University in collaboration with IBM. This course teaches in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. So don't forget to check out the course link from the description box below and the pinned comment. But what makes Strawberry different from what we have used before? So now let's take a look. One of the coolest things about Strawberry is that it uses something called system 2 thinking. This idea came from the famous psychologist Daniel Kahneman, and it refers to a more careful and slow way of thinking. Like when you really focus on solving a tricky problem, instead of answering question instantly, Strawberry takes about 10 to 20 seconds to process its thought. This extra time helps it to avoid mistakes and gives more accurate answers. But the model doesn't just think slowly. It's got some really cool abilities that makes it stand out. Let's talk about those. Strawberry is built to handle advanced reasoning and solve mathematical problems. These are areas where AI systems struggles. But Strawberry is designed to be a lot better at breaking down complex problems step by step. And here is something interesting. It might even be added to future versions of ChatGPT, possibly as a model name called Orion or GPT-5. If that happens, it could mean ChatGPT will become more smarter and more reliable in solving tough problems. Now, here is where it gets really fascinating. There is some research that might help us understand how Strawberry improves its thinking. Let's check it out. You might have heard about something called STAR, which stands for self-taught reasoner. This is a method where an AI can actually teach itself to think better. Here is how it works. STAR starts with a few examples where the AI is shown how to solve problems step by step. Then the AI tries solving their problem on its own, getting better as it goes. It keeps improving by looking at its mistakes and learning from them. This could be what's happening with Strawberry. It's using similar method to teach itself how to reason better and solve complex problems. But the AI doesn't just think better. It's also learning how to break down the problems in a very human-like way. So now let's explore that next. Strawberry uses something called chain of thought reasoning. Basically, when faced with a complex problem, it breaks it down into smaller, manageable steps. Kind of like how we do when we are solving a puzzle. Instead of just jumping on to an answer, it takes its time to go through each step, making the solution more understandable and accurate. So this is especially useful in math, where Strawberry is expected to be really strong. With all its potential, what does the future hold for AI models like Strawberry? So now let's wrap this thing with a look at what's next. So now what's next for OpenAI? Well, Strawberry is just the beginning. There is talk about a future model called Orion, which could be the next big version after GPT-4 or GPT-4o. It may even use that Strawberry learners to get better at solving problems. But here is the thing. Training these advanced models is expensive. Training GPT-4, for example, cost over 100 million, even though OpenAI CEO Sam Altman said the era of just making bigger models is coming to an end. It's clear that the models like Strawberry are focused on becoming smarter and more efficient. So what does all of this mean for the future of AI and how we use it? Strawberry could represent a huge leap in AI's ability to reason and solve complex problems. So with its focus on slower, more deliberate thinking and its potential connection to the STAR method, it's paving the way for smarter, more reliable AI system. And this is just the start. As we move forward, models like Orion, the possibilities are endless. And that's a wrap on OpenAI exciting new model Strawberry. It's clear that this AI could bring major advancement in reasoning and problem solving. and we can't to see how it all unfolds. What are thoughts on your strawberry? Do let us know in the comment section below.
Hey everyone, welcome to Simplilearn. Today's video will compare and contrast artificial intelligence, deep learning, machine learning, and data science. But before we get started, consider subscribing to Simplilearn's YouTube channel and hit the bell icon. That way you'll be the first to get notified when we post similar content. Before moving on, let me ask you two interesting queries. Which among the following is not a branch of artificial intelligence? Data analysis, machine learning, deep learning, neural networks. And the second query is, what is the main difference between machine learning and deep learning? Please leave your answer in the comments section below, and stay tuned to get the answer. First, we will unwrap deep learning. Deep learning was first introduced in the 1940s. Deep learning did not develop suddenly, it developed slowly and steadily over 7 decades. Many theses and discoveries were made on deep learning from the 1940s to 2000. Thanks to companies like Facebook and Google, the term deep learning has gained popularity and may give the perception that it is a relatively new concept. Deep learning can be considered as a type of machine learning and artificial intelligence, or AI, that imitates how humans gain certain types of knowledge. Deep learning includes statistics and predictive modeling. Deep learning makes processes quicker and simpler, which is advantageous to data scientists to gather, analyze, and interpret massive amounts of data. Having the fundamentals discussed, let's move into the different types of deep learning. Neural networks are the main component of deep learning, but neural networks comprise 3 main types, which contain artificial neural networks, or ANN, convolution neural networks, or CNN, and recurrent neural networks, or RNN. Artificial neural networks are inspired biologically by the animal brain. Convolutional neural networks surpass other neural networks when given inputs such as images, voice, or audio. It analyzes images by processing data. Recurrent neural networks uses sequential data or series of data. Convolutional neural networks and recurrent neural networks are used in natural language processes, speech recognition, image recognition, and many more. Machine learning. The evolution of ML started with the mathematical modeling of neural networks that served as the basis for the invention of machine learning. In 1943, neuroscientist Warren McCulloch and logician Walter Pitts attempted to quantitatively map out how humans make decisions and carry out thinking processes. Therefore, the term machine learning is not new. Machine learning is a branch of artificial intelligence and computer science that uses data and algorithms to imitate how humans learn, gradually increasing the system's accuracy. There are 3 types of machine learning, which include supervised learning. What is supervised learning? Well, here, machines are trained using labeled data. Machines predict output based on this data. Now, coming to unsupervised learning, models are not supervised using a training data set. It is comparable to the learning process that occurs in the human brain while learning something new. And the third type of machine learning is reinforcement learning. Here, the agent learns from feedback. It learns to behave in a given environment based on actions and the result of the action. This feature can be observed in robotics. Now, coming to the evolution of AI. The potential of artificial intelligence wasn't explored until the 1950s, although the idea has been known for centuries. The term artificial intelligence has been around for a decade. Still, it wasn't until British polymath Alan Turing posed the question of why machines couldn't use knowledge like humans do to solve problems and make decisions. We can define artificial intelligence as a technique of turning a computer-based robot to work and act like humans. Now let's have a glance at the types of artificial intelligence. Weak AI performs only specific tasks, like Apple's Siri, Google Assistant, and Amazon's Alexa. You might have used all of these technologies, but the types I am mentioning after this are under experiment. General AI can also be addressed as artificial general intelligence. It is equivalent to human intelligence, hence an AGI system is capable of carrying out any task that a human can. Strong AI aspires to build machines that are indistinguishable from the human mind. Both general and strong AI are hypothetical right now. Rigorous research is going on this matter. There are many branches of artificial intelligence, which include machine learning, deep learning, natural language processing, robotics, expert systems, fuzzy logic. Therefore, the correct answer for which is not a branch of artificial intelligence is option A, data analysis. Now that we have covered deep learning, machine learning, and artificial intelligence, the final topic is data science. Concepts like deep learning, machine learning, and artificial intelligence can be considered a subset of data science. Let us cover the evolution of data science. The phrase data science was coined in the early 1960s to characterize a new profession that would enable the comprehension and analysis of the massive volumes of data being gathered at the time. Since its beginnings, data science has expanded to incorporate ideas and methods from other fields, including artificial intelligence, machine learning, deep learning, and so forth. Data science can be defined as the domain of study that handles vast volumes of data using modern tools and techniques to find unseen patterns, derive meaningful information, and make business decisions. Therefore, data science comprises machine learning, artificial intelligence, and deep learning.
Hello everyone, I am Mank and welcome to this video where I will show you how to run Llama 3.1 on your systems, all while keeping your data private. If you are curious about AI and want to use it on your own PC without relying on online services, you are in the right place. Llama 3.1 is a powerful AI tool that can help with tasks like text generation, but instead of using it in the cloud, you can run it directly on your computer. So in this video, I will guide you through everything from setting up your system to installing and running Llama 3.1 step by step. It's a great way to experiment with AI while keeping your work private. So by the end of this video, you will have Llama 3.1 up and running on your own systems. And you won't need to worry about sharing your data with anyone else. Whether you are just learning about AI or planning to use it for bigger projects, this tutorial will make it easy for you to get started. So let's dive in, follow along, and by the end, you will have your own private AI setup. Don't forget to like, subscribe, and let's start running Llama 3.1.
Welcome to this demo part of this Llama, how to install Llama 3.1 in your system. So I'm using Windows right now. It is available for Mac OS, Linux, and Windows. So first what we will do, we will install this Llama. Just type llama.com and I will provide this link in the description as well. Then here you have to press the download. Here you can choose your system, your OS, Mac OS, Linux, Windows. Just follow the steps later. So I will download for the Windows. So the application will get download. It is like 625 MB. So it is downloading. Till then there is no official documentation for this Llama. So here in GitHub there is one. So Llama, this is Windows for here, Windows, Mac OS, Linux you can download, and these are some models. See, Llama 3.1, Llama 3.1, Llama 3.1, and 5, Gemma, and Mistral is there, Moondream is there, and so on. And see, these are some parameters. 8B is 4.7 GB, 70B is 40 GB, and for 05B is 231 GB. So here note, you should have at least 8 GB of RAM available to run 7B models. 16 GB RAM to run 13B models, and 32 GB RAMs to run 32B models. So here we will install this 8B parameters. You can choose anyone as per your specification of your system, your OS. So still it's downloading. I have already installed in this, but again I will reinstall it. Fine. So now we have Llama setup. Just double click on this and install. See why it is showing this error. And why it is showing this error? Why? Because the following applications are using files that need to be updated by setup. It is recommended that you allow setups to automatically. It is automatically installed. See, it's a simple steps. There are 3-4 steps that you have to do.
So yeah, the setup is done. And now what you can do, I am using PowerShell. You can use your command prompt as well. So here I will write Llama. Okay, so here you can see these are some available command I can do. Okay, so to run a model you have to just write run and this. Okay, now if you will see here, to download Llama 3.1 8B parameter 1 4.7 GB will be the size. So this is the command, just copy it and paste it here. Okay, and enter. So why it is coming like this? Because it is already installed on my system. Fine. So now Llama 3.1 is installed. Okay, so here you can write your questions. Okay, what is Llama 3.1? So see, it is start generating the output. So this is how you can, privately run or install Llama into your large language models applications into your system. See, it is like ChatGPT. If you are looking for more details, can you please provide context or more background about why you are interested in Llama 3.1? That would be me try to find more relevant information for you. Okay, so here what I will write, what is ChatGPT? Okay, so it will give you the answer. See, ChatGPT is a conversational AI model developed by OpenAI, a leading artificial intelligence research laboratory. Okay, what you have to note, just you have to note what's the size of your RAM. Okay, I have 16 GB of RAM, that's why I installed this 8B one. Okay, and if you have 8 GB RAM, there is no model of 7B. 7B we have Lava, and we have Code Llama, and we have Mistral. So if you have 16 GB of RAM and this one Llama 3.1, the latest one, is enough. Okay, so let's check. Yeah, see, ChatGPT stands for Conversational Generative Pre-trained Transformer. It is an AI chatbot designed to understand and respond to human-like language input. And some key features are this. So this is how you can, be protected from your data as well. And you can ask anything to this. Okay, and there is one more thing. If you will go here, this API section. Okay, yeah, so there is one thing, I guess here is a thing. So yeah, if you type this localhost 11434, so this is an API for the Llama. See, here you can see Llama is running. Fine. So this is how you can do this, perform or install your Llama 3.1 in your local system. See, it is now asking me, how is that? Did I cover what you wanted to know about ChatGPT? Okay, and you can give your prompt and again you can do something. So okay, I will write what is hello world. See, hello world is a simple phrase that has become iconic in the world of computer programming. Everyone know to print hello world, I guess so. So this is how you can install Llama 3.1 in your local system. Okay, just you have to install Llama first, then search this Llama run 3.1, or if you want to explore more thing, you can write version, so the version, server, create, and all that thing. Okay, LLMs. If you ever wondered how machine learning can now understand and generate human-like text, you are in the right place. From chatbots like ChatGPT to AI assistant that power search engines LLMs are transforming how we interact with technology. One of the most exciting advancements in this space is Google's Gemini or OpenAI ChatGPT, a cutting-edge large language model designed to push the boundaries of what AI can achieve. In this video, we will explore what LLMs are, how they work, and why models like Gemini are critical for the future of AI. Google Gemini is part of a new wave of AI models that are smarter, faster, and more efficient. It is designed to understand context better, offer more accurate responses, and integrate deeply into services like Google Search and Google Assistant, providing more human-like interactions. So we will break down the science behind LLMs, including their massive training datasets, transformer architecture, and how models like Gemini use deep learning innovation to change industries. Plus, we will compare Google Gemini to other popular LLMs such as OpenAI ChatGPT models, showing how each of these technologies is used to power chatbots, virtual assistants, and other AI-driven applications. By end of this video, you will have a clear understanding of how large language models like Gemini work, their key features, and what they mean for their future AI. Don't forget to like, subscribe, and hit the bell icon to never miss any update from Simplilearn. So what are the large language models? Large language models like ChatGPT 4, Generative Pre-trained Transformer 4, O, and Google Gemini are sophisticated AI systems designed to comprehend and generate human-like text. These models are built using deep learning techniques and are trained on vast datasets collected from the internet. They leverage self-attention mechanism to analyze relationship between words or tokens, allowing them to capture context and produce coherent, relevant responses. LLMs have significant applications, including powering virtual assistant, chatbots, content creation, language translation, and supporting research and decision making. Their ability to generate fluent and contextually appropriate text has advanced natural language processing and improved human-computer interaction. So now let's see what are large language models used for. Large language models are utilized in scenarios with limited or no domain-specific data available for training. These scenarios include both few-shot and zero-shot training approaches, which rely on the model's strong inductive bias and its capability to derive meaningful representation from a small amount of data or even no data at all. So now let's see how are large language models trained. Large language models typically undergo pre-training on a board, all-encompassing dataset that shares statistical similarities with the dataset specific to the target task. The objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning phase for specific tasks. So there are some training processes of LLM which involve several steps. The first one is text pre-processing. The textual data is transformed into a numerical representation that the LLM model can effectively process. This conversion may involve techniques like tokenization, encoding, and creating input sequences. The second one is random parameter initialization. The model's parameters are initialized randomly before the training process begins. The third one is input numerical data. The numerical representation of the text data is fed into the model of processing. The model's architecture, typically based on transformers, allows it to capture the contextual relationship between the words or tokens in the next. The fourth one is loss function calculation. A loss function calculation measures the discrepancy between the model's prediction and the actual next word or token in a sentence. The LLM model aims to minimize this loss during training. The fifth one is parameter optimization. The model's parameters are adjusted through optimization technique. This involves calculating gradient and updating the parameters accordingly, gradually improving the model's performance. The last one is iterative training. The training process is repeated over multiple iterations or epochs until the model's output achieves a satisfactory level of accuracy on that given task or dataset. By following this training process, large language models learn to capture linguistic patterns, understand context, and generate coherent responses, enabling them to excel at various language-related tasks. The next topic is how do large language models work? So large language models leverage deep neural network to generate output based on patterns learned from the training data. Typically, a large language model adopts a transformer architecture which enables the model to identify relationship between words in a sentence irrespective of their position in the sequence. In contrast to RNNs that rely on recurrence to capture token relationship, transformer neural network employs self-attention as their primary mechanism. Self-attention calculates attention scores that determine the importance of each token with respect to the other token in the text sequence, facilitating the modeling of intricate relationships within the data. Next, let's see application of large language models. Large language models have a wide range of applications across various domains. So here are some notable applications. The first one is natural language processing, NLP. Large language models are used to improve natural language understanding tasks such as sentiment analysis, named entity recognition, text classification, and language modeling. The second one is chatbot and virtual assistant. Large language models power conversational agents, chatbots, and virtual assistant, providing more interactive and human-like user interaction. The third one is machine translation. Large language models have been used for automatic language translation, enabling text translation between different languages with improved accuracy. The fourth one is sentiment analysis. LLMs can analyze and classify the sentiment or emotion expressed in a piece of text, which is valuable for market research, brand monitoring, and social media analysis. The fifth one is content recommendation. These models can be employed to provide personalized content recommendations, enhancing user experience and engagement on platforms such as news websites or streaming services. So these applications highlight the potential impact of large language models in various domains, improving language understanding, automation, and interaction between humans and computers. Hello everyone, I am Mank and welcome to today's video where we will be talking about LLM benchmarks, tools used to test and measure how well large language models like GPT and Google Gemini performs. If you have ever wondered how AI models are evaluated, this video will explain it in simple terms. LLM benchmarks are used to check how good these models are at tasks like coding, answering questions, and translating languages or summarizing text. These tests use sample data and specific measurement to see how well the model performs. For example, the model might be tested with a few examples, like few short learning, or none at all, like zero short learning, to see how it handles new tasks. So now the question arises, why are these benchmarks important? They help developers understand where a model is strong and where it needs improvement. They also make it easier to compare different models, helping people choose the best one for their needs. However, LLM benchmarks do have some limits. They don't always predict how well a model will work in real-world situations, and sometimes model can overfit, meaning they perform well on test data but struggle in practical use. We will also cover how LLM leaderboards rank different models based on their benchmark scores, giving us a clear picture of which models are performing the best. So stay tuned as we dive into how LLM benchmarks work and why they are so important for advancing AI.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we start, here is a quick info for you. Dive into the future of AI with our Generative AI and Machine Learning course in collaboration with ENICT Academy, IIT Guwahati. Learn tools like ChatGPT, OpenAI, Hugging Face, Python, and more. Join masterclass led by IIT Guwahati faculty, engage in hands-on projects, and earn executive alumni status. This Generative AI and Machine Learning course enriches your career journey with comprehensive coverage of machine learning, deep learning, NLP, generative AI, reinforcement learning, computer vision, and many more. So don't forget to find the course link from the description box below and the pinned comment. So without any further ado, let's get started. So what are LLM benchmarks? LLM benchmarks are standardized tools used to evaluate the performance of large language models. They provide a structured way to test LLMs on a specific task or question, using sample data and predefined metrics to measure their capabilities. These benchmarks assess various skills such as coding, common sense reasoning, and NLP tasks like machine translation, question answering, and text summarization. The importance of LLM benchmark lies in their role in advancing model development. They track the progress of an LLM, offering quantitative insights into where the model performs well and where improvement is needed. This feedback is crucial for guiding the fine-tuning process, allowing researchers and developers to enhance model performance. Additionally, benchmarks offers an objective comparison between different LLMs, helping developers and organizations choose the best model for their needs. So how LLM benchmarks work? LLM benchmarks follow a clear and systematic process. They present a task for LLM to complete, evaluate its performance using specific metrics, and assign a score based on how well the model performs. So here is a breakdown of how this process works. The first one is setup. LLM benchmark come with pre-prepared sample data, including coding challenges, long documents, math problem, and real-world conversation. The task span various areas like common sense reasoning, problem solving, question answering, summary generation, and translation, all present to the model at the start of testing. The second step is testing. The model is tested on one of the three ways. Few shot, the LLM is provided with a few examples before being prompted to complete a task, demonstrating its ability to learn from limited data. The second one is zero shot. The model is asked to perform a task without any prior examples, testing its ability to understand new concepts and adapt to unfamiliar scenarios. The third one is fine-tune. The model is trained on a dataset similar to the one used in the benchmark, aiming to enhance its performance on the specific task involved. The third step is the scoring. So after completing the task, the benchmark compares the model's output with the expected answer and generates a score, typically ranging from 0 to 100, reflecting how accurately the LLM performs. So now moving forward, let's see key metrics for benchmarking LLMs. So LLM's benchmark uses various metrics to assess the performance of large language model. So here are some commonly used metrics. The first one is accuracy or precision. Measure the percentage of correct prediction made by the model. The second one is recall, also known as sensitivity. Measure the number of true positive reflecting the correct prediction made by the model. The third one is F1 score. Combines both accuracy and recall into a single metric, weighing them equally to address any false positive or negatives. F1 score ranging from 0 to 1, where 1 indicates perfect precision and recall. The fourth one is exact match. Tracks the percentage of predictions that exactly match the correct answer, which is especially used for the tasks like translation and question answering. The fifth one is perplexity gauges. Here it will tell you how well a model predicts the next word or token. A lower perplexity score indicates better task comprehension by the model. The sixth one is BLUE, bilingual evaluation understudy. Is used for evaluating machine translation by comparing n-grams, sequence of adjacent text element, between the model's output and the human-produced translation. So these quantitative metrics are often combined for more through evaluation. So in addition, human evaluation introduces qualitatively factors like coherence, relevance, and semantic meaning, provide a nuanced assessment. However, human evaluation can be time-consuming and subjective, making a balance between quantitative and qualitative measures important for comprehensive evaluation. So now let's moving forward see some limitation of LLM benchmarking. While LLM benchmarking are valuable for assessing model performance, they have several limitations that prevents them from the fully predicting real-world effectiveness. So here are some few. The first one is bounded scoring. Once a model achieves the highest possible scores on the benchmark, that benchmark loses its utility and must be updated with more challenging tasks to remain a meaningful assessment tool. The second one is broad dataset. LLM benchmark often rely on sample data from diverse subjects and tasks. So this wide scope may not effectively evaluate a model's performance in edge cases, specialized fields, or specific use cases where more tailored data would be needed. The third one is finite assessment. Benchmark only tests a model's current skills, and as LLMs evolve and new capabilities emerge, new benchmarks must be created to measure these advancements. The fourth one is overfitting. So if an LLM is trained on the same data used for benchmarking, it can lead to overfitting, where the model performs well on the test data but struggles with the real task. So this result is scores that don't truly represent the model's broader capabilities. So now what are LLM leaderboards? So LLM leaderboards publish a ranking of LLMs based on the variety of benchmarks. Leaderboards provide a way to keep track to the myriad LLMs and compare their performance. LLM leaderboards are especially beneficial in making decisions on which models to use. So here are some. So in this you can see here OpenAI is leading and GPT-4o second and the Llama third with 405 parameter B and 3.5 sonnet is there. So this is best in multitask reasoning. What about the best in coding? So here OpenAI O1 is leading. I guess this is the Orion one, and the second one is 3.5 sonnet, and after that in the third position the next comes fastest and most affordable models. So fastest models are Llama 8B parameter, and the second one is LLAMA Llama 70B, and the third one is 1.5 flash. This is Gemini 1, and lowest latency. And here it is leading Llama again. In cheapest models, again Llama 8B is leading, and in the second number we have Gemini Flash 1.5, and in third we have GPT-4o Mini. Moving forward, let's see standard benchmarks between Claude 3 Opus and GPT-4. So in general they are equal. In reasoning, Claude 3 Opus is leading, and in coding GPT-4 is leading. In math, again GPT-4o is leading. In tool use, Claude 3 Opus is leading, and in multilingual, Claude 3 Opus is leading.
Today, we will discuss about booming topic of this era, multimodal AI. Let's understand with an example. Imagine you are showing a friend your vacation photos. You might describe the sight you saw, the sounds you heard, and even your emotions. This is how humans naturally understand the world, by combining information from different sources. Multimodal AI aims to do the same thing. Let's break the modal AI first. Multimodal refers to the two different ways of communicating information like text, speech, images, and videos, where AI stands for artificial intelligence, which are systems that can learn and make decisions. So, multimodal AI is a type of AI that can process and understand information from multiple sources, just like you do when you look at your vacation photos. Before delving more into multimodal AI, so here is a just quick info for you.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
If you want to switch careers with AI and ML, then try giving Simplilearn's postgraduate program in AI and machine learning from Purdue University in collaboration with IBM. This course teaches in-demand skills such as machine learning, deep learning, NLP, computer vision, reinforcement learning, generative AI, prompt engineering, ChatGPT, and many more. So don't forget to check out the course link from the description box and pin comment. Now that we have understood what is multimodal AI, let's now go a bit further. It is obvious that multimodal AI is not the only AI out there. But what is big deal about multimodal AI that everyone is talking about? That is what we will discuss in this segment. So now let's understand the difference between multimodal AI and the generative AI. While both multimodal AI and generative AI are exciting advancement in AI, they differ in their approach to data and functionality. So generative AI focus creates new data similar to the data it's trained on. And in multimodal AI, focus is to understand and processes information from multiple sources, that is text, speech, images, and videos. Data types of generative AI are primarily works with a single data type like text, writing poems or images, that is generating realistic portraits. Whereas in multimodal AI, data types works with diverse data types, enabling a more comprehensive understanding of the world. The third one is examples like chatbots, text generation models, image editing tools. Whereas multimodal AI example covers virtual assistants, medical diagnosis system, and autonomous vehicles. Strengths are can produce creative and innovative content, automate repetitive tasks, and personalize your experience. Whereas in multimodal AI, strengths are provides a more human-like understanding of the world and improve accuracy. In essence, generative AI excels at creating new data, while multimodal AI excels at understanding and utilizing existing data from diverse sources. They can be complementary with generative models being used to create new data for multimodal AI systems to learn more from and improve their understanding to the world. Next, let's understand what are the benefits of multimodal AI. The benefits of multimodal AI is that it offers developers and users an AI with more advanced reasoning, problem solving, and generation capabilities. These advancements offers endless possibilities for how next generation application can change the way we work and live. For developers looking to start building, Vortex AI Gemini API offers features such as enterprise security, data residency, performance, and technical support. If your existing Google Cloud customers can start prompting with Gemini AI in Vortex AI right now. Next, let's see what are the multimodal AI big challenges. Multimodal AI is powerful but faces hurdles. The first one is data overload. Managing and storing massive, diverse data is expensive and complex. The second one is meaning mystery. Teaching AI to understand subtle difference in between meaning like sarcasm is tricky. The third one is data alignment. Ensuring data points from different sources staying in tune is challenging. The fourth one is data scarcity. Limited and potentially biased datasets hinder effective training. The fifth one is missing data blues. What happens when data is missing, like distorted audio? The last one is black box blues. Understanding how AI makes decisions can be difficult. So these challenges must be addressed to unlock the full potential of model AI. Next, let's see what is the future of multimodal AI and why is it important. Multimodal AI and multimodals represent a leap forward in how developers build and expand the functionality of AI in the next generation of application. For example, Gemini can understand, explain, and generate high quality code in the world's
most popular programming languages like Python, Java, C++, and Go, freeing developers to work on building more featured field applications. Multimodal's AI potential also bring the world closer to AI that's less like smart software and more like an expert helper or assistant.
So here's the OpenAI documentation, and you could see the new features introduced with the ChatGPT 4.0. So these are the improvements. One is the updated and interactive bar graphs or pie charts that you can create, and these are the features that you could see here. You could change the color, you could download it, and what we have is you could upload the latest file versions directly from Google Drive and Microsoft OneDrive. And we have the interaction with tables and charts in a new expandable view that I showed you here. That is here, you can expand it in the new window. And you can customize and download charts for presentations and documents. Moreover, you can create the presentation also that we'll see in further. And here we have how data analysis works in ChatGPT. You could directly upload the files from Google Drive and Microsoft OneDrive. I will show you guys how we can do that and where this option is. And we can work on tables in real time. And there we have customized presentation ready charts. That is, you can create a presentation with all the charts based on a data provided by you. And moreover, a comprehensive security and privacy feature. So with that, guys, we'll move to ChatGPT. And here we have the ChatGPT 4.0 version. So before commencing, guys, there's a quick info for you. If you're one of the aspiring data analysts looking for online training and graduating from the best universities, or a professional who elicits to switch careers with data analytics by learning from the experts, then try giving a shot to Simplilearn's Purdue postgraduate program in data analytics in collaboration with IBM. You can find the link in the description box and pinned comment. So let's get started with data analysis part. So this is the pin section or the insert section where you can have the options to connect to Google Drive, connect to Microsoft OneDrive, and you can upload it from the computer. This option was already there, that is upload from computer. And you can upload at least or at max the 10 files. That could be around Excel files or documents. So the max limit is 10. And if you have connected to Google Drive, I'll show you guys. I'm not connecting you, but you guys can connect it too, and you could upload it from there also. And there's another cool update, that is ability to quote directly in your chat. So while chatting with ChatGPT, I'll show you guys how we can do that. And you could find some new changes that is in the layout. So this is the profile section. It used to be at the left bottom, but now it's moved to the top right and making it more accessible than ever. So let's start with the data analysis part. And the first thing we need is data. So you can find it on Kaggle, or you could ask ChatGPT 4.0 to provide the data. I will show you guys. So this is the Kaggle website. You can sign in here and click on datasets. You can find all the datasets here. That would be around computer science, education, classification, computer vision. Or else you could move back to ChatGPT and you could ask the ChatGPT 4.0 model to generate a data and provide it in Excel format. So we'll ask him, we'll not ask him can you, we'll just ask him provide a data set that I can use for data analysis and provide in CSV format. So you could see that it has responded that I can provide a sample data set, and he has started generating the data set here. So you could see that he has provided only 10 rows, and he is saying that I will now generate this data set in CSV format. First he has provided the visual presentation on the screen, and now he is generating the CSV format. So if you want more data, like if you want 100 rows or 1000 rows, you could specify in the prompt and ChatGPT will generate that for you. So we already have the data. I will import that data. You could import it from here, or else you can import it from your Google Drive. So we have a sales data here. We will open it. So we have the sales data here. So the first step we need to do is data cleaning. So this is the crucial step to ensure that the accuracy of our analysis is at its best. So we can do that by handling missing values. that is missing values can distort our analysis. And here ChatGPT 4 can suggest methods to impute these values, such as using the mean, median, or a sophisticated approach based on data patterns. And after handling the missing values, we will remove duplicates and outlier detection. So we'll ask ChatGPT, clean the data if needed. So we can just write a simple prompt that would be clean the data if needed. And this is also a new feature. You can see the visual presentation of the data here, that we have 100 rows here and the columns provided, that is sales ID, date, product, category, quantity, and price per unit and total sales. So this is also a new feature that, okay, we just had it back. We'll move back to our ChatGPT chat here. Okay, so here we are. So you could see that ChatGPT has cleaned the data and he has provided that it has checked for missing values, checked for duplicates, and ensured consistent formatting. And he's saying, okay, so now we will ask him that execute these steps and provide the clean data. As ChatGPT has provided that these are the steps to clean the data, and let's see. So he has provided a new CSV file with the clean sales data. We will download it and ask him to use the same file only. Use this new cleaned sales data CSV file for further analysis. So you could see that he is providing what analysis we can do further. But once our data is clean, the next step is visualization. So visualizations help us understand the data better by providing a graphical representation. So the first thing we will do is we will create a prompt for generating the histograms, and we'll do that for the age distribution part. So we'll write a prompt that generate a histogram to visualize the distribution of customer ages. To visualize the distribution of customer ages. And what I was telling you guys is this code button. If you just select the text and you would find this reply section, just click on that and you could see that it has selected the text or what you want to get, or the prompts started with ChatGPT. So we'll make it cross and you could see that it has provided the histogram here, and these are the new features here. And we could see that he is providing a notification that interactive charts of this type are not yet supported. That is, histogram don't have the color change option. I will show you the color change option in the bar chart section. So these features are also new. You can download the chart from here only, and this is the expand chart. If we click on that, you could see that you could expand the chart here and continue a chat with ChatGPT here. So this is the interactive section. So you could see that he has provided the histogram that is showing the distribution of customer ages, and the age range are from 18 to 70 years with the distribution visualized in 15 bins, that he has created 15 bins here. And now moving to another visualization that we'll do by sales by region. So before that, I will open the CSV file that is provided by the ChatGPT. So you guys can also see what data he has provided. So this is the clean sales data, and you could see that we have columns sales ID, date, product, category, quantity, price per item, total sales, region, and salesperson. So now moving back to ChatGPT. So now we will create a bar chart showing total sales by region. So we'll enter this prompt that create a bar chart showing total sales by region. So what we are doing here is we are creating bar charts or histogram charts, but we can do that for only 2 columns. If we want to create these data visualization charts, we need 2 columns to do so. So you could see that he has provided the response and created the bar chart here. And this is the interactive section. You could see that here's an option to switch to static chart. If we click on that, we can't, we are not getting any information if we scroll on that. And if I enable this option, you could see that I can visually see how many numbers this bar is indicating. And after that, we have the change color section. You can change the color of the data set provided. So we can change it to any color that is provided here, or you could just write the color code here. And similarly, we have other 2 options, that is download and another is the expand chart section. And if you need what code it has done to figure out this bar graph, so this is the code. You could use any ID to do so. If you don't want the presentations or the visualizations of the bar charts here, you could use your ID and use the Python language, and he will provide the code for you. Just take your data set and read it through pandas and generate the bar charts. So moving to next section, that is category wise sales section. So here we will generate a pie chart showing the proportion of sales for each product category. So for that, we'll write a prompt, generate a pie chart showing the proportion of sales for each product category. So you could see that it has started generating the pie chart, and this is also an interactive section. If you click on that, you would be seeing a static pie chart, and if you want to change the color, you can change for any section. That could be clothing, electronics, furniture or kitchen. And similarly, we have the download section and the expand chart section. So this is how this new ChatGPT 4 model is better than ChatGPT 4, that you could use a more interactive pie charts. You could change the colors for that, and you can just hover over these bar charts and found all the information according to them. So after this data visualization, now we'll move to statistical analysis. So this will help us uncover patterns and relationships in the data. So the first thing we'll do is correlation analysis, and for that we'll write the prompt, analyze the correlation between age and purchase amount. So this correlation analysis help us understand the relationship between 2 variables. So this can indicate if older customers tend to spend more or less. So we'll find out that by analyzing the data, and we'll provide a prompt to ChatGPT that analyze the correlation between age and purchase amount. So let's see what it provides. So here's the response by ChatGPT. You could see a scatter plot that shows the relationship between customer age and total sales. That is with a calculated correlation coefficient of approximately 0.16. So this indicates a weak positive correlation between age and purchase amount, suggesting that as customer age increases, there's a slight tendency for total sales to increase as well. So you could just see the scatter plot here, that if the age increases, so it is not correlated to sales, as you could see an empty graph here. So till 40 to 50 years of age or the 70 years of age, you could find what amount they have spent here. That is the total sales accumulated by these ages. So now moving to sales trend. So here we will perform a time series analysis of purchase amount over the given dates. So what does this do is, time series analysis allows us to examine how sales amount changes over time, helping us identify trends and seasonal patterns. So for that, we'll write a prompt. Perform a time series analysis of purchase amount over given dates. So you could see that ChatGPT has provided us the response, and here's the time series plot showing total sales over the given dates, and each point on the plot represents the total sales for a particular day. So through this you can find out, and the businesses find out, which is the seasonal part of the year and where to stock up their stocks for these kind of dates. And after that you could also do customer segmentation. So what does this do is, so we can use clustering here to segment customers based on age, income and purchase amount. So clustering groups customers into segments based on similarities. This is useful for targeted marketing and personalized services. And after that we have the advanced usage for data analysis. Here we can draw a predictive modeling table and do the market basket analysis and perform a customer lifetime value analysis. So we will see one of those, and what we'll do is we'll perform a market basket analysis and perform an association rule mining to find frequently bought together products. So the theory behind this is the association rule mining helps identify patterns of products that are often purchased together, aiding in inventory management and cross-selling strategies. So for that we'll write a prompt that, so perform an association rule mining to find frequently bought together products. So for that we'll write a prompt here. Perform an association rule mining to find frequently bought products together. So let's see for this prompt, what does ChatGPT 4 respond to us? So you could see that he is providing a code here, but we don't need a code here. We need the analysis. Don't provide code. Do the market basket analysis and provide visualizations. So you could see that ChatGPT has provided the response that given the limitations in this environment, so he is not able to do the market basket analysis here. So but he can help us how we can perform this in an IDE. So he's providing, you can install the required libraries, then prepare the data, and here he is providing the example code. So you could see there are some limitations to ChatGPT 4 also, that he can't do advanced data analysis. So you could use the code in your IDE and do the market basket analysis there. So there are some limitations to ChatGPT 4 also. And now we will ask ChatGPT, can you create a presentation based on the dataset? And we'll provide a dataset to it also. So we'll provide sample sales data. And we'll ask him, can you create a presentation or PowerPoint presentation based on this data set and only provide data visualization graphs. So you can see that ChatGPT 4 has started analyzing the data, and he is stating that, and he will start by creating a data visualization from the provided data set and compile them into a PowerPoint presentation. So you could see that ChatGPT 4 has provided us the response, and these are all the presentations or the bar graphs that he has created. And now we have downloaded the presentation here. We will open that. And here's the presentation that is created by ChatGPT 4.0.
Welcome to our video about transformers in AI. And no, we don't mean the robot toys from the movies. We are diving into something even cooler in the world of computers and AI. Have you ever wondered how your phone knows what word you might type next, or how Google Translate works so well? That's where transformers come in. They are like super smart computer brains that can understand and create human-like text. Here's a fun example. I asked a transformer to tell me a joke and it said, "Why did the computer go to the art school?" Because it wanted to improve its draw speed. Okay, that's a bit cheesy, but it shows how these computer programs can come up with new ideas on their own. Transformers are changing how we use technology every day. They help us with things like translating languages, summarizing long articles, writing emails and stories, and even playing games like chess. In this video, we will explore how transformers work, why they are so special, and what cool things they might do in the future. So let's talk about what exactly are transformers. Transformers are an artificial intelligence model used to process and generate natural languages. They can read and understand huge amount of text and then use that knowledge to answer questions, translate languages, summarize information, and even create stories or write code. The magic behind transformers is their ability to focus on different text paths with attention mechanisms. This means that they can understand context better than older models, making their outputs more accurate and natural sounding. The basic structure of a transformer includes two main parts, the encoder and the decoder. Think of the encoder as a translator that understands and processes the input, and the decoder as the one that takes the processed information and turns it into the output. For example, if we are translating a sentence from English to French, the encoder reads the English sentence and converts it into a form that AI can understand. The decoder then takes this form and generates the French sentence. A great example of a transformer in action is ChatGPT. ChatGPT uses transformers to understand and generate human-like text. When you ask a question, it processes your input with its encoder and generates a response with its decoder. This lets it have conversations, write essays, and even tell jokes. For instance, if you ask ChatGPT what's the weather like today, it uses its transformer model to understand your question and respond it with it's sunny with a chance of rain in the afternoon. This ability to understand and generate text makes transformers incredibly powerful. So let's talk about how transformers work. Transformers are especially good at sequence-to-sequence learning tasks, like translating a sentence from one language to another. Here's how they work. First, there's the attention mechanism. This allows the transformer to focus on different parts of input data. For example, if it's translating the sentence, "the cat sat on the mat," it can pay attention to each word's context to understand the meaning better. So it knows cat is related to sat and mat, helping it produce an accurate translation in another language. Transformers also use something called positional encoding. Since they process all words at once, they need a way to understand the order of the words. Positional encoding adds information about the position of each word to the input, helping the transformers understand the sequence. Another key feature is like parallel processing. Unlike older models like recurrent neural network, which is RNNs, the process text words by word. Transformers can process the entire sentence at once. This makes them much faster and more efficient. Let's compare transformers with recurrent neural networks. But first, let's understand what are RNNs. So RNNs is a type of neural network designed to handle sequential data. They process data one step at a time, maintaining a memory of previous steps. This makes them good for tasks where order matters, like speech recognition or time series prediction. However, RNNs have a problem called the vanishing gradient, which means that they can forget information from earlier in the sequence. Imagine trying to understand the sentence, "Alice went to the park and then to the store." And RNN might struggle to remember Alice by the time it gets to the store, but a transformer can easily keep track of Alice throughout the sentence. So why are transformers better? Unlike RNNs, transformers process the entire sentence at once, keeping the context intact. This solves the vanishing gradient problem and makes transformers faster and more accurate to tasks like language translation and text generation. So let's talk about the applications of transformers. At first, we have language translation. They are used by services like Google Translate to convert text from one language to another. For example, translating hello, how are you to Spanish as hola. Then we have document summarization. They can take long articles and summarize them into shorter, more concise versions. For instance, summarizing a 10-page report into a few key points, making it easier to understand the main ideas without reading the whole document. Then we have content generation. Transformers can write articles, stories, and even code. They can create new content based on what they have learned. For example, you could ask a transformer to write a short story about a space adventure, and then it would come up with a unique narrative. Then we have game playing. Transformers can learn and play complex games like chess, making strategic decisions just like a human player. They analyze the entire board and make moves considering all possible outcomes. Let's talk about image processing. They are used in tasks like image classification and object detection, helping computers understand visual data. For example, identifying objects in a photo, like recognizing a cat, tree, or a car. Now let's understand the training process. The training transformers involves two main steps. Semi-supervised learning. They can learn from both labeled data where the answer is known and unlabeled data where the answer is not provided. This makes them very versatile. For example, a transformer could be trained on a mix of articles with and without summaries to learn how to summarize text effectively. Pre-training and fine-tuning. Transformers are pre-trained on a large data set to learn general patterns. Then they are fine-tuned with specific tasks, making them highly versatile. For instance, a transformer might be pre-trained on a large collection of books to understand language and then fine-tuned to generate marketing copy for a specific brand. The future potential of transformers is huge. Researchers are continuously improving them, making them even more powerful. We can expect more advanced applications in areas like healthcare, finance, and more sophisticated AI systems that interact with humans in more natural ways. Imagine having an AI that can provide personalized medical advice or one that can help you write a novel. In conclusion, we can say that transformers are a revolutionary architecture in AI. They offer speed, efficiency, and versatility, changing how we interact with the technology. The future looks bright for transformers, and we can't wait to see what they'll do next.
We've looked at a lot of examples of machine learning, so let's see if we can give a little bit more of a concrete definition. What is machine learning? Machine learning is the science of making computers learn and act like humans by feeding data and information without being explicitly programmed. And we see here we have a nice little diagram where we have our ordinary system. Your computer, nowadays you can even run a lot of this stuff on a cell phone because cell phones have advanced so much. And then with artificial intelligence and machine learning, it now takes the data and it learns from what happened before. And then it predicts what's going to come next. And then really the biggest part right now in machine learning that's going on is it improves on that. How do we find a new solution? So we go from descriptive, where it's learning about stuff and understanding how it fits together, to predicting what it's going to do, to post-scripting, coming up with a new solution. And when we're working on machine learning, there's a number of different diagrams that people have posted for what steps to go through. A lot of it might be very domain specific. So if you're working on photo identification versus language versus medical or physics, some of these are switched around a little bit or new things are put in. They're very specific to the domain. This is kind of a very general diagram. First, you want to define your objective. Very important to know what it is you're wanting to predict. Then you're going to be collecting the data. So once you've defined an objective, you need to collect the data that matches. You spend a lot of time in data science collecting data, and the next step, preparing the data. You got to make sure that your data is clean going in. There's the old saying, bad data in, bad answer out, or bad data out. And then once you've gone through and we've cleaned all this stuff coming in, then you're going to select the algorithm. Which algorithm are you going to use? You're going to train that algorithm. In this case, I think we're going to be working with SVM, the support vector machine. Then you have to test the model. Does this model work? Is this a valid model for what we're doing? And then once you've tested it, you want to run your prediction. You want to run your prediction or your choice or whatever output it's going to come up with. And then once everything is set and you've done lots of testing, then you want to go ahead and deploy the model. And remember I said domain specific. This is very general as far as the scope of doing something. A lot of models, you get halfway through and you realize that your data is missing something, and you have to go collect new data because you've run a test in here someplace along the line. You're saying, hey, I'm not really getting the answers I need. So there's a lot of things that are domain specific that become part of this model. This is a very general model, but it's a very good model to start with. And we do have some basic divisions of what machine learning does that's important to know. For instance, do you want to predict a category? Well, if you're categorizing things, that's classification. For instance, whether the stock price will increase or decrease. So in other words, I'm looking for a yes-no answer. Is it going up or is it going down? And in that case, we'd actually say, is it going up? True. If it's not going up, it's false, meaning it's going down. This way, it's a yes-no, 0, 1. Do you want to predict a quantity? That's regression. So remember, we just did classification. Now we're looking at regression. These are the two major divisions in what data is doing. For instance, predicting the age of a person based on the height, weight, health, and other factors. So based on these different factors, you might guess how old a person is. And then there are a lot of domain-specific things, like do you want to detect an anomaly? That's anomaly detection. This is actually very popular right now. For instance, you want to detect money withdrawal anomalies. You want to know when someone's making a withdrawal that might not be their own account. We've actually brought this up because this is really big right now. If you're predicting the stock, whether to buy stock or not, you want to be able to know if what's going on in the stock market is an anomaly. Use a different prediction model because something else is going on. You got to pull out new information in there. Or is this just the norm? I'm going to get my normal return on my money invested. So being able to detect anomalies is very big in data science these days. Another question that comes up, which is on what we call untrained data, is do you want to discover structure in unexplored data? And that's called clustering. For instance, finding groups of customers with similar behavior given a large database of customer data containing their demographics and past buying records. And in this case, we might notice that anybody who's wearing a certain set of shoes goes shopping at certain stores, or whatever it is, they're going to make certain purchases. By having that information, it helps us to market or group people together so that we can now explore that group and find out what it is we want to market to them if you're in the marketing world. And that might also work in just about any arena. You might want to group people together, whether they're based on their different areas and investments and financial background, whether you're going to give them a loan or not. Before you even start looking at whether they're a valid customer for the bank, you might want to look at all these different areas and group them together based on unknown data. So you don't know what the data is going to tell you, but you want to cluster people together that come together. Let's take a quick detour for quiz time. Oh, my favorite. So we're going to have a couple questions here under quiz time, and we'll be posting the answers in the part 2 of this tutorial. So let's go ahead and take a look at these quiz times questions, and hopefully you'll get them all right, and it'll get you thinking about how to process data and what's going on. Can you tell what's happening in the following cases? Of course, you're sitting there with your cup of coffee and you have your checkbox and your pen trying to figure out what's your next step in your data science analysis. So the first one is grouping documents into different categories based on the topic and content of each document. Very big these days. You have legal documents, you have maybe it's a sports group documents, maybe you're analyzing newspaper postings, but certainly having that automated is a huge thing in today's world. B, identifying handwritten digits in images correctly. So we want to know whether they're writing an A or capital A, B, C. What are they writing out in their handwriting? C, behavior of a website indicating that the site is not working as designed. D, predicting salary of an individual based on his or her years of experience. Boy, HR hiring set up there. So stay tuned for part 2. We'll go ahead and answer these questions when we get to the part 2 of this tutorial. Or you can just simply write at the bottom and send a note to Simplilearn, and they'll follow up with you on it. Back to our regular content. And these last few bring us into the next topic, which is another way of dividing our types of machine learning, and that is with supervised, unsupervised, and reinforcement learning. Supervised learning is a method used to enable machines to classify, predict objects, problems, or situations based on labeled data fed to the machine. And in here you see we have a jumble of data with circles, triangles, and squares, and we label them. We have what's a circle, what's a triangle, what's a square, and we have our model training, and it trains it so we know the answer. Very important, when you're doing supervised learning, you already know the answer to a lot of your information coming in. So you have a huge group of data coming in, and then you have new data coming in. So we've trained our model. The model now knows the difference between a circle, a square, a triangle. And now that we've trained it, we can send in this case, a square and a circle goes in, and it predicts that the top one's a square and the next one's a circle. And you can see that this is being able to predict whether someone's going to default on a loan, because I was talking about banks earlier. Supervised learning on stock market, whether you're going to make money or not. That's always important. And if you are looking to make a fortune in the stock market, keep in mind it is very difficult to get all the data correct on the stock market. It is it fluctuates in ways really hard to predict. So it's quite a roller coaster ride. If you're running machine learning on the stock market, you start realizing you really have to dig for new data. So we have supervised learning, and if you have supervised, we should need unsupervised learning. In unsupervised learning, machine learning model finds the hidden pattern in an unlabeled data. So in this case, instead of telling it what the circle is, and what a triangle is, and what a square is, it goes in there and looks at them and says, for whatever reason, it groups them together. Maybe it'll group it by the number of corners. And it notices that a number of them all have 3 corners, a number of them all have 4 corners, and a number of them all have no corners. And it's able to filter those through and group them together. We talked about that earlier with looking at a group of people who are out shopping. We want to group them together to find out what they have in common. And of course, once you understand what people have in common, maybe you have one of them who's a customer at your store, or you have 5 of them are customer at your store, and they have a lot in common with 5 others who are not customers at your store. How do you market to those 5 who aren't customers at your store yet? They fit the demographics of who's going to shop there, and you'd like them to shop at your store, not the one next door. Of course, this is a simplified version. You can see very easily the difference between a triangle and a circle, which might not be so easy in marketing. Reinforcement learning. Reinforcement learning is an important type of machine learning where an agent learns how to behave in an environment by performing actions and seeing the result. And we have here where in this case, a baby. It's actually great that they used an infant for this slide, because the reinforcement learning is very much in its infant stages. But it's also probably the biggest machine learning demand out there right now, or in the future. It's going to be coming up over the next few years, is reinforcement learning and how to make that work for us. And you can see here where we have our action. In the action in this one, it goes into the fire. Hopefully the baby it was just a little candle, not a giant fire pit like it looks like here. When the baby comes out, and the new state is the baby is sad and crying because they got burned on the fire. And then maybe they take another action. The baby's called the agent because it's the one taking the actions. And in this case, they didn't go into the fire. They went a different direction, and now the baby's happy and laughing and playing. Reinforcement learning is very easy to understand because that's how, as humans, that's one of the ways we learn. We learn whether it is, you burn yourself on the stove, don't do that anymore. Don't touch the stove. In the big picture, being able to have a machine learning program or an AI be able to do this is huge because now it's starting to learn how to learn. That's a big jump in the world of computer and machine learning. And we're going to go back and just kind of go back over supervised versus unsupervised learning. Understanding this is huge because this is going to come up in any project you're working on. We have in supervised learning, we have labeled data, we have direct feedback. So someone's already gone in there and said, yes, that's a triangle. No, that's not a triangle. And then you predict an outcome. So you have a nice prediction. This new set of data is coming in and we know what it's going to be. And then with unsupervised training, it's not labeled. So we really don't know what it is. There's no feedback. So we're not telling it whether it's right or wrong. We're not telling it whether it's a triangle or a square. We're not telling it to go left or right. All we do is we're finding hidden structure in the data, grouping the data together to find out what connects to each other. And then you can use these together. So imagine you have an image and you're not sure what you're looking for. So you go in and you have the unstructured data, find all these things that are connected together. And then somebody looks at those and labels them. Now you can take that labeled data and program something to predict what's in the picture. So you can see how they go back and forth, and you can start connecting all these different tools together to make a bigger picture. There are many interesting machine learning algorithms. Let's have a look at a few of them. Hopefully this gives you a little flavor of what's out there. And these are some of the most important ones that are currently being used. We'll take a look at linear regression, decision tree, and the support vector machine. Let's start with a closer look at linear regression. Linear regression is perhaps one of the most well-known and well-understood algorithms in statistics and machine learning. Linear regression is a linear model. For example, a model that assumes a linear relationship between the input variables x and the single output variable y. And you'll see this if you remember from your algebra classes, y equals mx plus c. Imagine we are predicting distance traveled y from speed x. Our linear regression model representation for this problem would be y equals m times x plus c, or distance equals m times speed plus c, where m is the coefficient and c is the y-intercept. And we're going to look at two different variations of this. First, we're going to start with time is constant. And you can see we have a bicyclist. He's got his safety gear on, thank goodness. Speed equals 10 meters per second. And so over a certain amount of time, his distance equals 36 kilometers. We have a second bicyclist who's going twice the speed, or 20 meters per second. And you can guess if he's going twice the speed and time is a constant, then he's going to go twice the distance. And that's easily to compute. 36 times 2, you get 72 kilometers. And so if you had the question of how fast would somebody who's going 3 times that speed, or 30 meters per second is, you can easily compute the distance in our head. We can do that without needing a computer. But we want to do this for more complicated data. So it's kind of nice to compare the two, but let's just take a look at that and what that looks like in a graph. So in a linear regression model, we have our distance to the speed, and we have our m equals the VE slope of the line. And we'll notice that the line has a plus slope. And as the speed increases, distance also increases, hence the variables have a positive relationship. And so your speed of the person, which equals y equals mx plus c, distance traveled in a fixed interval of time, and we could very easily compute, either following the line or just knowing it's 3 times 10 meters per second, that this is roughly 102 kilometers distance that this third bicyclist has traveled. One of the key definitions on here is positive relationship. So the slope of the line is positive. As distance increase, so does speed increase. Let's take a look at our second example where we put distance is a constant. So we have speed equals 10 meters per second. They have a certain distance to go, and it takes them 100 seconds to travel that distance. And we have our second bicyclist who's still doing 20 meters per second. Since he's going twice the speed, we can guess that he'll cover the distance in about half the time, 50 seconds. And of course you could probably guess on the third one, 100 divided by 30, since he's going 3 times the speed, you could easily guess that this is 33.333 seconds time. When we put that into a linear regression model or a graph, if the distance is assumed to be constant, let's see the relationship between speed and time. And as time goes up, the amount of speed to go that same distance goes down. So now your m equals a minus VE slope of the line. As the speed increases, time decreases, hence the variable has a negative relationship. Again, there's our definition, positive relationship and negative relationship dependent on the slope of the line. And with a simple formula like this, and even a significant amount of data, let's see with the mathematical implementation of linear regression. And we'll take this data. So suppose we have this data set where we have x, y, x equals 1, 2, 3, 4, 5, standard series, and the y value is 3, 2, 2, 4, 3. When we take that and we go ahead and plot these points on a graph, you can see there's kind of a nice scattering, and you could probably eyeball a line through the middle of it. But we're going to calculate that exact line for linear regression. And the first thing we do is we come up here and we have the mean of xi. And remember, mean is basically the average. So we added 5 plus 4 plus 3 plus 2 plus 1 and divide by 5. And that simply comes out as 3. And then we'll do the same for y. We'll go ahead and add up all those numbers and divide by 5. And we end up with a mean value of y of I equals 2.8, where the xi references it's an average or means value, and the yi also equals a means value of y. And when we plot that, you'll see that we can put in the y equals 2.8 and the x equals 3 in there on our graph. We kind of gave it a little different color so you could sort it out with the dashed lines on it. And it's important to note that when we do the linear regression model should go through that dot. Now let's find our regression equation to find the best fit line. Remember, we go ahead and take our y equals mx plus c, so we're looking for m and c. So to find this equation for our data, we need to find our slope of m and our coefficient of c. And we have y equals mx plus c, where m equals the sum of x minus x average times y minus y average, or y means and x means, over the sum of x minus x means squared. That's how we get the slope of the value of the line. And we can easily do that by creating some columns here where we have x, y, computers are really good about iterating through data, and so we can easily compute this and fill in a graph of data. And in our graph, you can easily see that if we have our x value of 1, and if you remember the xi, or the means value, is 3, 1 minus 3 equals a negative 2, and 2 minus 3 equals a negative 1, so on and so forth. And we can easily fill in the column of x minus xi, y minus yi, and then from those we can compute x minus xi squared and x minus xi times y minus yi. And you can guess it that the next step is to go ahead and sum the different columns for the answers we need. So we get a total of 10 for our x minus xi squared, and a total of 2 for x minus xi times y minus yi. And we plug those in, we get 2/10, which equals 0.2. So now we know the slope of our line equals 0.2. So we can calculate the value of c. That'd be the next step, is we need to know where it crosses the y-axis. And if you remember, I mentioned earlier that the linear regression line has to pass through the means value, the one that we showed earlier. We can just flip back up there to that graph, and you can see right here there's our means value, which is 3, x equals 3 and y equals 2.8. And since we know that value, we can simply plug that into our formula, y equals 0.2x plus c. So we plug that in, we get 2.8 equals 0.2 times 3 plus c, and you can just solve for c. So now we know that our coefficient equals 2.2. And once we have all that, we can go ahead and plot our regression line. Y equals 0.2 times x plus 2.2. And then from this equation, we can compute new values. So let's predict the values of y using x equals 1, 2, 3, 4, 5 and plot the points. Remember, the 1, 2, 3, 4, 5 was our original x values. So now we're going to see what y thinks they are, not what they actually are. And when we plug those in, we get y of designated with y of p. You can see that x equals 1 equals 2.4, x equals 2 equals 2.6, and so on and so on. So we have our y predicted values of what we think it's going to be when we plug those numbers in. And when we plot the predicted values along with the actual values, we can see the difference. And this is one of the things that's very important with linear regression in any of these models, is to understand the error. And so we can calculate the error on all of our different values. And you can see over here we plotted x and y predict. And we draw in a little line so you can sort of see what the error looks like there between the different points. So our goal is to reduce this error. We want to minimize that error value on our linear regression model. Minimizing the distance. There are lots of ways to minimize the distance between the line and the data points, like sum of squared errors, sum of absolute errors, root mean square error, etc. We keep moving this line through the data points to make sure the best fit line has the least square distance between the data points and the regression line. So to recap with a very simple linear regression model, we first figure out the formula of our line through the middle, and then we slowly adjust the line to minimize the error. Keep in mind this is a very simple formula. The math gets, even though the math is very much the same, it gets much more complex as we add in different dimensions. So this is only 2 dimensions, y equals mx plus c, but you can take that out to x, z, ijq, all the different features in there, and they can plot a linear regression model on all of those using the different formulas to minimize the error. Let's go ahead and take a look at decision trees, a very different way to solve problems than the linear regression model. Decision tree is a tree-shaped algorithm used to determine a course of action. Each branch of a tree represents a possible decision, occurrence, or reaction. We have data which tells us if it is a good day to play golf. And if we were to open this data up in a general spreadsheet, you can see we have the outlook, whether it's rainy, overcast, sunny, temperature, hot, mild, cool, humidity, windy, and did I like to play golf that day, yes or no? So we're taking a census. And certainly I wouldn't want a computer telling me when I should go play golf or not. But you could imagine if you got up in the night before, you're trying to plan your day, and it comes up and says tomorrow would be a good day for golf for you in the morning, and not a good day in the afternoon, or something like that. This becomes very beneficial. And we see this in a lot of applications coming out now where it gives you suggestions and lets you know what would fit the match for you for the next day or the next purchase or the next whatever, next meal out. In this case, is tomorrow a good day for playing golf based on the weather coming in? And so we come up and let's determine if you should play golf when the day is sunny and windy. So we found out the forecast tomorrow is going to be sunny and windy. And suppose we draw our tree like this. We're going to have our humidity, And then we have our normal, which is if you have a normal humidity, you're going to go play golf. And if the humidity is really high, then we look at the outlook. And if the outlook is sunny, overcast, or rainy, it's going to change what you choose to do. So if you know that it's a very high humidity and it's sunny, you're probably not going to play golf because you're going to be out there miserable, fighting off the mosquitoes that are out joining you to play golf with you. Maybe if it's rainy, you probably don't want to play in the rain. But if it's slightly overcast and you get just the right shadow, that's a good day to play golf and be outside, out on the green. Now in this example, you can probably make your own tree pretty easily because it's a very simple set of data going in. But the question is, how do you know what to split? Where do you split your data? What if this is much more complicated data where it's not something that you would particularly understand? Like studying cancer, they take about 36 measurements of the cancerous cells, and then each one of those measurements represents how bulbous it is, how extended it is, how sharp the edges are. Something that as a human we would have no understanding of. So how do we decide how to split that data up? And is that the right decision tree? So that's a question that's going to come up. Is this the right decision tree? For that, we should calculate entropy and information gain. Two important vocabulary words there are the entropy and the information gain. Entropy. Entropy is a measure of randomness or impurity in the data set. Entropy should be low. So we want the chaos to be as low as possible. We don't want to look at it and be confused by the images or what's going on there with mixed data. And the information gain. It is a measure of decrease in entropy after the data set is split, also known as entropy reduction. Information gain should be high, so we want our information that we get out of the split to be as high as possible. Let's take a look at entropy from the mathematical side. In this case, we're going to denote entropy as I of P of n, where P is the probability that you're going to play a game of golf, and n is the probability where you're not going to play the game of golf. Now, you don't really have to memorize these formulas. There's a few of them out there depending on what you're working with. But it's important to note that this is where this formula is coming from, so when you see it, you're not lost when you're running your programming, unless you're building your own decision tree code in the back. And we simply have a log squared of p over p plus n minus n over p plus n times the log squared of n of p plus n. But let's break that down and see what it actually looks like when we're computing that from the computer script side. Entropy of a target class of the data set is the whole entropy. So we have entropy play golf. And when we look at this, if we go back to the data, you can simply count how many yeses and no in our complete data set for playing golf days. In our complete set, we find we have 5 days we did play golf and 9 days we did not play golf. And so our I equals, if you add those together, 9 plus 5 is 14. And so our I equals 5 over 14 and 9 over 14. That's our P and N values that we plug into that formula. And you can go 5 over 14 equals 0.36, 9 over 14 equals 0.64. And when you do the whole equation, you get the minus 0.36 log root squared of 0.36 minus 0.64 log squared root of 0.64. And we get a set value. We get 0.94. So we now have a full entropy value for the whole set of data that we're working with. And we want to make that entropy go down. And just like we calculated the entropy out for the whole set, we can also calculate entropy for playing golf and the outlook. Is it going to be overcast or rainy or sunny? And so when we look at the entropy, we have P of sunny times E of 3 of 2. And that just comes out how many sunny days yes and how many sunny days no over the total, which is 5. Don't forget to put we'll divide that 5 out later on. Equals P overcast equals 4 comma 0 plus rainy equals 2 comma 3. And then when you do the whole setup, we have 5 over 14. Remember I said there was a total of 5? 5 over 14 times the I of 3 of 2 plus 4 over 14 times the 4 comma 0 and 514 over I of 2, 3. And so we can now compute the entropy of just the part that has to do with the forecast. And we get 0.693. Similarly, we can calculate the entropy of other predictors like temperature, humidity, and wind. And so we look at the gain outlook. How much are we going to gain from this? Entropy play golf minus entropy play golf outlook. And we can take the original 0.94 for the whole set minus the entropy of just the rainy day and temperature, and we end up with a gain of 0.247. So this is our information gain. Remember, we define entropy and we define information gain. The higher the information gain, the lower the entropy, the better. The information gain of the other three attributes can be calculated in the same way. So we have our gain for temperature equals 0.029. We have our gain for humidity equals 0.152, and our gain for a windy day equals 0.048. And if you do a quick comparison, you'll see the 0.247 is the greatest gain of information, so that's the split we want. Now let's build the decision tree. So we have the outlook. Is it going to be sunny, overcast, or rainy? That's our first split because that gives us the most information gain. And we can continue to go down the tree using the different information gains with the largest information. We can continue down the nodes of the tree where we choose the attribute with the largest information gain as the root node, and then continue to split each subnode with the largest information gain that we can compute. And although it's a little bit of a tongue twister to say all that, you can see that it's a very easy to view visual model. We have our outlook, we split it 3 different directions. If the outlook is overcast, we're going to play. And then we can split those further down if we want. So if the outlook is sunny, but then it's also windy, if it's windy, we're not going to play. If it's not windy, we'll play. So we can easily build a nice decision tree to guess what we would like to do tomorrow and give us a nice recommendation for the day. So we want to know if it's a good day to play golf when it's sunny and windy. Remember the original question that came out? Tomorrow's weather report is sunny and windy. You can see by going down the tree, we go outlook sunny, outlook windy. We're not going to play golf tomorrow. So our little smartwatch pops up and says, I'm sorry, tomorrow's not a good day for golf. It's going to be sunny and windy. And if you're a huge golf fan, you might go, uh-oh, it's not a good day to play golf. We can go in and watch a golf game at home. So we'll sit in front of the TV instead of being out playing golf in the wind. Now that we've looked at our decision tree, let's look at the third one of our algorithms we're investigating. Support vector machine. Support vector machine is a widely used classification algorithm. The idea of support vector machine is simple. The algorithm creates a separation line which divides the classes in the best possible manner. For example, dog or cat, disease or no disease. Suppose we have a labeled sample data which tells height and weight of males and females. A new data point arrives and we want to know whether it's going to be a male or a female. So we start by drawing a line. We draw decision lines, but if we consider decision line 1, then we will classify the individual as a male. And if we consider decision line 2, then it will be a female. So you can see this person kind of lies in the middle of the two groups, so it's a little confusing trying to figure out which line they should be under. We need to know which line divides the classes correctly, but how? The goal is to choose a hyperplane, and that is one of the key words they use when we talk about support vector machines. Choose a hyperplane with the greatest possible margin between the decision line and the nearest point within the training set. So you can see here we have our support vector, we have the two nearest points to it, and we draw a line between those 2 points. And the distance margin is the distance between the hyperplane and the nearest data point from either set. So we actually have a value, and it should be equally distant between the 2 points that we're comparing it to. When we draw the hyperplanes, we observe that line 1 has a maximum distance. So we observe that line 1 has a maximum distance margin, so we'll classify the new data point correctly. And our result on this one is going to be that the new data point is male. One of the reasons we call it a hyperplane versus a line is that a lot of times we're not looking at just weight and height. We might be looking at 36 different features or dimensions. And so when we cut it with a hyperplane, it's more of a 3-dimensional cut in the data, or multi-dimensional. It cuts the data a certain way. And each plane continues to cut it down until we get the best fit or match. Let's understand this with the help of an example. Problem statement. I always start with a problem statement when you're going to put some code together. We're going to do some coding now. Classifying muffin and cupcake recipes using support vector machines. So the cupcake versus the muffin. Let's have a look at our data set. And we have the different recipes here. We have a muffin recipe that has so much flour. I'm not sure what measurement 55 is in, but it has 55, maybe it's ounces? But it has a certain amount of flour, a certain amount of milk, sugar, butter, egg, baking powder, vanilla, and salt. And so based on these measurements, we want to guess whether we're making a muffin or a cupcake. And you can see in this one, we don't have just 2 features. We don't just have height and weight as we did before between the male and female. In here, we have a number of features. In fact, in this, we're looking at 8 different features to guess whether it's a muffin or a cupcake. What's the difference between a muffin and a cupcake? Turns out muffins have more flour, while cupcakes have more butter and sugar. So basically the cupcake's a little bit more of a dessert, where the muffin's a little bit more of a fancy bread. But how do we do that in Python? How do we code that to go through recipes and figure out what the recipe is? And I really just want to say cupcakes versus muffins, like some big professional wrestling thing. Before we start in our cupcakes versus muffins, we are going to be working in Python. There's many versions of Python, many different editors. That is one of the strengths and weaknesses of Python, is it just has so much stuff attached to it, and it's one of the more popular data science programming packages you can use. In this case, we're going to go ahead and use Anaconda and Jupyter Notebook. The Anaconda Navigator has all kinds of fun tools. Once you're into the Anaconda Navigator, you can change environments. I actually have a number of environments on here. We'll be using Python 3.6 environment. So this is in Python version 3.6. Although it doesn't matter too much which version you use. I usually try to stay with the 3x because they're current, unless you have a project that's very specifically in version 2x. 2.7 I think is usually what most people use in the version 2. And then once we're in our Jupyter Notebook editor, I can go up and create a new file. And we'll just jump in here. In this case, we're doing SVM muffin versus cupcake. And then let's start with our packages for data analysis. And we almost always use there's a few very standard packages we use. We use import numpy. That's for number Python. They usually denote it as NP. That's very common. And then we're going to import pandas as PD. And numpy deals with number arrays. There's a lot of cool things you can do with the numpy setup as far as multiplying all the values in an array, in a numpy array, data array. Pandas, I can't remember if we're using it actually in this data set. I think we do as an import. It makes a nice data frame. And the difference between a data frame and a numpy array is that a data frame is more like your Excel spreadsheet. You have columns, you have indexes, so you have different ways of referencing it, easily viewing it, and there's additional features you can run on a data frame. And Pandas kind of sits on numpy, so you need them both in there. And then finally, we're working with the support vector machine. So from sklearn, we're going to use the sklearn model, import SVM, support vector machine. And then as a data scientist, you should always try to visualize your data. Some data obviously is too complicated or doesn't make any sense to the human. But if it's possible, it's good to take a second look at it so that you can actually see what you're doing. Now for that, we're going to use two packages. We're going to import matplotlibary.pyplot as PLT, again very common. And we're going to import Seaborn as SNS. And we'll go ahead and set the font scale in the SNS right in our import line. That's what this semicolon followed by a line of data. We're going to set the SNS. And these are great because the Seaborn sits on top of matplotlibary, just like Pandas sits on numpy. So it adds a lot more features and uses and control. We're obviously not going to get into matplotlibary and Seaborn. That'd be its own tutorial. We're really just focusing on the SVM, the support vector machine from sklearn. And since we're in Jupyter Notebook, we have to add a special line in here for our matplotlibary. And that's your percentage sign or ampersand matplotlibary in line. Now, if you're doing this in just a straight code project, a lot of times I use like Notepad++, and I'll run it from there. You don't have to have that line in there because it'll just pop up as its own window on your computer, depending on how your computer's set up. Because we're running this in the Jupyter Notebook as a browser setup, this tells it to display all of our graphics right below on the page. So that's what that line is for. I remember the first time I ran this, I didn't know that, and I had to go look that up years ago. It was quite a headache. So matplotlibary inline is just because we're running this on the web setup. And we can go ahead and run this, make sure all our modules are in. They're all imported, which is great. If you don't have them import, you'll need to go ahead and pip, use the PIP or however you do it. There's a lot of other install packages out there, although pip is the most common. And you have to make sure these are all installed on your Python setup. The next step, of course, is we got to look at the data. You can't run a model for predicting data if you don't have actual data. So to do that, let me go ahead and open this up and take a look. And we have our cupcakes versus muffins. And it's a CSV file, or .csv, meaning that it's comma-separated variable. And it's going to open it up in a nice spreadsheet for me. And you can see up here we have the type. We have muffin, 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 cupcake, cupcake, cupcake. And then it's broken up into flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. So what we can do is we can go ahead and look at this data also in our Python. Let us create a variable recipes equals, we're going to use our pandas module, dot read CSV. Remember, it's a comma-separated variable. And the file name happened to be cupcakes versus muffins. Oops, I got double brackets there. Do it this way. There we go. Cupcakes versus muffins. Because the program I loaded, or the place I saved this particular Python program, is in the same folder, we can get by with just the file name. But remember, if you're storing it in a different location, you have to also put down the full path on there. And then because we're in pandas, we're going to go ahead and you can actually, inline you can do this, but let me do the full print. You can just type in recipes.head in the Jupyter Notebook. But if you're running in code in a different script, you need to go ahead and type out the whole print recipes.head. And pandas knows that that's going to do the first 5 lines of data. And if we flip back on over to the spreadsheet where we opened up our CSV file, you can see where it starts on line 2. This one calls it 0, and then 2, 3, 4, 5, 6 is going to match. Go and close that out because we don't need that anymore. And it always starts at 0. And it automatically indexes it since we didn't tell it to use an index in here. So that's the index number for the left-hand side. And it automatically took the top row as labels. So pandas using it to read a CSV is just really slick and fast. One of the reasons we love our pandas. Not just because they're cute and cuddly teddy bears. And let's go ahead and plot our data. And I'm not going to plot all of it. I'm just going to plot the sugar and flour. Now, obviously, you can see where they get really complicated if we have tons of different features. And so you'll break them up and maybe look at just 2 of them at a time to see how they connect. And to plot them, we're going to go ahead and use Seaborn. So that's our SNS. And the command for that is sns.lmplot. And then the 2 different variables I'm going to plot is flour and sugar. Data equals recipes. The hue equals type. And this is a lot of fun because it knows that this is pandas coming in. So this is one of the powerful things about pandas mixed with Seaborn and doing graphing. And then we're going to use a palette set 1. There's a lot of different sets in there. You can go look them up for Seaborn. We'll do a fit regular equals false, so we're not really trying to fit anything. And it's a scatter, KWS. A lot of these settings you can look up in Seaborn. Half of these you could probably leave off when you run them. Somebody played with this and found out that these were the best settings for doing a Seaborn plot. And let's go ahead and run that. And because it does it inline, it just puts it right on the page. And you can see right here that just based on sugar and flour alone, there's a definite split. And we use these models because you can actually look at it and say, hey, if I drew a line right between the middle of the blue dots and the red dots, we'd be able to do an SVM and a hyperplane right there in the middle. Then the next step is to format or pre-process our data. And we're going to break that up into 2 parts. We need a type label, and remember, we're going to decide whether it's a muffin or a cupcake. Well, a computer doesn't know muffin or cupcake, it knows 0 and 1. So, what we're going to do is we're going to create a type label, and from this we'll create a numpy array, np, where, and this is where we can do some logic. We take our recipes from our panda, and wherever type equals muffin, it's going to be 0. And then if it doesn't equal muffin, which is cupcakes, it's going to be 1. So we create our type label. This is the answer. So when we're doing our training model, remember we have to have a training data. This is what we're going to train it with, is that it's 0 or 1. It's a muffin or it's not. And then we're going to create our recipe features. And if you remember correctly from right up here, the first column is type. So we really don't need the type column because that's our muffin or cupcake. And in pandas, we can easily sort that out. We take our value recipes dot columns. That's a pandas function built into pandas. Dot values, converting them to values. So it's just the column titles going across the top. And we don't want the first one. So what we do is, since it always starts at 0, we want 1 colon till the end. And then we want to go ahead and make this a list. And this converts it to a list of strings. And then we can go ahead and just take a look and see what we're looking at for the features. Make sure it looks right. Let me go ahead and run that. And I forgot the S on recipes, so we'll go ahead and add the S in there and then run that. And we can see we have flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. And that matches what we have up here, right where we printed out. Everything but the type. So we have our features and we have our label. Now, the recipe features is just the titles of the columns, and we actually need the ingredients. And at this point, we have a couple options. One, we could run it over all the ingredients. And when you're doing this, usually you do. But for our example, we want to limit it so you can easily see what's going on. Because if we did all the ingredients, we have, that's what, 7, 8 different hyperplanes that would be built into it. We only want to look at one so you can see what the SVM is doing. And so we'll take our recipes and we'll do just flour and sugar. Again, you can replace that with your recipe features and do all of them, but we're going to do just flour and sugar, and we're going to convert that to values. We don't need to make a list out of it because it's not string values. These are actual values on there. And we can go ahead and just print ingredients, and you can see what that looks like. And so we have just the amount of flour and sugar, just the 2 sets of plots. And just for fun, let's go ahead and take this over here and take our recipe features. And so if we decided to use all the recipe features, you'll see that it makes a nice column of different data. So it just strips out all the labels and everything. We just have just the values. But because we want to be able to view this easily in a plot later on, we'll go ahead and take that and just do flour and sugar. And we'll run that and you'll see it's just the 2 columns. So the next step is to go ahead and fit our model. We'll go ahead and just call it model. And it's a SVM. We're using a package called SVC. In this case, we're going to go ahead and set the kernel equals linear. So it's using a specific setup on there. And if we go to the reference on their website for the SVM, you'll see that there's 8 of them here. 3 of them are for regression. 3 are for classification. The SVC, support vector classification, is probably one of the most commonly used. And then there's also one for detecting outliers, and another one that has to do with something a little bit more specific on the model. But SVC and SVR are the 2 most commonly used, standing for support vector classifier and support vector regression. Remember, regression is an actual value, a float value or whatever you're trying to work on. And SVC is a classifier, so it's a yes, no, true, false. But for this, we want to know 0, 1, muffin, cupcake. We go ahead and create our model. And once we have our model created, we're going to do model.fit. And this is very common, especially in the sklearn. All their models are followed with the fit command. And what we put into the fit, what we're training with it, is we're putting in the ingredients, which in this case we limited to just flour and sugar. And the type label, is it a muffin or a cupcake? Now, in more complicated data science series, you'd want to split into, we won't get into that today, we split it into training data and test data, and they even do something where they split it into thirds, where a third is used for where you switch between which one's training and test. There's all kinds of things that go into that, and it gets very complicated when you get to the higher end. Not overly complicated, just an extra step which we're not going to do today because this is a very simple set of data. And let's go ahead and run this, and now we have our model fit. And I got an error here, so let me fix that real quick. It's capital SVC, it turns out. I did it lowercase. Support vector classifier. There we go. Let's go ahead and run that. And you'll see it comes up with all this information that it prints out automatically. These are the defaults of the model. You notice that we changed the kernel to linear. And there's our kernel linear on the printout. And there's other different settings you can mess with. We're going to just leave that alone for right now. For this, we don't really need to mess with any of those. So next, we're going to dig a little bit into our newly trained model. And we're going to do this so we can show you on a graph. And let's go ahead and get the separating. And we're going to say we're going to use a W for our variable on here. And we're going to do model.coefficient_0. So what the heck is that? Again, we're digging into the model. So we've already got a prediction and a train. This is the math behind it that we're looking at right now. And so the W is going to represent two different coefficients. And if you remember, we had y equals mx plus c. So these coefficients are connected to that, but in two-dimensional. It's a plane. We don't want to spend too much time on this because you can get lost in the confusion of the math. So if you're a math whiz, this is great. You can go through here and you'll see that we have a equals minus w of 0 over w of 1. Remember, there's two different values there. And that's basically the slope that we're generating. And then we're going to build an XX. What is XX? We're going to set it up to a numpy array. There's our np dot line space. So we're creating a line of values between 30 and 60. So it just creates a set of numbers for x. And then if you remember correctly, we have our formula, y equals the slope times x plus the intercept. Well, to make this work, we can do this as yy equals the slope times each value in that array. That's the neat thing about numpy. So when I do a times xx, which is a whole numpy array of values, it multiplies a across all of them. And then it takes those same values and we subtract the model intercept. That's your, remember we had mx plus c, so that'd be the c from the formula, y equals mx plus c. And that's where all these numbers come from. A little bit confusing because it's digging out of these different arrays. And then what we want to do is we're going to take this and we're going to go ahead and plot it. So plot the parallels to separating hyperplane that pass through the support vectors. And so we're going to create B equals a model support vectors, pulling our support vectors out there. Here's our YY, which we now know is a set of data. And we have we're going to create YY down equals A times XX plus B1 minus A times B0. And then model support vector B is going to be set that to a new value, the -1 setup. And YY up equals A times XX plus B1 minus A times B0. And we can go ahead and just run this to load these variables up. If you want to understand a little bit more of what's going on, you can see if we print YY, we just run that, you can see it's an array. This is a line. It's going to have, in this case, between 30 and 60, so it's going to be 30 variables in here. And the same thing with YY up, YY down. And we'll plot those in just a minute on a graph so you can see what those look like. You just go ahead and delete that out of here and run that so it loads up the variables. Nice clean slate. I'm just going to copy this from before. Remember this, our SNS, our seaborn plot, LM plot, flour, sugar. And I'll just go ahead and run that real quick so you can see remember what that looks like. It's just a straight graph on there. And then one of the neat things is because seaborn sits on top of pyplot, we can do the pyplot for the line going through. And that is simply plt.plot. And that's our XX. and YY are two corresponding values, XY. And then somebody played with this to figure out that the line width equals 2 and the color black would look nice. So let's go ahead and run this whole thing with the pie plot on there. And you can see when we do this, it's just doing flour and sugar on here. Corresponding line between the sugar and the flour and the muffin versus cupcake. And then we generated the support vectors, the YY down and YY up. So let's take a look and see what that looks like. So we'll do our PL plot. And again, this is all against XX, our X value. But this time we have YY down. And let's do something a little fun with this. We can put in a K dash dash. That just tells it to make it a dotted line. And if we're going to do the down one, we also want to do the up one. So here's our YY up. And when we run that, it adds both sets of line. And so here's our support, and this is what you expect. You expect these two lines to go through the nearest data point. So the dashed lines go through the nearest muffin and the nearest cupcake when it's plotting it. And then your SVM goes right down the middle. So it gives it a nice split in our data. And you can see how easy it is to see, based just on sugar and flour, which one's a muffin or a cupcake. Let's go ahead and create a function to predict muffin or cupcake. I've got my recipes I pulled off the internet, and I want to see the difference between a muffin or a cupcake. And so we need a function to push that through, and we'll create a function with def, and let's call it muffin or cupcake. And remember, we're just doing flour and sugar today. We're not doing all the ingredients. And that actually is a pretty good split. You really don't need all the ingredients to know it's flour and sugar. And let's go ahead and do an if-else statement. So if model predict is of flour and sugar equals 0, so we take our model and we run a predict. It's very common in sklearn where you have a dot predict. You put the data in, and it's going to return a value. In this case, if it equals 0, then print you're looking at a muffin recipe. Else, if it's not 0, that means it's 1, then you're looking at a cupcake recipe. That's pretty straightforward for a function, or def for definition. DEF is how you do that in Python. And of course, if you're going to create a function, you should run something in it. And so let's run a cupcake, and we're going to send it values 50 and 20, a muffin or a cupcake. I don't know what it is. And let's run this and just see what it gives us. And it says, oh, it's a muffin. You're looking at a muffin recipe. So it very easily predicts whether we're looking at a muffin or a cupcake recipe. Let's plot this. Oops, there we go. Plot this on the graph so we can see what that actually looks like. And I'm just going to copy it and paste it from below, where we're plotting all the points in there. So this is nothing different than what we did before. If I run it, you'll see it has all the points and the lines on there. And what we want to do is we want to add another point. And we'll do PLT plot. And if you remember correctly, we did, for our test, we did 50 and 20. And then somebody went in here and decided we'll do YO for yellow, or it's kind of an orangish yellow color is going to come out. Marker size 9. Those are settings you can play with. Somebody else played with them to come up with the right setup so it looks good. And you can see there it is graphed, clearly a muffin. In this case, in cupcakes versus muffins, the muffin has won. And if you'd like to do your own muffin cupcake contender series, you certainly can send a note down below, and the team at Simplilearn will send you over the data they use for the muffin and cupcake. And that's true of any of the data. We didn't actually run a plot on it earlier. We had men versus women. You can also request that information to run it on your data setup so you can test that out. So to go back over our setup, we went ahead for our support vector machine code. We did a predict 40 parts flour, 20 parts sugar. I think it was different than the one we did, whether it's a muffin or a cupcake. Hence, we have built a classifier using SVM, which is able to classify if a recipe is of a cupcake or a muffin.
Think about this. You're about to create something amazing. An AI that can think, learn, and grow in ways we only dreamed of. And here's the best part. You don't need to be an AI expert to make it happen. What if you could use LangChain, a tool that connects most advanced language models to real-time data, allowing you to build AI applications that are both smart and flexible? It sounds like something out of science fiction, but with LangChain, it's real. As large language models quickly become the backbone of many applications, LangChain has emerged as a game-changing tool, transforming the way we use these powerful technologies. Today, we are diving into LangChain, the ultimate framework that makes AI development easier for everyone. Whether you want to understand user questions with one LLM, create human-like responses with another, or pull in data insights, LangChain makes it all happen. But LangChain is more than just making AI easy to use. It's about getting these models to work together seamlessly. LangChain simplifies what could be a complex process into a simple, powerful system. From smart chatbots to enhancing data for machine learning, the possibilities with LangChain are endless. So why has LangChain become one of the fastest growing open source projects ever? And how you can use LangChain to get ahead in the world of AI. So let's first start by understanding what is LangChain. LangChain is an open source framework designed to help developers build AI-powered applications using large language models or LLMs, just like GPT-4. But what really sets LangChain apart is its ability to link these powerful models with external data sources and other components. So this allows you to create sophisticated natural language processing NLP applications that can do much more than just understand and generate text. They can interact with live data, databases, and other software tools. Now you might be asking, is LangChain a Python library? Yes, it is. LangChain is available as a Python library, which means you can easily integrate into your existing Python projects. But it doesn't stop there. LangChain is also available in JavaScript and TypeScript, making it accessible to a wide range of developers. Whether you're working on a web app or backend system or a standalone tool, LangChain fits right in. So why should we use LangChain? So why is LangChain such a big deal? Developing AI applications typically requires using multiple tools and writing a lot of complex code. You need to manage data retrieval, processing, integration with language models, and many more. This can be time-consuming and complicated, especially if you're not deeply familiar with AI. LangChain simplifies the entire process, allowing you to develop and deploy and even manage AI applications more easily and efficiently. Let's break down this with an example. Imagine you're building a chatbot that needs to provide real-time weather updates. Without LangChain, you would need to manually connect your AI to a weather API, fetch data, process it, and then format the response. But with LangChain, the process becomes much more straightforward. You can focus on what matters the most, building the features and functionalities of your application, while LangChain handles the complex integrations behind the scenes. So let's discuss the key features of LangChain. LangChain is packed with features that make it incredibly powerful and flexible. Let's take a closer look at some of the key components. At first, we have model interaction. LangChain allows you to interact with any language model seamlessly. It manages the inputs and outputs to these data models, ensuring that you can integrate them into your application without a hitch. For example, if you want to use GPT-4 to generate responses to customer inquiries, LangChain makes it easy to plug that model into your workflow. Next, we have data connection and retrieval. One of the LangChain's strengths is its ability to connect to external data sources. So whether you need to pull data from a database or web API or even a file system, LangChain simplifies this process. You can retrieve, transform, and use data from almost any source, making your AI applications more robust and versatile. Next, we have chains. LangChain introduces the concept of chains, where you can link multiple models and components together to perform complex tasks. For example, you might have a chain where one component retrieves data and another processes it, and a third generates a human-like response. This chaining ability allows you to build workflows that would otherwise require extensive coding. Next, we have agents. Agents are like the decision makers in LangChain. They can create commands deciding the best course of action based on the input they receive. For example, an agent cloud determines which language model to use based on the type of query it's handling, making your application smarter and more adaptive. Then we have memory. LangChain supports both short-term and long-term memory. making that your AI can remember past interactions. This is particularly useful for applications like chatbots, where maintaining context over multiple interactions has significantly improved the user experience. Imagine you're building a virtual assistant. The assistant needs to remember previous interactions to provide relevant responses. Now, with the help of LangChain, you can easily implement memory so that the assistant knows what you have talked before, making the conversation more natural and engaging. So, what are the integrations supported by LangChain? Well, LangChain is designed to work seamlessly with a wide variety of integrations, making it extremely versatile for different use cases. LLM providers. LangChain supports integration with major LLM providers like OpenAI, Hugging Face, and Cohort. This means you can easily incorporate the latest and most powerful language models into your applications. Then we have data sources. LangChain can connect to a variety of data sources such as Google Search, Wikipedia, and cloud platforms like AWS, Google Cloud, and Azure. This makes it easy to retrieve and use the most up-to-date information in your applications. Vector databases are used for handling large volumes of complex data such as images or long text. So LangChain integrates with vector databases like Pinecone, and these databases store data as high-dimensional vectors, which helps in allowing for efficient and accurate retrieval. So this is particularly useful for applications that require searching through large data sets quickly. For example, let's say you're building an application that needs to analyze thousands of documents to find relevant information. With LangChain, you can integrate a vector database like Pinecone, store your documents as vectors, and quickly search through using them powerful language models. This capability can save you a lot of time and make your application much more effective. Now the question arises, how to create prompts in LangChain. Creating prompts in LangChain is much easier with something called a prompt template. A prompt template acts as a set of instructions for language model, and these templates can be customized to varying levels of customizations. For example, you might design a prompt template to ask simple questions, or you could create more detailed instructions that guide the language model to produce high-quality responses. Let's walk through how you can create a prompt using LangChain in Python. Step 1 is installing LangChain. First, you'll need to have Python installed in your system. Once that's set up, you can install LangChain by opening your Python shell or terminal and running the following command: pip install LangChain. The next step is adding integrations to LangChain. This often requires at least one integration to function properly. A common choice is OpenAI's Language Model API. To use OpenAI's API, you'll need to create an account on the OpenAI website and obtain your API key. After that, install OpenAI's Python package and input your API key like this. So this is the following command which is inserted below. You can look into that. Next step is importing and using a prompt template. Now that you have LangChain and the necessary integration set up, you can start creating your prompts. LangChain offers a pre-made prompt template that allows you to structure your text in a way that the language model can easily understand. Here's how you can do it through this particular prompt given below. So in this example, the prompt template asks two variables, which is an adjective and a content subject, and uses them to generate a prompt. The output might be something like, "Tell me an interesting fact about zebras." The language model would then take this prompt and return a relevant fact about zebras based on the given adjective. This is a simple but powerful way to generate dynamic prompt that can be adapted to a wide range of tasks, from answering questions to generating creative content. Let's now talk about how to develop applications with LangChain. So building applications with LangChain is straightforward and involves a few key steps. First, define your application, know exactly what problem it's solving, and identify the necessary components like language models, data sources, and user interaction. The next step is to build the functionality using LangChain's components such as prompt, chains, and agents. This is where you can create the logic that drives your application, like processing user input or retrieving data. Then we have customizing your application to meet specific needs. LangChain's flexibility allows you to tweak prompts, integrate additional data sources, and fine-tune models for optimal performance. Before going live, it's crucial to test and deploy your application. Testing helps catch any issues, and LangChain makes debugging easy, so you can deploy your application with confidence. For example, let's build a chatbot using LangChain. First, we have to define it is a chatbot that answers questions about technology trends. We then create a functionality by setting a prompt and a chain to process input. Next, we have customization. We customize it by integrating a new API to pull in the latest information. And finally, we test and deploy the chatbot to ensure it responds accurately to users. So LangChain offers endless possibilities across various industries. Let's now look into the examples and use cases of LangChain. LangChain offers endless possibilities across various industries. You can create customer service chatbots that manage queries and transaction or coding assistants that suggest code snippets and debug issues. In healthcare, LangChain can assist doctors with diagnosis and patient data management. Then we have marketing and e-commerce. It can analyze consumer behavior, generate product recommendations, and craft compelling product descriptions. So with the help of this AI assistant, it helps doctors make quicker, more informed decisions. So LangChain is a powerful framework that makes AI development accessible and efficient.
It was November 30, 2022. Sam Altman, Greg Brockman, and Ilya Sutskever would never have thought that with the push of a button, they would completely alter the lives of all human beings living on the earth and of future generations to come. On November 30, the OpenAI team launched ChatGPT. ChatGPT was born that day. Albeit a very small event in the history of internet evolution, but one that can no less be marked as one of the most significant events of modern IT industry. ChatGPT, a text-based chatbot that gives replies to questions asked to it, is built on GPT large language model. But what was so different? I mean, the Google search engine, YouTube, Firefox browser, they all have been doing the same for decades. So how is ChatGPT any different and why is it such a big deal? Well, for starters, ChatGPT was not returning index to websites that have been SEO tuned and optimized to rank at the top. ChatGPT was able to comprehend the nature, tone, and the intent of the query asked and generated text-based responses based on the questions asked. It was like talking to a chatbot on the internet minus the out-of-context responses with the knowledge of 1.7 trillion parameters. It was no shock that a computing system as efficient and prompt as ChatGPT would have its own setbacks. So did ChatGPT. It was bound by the parameters of the language model it was trained on, and it was limited to giving outdated results since the last training data was from September. Still, ChatGPT made waves in the tech community and continues to do so. Just have a look at the Google Trends search on ChatGPT. Every day, new content is being published on ChatGPT and hundreds of AI tools. The sheer interest that individuals and enterprises across the globe has shown in ChatGPT and AI tools is immense.
AI, generative AI, generative AI, generative AI, AI.
Now here comes the fun part. ChatGPT, or for that matter any large language model, runs on neural networks trained on multi-million, billion and even trillions of data parameters. These chatbots generate responses to user queries based on the input given to it. While it may generate similar responses for identical or similar queries, it can also produce different responses based on the specific context, phrasing, and the quality of input provided by each user. Additionally, ChatGPT is designed to adapt its language and tone to match the style and preferences of each user. So its responses may vary in wording and tone depending on the individual user's communication style and preferences. Every user has their own unique style of writing and communication, and ChatGPT's response can vary based on the input given to it. So this is where prompt engineers come into play. Prompt engineers are expert at prompt engineering. Sounds like a cyclic definition, right? Well, let's break it down. First, let's understand what prompts are. So prompts are any text-based input given to the model as a query. This includes statements like questions asked, the tone mentioned in the query, the context given for the query, and the format of output expected. So here is a quick example for your understanding. Now that we have discussed what a prompt is, so let us now understand who is a prompt engineer and why it has become the job for the future. Broadly speaking, a prompt engineer is a professional who is capable of drafting queries or prompts in such a way that large language models like GPT, Palm, Llama, Bloom, etc. can generate the response that is expected. These professionals are skilled at crafting accurate and contextual prompts, which in turn allows the model to generate desired results. So here is a quick example for you. Prompt engineers are experts not only at the linguistic front, but they also had extensive domain knowledge and are very well versed with the functioning of neural networks and natural language processing, along with the knowledge of scripting languages and data analysis. Leading job platforms like Indeed and LinkedIn already have many prompt engineer positions. In the United States alone, Job postings for this role run in the thousands, reflecting the growing demand. The salary of prompt engineers is also compelling, with a range that spans from $50,000 to over $150,000 per year, depending on experience and specialization. So there are multiple technical concepts that a prompt engineer must be well versed in to be successful in their jobs, such as multimodality, tokens, weights, parameters, transformers, to name a few. Whether it's healthcare, defense, IT services, or edtech industry, the need for skilled prompt engineers is on the rise. There are already several thousand job openings in this field, and the demand will continue to grow. So if you want to hop on this amazing opportunity and become an expert prompt engineering professional, then now is the time. Let us know in the comments what you think about prompt engineering, and if you want to know more about the skills needed to become a prompt engineer, then make sure to like and share this video with your friends and family and tell them about this amazing new job opportunity.
Let's get started with the main topic of today's session, which is data analytics with AI. So before proceeding with data analytics with AI, let's understand what exactly is data analytics. So data analytics is not just a step where you just give your data to AI and it will be done, right? So it's a stage-by-stage process. Let's understand all the stages one after the other. Firstly, you might have different sources. So before we go ahead with the sources, let's understand the situation. You might be dealing with your client. You might be working with the company as a data analyst. So before you begin with the data analysis, you might have to have a conversation with your client or the company. You might have to go through something called as requirement gathering, right? So requirement gathering will let you know from where exactly you're getting the data. Is it in the form of a PDF? Is it in the form of an Excel spreadsheet? Or is it going to be cloud or anything like that, right? So you'll be understanding what the source exactly is. And followed by that, you will understand what is the request of your client, what he's looking for, what he wants you to give him, right? The insights of the data, which part of the business he wants you to focus on, and which part of the business he wants to improve, right? And followed by that, you will come up with a time span. Within that time span, you need to use that data, build some insights, and give it to the client or your business owner so that he comes up with a business decision, right? So that's the first requirement gathering step. Once you have the source, you come up with the next step of the data analytics, which is cleaning the data and transforming the data. So it's really obvious for any beginner or an expert who is a data analyst. It is cleaning and transformation what makes or what adds value to your data. Once you clean your data and transform it. So what exactly you mean by clean and transform? So let's say you might have some blank entries, or might be some wrong data type, or there might be some places where you might have to split the data. For example, if there is a customer and customer ID mixed up together, let's say customer ID 1345 hyphen the name of the customer, right? You wanted to split the customer ID and split the customer name. Then comes the data split option. Apart from that, if you want to categorize the data into buckets, let's say you might have a column for customer age. There might be customers starting from 10 and all the way end up to 80, right? In those scenarios, you might want to split the data into buckets. Let's say 10 to 20 are teenagers, and above 20 to 30 are youth, and above 30 to under 50 or under 60, let's say like 59 are adults, and after that maybe senior citizens, right? Then you have a smaller window so that you can capture which category of the age group is bringing you the most of the revenue, right? So these are the parts of cleaning the data and transforming the data. And once you're comfortable with it, then you can choose a platform where you want to analyze your data, which can be Tableau, which can be Power BI, ClickView, or Excel, or any of the tools that you might want to prefer. In our scenario, we want to go with AI, right? So AI can be anything. You can go with the Microsoft's Copilot. You can go with the OpenAI's ChatGPT, you can go with Google's Gemini, or any of the AIs which can perform data analytics. There are some AI tools out there which are dedicated for AI data analytics, right? And once you're done with it, and the final stage is analyzing the outcomes and reporting that to your business owner or client. So I hope I made myself clear with these stages of data analytics and reporting. Now let's look at an example to explain this a little better. So I have the dataset in Excel for now. This is our source, the first part of data analytics. Let's expand the columns. So there you go. I said something about data type. So here you can see we have some different data type which we don't want, which is in general. So we will change this data type to short date to make a little more meaning out of it. And after that, here we have customer ID, right? So what we will do is use data split here. Go to text to columns, delimited. Next. So we have other. So here's the preview. So you will be receiving it in this form. And if you want to format the data as you like, you can go ahead. So I'll leave it as general for now and finalize the data type after the split is finished. So what you can do is add a column, new column here, so that you can get an empty column here to split the data. Go to text to columns once again. Select delimited. Select next. And we have the input other. Next and finish. There you go. You have customer ID and you have customer name, the respective customer name here itself. So proceeding ahead, we have quantity, the quantity of product ordered, and we have traffics, leads, orders, and revenue, right? Cost to company and delivery status. So in case if you wanted to kind of calculate profit, what you can do is add a new column, profit, and here you can do a mathematical calculation equals to revenue minus cost to company. And you can extend this particular column all the way to the end so that you have the profit numbers. And here you can also change the data type to currency and go to home. And here the data type from general to currency. And there you go. And if you want it in rupees, you can go with rupees. Or if you want it in dollar, you can also have dollars. Right? So that's how you do it. I would like to go with dollars. So more. And here go to currency. And in currency symbol, I'll go with the dollar. Then okay. There you go. You can quickly save it. If you want to add some borders to the data, you can also do that. There you go. So far, so good. So we are now good data. Now comes the next step, which is loading the data and analyzing it, right? So currently we choose the platform as Excel. So you can do this on Excel, Power BI, and ChatGPT as well. So let's go with the first one, which is Excel's AI. So here you can see analyze data, or also people call it the co-pilot of Excel, right? Now you can just click all the data and click on analyze. Basically what you can do is insert and go to the pivot table option, and here you can insert a pivot table, and after that you can find out the requirements what you want, the sales from the central region, south region, and which category of the products have been sold the highest, and what's the highest grossing product, what are the number of leads, and you can estimate the performance of traffic on a month-on-month basis, right? You can do that all, but if you want to reduce the time, basically I would like to tell you, go to that particular part first. understand manual process, and after that go to the analyze data option, which is the automated or AI generated report, right? It will now read your data and it will give you some insights from the data given. Right here you can see the cost to company by order status, and here you can see you can set up a pivot table for that, and here you can see you can insert some graphs and charts here, bar graph, and here you have another one. Now you can see that it has all 24 results, all the insights. Now if I can ask, give me a pie chart of sales and category. Here you go. Here you have so basically what Copilot did is it created a pivot table of sales and category, and out of that pivot table it extracted the pie chart and generated one for you. In this way you can create multiple options. Let's say I want to create a line graph month on month. Enter. Now here it again created a pivot table, and here it generated a line graph on month basis and how many number of traffic or how many number of visitors your website had. Right? In this way you can create a long list of all the required charts and graphs for your website and or the client, and create a dashboard out of it, which is completely interactive. Now this was the Excel's AI. Now if we go to another one, which is Power BI, so here you can see a completely prepared dashboard in Power BI, and we can create this once again, or you can at least understand how it was done, right? Now let's get the data from Excel workbook. So my workbook or my data set is somewhere here, sales data. I would like to go with orders data. Only one file is enough for 2024, and your data will be shortly loaded. Select spreadsheet 1 and load the data. Since we already transformed it, there is no need for transforming it once again. So the data is being loaded successfully. It's going to take some time. 2000 rows loaded. Sheet 1. So we are going to work with sheet 1. Now you can select the visualization you want. Like I want to create a line graph here. Repeat. Like I want to create a line graph here. Select. And for this particular line graph, you will have fields, x-axis and y-axis. Now what I'll do is I'll drag and drop date to x-axis field and traffic to y-axis field. Now here in x-axis, I would eliminate year, I would eliminate quarter, I would eliminate date. I just want month on month, right? Here you have a clear month on month traffic line graph. Right now let's quickly delete it. We don't want this now. And remove it. Now, what if I tell you there is an option where you can just double click and or right click and you will get an option. Here you can query, right? You can just write down the query, line graph, type of graph you require, traffic, write the spellings correctly, month on month. And enter, you will get the graph you are looking for. There you go. Right? So apart from this, let's put the month on month graph here. Apart from this, let's double click once again and category wise sales. Category sale, pie chart. There you go. And now region wise, double click once again. Region wise sales, bar graph. Select the first one, and there you go. I think there is a small mistake in the selection, spelling. Select the first one once again, and there you go. You will have a bar graph in region-wise basis. Or we can also go with similarly, we can also go with a map chart for states and revenue. Select the first option, and you will have all the American states and their revenue details here. Right? So in such way, you can use the artificial intelligence of Power BI and create a completely interactive graph just like this one. So if I select the standard shipment mode, what are the sales reports? And if I select the entire shipment modes, what are the reports? And if I select the home category, what are the sales reports and which part of the nation and and what are the sales and order per month, traffic and everything details here, right? In one go. It's completely interactive. Now, let's move on to the next part of our session for today. So we will be using ChatGPT for our data analytics. So here you go. Now, let's load the data. Before that, let's write a prompt. Some data on sales. Or sales reporter. Visualization. And now load the data. Upload from computer. And we have the sales data here. The orders data. Select the orders data file and open. The data will be loaded shortly. And since it's loaded, you can just push the command or prompt. It'll first review the contents and understand what exactly is present in your content and the data type along with the data type, right? It has 2000 entries, 17 columns. Here's the brief overview of all the columns. So it's asking you, would you like an overall summary or a specific aspect? So let's go with the specific aspect instead of overall summary. I want region-wise sales as a bar graph. Okay, we didn't have a column as bar sales. It's in turn taking revenue. Yes, there you go. Sales revenue by region as a bar graph. Now, pie chart for category revenue. Okay, so there is some limit for analysis. Okay, that's not a problem. We can change the account and try to do it once again, or I should have chosen the overall summary, right? But if you go to the ChatGPT Plus edition, you can get that. Let's try the Plus edition once. So we are on the Plus edition now. So it generated some visualizations, which is completely downloadable here. You can go with that as well. So the prompt is still running. Let's wait for a couple of more minutes and see what exactly ChatGPT is up to. So here we have a profit by category, which was our second request, which did not get successfully authorized because we didn't have a +1. So now we can see revenue versus cost to company in top 10 products. So which are the top 10 products which are giving the maximum revenue? And here is a detailed report. And if you would like to continue with a few more reports like we did before in Power BI and Excel, like traffic versus month on month is a line graph. Let's try that. There you go. So we have a line graph of traffic on a month-on-month basis. So that's how you can conduct some data analytics using different AIs on different platforms. So there are many number of platforms: Tableau, Power BI, ClickView, Excel, SQL, ChatGPT, Gemini, and a few more dedicated artificial intelligence tools which are for AI data analytics. And that brings us to the next part of data analytics with AI. So, how does data analytics and AI work? So, first, basically, once you load the data, AI will start preparing and processing your data, right? So, the transformations, what you do, are also can be possible in AI as well. If you request AI to do the transformations, it can do itself. But I would recommend you perform the transformations because you know where the exact requirements are. Once your data is completely transformed, you can load it and get the reports. The next part of it is pattern recognition. As you've already seen, ChatGPT recognizes each and every aspect of the data, from the data type to the minute details like currency and everything. It understands the data first, and then it will request you. It will ask you if you want a complete summary or if you are looking for a particular aspect, right? Machine learning algorithms can identify patterns, trends, and relationships that may not be apparent to human analysts. And there is a possibility that ChatGPT can even identify a few more insights that you never expected to have, right? And moving on to the next part, predictive analytics. AI can also perform some predictive analytics and give you the forecast of what exactly is going to happen in the upcoming future in your business. That may or may not happen. If you find something is about to go down, you can prevent it by taking some predictive steps or measurable steps which can avoid that loss, right? And automated insights and reports. You can also request ChatGPT, right? In Excel, there is something called as Power Query. It acts like a macro or Excel VBA where it stores each and every transformation step you apply. In a similar way, each and every transformation or step that you apply to modify or try to add value to your data and teach that to your AI so that it can also understand that particular automated transformation steps and report to you on a month-on-month basis, right? So this will stop your month-on-month activity of cleaning your data, transforming your data, loading your data, analyzing, extracting some insights, and then creating a strategy. So all these steps will be eliminated because ChatGPT or any other AI will take care of it, and you can focus on implementing some business strategies. And we have decision making. So AI can also help you with some critical business strategies and also help you in decision making. AI algorithms can optimize complex processes and decision making by evaluating multiple variables and multiple scenarios. Now, last but not least, continuous learning. So AI is capable to adapt and learn new things in your business, like how it processes, how it functions, and what's the data source, and most of the aspects in which are involved in business and data analytics. AI systems have the ability to continuously learn and adapt based on the new data and feedback.
Today, I will tell you a story of a guy named Leo. Leo, a young software engineer with big dreams. He loved building things, mobile apps, web platforms, and even small games. But coding was tricky, even for someone as skilled as Leo. No matter how much experience he had, he kept running into bugs and inefficiencies that made his applications crash or run slowly. He would spend hours staring at his computer screen, debugging line after line of codes, trying to figure out where things went wrong. One day, Leo heard about Cursor AI, a powerful code editor that could help him code faster and smarter. Unlike regular code editors, Cursor AI didn't just highlight errors, it understood the code deeply. It could analyze problems, suggest better solutions, and even write sections of code for him. Feeling curious, Leo decided to give it a try. He opened Cursor AI and loaded his project, which had been stuck for days due to a tricky bug. Almost instantly, Cursor AI flagged the error in the code and suggested an efficient fix. Not only that, it also recommended a cleaner way to structure his code, making it easier to read and less prone to future bugs. Leo followed the suggestions and his app started running flawlessly. In fact, Cursor AI helped him optimize the entire project, making the application faster and smoother than before. Tasks that would usually take hours like debugging, refactoring, and testing were now completed in minutes. Before I tell you that you too can code in minutes like Leo, just for your information. In this video, I will let you know what Cursor AI is and your ultimate guide to use it as a beginner. So let's jump into the video. Let us understand what is Cursor AI. Cursor AI is a smart coding assistant that speeds up your workflow by suggesting code completions, fixing bugs, and optimizing code in real time. It supports multiple languages, helps with code reviews, and even generate documentation, making coding faster, easier, and more efficient for developers of all levels. Well, after we have a basic understanding of Cursor AI, let us explore more. I will first take you to the browser, and in that, you need to search for Cursor AI. And the first official website that will appear is www.cursor.com. You need to click on it and obviously download it. It is free, and you need to sign in as you are using their model. So it is very important to log in before exploring their model. After you download and install it, I will show you what screen you are gonna get. Yeah, this is the visual representation of Cursor AI, the code editor, and it somewhat looks like VS Code. If you have seen VS Code before, it almost looks like this. This is basically your project section. And yeah, obviously file, edit, selection, view, go, run, and everything. So initially, it is very important to start with the basics. So obviously, you're using a new application for the first time. It is very important to learn the cursor settings. So to see the cursor settings, for that, press Command Shift plus P. Command Shift plus P. Yeah, see? It will direct you to a menu bar on the top of the application and search there as cursor settings. See, it is already available. So, cursor settings. So, basically, cursor setting has 4 types of settings: general, models, features, and beta. So, initially, start with this general. Account, basically, the account shows like through what Gmail account you have logged in. And currently I'm using this pro trial, and it is basically of 2 weeks, I guess, for free. And after that, if you want to use it, then you can use it like upgrading to pro. And after that, there is VS Code import. This is basically for like if you have VS Code in this particular laptop or system you're using, then you can obviously import the type of extensions or key bindings you have there. You can generally import it. And after that comes rules for AI. This is basically the section where you can like tell or instruct the Cursor AI what are the things you want, or even what are the things you don't want. Like for example, you're working on a particular project and you only want to like use a particular language, then you can just type there, like I will show you. Use only React.js. So basically you can write there and it will automatically get saved, but obviously I won't be using that. And after that comes a very important part. There is a privacy mode. It is already written: if on, none of your code will be stored by us. If off, we may save prompts or collect telemetry data to improve cursor. So obviously I don't want my data to get to them. So obviously I have enabled it. If you have no problem in showing your data to the cursor, so you can obviously disable it. Then I will show you about the models. This is basically the section where you can see what are the type of models, API models you're using or it is getting used, and even you can even add your own model and see like OpenAI API key, Anthropic API key, Google API. Oh wow, this is nice. Azure API key, they're almost there. Let's come to beta. This is basically a section where if any of the new features like get upgraded in Cursor AI, then you can obviously see it over here. And it is like a default setting is disabled, so let it be. Like don't have to do anything. So after you have seen the Cursor settings, I will take you to see the actual presentation where you can actually code more faster than any of the editors. So I will take you to see a magic. So let's start. So I will cross it. I will now show you why Cursor AI is the next code editor. For that, press Ctrl+Shift+I and you can see the composer. It is named as composer. You can write your any instructions or commands that you want Cursor AI to execute. So basically you can give prompts like create a particular website for me using this. So I will let you understand with an example. Create a simple retro game using HTML, CSS and JavaScript. I hope it does. And enter. See, it has even started to build this game. Pong style, retro style Pong game using HTML, CSS and JavaScript. Okay, it has already made index.html and it has been building with JavaScript. Okay, it has only used HTML and JavaScript. Okay, I wanted to use CSS too for better appearance. Obviously, CSS is the thing you need to. Okay, it has already started linking. Okay, here's the code for the game. Okay, maybe some confusion has occurred. Okay, it has used CSS as a. Okay, it has not made a different file. So I wanted to make a CSS as a different file. I want a separate file for CSS. Okay, now see, it has actually executed what I said. Okay. Now, after you have got it, you can just accept all and see if it is actually working or not. So let's start. Accept all. After that, you can close this composer window and you will find that files already in your project section. See, it is there. If you want to run the game and see if it is actually getting the code is running or not and the game is playable or not, you need to download one extension. Yeah, here like live server. Yeah, I have already installed it. You need to just install it and you are ready to go. Let's come back and right click on the index.html and open with live server. Okay, see, it's nice. Oh wow. Move your mouse up and down to control the left paddle first to 10 points. First to 10 points win. Okay. This is nice. So I want basically my game, it is glowing, yeah. So I want to use one theme. So see if it can. Let's see. After the game is basically made, you can just use your imagination or your creativeness on how you can design your game. So Ctrl+Shift+I. Yeah. Wow, the game is nice. I don't know why I'm appreciating, but yes, you need to appreciate because it did so much work for you. Oh, wow, the game is nice. I want you to use Harry Potter theme. I think everyone knows Harry Potter and I want it basically to use Harry Potter theme in the game and submit. So it has started formulating it. I think it is nice. Now, okay, accept all. And now you can cross it. And let's see. Open with live server. Wow, see. Oh, it is nice. See, it is almost green and yellow, the type of that is used in Harry Potter and everything. See, it is nice. And it is also written golden snitch. Wow, it is nice. So basically, you can do anything. You can even use a particular type of like font. You can do anything. Let's see how we can improve it. Control Shift I. Yeah, this is nice. Can you just use the font style used in Harry Potter movie? I hope it does. Enter. I understand. Yeah, it is trying. Because of the copyright, maybe it fully can't, but yeah, it is trying. Let's see. Accept all. Cross it. And right click and open with live server. Okay. Maybe there's a difference there. There is a difference. I can see. Fine. It is nice. Huh. So in this way, you can just command it and do anything. You can even like attach files, I guess. You can over here, you can just use @, and you can like upload files, folders, code, web, like the you can attach, you can @web, and you can even tell it to take a picture from the website and replicate it, use that for reference and anything. So it basically depends upon your designing and your creativeness, how you want to make it, and it will just code for you. This is the power of AI. So you can do anything over here, I believe. It will help you to code much, much, much faster.
Why reinforcement learning? Training a machine learning model requires a lot of data, which might not always be available to us. Further, the data provided might not be reliable. Learning from a small subset of actions will not help expand the vast realm of solutions that may work for a particular problem. You can see here we have the robot learning to walk. Very complicated setup when you're learning how to walk, and you'll start asking questions like, if I'm taking one step forward and left, well, what happens if I pick up a 50-pound object? How does that change how a robot would walk? These things are very difficult to program because there's no actual information on it until it's actually tried out. Learning from a small subset of actions will not help expand the vast realm of solutions that may work for a particular problem. And we'll see here it learned how to walk. This is going to slow the growth that technology is capable of. Machines need to learn to perform actions by themselves and not just learn off humans. And you see the objective climb a mountain. A real interesting point here is that as human beings we can go into a very unknown environment and we can adjust for it and kind of explore and play with it. Most of the models, the non-reinforcement models in computer machine learning, aren't able to do that very well. There's a couple of them that can be used or integrated. To see how it goes is what we're talking about with reinforcement learning. So what is reinforcement learning? Reinforcement learning is a sub-branch of machine learning that trains a model to return an optimum solution for a problem by taking a sequence of decisions by itself. Consider a robot learning to go from one place to another. The robot is given a scenario and must arrive at a solution by itself. The robot can take different paths to reach the destination. It will know the best path by the time taken on each path. It might even come up with a unique solution all by itself. And that's really important as we're looking for unique solutions. We want the best solution, but you can't find it unless you try it. So when we're looking at our different systems, our different model, we have supervised versus unsupervised versus reinforcement learning. And with the supervised learning, that is probably the most controlled environment. We have a lot of different supervised learning models, whether it's linear regression, neural networks, there's all kinds of things in between, decision trees. The data provided is labeled data with output values specified. And this is important because when we talk about supervised learning, you already know the answer for all this information. You already know the picture has a motorcycle in it, so you're supervised learning. You already know that the outcome for tomorrow, for going back a week, you're looking at stock, you can already have like the graph of what the next day looks like, so you have an answer for it. And you have labeled data, which is used. You have an external supervision and solves problems by mapping labeled input to known output. So very controlled. Unsupervised learning. And unsupervised learning is really interesting because it's now taking part in many other models. They start with you can actually insert an unsupervised learning model in almost either supervised or reinforcement learning as part of the system, which is really cool. Data provided is unlabeled data. The outputs are not specified. Machine makes its own predictions. Used to solve association with clustering problems. Unlabeled data is used. No supervision. Solves problems by understanding patterns and discovering output. So you can look at this and you can think some of these things go with each other. They belong together. So it's looking for what connects in different ways. And there's a lot of different algorithms that look at this. When you start getting into those, there's some really cool images that come up of what unsupervised learning is. How it can pick out, say, the area of a donut. One model will see the area of the donut, and the other one will divide it into 3 sections based on its location versus what's next to it. So there's a lot of stuff that goes in with unsupervised learning. And then we're looking at reinforcement learning. Probably the biggest industry in today's market in machine learning, or growing market. It's very infant stage as far as how it works and what it's going to be capable of. The machine learns from its environment using rewards and errors. Used to solve reward-based problems. No predefined data is used. No supervision. Follows trial and error problem solving approach. So again, we have a random, at first you start with a random, I try this, it works and this is my reward, doesn't work very well maybe, or maybe doesn't even get you where you're trying to get it to do, and you get your reward back, and then it looks at that and says, well, let's try something else, and it starts to play with these different things, finding the best route. So let's take a look at important terms in today's reinforcement model. And this has become pretty standardized over the last few years, so these are really good to know. We have the agent. Agent is the model that is being trained via reinforcement learning. So this is your actual entity that has, however you're doing it, whether you're using a neural network or a Q table or whatever, combination thereof. This is the actual agent that you're using. This is the model. And you have your environment. The training situation that the model must optimize to is called its environment. And you can see here, I guess we have a robot who's trying to get a chest full of gems or whatever, and that's the output. And then you have your action. This is all possible steps that can be taken by the model, and it picks one action. And you can see here that it's picked 3 different routes to get to the chest of diamonds and gems. We have a state, the current position condition returned by the model. And you could look at this if you're playing like a video game. This is the screen you're looking at. So when you go back here, the environment is a whole game board. So if you're playing one of those Mobius games, you might have the whole game board going on, but then you have your current position. Where are you on that game board? What's around that? What's around you? If you were talking about a robot, the environment might be moving around the yard, where it is in the yard and what it can see, what input it has in that location. That would be the current position condition returned by the model. And then the reward. To help the model move in the right direction, it is rewarded. Points are given to it to appraise some kind of action. So, yeah, you did good, or if didn't do as good, trying to maximize the reward and have the best reward possible. And then policy. Policy determines how an agent will behave at any time. It acts as a mapping between action and present state. This is part of the model. What is your action that you're going to take? What's the policy you're using to have an output from your agent? One of the reasons they separate policy as its own entity is that you usually have a prediction of different options, and then the policy, well, how am I going to pick the best? Based on those predictions, I'm going to guess at different options. And we'll actually weigh those options in and find the best option we think will work. So it's a little tricky, but the policy thing is actually pretty cool how it works. Let's go ahead and take a look at a reinforcement learning example. And just in looking at this, we're going to take a look, consider what a dog that we want to train. So the dog would be like the agent. So you have your puppy or whatever. And then your environment is going to be the whole house or whatever it is where you're training them. And then you have an action. We want to teach the dog to fetch. Perform various actions by offering incentives such as a dog biscuit as a reward. The dog will follow a policy to maximize this reward and hence will follow every command and might even learn new actions like begging by itself. So you have, so we start off with fetching. It goes, oh, I get a biscuit for that. It tries something else, and you get a handshake or begging or something like that. And it goes, oh, this is also reward based. And so it kind of explores things to find out what will bring it as biscuit. And that's very much like how a reinforced model goes. Is it looks for different rewards. How do I find? Can I try different things and find a reward that works? The dog also will want to run around and play and explore its environment. This quality of model is called exploration. So there's a little randomness going on in exploration. And it explores new parts of the house. Climbing on the sofa doesn't get a reward. In fact, it usually gets kicked off the sofa. So let's talk a little bit about Markov's decision process. Markov's decision process is a reinforcement learning policy used to map a current state to an action where the agent continuously interacts with the environment to produce new solutions and receive rewards. And you'll see here's all of our different vocabulary we just went over. We have a reward, our state, our agent, our environment, and our action. And so even though the environment kind of contains everything, that you really, when you're actually writing the program, your environment's going to put out a reward and state that goes into the agent. The agent then looks at this state, or it looks at the reward usually first, and it says, okay, I got rewarded for whatever I just did, or I didn't get rewarded. And then it looks at the state, and then it comes back, and if you remember from policy, the policy comes in, and then we have a reward. The policy is that part that's connected at the bottom. And so it looks at that policy and it says, hey, what's a good action that will probably be similar to what I did, or sometimes they're completely random, but what's a good action that's going to bring me a different reward? So taking the time to just understand these different pieces as they go is pretty important in most of the models today. And so a lot of them actually have templates based on this that you can pull in and start using. Pretty straightforward as far as once you start seeing how it works, you can see your environment says, hey, this is the agent did this. If you're a character in a game, this happened, and it shoots out a reward in a state. The agent looks at the reward, looks at the new state, and then takes a little guess and says, I'm going to try this action. And then that action goes back into the environment. It affects the environment. The environment then changes depending on what the action was, and then it has a new state and a new reward that goes back to the agent. So in the diagram shown, we need to find the shortest path between node A and D. Each path has a reward associated with it, and the path with a maximum reward is what we want to choose. The nodes A, B, C, D denote the nodes to travel from node A to B is an action. Reward is the cost of each path, and policy is each path taken. And you can see here A can go to B, or A can go to C right off the bat, or it can go right to D. And if you explored all three of these, you would find that A going to D was a 0 reward, A going to C and D would generate a different reward, or you could go A, C, B, D. There's a lot of options here. And so when we start looking at this diagram, you start to realize that even though today's reinforced learning models do really good at finding an answer, they end up trying almost all the different directions you see. And so they take up a lot of work or a lot of processing time for reinforcement learning. They're right now in their infant stage, and they're really good at solving simple problems. And we'll take a look at one of those in just a minute in a tic-tac-toe game. But you can see here, once it's gone through these and it's explored, it's going to find the A, C, D is the best reward. It gets a full 30 points for it. So let's go ahead and take a look at a reinforcement learning demo. In this demo, we're going to use reinforcement learning to make a tic-tac-toe game you will be playing this game against the machine learning model. And we'll go ahead, we're doing it in Python. So let's go ahead and go through, not always, I actually have a lot of Python tools. Let's go through Anaconda, which will open up a Jupyter notebook. Seems like a lot of steps, but it's worth it to keep all my stuff separate, and it also has a nice display when you're in the Jupyter notebook for doing Python. So here's our Anaconda navigator. I open up the notebook, which is going to take me to a web page, and I've gone in here and created a new Python folder. In this case, I've already done it and enabled it to change the name to tic-tac-toe. And then for this example, we're going to go ahead and import a couple things. We're going to import numpy as np. We'll go ahead and import pickle. Numpy, of course, is our number array, and then pickle is just a nice way sometimes for storing different information, different states that we're going to go through on here. And so we're going to create a class called state. We're going to start with that. And there's a lot of lines of code to this class that we're going to put in here. Don't let that scare you too much. There's not as much here. It looks like there's going to be a lot here, but there really is just a lot of setup going on in our class state. And so we have up here, we're going to initialize it. We have our board. It's a tic-tac-toe board, so we're only dealing with 9 spots on the board. We have player 1, player 2 is end. We're going to create a board hash. We'll look at that in just a minute. We're just going to store some information in there. Symbol of player equals 1. So there's a few things going on as far as the initialization. Then something simple, we're just going to get the hash of the board. We're going to get the information from the board on there, which is columns and rows. We want to know when a winner occurs. So if you get 3 in a row, that's what this whole section here is for. Let me go ahead and scroll up a little bit. And you can get a copy of this code if you send a note over to Simplilearn. We'll send you over this particular file, and you can play with it yourself and see how it's put together. I don't want to spend a huge amount of time on this because this is just some real general Python coding. But you can see here we're just going through all the rows, and you add them together, and if it equals 3 in a row, the same thing with columns. Diagonal, so you got to check the diagonal. That's what all this stuff does here, is it just goes through the different areas. Actually, let me go ahead and put, there we go. And then it comes down here and we do our sum, and it says true, -3 just says did somebody win, or is it a tie? So you got to add up all the numbers on there anyway, just in case they're all filled up. And next we also need to know available positions. These are ones that no one's ever used before. This way when you try something, or the computer tries something, it's not going to give it an illegal move. That's what the available positions is doing. Then we want to update our state. And so you have your position going in. We're just sending in the position that you just chose. And you'll see there's a little user interface we put in there. You can pick the row and column in there. And again, I mean, this is a lot of code. So really it's kind of a thing you'd want to go through and play with a little bit and just read through it, get a copy of it. A great way to understand how this works. And here is a given reward. So we're going to give a reward, result equals self winner. This is one of the hearts of what's going on here, is we have a result self.winner. So if there's a winner, then we have a result. If the result equals 1, here's our feedback. If it doesn't equal 1, then it gets a 0. So it only gets a reward in this particular case if it wins. And that's important to know because different systems of reinforced learning do rewarding a lot differently depending on what you're trying to do. This is a very simple example with a 3x3 board. Imagine if you're playing a video game, certainly you only have so many actions, but your environment is huge. You have a lot going on in the environment. And suddenly a reward system like this is going to be just, it's going to have to change a little bit. It's going to have different rewards and different setup. And there's all kinds of advanced ways to do that as far as weighing, you add weights to it. And so they can add the weights up depending on where the reward comes in. So it might be that you actually get a reward. In this case, you get the reward at the end of the game. And I'm spending just a little bit of time on this because this is an important thing to note. But there's different ways to add up those rewards. It might have, like if you take a certain path, the first reward is going to be weighed a little bit less than the last reward, because the last reward is actually winning the game or scoring or whatever it is. So this reward system gets really complicated in some of the more advanced setups. In this case, though, you can see right here that they give a 0.1 and a 0.5 reward just for picking the right value and something that's actually valid instead of picking an invalid value. So rewards, again, that's like key. It's huge. How do you feed the rewards back in? Then we have a board reset. That's pretty straightforward. It just goes back and resets the board to the beginning because it's going to try out all these different things while it's learning. It's going to do it by trial and error, so you have to keep resetting it. And then, of course, there's the play. We want to go ahead and play rounds equals 100. Depends on what you want to do on here. You can set this different. You can obviously set that to higher level. But this is just going to go through, and you'll see in here that we have player 1 and player 2. This is the computer playing itself. One of the more powerful ways to learn to play a game, or even learn something that isn't a game, is to have two of these models that are basically trying to beat each other. And so they keep explore new things. This one works for this one, so this one tries new things. It beats this. We've seen this in chess. I think was a big one where they had the two players in chess with reinforcement learning. It was one of the ways they trained one of the top computer chess playing algorithms. So this is just what this is. It's going to choose an action. It's going to try something, and the more it tries stuff, the more we're going to record the hash. We actually have a board hash where you self get the hash set up on here where it stores all the information. And then once you get to a win, one of them wins, it gets the reward. Then we go back and reset and try again. And then kind of the fun part we actually get down here is we're going to play with a human. So we'll get a chance to come in here and see what that looks like when you put your own information in. And then it just comes in here and does the same thing it did above. It gives it a reward for its things, or sees if it wins or ties, looks at available positions, all that kind of fun stuff. And then finally we want to show the board. So it's going to print the board out each time. Really, as an integration, is not that exciting. What's exciting in here is, one, looking at this reward system. Whoops, play one more up. The reward system is really the heart of this. How do you reward the different setup? And the other one is when it's playing, it's got to take an action. And so what it chooses for an action is also the heart of reinforcement learning. How do we choose that action? And those are really key to right now where reinforcement learning is in today's technology, is figuring this out. How do we reward it, and how do we guess the next best action? So we have our environment, and you can see the environment is or the state, which is kind of like what's going on. We're going to return the state depending on what happens. And we want to go ahead and create our agent, in this case our player. So each one is, let me go and grab that. And so we look at a class player. This is where a lot of the magic is really going on, is how is this player figuring out how to maneuver around the board, and then the board of course returns a state that it can look at and a reward. So we want to take a look at this. We have name, self-state. This is class player. And when we say class player, we're not talking about a human player. We're talking about just the computer players. And this is kind of interesting. So remember I told you depending on what you're doing, there's going to be a decay gamma, explore rate. These are what I'm talking about, is how do we train it? As you try different moves, it gets to the end. The first move is important, but it's not as important as the last one. And so you could say that the last one has the heaviest weight, and then as you get there, the first one, let's see, the first move gives you a 5 reward, the second gives you a 2 reward, and the third one gives you a 10 reward, because that's the final ending. You got it. The 10's going to count more than the first step. And here's our, we're going to get the board information coming in, and then choose an action. This was the second part that I was talking about that was so important. So once you have your training going on, we have to do a little randomness, and you can see right here is our NP random uniform. So it's picking out a random number. Take a random action. This is going to just pick which row and which column it is. And so choosing the action, this one you can see we're just doing random states, choice, length of positions, action position, and then it skips in there and takes a look at the board for P in positions. And it's actually storing the different boards each time you go through, so it has a record of what it did, so it can properly weigh the values. And this simply just appends a hash state. What's the last state? Append it to the to our states on here. Here's our feedback reward. So the reward comes in, and it's going to take a look at this and say, is it none? What is the reward? And here is that formula. Remember I was telling you about up here that was important because it has decay gamma times the reward. This is where, as it goes through each step, and this is really important. This is kind of the heart of this, of what I was talking about earlier. You have step 1, and this might have a reward of 2. You have step 2. I probably should have done ABC. This has a step 3, step 4, and so on until you get to step N. And this might have a reward of 10. So reward of 10, we're going to add that, but we're not adding, let's say this one right here, let's say this reward here right before 10 was, let's say it's also 10. That just makes the math easy. So we had 10 and 10. We had 10, this is 10 and 10n, whatever it is, but it's 0.9. So instead of putting a full 10 here, we only do 9. That's 0.9 times 10. And so this formula, as far as the decay times the reward minus the cell state value, it basically adds in, it says here's 1, or here's 2, I'm sorry, I should have done this ABC, it would have been easier. So the first move goes in here and it puts 2 in here. Then we have our self set up on here. You can see how this gets pretty complicated in the math, but this is really the key, is how do we train our states? And we want the final state, the win, to get the most points. If you win, you get most points. And the first step gets the least amount of points. So you're really training this almost in reverse. You're training it from the last place where you have, like it says, okay, this is now where I need to sum up my rewards, and I want to sum them up going in reverse, and I want to find the answer in reverse. Kind of an interesting play on the mind when you're trying to figure this stuff out. And of course we want to go ahead and reset the board down here and save the policy, load policy. These are the different things that are going in between the agent and the state to figure out what's going on. Let's go ahead and load that up. And then finally we want to go ahead and create a human player. And the human player is going to be a little different in that you choose an action, row and column. Here's your action. If action in positions, meaning positions that are available, you return the action. If not, it just keeps asking you until you get the action that actually works. And then we're going to go ahead and append to the hash state, which we don't need to worry about because it returns the action up here. And feed forward. Again, this is because it's a human. At the end of the game, backpropagate and update state values. This part isn't being done because it's not programming the model. The model is getting its own rewards. So we've gone ahead and loaded this in here. So here's all our pieces. And the first thing we want to do is set up P1 player 1, P2 player 2, and then we're going to send our players to our state. So now it has P1, P2, and it's going to play, 50,000 rounds. Now we can probably do a lot less than this, and it's not going to get the full results. In fact, you know what? Let's go ahead and just do 5, just to play with it, because I want to show you something here. Oops, somewhere in there I forgot to load something. There we go. I must have forgot to run this. Run. Oops, forgot a reference there for the board, rows and columns, 3 by 3. There's actually in the state, it references that. We can just tack it on the end. It was supposed to be at the beginning. So now I've only set this up with, let's see, where are we going here? I've only set this up to train 5 times. And the reason I did that is we're going to come in and actually play it, and then I'm going to change that, and we can see how it differs on there. There we go. And it didn't even make it through a run, and we're going to go ahead and save the policy. So now we have our player 1 and our player 2 policy. The way we set it up, it has 2 separate policies loaded up in there. And then we're going to come in here, and we're going to do player 1 is going to be the computer, experience rate 0, load policy 1, human player human, and we're going to go ahead and play this. Now remember, I only went through it just 1 round of training, in fact minimal training, and so it puts an X there, and I'm going to go ahead and do row 0, column 1. And you can see this is very basic on here, and so I put in my 0, and then I'm going to go 0, block it, 0, 0, and you can see right here it let me win. Just like that, I was able to win. 0, 2, and woo, human wins. So I only trained it 5 times. We're going to run this again, and this time, instead of 5, let's do 5,000 or 50,000. I think that's what the guys in the back had. And this takes a while to train it. This is where reinforcement learning really falls apart. Look how simple this game is. We're talking about a 3 by 3 set of columns. And so for me to train it on this, I could do a Q table which would go much quicker. You could build a quick Q table with almost all the different options on there, and you would probably get the same result much quicker. We're just using this as an example. So when we look at reinforcement learning, you need to be very careful what you apply it to. It sounds like a good deal until you do like a large neural network where you're doing, you set the neural network to a learning increment of 1, so every time it goes through it learns, and then you do your actions. So you pick from the learning setup, and you actually try actions on the learning setup until you get what you think is going to be the best action. So you actually feed what you think is right back through the neural network. There's a whole layer there, which is really fun to play with. And then it has an output. Well, think of all those processes. I mean, that is just a huge amount of work it's going to do. Let's go ahead and skip ahead here. Give it a moment. It's going to take a minute or two to go ahead and run. Now, to train it, we went ahead and let it run, and it took a while. This took, I got a pretty powerful processor, and it took about 5 minutes plus to run it. And we'll go ahead and 5 minutes plus to run it. And we'll go ahead and run our player setup on here. Oops, it brought in the last whoops, it brought in the last round. So give me just a moment to redo the policy save. There we go. I forgot to save the policy back in there. And then go ahead and run our player again. So we've saved the policy, and then we want to go ahead and load the policy for P1 as a computer. And we can see the computer's gone in the bottom right corner. I'm going to go ahead and go 1, 1, which is the center. And it's gone right up the top, and if you have ever played tic-tac-toe, you know the computer has me. But we'll go ahead and play it out. Row 0, column 2. There it is, and then it's gone here, and so I'm going to go ahead and go row 0, 1, 2, no, 0, 1, there we go, and column 0. That's where I wanted. Oh, and it says, okay, your action, there we go, boom. So you can see here, we've got didn't catch the win on this, it said tie. Kind of funny that it didn't catch the win on there. But if we play this a bunch of times, you'll find that it's going to win more and more. The more we train it, the more the reinforcement happens. This lengthy training process is really the stopper on reinforcement learning. As this changes, reinforcement learning will be one of the more powerful packages evolving over the next decade or two. In fact, I would even go as far as to say it is the most important machine learning tool and artificial intelligence tool out there, as it learns not only a simple tic-tac-toe board, but we start learning environments. And the environment would be like in language. If you're translating a language or something from one language to the other, so much of it is lost if you don't know the context it's in, what's the environments it's in. And so being able to attach environment and context and all those things together is going to require reinforcement learning to do. So again, if you want to get a copy of the tic-tac-toe board, it's kind of fun to play with. Run it, you can test it out, you can do test it for different values. You can switch from P1 computer where we loaded the policy 1 to load the policy 2 and just see how it varies. There's all kinds of things you can do on there. So what is Q-learning? Q-learning is reinforcement learning policy which will fill the next best action given a current state. It chooses this action at random and aims to maximize the reward. And so you can see here's our standard reinforcement learning graph. By now, if you're doing any reinforcement learning, you should be familiar with this, where you have your agent takes an action, the action affects the environment, and then the environment sends back the reward or the feedback, and the state, it's the new state the agent's in. Where is it at on the chessboard? Where is it at in the video game? If your robot's out there picking trash up off the side of the road, where is it at on the road? Consider an ad recommendation system. Usually when you look up a product online, you get ads which will suggest the same product over and over again. Using Q-learning, we can make an ad recommendation system which will suggest related products to our previous purchase. The reward will be if user clicks on the suggested product. And again, you can see you might have a lot of products on your web advertisement or your pages, but it's still not a float number. It's still a set number, and that's something to be aware of when you're using Q-learning. And you can see here that if you have 100 people clicking on ads and you click on one of the ads, it might go in there and say, okay, this person clicked on this ad. What is the best set of ads based on clicking on this ad or these two ads afterwards based on where they are browsing? So let's go ahead and take a look at some important terms when we talk about Q-learning. We have states. The state S represents the current position of an agent in an environment. The action A is the step taken by the agent when it is a particular state. Rewards. For every action, the agent will get a positive or negative reward. And again, when we talk about states, we're usually not, when you're using a Q table, you're not usually talking about float variables. You're talking about true, false. And we'll take a closer look at that in a second. And episodes, when an agent ends up in a terminating state and can't take a new action. This might be if you're playing a video game, your character stepped in and is now dead or whatever. Q values used to determine how good an action A taken at a particular state S is Q A of S. And temporal difference, a formula used to find the Q value by using the value of the current state and action and previous state and action. And there's Bellman's equation, which basically is the equation that kind of covers what we just looked at in all those different terms. The Bellman equation is used to determine the values of a particular state and deduce how good it is to be in take that state. The optimal state will give us the highest optimal value. Factor influencing Q values, the current state and action, that's your SA, so your current state and your action. Then you have your previous state and action, which is your S, I guess prime, I'm not sure how they reference that, S prime, A prime. So this is what happened before. Then you have a reward for action, so you have your R reward, and you have your maximum expected future reward. And you can see there's also a learning rate put in there and a discount rate. So when we're looking at these, just like any other model, we don't want to have an absolute final value on here. We don't want it to, if you do absolute values instead of taking smaller steps, you don't really have that approach to the solution. You just have a jump and then pretty soon if you jump one solution out, that's what's going to be the new solution, whichever one jumps up really high first. Kind of ruining the whole idea of doing a random selection. I'll go into the random selection in just a second. Steps in Q learning. Step 1. Create an initial Q table with all values initialized to 0. Again, we're looking at 0, 1. So are you know, here's our action. We start, we're an idle, we took a wrong action, we took a correct action, and int. And then we have our actions, fetching, sitting, and running. And of course, we're just using the dog example. And choose an action and perform it. Update values in the table. And of course, when we're choosing an action, we're going to kind of do something random and just randomly pick one. So you start out and you sit, and you have then depending on that action you took, you can now update the value for sitting after you start, from start to sitting. Get the value of the reward and calculate the value Q value using the Bellman equation. And so now we attach a reward to sitting. And when we attach all those rewards, we continue the same until the table is filled with or an episode ends. And I mentioned I was going to come back to the random side of this. And there's a few different formulas I use for the random setup to pick it. I usually let whatever Q model I'm using do their standard one, because someone's usually gone in and done the math for the optimal spread. But you can look at this. If I have running has a reward of 10, sitting has a reward of 7, fetching has a reward of 5, just kind of without doing like a means, you know, using the bell curve for the means value, and like I said, there's some math you can put in there to pick so that you're more like, so that running has even a higher chance. But even if you were just going to do an average on this, you could do an average, a random number by adding them all together. So you get 10 plus 7 plus 5 is 22. You could do 0 to 22, or 0 to 21, but 1 to 22. 1 to 5 would be fetching, and so forth, you know, the last 10. So you can just look at this as what percentage are you going to go for that particular option. And then that gets your random setup in there, and then as you slowly increment these up, you see that if you're idle, where's one? Here we go. Sitting at the end, if you're at the end of wherever you're at, sitting gets a reward of 1. Where's a good one on here? Oh, wrong action. Running for a wrong action gets almost no reward. So that becomes very, very less likely to happen, but it still might happen. It still might have a percentage of coming up. And that's where the random programming and Q learning comes in. The below table gives us an idea of how many times an action has been taken and how positively correct action or negatively wrong action it is going to affect the next state. So let's go ahead and dive in and pull up a little piece of code and see what this looks like in Python. In this demo, we'll use Q learning to find the shortest path between two given points.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
If you've seen my videos before, I like to do it in the Anaconda Jupyter Notebook setup, just because it's really easy to see and it's a nice demo. And so here's my Anaconda. This one I'm actually using a Python 3.6 environment that I set up in here. And we'll go ahead and launch the Jupyter Notebook on this. And once we're in our Jupyter Notebook, which has the kernel loaded with Python 3, we'll go ahead and create a new Python 3 folder in here. And we'll call this Q Learning. And to start this demo, let's go ahead and import our NumPy array. We'll just run that so it's imported. And like a lot of these model programs, when you're building them, you spend a lot of time putting it all together, and then you end up with this really short answer at the end. And we'll take a look at that as we come into it. So we go ahead and start with our location to state. So we have L1, L2. These are our 9 locations, 1 to 9. And then, of course, the state is going to be 0, 1, 2, 3, 4. It's just a mapping of our location to an integer on there. And then we have our actions. Our actions are simply moving from one location to another. So I can go to location 0, I can go to location 1, 2, 3, 4, 5, 6, 7, 8. So these are my actions I can choose. These are the locations of our state. And if you remember earlier, I mentioned that the limitation is that you don't want to put in a continually growing table, because you can actually create a dynamic queue table where you continually add in new values as they arise. Because if you have float values, it just becomes infinite, and then your memory in your computer is gone, or it's not going to work. At the same time, you might think, well, that kind of really limits the queue learning setup. But there are ways to use it in conjunction with other systems. And so you might look at, well, I've been doing some work in stock. And one of the questions that comes out is to buy or sell the stock. And the state coming in might be, you might take it and create what we call buckets, where anything that you predict is going to return more than a certain amount of money, the error for that stock that you've had in the past, you put those in buckets, and suddenly as you start creating these buckets, you realize you do have a limited amount of information coming in. You no longer have a float number. You now have bucket 1, 2, 3, and 4. And then you can take those buckets, put them through a queue learning table, and come up with the best action. Which stock should I buy? It's like gambling. Stock is pretty much gambling if you're doing day trading. You're not doing long-term investments. And so you can start looking at it like that. A lot of the current feeds say that the best algorithms used for day traders, where you're doing it on your own, is really to ask the question, do I want to trade the stock? Yes or no? And now you have it in a queue learning table, and now you can take it to that next level, and you can see where that can be a really powerful tool at the end of doing a basic linear regression model or something. What is the best investment? And you start getting the best reward on there. And so if we're going to have rewards, these rewards we just create. It says if you're this should match our queue table, because it's going to be you have your state and you have your action across the top, if you remember from the dog. And so we have whatever state we're in going down, and then the next action and what the reward is for it. And of course, if you were actually doing something more connected, your reward would be based on the actual environment it's in. And then we want to go ahead and create a state to location so we can map the indexes. So just like we defined our rewards, we're going to go ahead and do state to location. And you can see here it's a dictionary setup for location state and location to state with items. And we also need to define what we want for learning rates. You remember we had our two different rates as far as like learning from the past and learning from the current. So we'll go ahead and set those to 0.75 and the alpha set to 0.9. And we'll see that when we do the formula. And of course, any of this code, send a note to our Simplilearn team. They'll get you a copy of this code on here. And let's go ahead and pull. There we go. Well, the next two sections. Since we're going to keep it short and sweet. Here we go. So let's go ahead and create our agent. So our agent is going to have our initialization where we send it all the information. We'll define our self gamma equals gamma. We could have just set the gamma rate down here instead of submitting it. It's kind of nice to keep them separate because you can play with these numbers. Our self alpha. Then we have our location state. We'll set that in here. We have our choice of actions. We're going to go ahead and just embed the rewards right into the agent. So obviously this would be coming from somewhere else instead of from self-generated. And then a self state to location equals our state to location dictionary. And we go ahead and create a queue learning table. And I went ahead and just set the queue learning table up to 0 to 0, what the setup is, location to state, how many of them are there. And this just creates an array of 0 to 0 setup on there. And then the big part is the training. We have our rewards new equals a copy of self.rewards. ending state equals the self-location state in location. So this is whatever we end up at. Rewards new equals ending state plus ending state equals 999. Just kind of goes to a dead end. And we start going through iterations. And we'll go ahead, let's do this. So this, we're going to come back and we're going to call it on here. Let me just erase that. Switch it to an arrow. There we go. So what we're doing is we're going to send in here to train it. We're going to say, hey, I want to iterate through this 1,000 times and see what happens. Now this part would actually be, instead of iterating, you might have your external environment and they're going back and forth and you iterate through outside of here. But just for ease of use, our agent's going to come in here and iterate through this. Sometimes I'll put this iteration in here and I'll have it call the environment and say, hey, this is what I did, what's the next state? And the environment does its thing right in here as I iterate through it. And then we want to go ahead and pick a random state to start with. That's what's going on here. You have to start somewhere. And then you have your playable actions. We're going to start with just an empty thing for playable actions and we'll fill that up. So that's what choices I have. And so we're going to iterate through the rewards matrix to get the states. Directly reachable from the randomly chosen current state. Assign those states to a list named playable actions. And so you can see here we have range 9. I usually use length of whatever I'm looking at, which is our locations or states as they are. We have a reward, so we want to look at the rewards. The new reward is our is in our chart here of rewards underscore new current state plus J. J being what is the next state we want to try. And so we go ahead and do our playable actions and we append J. And so what we're doing is we're randomly trying different things in here to see what's going to generate a better reward. And then of course we go ahead and choose our next state. So we have our random choice playable actions. And if you remember, I mentioned on this, let me just go ahead and, whoops, let's do a free form. When we were talking about the next state, this right here just does a random selection. Instead of a random selection, you might do something where whatever the best selection is, which might be option 3 here, and then so you can see that it might use a bell curve, and then option 2 over here might have a bell curve like this. Oops. And we start looking at these averages and these spreads, or we can just add them all together and pick the one that kind of goes in all of those. So those are some of the options we have in here. We just go with a random choice. That's usually where you start, play with it. And then we have our reward section down here. And so we want to go ahead and find, well, in this case, the temporal difference. So you have your rewards new plus the self gamma, and this is the formula we were looking at. This is Bellman's equation here. So we have our current value, our learning rate, our discount rate involved in there, the reward system coming in for that, and we can add it all together. This is of course our maximum expected future setup in here. So this is all of our Bellman's equation that we're looking at here. And then we come up in here and we update our Q table. That's all this is on this one. And that's right here. We have self Q, current state, next state, and we add in our alpha because we don't want to train all of it at once in case there's slight differences coming in there. We want to slowly approach the answer. And then we have our route equals the start location, and next location equals start location. So we're just incrementing. We took a step forward. And then finally, remember I was telling you how we're going to do all this and just have some simple thing at the end where it just generates a simple path. We're going to go ahead and get the optimal route. We want to find the best route in here. And so we've created a definition for the optimal route down here. Just scroll down for that. And we get the optimal route. We go ahead and put the information in, including the Q table, self, start location, end location, next location, route, Q. And it says while next location is not equal to end location, so while we can still go, our start location equals self location to state start location. So we already have our best value for the start location. The next state looks at the Q table and says, hey, what's the next one with the best value? And then the next location, we go ahead and pull that in, and we just append it. That's what's going on down here. And then our start location equals the next location. And we just go through all the steps. And we'll go ahead and run this. And now that we have our Q table, our Q agent loaded, we're going to go ahead and take our Q agent, load them up with our alpha gamma that we set up above, along with the location step, action, reward, state to location. And our goal is to plot a course between L9 and L1. And we're going to go through 1,000 iterations on here. And so when I run that, it runs pretty quick. Why is this so fast? If you've been running neural networks and you've been doing all these other models, you sit here and wait a long time. Well, we're a very small amount of data. These are all integers. These aren't float values. The math is not heavy on the processing end, and this is where Q tables are so powerful. If you have a small amount of information coming in, you very quickly get an answer off of this, even though we went through it 1,000 times to train it. And you'll see here we have L9, 8, 5, 2, and 1, and that's based on our reward table we had set up on there. And this is the shortest path going between these different setups in here. And if you remember on our reward table, you can see that if you start here, you can go to here. There's places you can't go. That's how this reward table was set up. So I can only go to certain places. So kind of a little maze set up in there. And you can play with it. This is really fun setup to play with. And you can see how you can take this whole code and you can, like I was saying earlier, you can embed it into another setup in model and predictions, where you put things in model and predictions, where you put things into buckets and you're trying to guess the best investment, the best course of action. Long as you can take that course of action and reduce it down to a yes, no. Or if you're using text, you can use a one-hot encoder, which word is next. There's all kinds of things you can do with a Q table, depending on just how much information you're putting in there. So that wraps up our demo. In this demo, we've found the shortest distance between two paths based on whatever rules or state rewards we have to get from point A to point B and what available actions there are.
Hello and welcome to this tutorial on deep learning. My name is Mohan, and in the next about 1.5 hours I will take you through what is deep learning and into TensorFlow environment to show you an example of deep learning. Now, there are several applications of deep learning, really very interesting and innovative applications, and one of them is identifying the geographic location based on a picture. And how does this work? The way it works is pretty much we train an artificial neural network with millions of images which are tagged, their geolocation is tagged, and then when we feed a new picture, it will be able to identify the geolocation of this new image. For example, you have all these images, especially with maybe some significant monuments or significant locations, and you train with millions of such images, and then when you feed another image, it need not be exactly one of those that you have trained. It can be completely different. That is the whole idea of training. It will be able to recognize, for example, that this is a picture from Paris because it is able to recognize the Eiffel Tower. So the way it works internally, if we have to look a little bit under the hood, is these images are nothing but this is digital information in the form of pixels. So each image could be a certain size. It can be 256 by 256 pixel kind of a resolution, and then each pixel is either having a certain grade of color, and all that is fed into the neural network, and it then gets trained in, and it's able to, based on these pixel information, it is able to get trained and able to recognize the features and extract the features, and thereby it is able to identify these images and the location of these images. And then when you feed a new image, it kind of, based on the training, it will be able to figure out where this image is from. So that's the way, a little bit under the hood, how it works. So what are we going to do in this tutorial? We will see what is deep learning and what do we need for deep learning. And one of the main components of deep learning is neural networks. So we will see what is neural network, what is a perceptron, and how to implement logic gates like AND, OR, NOR, and so on using perceptrons, the different types of neural networks, and then applications of deep learning. And we will also see how neural networks works. So how do we do the training of neural networks? And at the end, we will end up with a small demo code which will take you through in TensorFlow. Now, in order to implement deep learning code, there are multiple libraries or development environments that are available, and TensorFlow is one of them. So the focus at the end of this would be on how to use TensorFlow to write a piece of code using Python as a programming language. And we will take up an example which is a very common one, which is like the hello world of deep learning, the handwriting number recognition, which is a MNIST, commonly known as MNIST database. So we will take a look at MNIST database and how we can train a neural network to recognize handwritten numbers. So that's what you will see in this particular video. So let's get started. What is deep learning? Deep learning is like a subset of what is known as a high-level concept called artificial intelligence. You must be already familiar, must have heard about this term, artificial intelligence. So artificial intelligence is like the high-level concept, if you will. And in order to implement artificial intelligence applications, we use what is known as machine learning. And within machine learning, a subset of machine learning is deep learning. Machine learning is a little bit more generic concept, and deep learning is one type of machine learning, if you will. And we will see a little later in maybe the following slides a little bit more in detail how deep learning is different from traditional machine learning. But to start with, we can mention here that deep learning uses one of the differentiators between deep learning and traditional machine learning is that deep learning uses neural networks. And we will talk about what are neural networks and how we can implement neural networks and so on and so forth as a part of this tutorial. So a little deeper into deep learning. Deep learning primarily involves working with complicated unstructured data compared to traditional machine learning where we normally use structured data. In deep learning, the data would be primarily images or voice or maybe text file. And it is a large amount of data as well. And deep learning can handle complex operations. It involves complex operations. And the other difference between traditional machine learning and deep learning is that the feature extraction happens pretty much automatically. In traditional machine learning, feature engineering is done manually. The data scientists, we data scientists have to do feature engineering, feature extraction. But in deep learning, that happens automatically. And of course, deep learning, for large amounts of data, complicated unstructured data, deep learning gives very good performance. Now, as I mentioned, one of the secret sources of deep learning is neural networks. Let's see what neural networks is. Neural networks is based on our biological neurons. The whole concept of deep learning and artificial intelligence is based on human brain, and human brain consists of billions of tiny stuff called neurons, and this is how a biological neuron looks, and this is how an artificial neuron looks. So neural networks is like a simulation of our human brain. Human brain has billions of biological neurons, and we are trying to simulate the human brain using artificial neurons. This is how a biological neuron looks. It has dendrites, and the corresponding component with an artificial neural network is, or an artificial neuron, are the inputs. They receive the inputs through dendrites. And then there is the cell nucleus, which is basically the processing unit in a way. So in artificial neuron also there is a piece which is an equivalent of this cell nucleus, and based on the weights and biases, we will see what exactly weights and biases are as we move. The input gets processed and that results in an output. In a biological neuron, the output is sent through a synapse, and in an artificial neuron there is an equivalent of that in the form of an output. And biological neurons are also interconnected. So there are billions of neurons which are interconnected. In the same way, artificial neurons are also interconnected. So this output of this neuron will be fed as an input to another neuron and so on. Now, in neural network, one of the very basic units is a perceptron. So what is a perceptron? A perceptron can be considered as one of the fundamental units of neural networks. It can consist at least of one neuron, but sometimes it can be more than one neuron. But you can create a perceptron with a single neuron, and it can be used to perform certain functions. It can be used as a basic binary classifier. It can be trained to do some basic binary classification, and this is how a basic perceptron looks like. And this is nothing but a neuron. You have inputs x1, x2, to xn, and there is a summation function, and then there is what is known as an activation function. And based on this input, what is known as the weighted sum, the activation function either gives an output like a 0 or a 1. So we say the neuron is either activated or not. So that's the way it works. So you get the inputs. These inputs are, each of the inputs are multiplied by a weight, and there is a bias that gets added, and that whole thing is fed to an activation function, and then that results in an output. And if the output is correct, it is accepted. If it is wrong, if there is an error, then that error is fed back, and the neuron then adjusts the weights and biases to give a new output, and so on and so forth. So that's what is known as the training process of a neuron or a neural network. There's a concept called perceptron learning. So perceptron learning is again one of the very basic learning processes. The way it works is somewhat like this. So you have all these inputs like x1 to xn, and each of these inputs is multiplied by a weight, and then that sum, this is the formula, the equation. So that sum, wi xi sigma of that, which is the sum of all these product of x and w, is added up, and then a bias is added to that. The bias is not dependent on the input or the input values, but the bias is common for one neuron. However, the bias value keeps changing during the training process. Once the training is completed, the values of these weights, W1, W2, and so on, and the value of the bias gets fixed. So that is basically the whole training process, and that is what is known as the perceptron training. So the weights and biases keep changing till you get the accurate output, and the summation is of course passed through the activation function. As you see here, this wixi summation plus b is passed through activation function, and then the neuron gets either fired or not, and based on that there will be an output. That output is compared with the actual or expected value, which is also known as labeled information. So this is the process of supervised learning. So the output is already known, and that is compared, and thereby we know if there is an error or not. And if there is an error, the error is fed back, and the weights and biases are updated accordingly till the error is reduced to the minimum. So this iterative process is known as perceptron learning or perceptron learning rule, and this error needs to be minimized. So till the error is minimized, this iteratively the weights and biases keep changing, and that is what is the training process. So the whole idea is to update the weights and the bias of the perceptron till the error is minimized. The error need not be 0. The error may not ever reach 0, but the idea is to keep changing these weights and bias so that the error is the minimum possible that it can have. So this whole process is an iterative process, and the iteration continues till either the error is 0, which is unlikely situation, or it is the minimum possible within these given conditions. Now, in 1943, two scientists, Warren McCulloch and Walter Pitts, came up with an experiment where they were able to implement the logical functions like AND, OR, and NOR using neurons. And that was a significant breakthrough in a sense. So they were able to come up with the most common logical gates. They were able to implement some of the most common logical gates, which could take two inputs like A and B and then give a corresponding result. So for example, in case of an AND gate, A and B, and then the output is AB. In case of an OR gate, it is A plus B, and so on and so forth. And they were able to do this using a single layer perceptron. Now, most of these gates, it was possible to use single layer perceptron except for XOR, and we will see why that is in a little bit. So this is how an AND gate works. The inputs A and B, the output should be fired, or the neuron should be fired only when both the inputs are 1. So if you have 0, 0, the output should be 0. For 0, 1, it is again 0, 1, 0 again 0, and 1, 1, the output should be 1. So how do we implement this with a neuron? So it was found that by changing the values of weights, it is possible to achieve this logic. So for example, if we have equal weights like 0.7, 0.7, and then if we take the sum of the weighted product, so for example 0.7 into 0, and then 0.7 into 0 will give you 0, and so on and so forth. And in the last case, when both the inputs are 1, you get a value which is greater than 1, which is the threshold. So only in this case the neuron gets activated and the output is, there is an output. In all the other cases, there is no output because the threshold value is 1. So this is implementation of an AND gate using a single perceptron or a single neuron. Similarly, an OR gate. In order to implement an OR gate, in case of an OR gate, the output will be 1 if either of these inputs is 1. So for example, 0, 1 will result in 1, or rather, in all the cases it is 1 except for 0, 0. So how do we implement this using a perceptron? Once again, if you have a perceptron with weights, for example 1.2, now if you see here, if in the first case when both are 0, the output is 0. In the second case, when it is 0 and 1, 1.2 into 0 is 0, and then 1.2 into 1 is 1. And in the second case, similarly, the output is 1.2. In the last case, when both the inputs are 1, the output is 2.4. So during the training process, these weights will keep changing, and then at one point where the weights are equal to W1 is equal to 1.2 and W2 is equal to 1.2, the system learns that it gives the correct output. So that is implementation of OR gate using a single neuron or a single layer perceptron. Now, XOR gate. This was one of the challenging ones. They tried to implement an XOR gate with a single level perceptron, but it was not possible. And therefore, in order to implement an XOR, so this was like a roadblock in the progress of neural network. However, subsequently they realized that this can be implemented, an XOR gate can be implemented using a multi-level perceptron or MLP. So in this case, there are two layers instead of a single layer, and this is how you can implement an XOR gate. So you will see that X1 and X2 are the inputs, and there is a hidden layer, and that's why it is denoted as H3 and H4, and then you take the output of that and feed it to the output at O5 and provide a threshold here. So we will see here that this is the numerical calculation. So the weights are, in this case for X1 it is 20 and minus 20, and once again 20 and minus 20. So these inputs are fed into H3 and H4. So you will see here for H3 the input is 0, 1, 1, 1, and for H4 it is 1, 0, 1, 1. And if you now look at the output, final output, where the threshold is taken as 1. If we use a sigmoid with the threshold 1, you will see that in these two cases it is 0, and in the last two cases it is 1. So this is the implementation of XOR. In case of XOR, only when one of the inputs is 1, you will get an output. So that is what we are seeing here. If we have either both the inputs are 1 or both the inputs are 0, then the output should be 0. So that is what is an exclusive OR gate. So it is exclusive because only one of the inputs should be 1, and then only you will get an output of 1, which is satisfied by this condition. So this is a special implementation. XOR gate is a special implementation of perceptron. Now that we got a good idea about perceptron, let's take a look at what is a neural network. So we have seen what is a perceptron, we have seen what is a neuron, so we will see what exactly is a neural network. So neural network is nothing but a network of these neurons, and they are different types of neural networks. There are about 5 of them. These are artificial neural network, convolutional neural network, then recursive neural network or recurrent neural network, deep neural network, and deep belief network. So, and each of these types of neural networks have a special, they can solve a special kind of problems. For example, convolutional neural networks are very good at performing image processing and image recognition and so on, whereas RNN are very good for speech recognition and also text analysis and so on. So each type has some special characteristics, and they are good at performing certain special kind of tasks. What are some of the applications of deep learning? Deep learning is today used extensively in gaming. You must have heard about AlphaGo, which is a game created by a startup called DeepMind, which got acquired by Google. And AlphaGo is an AI which defeated the human world champion Lee Sedol in this game of Go. So gaming is an area where deep learning is being extensively used, and a lot of research happens in the area of gaming as well. In addition to that, nowadays there are neural networks or special type called generative adversarial networks, which can be used for synthesizing either images or music or text and so on, and they can be used to compose music. So the neural network can be trained to compose a certain kind of music. And autonomous cars, you must be familiar with Google's self-driving car, and today a lot of automotive companies are investing in this space, and deep learning is a core component of this autonomous cars. The cars are trained to recognize, for example, the road, the lane markings on the road, signals, any objects that are in front, any obstruction, and so on and so forth. So all this involves deep learning. So that's another major application. And robots, we have seen several robots, including Sophia. You may be familiar with Sophia, who was given a citizenship by Saudi Arabia. And there are several such robots which are very human-like, and the underlying technology in many of these robots is deep learning. Medical diagnostics and healthcare is another major area where deep learning is being used. And within healthcare diagnostics, again, there are multiple areas where deep learning and image recognition, image processing can be used. For example, for cancer detection, as you may be aware, if cancer is detected early on, it can be cured. And one of the challenges is in the availability of specialists who can diagnose cancer using these diagnostic images and various scans and so on and so forth. So the idea is to train neural network to perform some of these activities so that the load on the cancer specialist doctors or oncologists comes down. And there is a lot of research happening here, and there are already quite a few applications that are claimed to be performing better than human beings in this space. It can be lung cancer, it can be breast cancer, and so on and so forth. So healthcare is a major area where deep learning is being applied. Let's take a look at the inner working of a neural network. So how does an artificial neural network, let's say, identify, can we train a neural network to identify the shapes like squares and circles and triangles when these images are fed. So this is how it works. Any image is nothing but it is a digital information of the pixels. So in this particular case, let's say this is an image of 28 by 28 pixel and this is an image of a square. There is a certain way in which the pixels are lit up, and so these pixels have a certain value, maybe from 0 to 256, and 0 indicates that it is black or it is dark, and 256 indicates it is white or lit up. So that is like an indication or a measure of how the pixels are lit up. And so this is an image is, let's say, consisting of information of 784 pixels. So all the information what is inside this image can be kind of compressed into these 784 pixels. The way each of these pixels is lit up provides information about what exactly is the image. So we can train neural networks to use that information and identify the images. So let's take a look how this works. So each neuron, the value, if it is close to 1, that means it is white, whereas if it is close to 0, that means it is black. Now this is an animation of how this whole thing works. So these pixels, one of the ways of doing it is we can flatten this image and take this complete 784 pixels and feed that as input to our neural network. The neural network can consist of probably several layers. There can be a few hidden layers, and then there is an input layer and an output layer. Now the input layer takes these 784 pixels as input, the values of each of these pixels, and then you get an output which can be of 3 types or 3 classes. One can be a square, a circle, or a triangle. Now during the training process, there will be initially, obviously you feed this image and it will probably say it's a circle or it will say it's a triangle. So as a part of the training process, we then send that error back, and the weights and the biases of these neurons are adjusted till it correctly identifies that this is a square. That is the whole training mechanism that happens out here. Now let's take a look at a circle. Same way. So you feed these 784 pixels. There is a certain pattern in which the pixels are lit up, and the neural network is trained to identify that pattern. And during the training process, once again, it would probably initially identify it incorrectly, saying this is a square or a triangle, and then that error is fed back and the weights and biases are adjusted finally till it finally gets the image correct. So that is the training process. So now we will take a look at same way a triangle. So now if you feed another image which is consisting of triangles. So this is the training process. Now we have trained our neural network to classify these images into a triangle or a circle and a square. So now this neural network can identify these 3 types of objects. Now if you feed another image, and it will be able to identify whether it's a square or a triangle or a circle. Now what is important to be observed is that when you feed a new image, it is not necessary that the image or the triangle is exactly in this position. Now the neural network actually identifies the patterns. So even if the triangle is, let's say, positioned here, not exactly in the middle but maybe at the corner or in the side, it would still identify that it is a triangle. And that is the whole idea behind pattern recognition. So how does this training process work? This is a quick view of how the training process works. So we have seen that a neuron consists of inputs. It receives inputs, and then there is a weighted sum, which is nothing but this xi, wi summation of that plus the bias. And this is then fed to the activation function, and that in turn gives us a output. Now, during the training process, initially, obviously, when you feed these images, when you send maybe a square, it will identify it as a triangle, and when you maybe feed a triangle, it will identify as a square, and so on. So that error information is fed back, and initially these weights can be random. Maybe all of them have 0 values, and then it will slowly keep changing. So as a part of the training process, the values of these weights, W1, W2, up to Wn, keep changing in such a way that towards the end of the training process, it should be able to identify these images correctly. So till then, the weights are adjusted, and that is known as the training process. And these weights are numeric values. Could be 0.5, 0.25, 0.35, and so on. It could be positive or it could be negative, and the value that is coming here is the pixel value. As we have seen, it can be anything between 0 to 1. You can scale it between 0 to 1 or 0 to 256, whichever way. 0 being black and 256 being white, and then all the other colors in between. So that is the input. So these are numerical values. This multiplication or the product, WIXI, is a numerical value, and the bias is also a numerical value. We need to keep in mind that the bias is fixed for a neuron. It doesn't change with the inputs, whereas the weights are 1 per input. So that is one important point to be noted. But the bias also keeps changing. Initially, it will again have a random value, but as a part of the training process, the weights, the values of the weights W1, W2, Wn, and the value of B will change. And ultimately, once the training process is complete, these values are fixed for this particular neuron. W1, W2 up to Wn, and plus the value of the B is also fixed for this particular neuron. And in this way, there will be multiple neurons, and there may be multiple levels of neurons here, and that's the way the training process works. So this is another example of multi-layer. So there are 2 hidden layers in between, and then you have the input layer, values coming from the input layer, then it goes through multiple layers, hidden layers, and then there is an output layer. And as you can see, there are weights and biases for each of these neurons in each layer, and all of them keeps changing during the training process. And at the end of the training process, all these weights have a certain value, and that is a trained model, and those values will be fixed once the training is completed. Alright, then there is something known as activation function. Neural networks consists of one of the components in neural networks is activation function, and every neuron has an activation function, and there are different types of activation functions that are used. It could be a ReLU, it could be sigmoid, and so on and so forth. And the activation function is what decides whether a neuron should be fired or not. So whether the output should be 0 or 1 is decided by the activation function. And the activation function in turn takes the input, which is the weighted sum. Remember, we talked about WIXI plus B. That weighted sum is fed as an input to the activation function, and then the output can be either a 0 or a 1. And there are different types of activation functions which are covered in an earlier video you might want to watch. Alright, so as a part of the training process, we feed the inputs, the labeled data or the training data, and then it gives an output, which is the predicted output by the network, which we indicate as Y hat. And then there is a labeled data, because for supervised learning, we already know what should be the output. So that is the actual output. And in the initial process, before the training is complete, obviously there will be error. So that is measured by what is known as a cost function. So the difference between the predicted output and the actual output is the error. And the cost function can be defined in different ways. There are different types of cost functions. So in this case, it is like the average of the squares of the error. So, and then all the errors are added, which can sometimes be called as sum of squares. Sum of square errors, or SSE, and that is then fed as a feedback in what is known as backward propagation or back propagation, and that helps in the network adjusting the weights and biases. And so the weights and biases get updated till this value, the error value or the cost function, is minimum. Now there is a optimization technique which is used here called gradient descent optimization, and this algorithm works in a way that the error, which is the cost function, needs to be minimized. So there's a lot of mathematics that goes behind this. For example, they find the local minima and the global minima using the differentiation and so on and so forth. But the idea is this. So as a training process, as the part of training, the whole idea is to bring down the error, which is like, let's say this is the function, the cost function. At certain levels it is very high, the cost value of the cost function, the output of the cost function is very high. So the weights have to be adjusted in such a way, and also the bias of course, that the cost function is minimized. So there is this optimization technique called gradient descent that is used, and this is known as the learning rate. Now gradient descent, you need to specify what should be the learning rate, and the learning rate should be optimal, because if you have a very high learning rate, then the optimization will not converge, because at some point it will cross over to the side. On the other hand, if you have very low learning rate, then it might take forever to converge. So you need to come up with the optimum value of the learning rate, and once that is done, using the gradient descent optimization, the error function is reduced, and that's like the end of the training process. Alright, so this is another view of gradient descent. So this is how it looks. This is your cost function, the output of the cost function, and that has to be minimized using gradient descent algorithm. And these are like the parameters, and weight could be one of them. So initially we start with certain random values, so cost will be high, and then the weights keep changing, and in such a way that the cost function needs to come down, and at some point it may reach the minimum value, and then it may increase. So that is where the gradient descent algorithm decides that, okay, it has reached a minimum value and it will kind of try to stay here. This is known as the global minima. Now sometimes these curves may not be, just for explanation purpose, this has been drawn in a nice way, but sometimes these curves can be pretty erratic. There can be some local minima here, and then there is a peak, and so on. So the whole idea of gradient descent optimization is to identify the global minima and to find the weights and the bias at that particular point. So that's what is gradient descent. And then this is another example. So you can have these multiple local minima. So as you can see, at this point when it is coming down, it may appear like this is a minimum value, but then it is not. This is actually the global minimum value, and the gradient descent algorithm will make an effort to reach this level and not get stuck at this point. So the algorithm is already there, and it knows how to identify this global minimum, and that's what it does during the training process. Now, in order to implement deep learning, there are multiple platforms and languages that are available, but the most common platform nowadays is TensorFlow, and so that's the reason we have this tutorial. We have created this tutorial for TensorFlow. So we will take you through a quick demo of how to write a TensorFlow code using Python. And TensorFlow is an open source platform created by Google. So let's just take a look at the details of TensorFlow. And so this is a library, a Python library, so you can use Python or any other languages. It's also supported in other languages like Java and R and so on. But Python is the most common language that is used. So it is a library for developing deep learning applications, especially using neural networks. And it consists of primarily two parts, if you will. So one is the tensors, and then the other is the graphs or the flow. That's the way the name, that's the reason for this kind of a name called TensorFlow. So what are tensors? Tensors are like multi-dimensional arrays, if you will. That's one way of looking at it. So usually you have a one-dimensional array. So first of all, you can have what is known as a scalar, which means a number. And then you have a one-dimensional array, something like this, which means this is like a set of numbers. So that is a one-dimensional array. Then you can have a two-dimensional array, which is like a matrix. And beyond that, sometimes it gets difficult. So this is a three-dimensional array, but TensorFlow can handle many more dimensions. So it can have multi-dimensional arrays. That is the strength of TensorFlow, and which makes computation, deep learning computation, much faster. And that's the reason why TensorFlow is used for developing deep learning applications. So TensorFlow is a deep learning tool, and this is the way it works. So the data basically flows in the form of tensors, and the way the programming works as well is that you first create a graph of how to execute it, and then you actually execute that particular graph in the form of what is known as a session. We will see this in the TensorFlow code as we move forward. So all the data is managed or manipulated in tensors, and then the processing happens using these graphs. There are certain terms called, like for example, ranks of a tensor. The rank of a tensor is like a dimensionality in a way. So for example, if it is scalar, so there is just a number, just one number, the rank is supposed to be 0, and then it can be a one-dimensional vector, in which case the rank is supposed to be 1, and then you can have a two-dimensional vector, typically like a matrix. Then in that case we say the rank is 2, and then if it is a three-dimensional array, then rank is 3, and so on. So it can have more than 3 as well. So it is possible that you can store multi-dimensional arrays in the form of tensors. So what are some of the properties of TensorFlow? I think today it is one of the most popular platform. TensorFlow is the most popular deep learning platform or library. It is open source. It's developed by Google, developed and maintained by Google, but it is open source. One of the most important things about TensorFlow is that it can run on CPUs as well as GPUs. GPU is a graphical processing unit, just like CPU is central processing unit. Now, in earlier days, GPU was used primarily for graphics, and that's how the name has come. And one of the reasons is that it cannot perform generic activities very efficiently like CPU, but it can perform iterative actions or computations extremely fast and much faster than a CPU. So they are really good for computational activities, and in deep learning there is a lot of iterative computation that happens, so in the form of matrix multiplication and so on. So GPUs are very well suited for this kind of computation, and TensorFlow supports both GPU as well as CPU. And there's a certain way of writing code in TensorFlow. We will see as we go into the code. And of course, TensorFlow can be used for traditional machine learning as well, but then that would be an overkill. But just for understanding, it may be a good idea to start writing code for a normal machine learning use case, so that you get a hang of how TensorFlow code works, and then you can move into neural networks. So that is just a suggestion, but if you're already familiar with how TensorFlow works, then probably you can go straight into the neural networks part. So in this tutorial, we will take the use case of recognizing handwritten digits. This is like a hello world of deep learning, and this is a nice little, the MNIST database is a nice little database that has images of handwritten digits, nicely formatted, because very often in deep learning and neural networks, we end up spending a lot of time in preparing the data for training. And with MNIST database, we can avoid that. You already have the data in the right format, which can be directly used for training. And MNIST also offers a bunch of built-in utility functions that we can straight away use and call those functions without worrying about writing our own functions. And that's one of the reasons why MNIST database is very popular for training purposes. Initially, when people want to learn about deep learning and TensorFlow, this is the database that is used. And it has a collection of 70,000 handwritten digits, and a large part of them are for training. Then you have test, just like in any machine learning process, and then you have validation, and all of them are labeled. So you have the images and their label, and these images, they look somewhat like this. So they are handwritten images collected from a lot of individuals. People have, these are samples written by human beings. They have handwritten these numbers going from 0 to 9. So people have written these numbers, and then the images of those have been taken and formatted in such a way that it is very easy to handle. So that is MNIST database, and the way we are going to implement this in our TensorFlow is we will feed this data, especially the training data, along with the label information. And the data is basically these images are stored in the form of the pixel information, as we have seen in one of the previous slides. All the images are nothing but these are pixels. So an image is nothing but an arrangement of pixels, and the value of the pixel, either it is lit up or it is not, or in somewhere in between. That's how the images are stored, and that is how they are fed into the neural network and for training. Once the network is trained, when you provide a new image, it will be able to identify within a certain error, of course. And for this, we will use one of the simpler neural network configurations called softmax. And for simplicity, what we will do is we will flatten these pixels. So instead of taking them in a two-dimensional arrangement, we just flatten them out. So for example, it starts from here. It is a 28 by 28, so there are 784 pixels. So pixel number 1 starts here, it goes all the way up to 28, then 29 starts here and goes up to 56 and so on. And the pixel number 784 is here. So we take all these pixels, flatten them out, and feed them like one single line into our neural network. And this is what is known as a softmax layer. What it does is, once it is trained, it will be able to identify what digit this is. So there are, in this output layer, there are 10 neurons, each signifying a digit. And at any given point of time, when you feed an image, only one of these 10 neurons gets activated. So for example, if this is trained properly, and if you feed a number 9 like this, then this particular neuron gets activated. So you get an output from this neuron. Let me just use a pen or a laser to show you here. Okay, so you're feeding a number 9. Let's say this has been trained, and now if you're feeding a number 9, this will get activated. Now let's say you feed 1 to the trained network, then this neuron will get activated. If you feed 2, this neuron will get activated, and so on. I hope you get the idea. So this is one type of a neural network or an activation function known as softmax layer. So that's what we will be using here. This is one of the simpler ones for quick and easy understanding. So this is how the code would look. We will go into our lab environment in the cloud, and we will show you there directly. But very quickly, this is how the code looks. And let me run you through briefly here, and then we will go into the Jupyter notebook where the actual code is, and we will run that as well. So as a first step, first of all, we are using Python here, and that's why the syntax of the language is Python. And the first step is to import the TensorFlow library. So, and we do this by using this line of code saying import TensorFlow as TF. TF is just for convenience, so you can give any name. And once you do this, TensorFlow is available as an object in the name of TF, and then you can run its methods and accesses its attributes and so on and so forth. And MNIST database is actually an integral part of TensorFlow, and that's again another reason why we, as a first step, we always use this example, MNIST database example. So you just simply import MNIST database as well using this line of code, and you slightly modify this so that the labels are in this format, what is known as one hot true, which means that the label information is stored like an array. And let me just use the pen to show what exactly it is. So when you do this one hot true, what happens is each label is stored in the form of an array of 10 digits, and let's say the number is 8. Okay, so in this case, all the remaining values, there will be a bunch of zeros. So this is like array at position 0, this is at position 1, position 2, and so on and so forth. Let's say this is position 7, then this is position 8. That will be 1 because our input is 8, and again position 9 will be 0. Okay, so one hot encoding, this one hot encoding true will kind of load the data in such a way that the labels are in such a way that only one of the digits has a value of 1, and that indicates. So based on which digit is 1, we know what is the label. So in this case, the 8th position is 1, therefore we know this sample data, the value is 8. Similarly, if you have a 2 here, let's say, then the labeled information will be somewhat like this. So you have your labels. So you have this as 0, the 0th position. The first position is also 0. The second position is 1 because this indicates number 2. And then you have third as 0 and so on. Okay, so that is the significance of this one hot true. All right, and then we can check how the data is looking by displaying the data. And as I mentioned earlier, this is pretty much in the form of digital form, like numbers. So all these are like pixel values, so you will not really see an image in this format, but there is a way to visualize that image. I will show you in a bit. And this tells you how many images are there in each set. So the training, there are 55,000 images in training, and in the test set there are 10,000, and then validation there are 5,000. So altogether there are 70,000 images. All right, so let's move on, and we can view the actual image by using the matplotlib library, and this is how you can view. This is the code for viewing the images, and you can view them in color or you can view them in grayscale. So the CMap is what tells in what way we want to view it, and what are the maximum values and the minimum values of the pixel values. So these are the max and minimum values of the pixel values. So maximum is 1 because this is a scaled value. So 1 means it is white, and 0 means it is black, and in between is, it can be anywhere in between black and white. And the way to train the model, there is a certain way in which you write your TensorFlow code, and the first step is to create some placeholders, and then you create a model. In this case we will use the softmax model, one of the simplest ones, and placeholders are primarily to get the data from outside into the neural network. So this is a very common mechanism that is used. And then of course you will have variables, which are your, remember, these are your weights and biases. So in our case there are 10 neurons, and each neuron actually has 784 because each neuron takes all the inputs. If we go back to our slide here, actually every neuron takes all the 784 inputs. Right? This is the first neuron. It receives all the 784. This is the second neuron. This also receives all the 708. So each of these inputs needs to be multiplied with a weight, and that's what we are talking about here. So this is a matrix of 784 values for each of the neurons, and so it is like a 10 by 784 matrix because there are 10 neurons. And similarly, there are biases. Now remember, I mentioned bias is only 1 per neuron, so it is not 1 per input, unlike the weights. So therefore there are only 10 biases because there are only 10 neurons in this case. So that is what we are creating a variable for biases. So this is something little new in TensorFlow. You will see, unlike our regular programming languages where everything is a variable, here the variables can be of 3 different types. You have placeholders, which are primarily used for feeding data. You have variables, which can change during the course of computation. And then a third type, which is not shown here, are constants. So these are like fixed numbers. All right. So in a regular programming language, you may have everything as variables or at the most variables and constants. But in TensorFlow, you have 3 different types: placeholders, variables, and constants. And then you create what is known as a graph. So TensorFlow programming consists of graphs and tensors, as I mentioned earlier. So this can be considered ultimately as a tensor. And then the graph tells how to execute the whole implementation, so that the execution is stored in the form of a graph. And in this case, what we are doing is we are doing a multiplication. TF, you remember this TF was created as a TensorFlow object here. One more level, one more. So TF is available here. Now TensorFlow has what is known as a matrix multiplication or MLFull function. So that is what is being used here in this case. So we are using the matrix multiplication of TensorFlow so that you multiply your input values x with w, right? This is what we were doing, xw plus b. You're just adding b, and this is in very similar to one of the earlier slides where we saw sigma xi wi. So that's what we are doing here. Matrix multiplication is multiplying all the input values with the corresponding weights and then adding the bias. So that is the graph we created. And then we need to define what is our loss function and what is our optimizer. So in this case, we again use the TensorFlow's APIs. So tf.nn softmax cross entropy with logits is the API that we will use, and reduce mean is what is like the mechanism whereby which says that you reduce the error. And optimizer for doing reduction of the error, what optimizer are we using? So we are using gradient descent optimizer. We discussed about this in a couple of slides earlier. And for that, you need to specify the learning rate. You remember we saw that there was a slide somewhat like this, and then you define what should be the learning rate, how fast you need to come down. That is the learning rate. And this again needs to be tested and tried, and to find out the optimum level of this learning rate. It shouldn't be very high, in which case it will not converge, or shouldn't be very low, because it will, in that case, it will take very long. So you define the optimizer and then you call the method minimize for that optimizer, and that will kickstart the training process. And so far we've been creating the graph, and in order to actually execute that graph, we create what is known as a session, and then we run that session. And once the training is completed, we specify how many times, how many iterations we want it to run. So for example, in this case, we are saying 1000 steps. So that is a exit strategy in a way. So you specify the exit condition. So training will run for 1000 iterations. And once that is done, we can then evaluate the model using some of the techniques shown here. So let us get into the code quickly and see how it works. So this is our cloud environment. Now you can install TensorFlow on your local machine as well. I'm showing this demo on our existing cloud, but you can also install TensorFlow on your local machine, and there is a separate video on how to set up your TensorFlow environment. You can watch that if you want to install your local environment. Or you can go for any cloud service, like for example Google Cloud, Amazon, or Cloud Labs. Any of these you can use and run and try the code. Okay, so it has got started. We will log in. Alright, so this is our deep learning tutorial code, and this is our TensorFlow environment. And so let's get started. We have seen a little bit of a code walkthrough in the slides as well. Now you will see the actual code in action. So the first thing we need to do is import TensorFlow, and then we will import the data. And we need to adjust the data in such a way that the one hot encoding is set to true, one hot encoding, right? As I explained earlier. So in this case, the label values will be shown appropriately. And if we just check what is the type of the data, so you can see that this is a data sets, Python data sets. And if we check the number of images, the way it looks, so this is how it looks. It is an array of type float 32. Similarly, the number, if you want to see what is the number of training images, there are 55,000, then there are test images 10,000, and then validation images 5,000. Now let's take a quick look at the data itself, visualization. So we will use matplotlib for this. And if we take a look at the shape, now shape gives us like the dimension of the tensors or the arrays, if you will. So in this case, the training data set, if we see the size of the training data set using the method shape, it says there are 55,000, and 55,000 by 784. So remember, the 784 is nothing but the 28 by 28, 28 into 28. So that is equal to 784. So that's what it is showing. Now we can take just one image and just see what is the first image and see what is the shape. So again, size, obviously it is only 784. Similarly, you can look at the image itself, the data of the first image itself. So this is how it shows. So large part of it will probably be zeros, because as you can imagine, in the image only certain areas are written, rest is blank. So that's why you will mostly see zeros, either it is black or white. But then there are these values are, so the values are actually, they are scaled, so their values are between 0 and 1. Okay, so this is what you're seeing. So certain locations there are some values, and then other locations there are zeros. So that is how the data is stored and loaded. If we want to actually see what is the value of the handwritten image, if you want to view it, this is how you view it. So you create, like, do this reshape, and Matplotlib has this feature to show you these images. So we will actually use the function called IMShow, and then if you pass this parameters appropriately, you will be able to see the different images. Now I can change the values in this position, so which image we are looking at, right? So we can say, if I want to see what is there in maybe 5000, right? So 5000 has 3. Similarly, you can just say 5. What is in 5? 5 has 8. What is in 50? Again 8. So basically, by the way, if you're wondering how I'm executing this code, Shift Enter, in case you're not familiar with Jupyter Notebooks, Shift Enter is how you execute each cell, individual cell. And if you want to execute the entire program, you can go here and say run all. So that is how this code gets executed. And here again, we can check what is the maximum value and what is the minimum value of these pixel values. As I mentioned, it is scaled, so therefore it is between, the values lie between 1 and 0. Now this is where we create our model. The first thing is to create the required placeholders and variables, and that's what we are doing here, as we have seen in the slides. So we create one placeholder and we create 2 variables, which is for the weights and biases. These 2 variables are actually matrices. So each variable has 784 by 10 actual values. Okay, so one for this 10 is for each neuron. There are 10 neurons, and 784 is for the pixel values inputs that are given, which is 28 into 28. And the biases, as I mentioned, one for each neuron, so there will be 10 biases. They are stored in a variable by the name B. And this is the graph, which is basically the multiplication of these matrix multiplication of X into W, and then the bias is added for each of the neurons. And the whole idea is to minimize the error. So let me just execute. I think this code is executed. Then we define what is the Y value is basically the label value. So this is another placeholder. We had X as one placeholder and Y underscore true as a second placeholder, and this will have values in the form of 10 digit arrays. And since we said one hot encoded, the position which has a 1 value indicates what is the label for that particular number. All right, then we have cross entropy, which is nothing but the loss function, and we have the optimizer. We have chosen gradient descent as our optimizer. Then the training process itself. So the training process is nothing but to minimize the cross entropy, which is again nothing but the loss function. So we define all of this in the form of a graph. So up to here, remember what we have done is we have not exactly executed any TensorFlow code till now. We are just preparing the graph, the execution plan. That's how the TensorFlow code works. So the whole structure and format of this code will be completely different from how we normally do programming. So even with people with programming experience may find this a little difficult to understand it, and it needs quite a bit of practice. So you may want to view this video also maybe a couple of times to understand this flow, because the way TensorFlow programming is done is slightly different from the normal programming. Some of you who, let's say, have done maybe Spark programming to some extent will be able to easily understand this, but even in Spark, the programming, the code itself is pretty straightforward. Behind the scenes, the execution happens slightly differently. But in TensorFlow, even the code has to be written in a completely different way. So the code doesn't get executed in the same way as you have written. So that's something you need to understand, and a little bit of practice is needed for this. So far what we have done up to here is creating the variables and feeding the variables, and or rather not feeding, but setting up the variables and the graph. That's all. Defining maybe the what kind of a network you want to use. For example, we want to use softmax and so on. So you have created the variables, how to load the data, loaded the data, viewed the data, and prepared everything, but you have not yet executed anything in TensorFlow. Now the next step is the execution in TensorFlow. So the first step for doing any execution in TensorFlow is to initialize the variables. So anytime you have any variables defined in your code, you have to run this piece of code always. So you need to basically create what is known as a node for initializing. So this is a node. You still are not yet executing anything here. You just created a node for the initialization. So let us go ahead and create that. And here onwards is where you will actually execute your code in TensorFlow. And in order to execute the code, what you will need is a session, TensorFlow session. So tf.session will give you a session, and there are a couple of different ways in which you can do this, but one of the most common methods of doing this is with what is known as a with loop. So you have a with tf.session as ses and with a colon here, and this is like a block, starting of the block, and these indentations tell how far this block goes, and this session is valid till this block gets executed. So that is the purpose of creating this with block. This is known as a with block. So with tf.session as ses, you say ses.run init. Now ses.run will execute a node that is specified here. So for example, here we are saying ses.run. Ses is basically an instance of the session, right? So here we are saying tf.session. So an instance of the session gets created and we are calling that ses. And then we run a node within that, one of the nodes in the graph. So one of the nodes here is init. So we say run that particular node, and that is when the initialization of the variables happens. Now what this does is, if you have any variables in your code, in our case we have w is a variable and b is a variable. So any variables that we created, you have to run this code, you have to run the initialization of these variables, otherwise you will get an error. Okay, so that's what this is doing. Then we, within this with block, we specify a for loop, and we are saying we want the system to iterate for 1,000 steps and perform the training. That's what this for loop does. Run training for 1,000 iterations. And what it is doing basically is it is fetching the data or these images. Remember, there are about 50,000 images, but it cannot get all the images in one shot because it will take up a lot of memory and performance issues will be there. So this is a very common way of performing deep learning training. You always do in batches. So we have maybe 50,000 images, but you always do it in batches of 100 or maybe 500 depending on the size of your system and so on and so forth. So in this case we are saying, okay, get me 100 images at a time and get me only the training images. Remember, we use only the training data for training purpose, and then we use test data for test purpose. You must be familiar with machine learning, so you must be aware of this. But in case you are not, in machine learning also, this is not specific to deep learning, but in machine learning in general, you have what is known as training data set and test data set. Your available data, typically you will be splitting into two parts and using the training data set for training purpose. And then to see how well the model has been trained, you use the test data set to check or test the validity or the accuracy of the model. So that's what we are doing here. And you observe here that we are actually calling an MNIST function here. So we are saying MNIST train.next batch. Right? So this is the advantage of using MNIST database, because they have provided some very nice helper functions which are readily available. Otherwise, this activity itself, we would have had to write a piece of code to fetch this data in batches. That itself is a lengthy exercise. So we can avoid all that if we are using MNIST database, and that's why we use this for the initial learning phase. Okay, so when we say fetch, what it will do is it will fetch the images into X and the labels into Y, and then you use this batch of 100 images and you run the training. So ses.run, basically what we are doing here is we are running the training mechanism, which is nothing but it passes this through the neural network, passes the images through the neural network, finds out what is the output, and if the output, obviously initially it will be wrong, so all that feedback is given back to the neural network, and thereby all the W's and B's get updated till it reaches 1000 iterations. In this case, the exit criteria is 1000, but you can also specify probably accuracy rate or something like that for the as an exit criteria. So here it just says that, okay, this particular image was wrongly predicted, so you need to update your weights and biases. That's the feedback given to each neuron, and that is run for 1000 iterations. And typically by the end of this 1000 iterations, the model would have learned to recognize these handwritten images. Obviously, it will not be 100% accurate. Okay, so once that is done, so this happens for 1000 iterations. Once that is done, you then test the accuracy of these models by using the test data set. Right? So this is what we are trying to do here. The code may appear a little complicated because if you're seeing this for the first time, you need to understand the various methods of TensorFlow and so on. But it is basically comparing the output with what is actually there. That's all it is doing. So you have your test data and you're trying to find out what is the actual value and what is the predicted value and seeing whether they are equal or not, tf.equal, right? And how many of them are correct and so on and so forth. And based on that, the accuracy is calculated as well. So this is the accuracy, and that is what we are trying to see, how accurate the model is in predicting these numbers or these digits. Okay, so let us run this. This entire thing is in one cell. So we will have to just run it in one shot. It may take a little while. Let us see. And not bad. So it has finished the 1000 iterations. And what we see here as an output is the accuracy. So we see that the accuracy of this model is around 91%. Okay. Now, which is pretty good for such a short exercise. Within such a short time, we got 90% accuracy. However, in real life, this is probably not sufficient. So there are other ways to increase the accuracy. We will see probably in some of the later tutorials how to improve this accuracy, how to change maybe the hyperparameters like number of neurons or number of layers and so on and so forth, and so that this accuracy can be increased beyond 90%.
Hello and welcome to the TensorFlow Object Detection API tutorial. In this video, I will walk you through the TensorFlow code to perform object detection in a video. So let's get started. This part is basically you're importing all the libraries. We need a lot of these libraries, for example, NumPy, we need image IO, datetime, and MLFull, and so on and so forth, and of course matplotlib. So we import all these libraries, and then there are a bunch of variables which have some paths for the files and folders. So this is regular stuff. Let's keep moving. Then we import the matplotlib and make it inline, and a few more imports. All right. And then these are some warnings. We can just ignore them. So if I run this code once again, it will go away. All right. And then here onwards, we do the model preparation. Now what we're going to do is we are going to use an existing neural network model. So we are not going to train a new one because that really will take a long time, and it needs a lot of computation resources and so on, and it is really not required. There are already models that have been trained, and in this case it is the SSD with MobileNet. That's the model that we are going to use, and this model is trained to detect objects, and it is readily available as open source, so we can actually use this. And if you want to use other models, there are a few more models available, so you can click on this link here, and let me just take you there. There are a few more models, but we have chosen this particular one because this is faster. It may not be very accurate, but that is one of the faster models. But on this link you will see a lot of other models that are readily available. These are trained models. Some of them would take a little longer, but they may be more accurate and so on, so you can probably play around with these other models. Okay, so we will be using that model. So this piece of code, this line, is basically importing that model, and this is also known as frozen model. The term we use is frozen model. So we import, download and import that, and then we will actually use that model in our code. Alright, so these two cells, we have downloaded and imported the model, and then once it is available locally, we will then load this into our program. Alright, so we are loading this into memory, and you need to perform a couple of additional steps, which is basically we need to map the numbers to text. As you may be aware, when we actually build the model and when we run predictions, the model will not give a text. The output of the model is usually a number. So we need to map that to a text. So for example, if the network predicts that the output is 5, we know that 5 means it is an aeroplane. So things like that. So this mapping is done in this next cell. Alright, so let's keep moving. And then we have a helper code which will basically load the data or load the images and transform into NumPy arrays. This is also used in doing object detection in images. So we are actually going to reuse, because video is nothing but it consists of frames, which in turn are images. So we are going to pretty much reuse the same code which we used for doing object detection in images. So this is where the actual detection starts. So here, this is the path for where the images are stored. So this is, here once again we are reusing the code which we wrote for detecting objects in an image. So this is the path where the images were stored, and this is the extension, and this was done for about 2 or 3 images. So we will continue to use this, and if we go down, I'll skip this section. So this is the cell where we are actually loading the video and converting it into frames, and then using frame by frame we are detecting the objects in the image. So in this code, what we are doing basically is there are a few lines of code. What they do is basically once they find an object, a box will be drawn around those each of those objects, and the input file, the name of the input video file is traffic. It is the extension is MP4, and we have this video reader. It's an excellent object which is basically part of this class called image.io, so we can read and write videos using that. And the video that we are going to use is traffic.mp4. You can use any MP4 file, but in our case I picked up video which has like car. So let me just show you. So this is in this object detection folder. I have this MP4 file. I'll just quickly play this video. It's a little slow. Yeah, okay. So here we go. This is the video. It's a short one, relatively small video, so that for this particular demo. And what it will do is, once we run our code, it will detect each of these cars and it will annotate them as cars. So in this particular video we only have cars. We can later on see with another video. I think I have cat here, so we can also try with that, but let's first check with this traffic video. So let me go back. So we will be reading this frame by frame, and no, actually we will be reading the video file, but then we will be analyzing it frame by frame, and we will be reading them at 10 frames per second. That is the rate we are mentioning here, and analyzing it and then annotating and then writing it back. So you will see that we will have a video file named something like this, traffic_annotated, and we will see the annotated video. So let's go back and run through this piece of code, and then we will come back and see the annotated video. This might take a little while, so I will pause the video after running this particular cell and then come back to show you the results. Alright, so let's go ahead and run it. So it is running now, and it is also important that at the end you close the video writer, so that it is similar to a file pointer. When you open a file, you should also make sure you close it so that it doesn't hog the resources. So it's very similar. So at the end of it, the last piece or last line of code should be video_writer.close. Alright, so I'll pause and then I'll come back. Okay, so I will see you in a little bit. Alright, so now as you can see here, the processing is done. The hourglass has disappeared. That means the video has been processed. So let's go back and check the annotated video. I'll go back to my file manager. So this was the original traffic.mp4, and now you have here traffic_annotated mp4. So let's go and run this and see how it looks. You see here, it has got each of these cars are getting detected. Let me pause and show you. So we pause here. It says car 70%. Let us allow it to go a little further. It detects something on top. What is that? Truck. Okay. So I think because of the board on top, it somehow thinks there is a truck. Let's play some more and see if it detects anything else. So this is again a car, looks like. So let us, yeah. So this is a car, and it has confidence level of 69%. Okay, this is again a car. Alright, so basically till the end it goes and detects each and every car that is passing by. Now we can quickly repeat this process for another video. Let me just show you the other video, which is a cat. Again, there is this cat is not really moving or anything, but it is just standing there staring and moving a little slowly, and our application will, our network will detect that this is a cat, and even when the cat moves a little bit in the other direction, it will continue to detect and show that it is a cat. Okay, so yeah, so this is how the original video is. Let's go ahead and change our code to analyze this one and see if it detects, our network detects this cat. Close this, here we go, and I'll go back to my code. All we need to do is change this traffic to cat. The extension, it will automatically up because it is given here, and then it will run through. So very quickly, once again, what it is doing is this video reader, video_reader, has a neat little feature or interface whereby you can say for frame in video_reader. So it will basically provide frame by frame. So you are in a loop frame by frame, and then you take that each frame that is given to you, you take it and analyze it as if it is an image, individual image. So that's the way it works. So it is very easy to handle this. Alright, so now let's once again run just this cell. The rest of the stuff remains the same. So I will run this cell again. It will take a little while, so the hourglasses come back. I will pause and then come back in a little while. Alright, so the processing is done. Let's go and check the annotated video. Go here. So we have cat annotated.mp4. Let's play this. Alright, so you can see here it is detecting the cat, and in the beginning you also saw it detected something else here. There looks like it detected one more object. So let's just go back and see what it has detected here. Let's see. Yes. So what is it trying to show here? It's too small, not able to see, but it is trying to detect something. I think it is saying it is a car. I don't know. Alright, okay, so in this video there's pretty much only one object, which is the cat, and let's wait for some time and see if it continues to detect it when the cat turns around and moves as well. Just in a little bit that's going to happen, and we will see. There we go. And in spite of turning the other way, I think our network is able to detect that it is a cat. So let me freeze and then show here. It is actually still continues to detect it as a cat. Alright, so that's pretty much it. I think that's the only object that it detects in this particular video. Okay, so close this. So that's pretty much it. Thank you very much for watching this video, and you have a great day. And in case you have any questions, please put them below the video here, and we will be more than happy to get back to you. And make sure you put your email ID so that we can contact you in case you have any questions. Thank you once again. Bye-bye.
Today we're going to be covering the convolutional neural network tutorial. Do you know how deep learning recognizes the objects in an image? And really, this particular neural network is how image recognition works. It's very central, one of the biggest building blocks for image recognition. It does it using convolution neural network. And over here we have the basic picture of a hummingbird. Pixels of an image fed as input. You have your input layer coming in, so it takes that graphic and puts it into the input layer. You have all your hidden layers. And then you have your output layer, and your output layer, one of those is going to light up and say, oh, it's a bird. We're going to go into depth. We're going to actually go back and forth on this a number of times today. So if you're not catching all the image, don't worry, we're going to get into the details. So we have our input layer accepts the pixels of the image as input in the form of arrays. And you can see up here where they've actually labeled each block of the bird in different arrays. So we'll dive into deep as to how that looks like and how those matrices are set up. Your hidden layer carry out feature extraction by performing certain calculations and manipulations. So this is the part that kind of reorganizes that picture multiple ways until we get some data that's easy to read for the neural network. This layer uses a matrix filter and performs convolution operation to detect patterns in the image. And if you remember that convolution means to coil or to twist. So we're going to twist the data around and alter it and use that operation to detect a new pattern. There are multiple hidden layers like convolution layer. ReLU is how that is pronounced. And that's the rectified linear unit. That has to do with the activation function that's used. Pooling layer also uses multiple filters to detect edges, corners, eyes, feathers, beak, etc. And just like the term says, pooling is pooling information together. And we'll look into that a lot closer here. So if it's a little confusing now, we'll dig in deep and try to get you squared away with that. And then finally, there is a fully connected layer that identifies the object in the image. So we have these different layers coming through in the hidden layers, and they come into the final area, and that's where we have, say, one node or one neural network entity that lights up that says it's a bird. What's in it for you? We're going to cover an introduction to the CNN, what is convolution neural network, how CNN recognizes images. We're going to dig deeper into that and really look at the individual layers in the convolutional neural network. And finally, we do a use case implementation using the CNN. We'll begin our introduction to the CNN by introducing the pioneer of convolutional neural network, Yann LeCun. He was the director of Facebook AI Research Group. Built the first convolutional neural network called LeNet in 1988. So these have been around for a while and have had a chance to mature over the years. It was used for character recognition tasks like reading zip code digits. Imagine processing mail and automating that process. CNN is a feed-forward neural network that is generally used to analyze visual images by producing data with a grid-like topology. A CNN is also known as a convnet. And very key to this is we are looking at images. That was what this was designed for. And you'll see the different layers as we dig in mirror some of them are actually now used since we're using TensorFlow and Keras in our code later on. You'll see that some of those layers appear in a lot of your other neural network frameworks. But in this case, this is very central to processing images and doing so in a variety that captures multiple images and really drills down into their different features. In this example here you see flowers of two varieties, orchid and a rose. I think the orchid is much more dainty and beautiful, and the rose smells quite beautiful. I have a couple rose bushes in my yard. They go into the input layer. That data is then sent to all the different nodes in the next layer, one of the hidden layers, based on its different weights and its setup. It then comes out and gives those a new value. Those values then are multiplied by their weights and go to the next hidden layer, and so on. And then you have the output layer, and one of those nodes comes out and says it's an orchid, and the other one comes out and says it's a rose, depending on how well it was trained. What separates the CNN, or the convolutional neural network, from other neural networks is a convolutional operation. Forms the basis of any convolutional neural network. In a CNN, every image is represented in the form of arrays of pixel values. So here we have a real image of the digit 8. That then gets put onto its pixel values, represented in the form of an array. In this case, you have a two-dimensional array. And then you can see in the final end form, we transform the digit 8 into its representational form of pixels of zeros and ones, where the ones represent, in this case, the black part of the 8, and the zeros represent the white background. To understand the convolution neural network, or how that convolutional operation works, we're going to take a sidestep and look at matrices. In this case, we're going to simplify it, and we're going to take two matrices, A and B, of one dimension. Now, kind of separate this from your thinking as we learn that you want to focus just on the matrix aspect of this. And then we'll bring that back together and see what that looks like when we put the pieces for the convolutional operation. Here we've set up two arrays. We have, in this case, they're a single dimension matrix. And we have A equals 5, 3, 7, 5, 9, 7. And we have B equals 1, 2, 3. So in the convolution, as it comes in there, it's going to look at these two, and we're going to start by multiplying them, A times B. And so we multiply the arrays element-wise, and we get 5, 6, 6, where 5 is the 5 times 1, 6 is 3 times 2, and then the other 6 is 2 times 3. And since the two arrays aren't the same size, they're not the same setup, we're going to just truncate the first one, and we're going to look at the second array multiplied just by the first three elements of the first array. Now that's going to be a little confusing. Remember, a computer gets to repeat these processes hundreds of times, so we're not going to just forget those other numbers later on. We'll bring those back in. And then we have the sum of the product. In this case, 5 plus 6 equals 17. So in our A times B, our very first digit in that matrix of A times B is 17. And if you remember, I said we're not going to forget the other digits. So we now have 3, 2, 5. We move one set over, and we take 3, 2, 5, and we multiply that times B. And you'll see that 3 times 1 is 3, 2 times 2 is 4, and so on and so on. We sum it up, so now we have the second digit of our A times B product in the matrix. And we continue on with that same thing, so on and so on. So then we would go from 375 to 759 to 597. This short matrix that we have for A, we've now covered all the different entities in A that match three different levels of B. Now, in a little bit, we're going to cover where we use this math at, this multiplying of matrices and how that works. But it's important to understand that we're going through the matrix and multiplying the different parts to it to match the smaller matrix with the larger matrix. I know a lot of people get lost at is, what's going on here with these matrices? Ooh, scary math. Not really that scary when you break it down. We're looking at a section of A and we're comparing it to B. So when you break that down in your mind like that, you realize, okay, so I'm just taking these two matrices and comparing them, and I'm bringing the value down into one matrix, A times B. We're reducing that information in a way that will help the computer see different aspects. Let's go ahead and flip over again back to our images. Here we are back to our images. Talking about going to the most basic two-dimensional image you can get to. Consider the following two images. The image for the symbol backslash. When you press the backslash, the above image is processed. And you can see there for the image for the forward slash is the opposite. So when we click the forward slash button, that flips. Very basic. We have 4 pixels going in. Can't get any more basic than that. Here we have a little bit more complicated picture. We take a real image of a smiley face. Then we represent that in the form of black and white pixels. So if this was an image in the computer, it's black and white. And like we saw before, we convert this into the zeros and ones. So where the other one would have just been a matrix of just 4 dots, now we have a significantly larger image coming in. So don't worry, we're going to bring this all together here in just a little bit. Layers in convolutional neural network. When we're looking at this, we have our convolution layer. And that really is the central aspect of processing images in the convolutional neural network. That's why we have it. And then that's going to be feeding in. And you have your ReLU layer, which is, as we talked about, the rectified linear unit. We'll talk about that a little bit later. The ReLU is how that layer is activated, is the math behind it, what makes the neurons fire. You'll see that in a lot of other neural networks. When you're using it just by itself, it's for processing smaller amounts of data, where you use the atom activation feature for large data coming in. Now, because we're processing small amounts of data in each image, the ReLU layer works great. You have your pooling layer. That's where you're pooling the data together. Pooling is a neural network term. It's very commonly used. I like to use the term reduce. So if you're coming from the map and reduce side, you'll see that we're mapping all this data through all these networks, and then we're going to reduce it. We're going to pool it together. And then finally we have the fully connected layer. That's where our output's going to come out. So we have started to look at matrices. We've started to look at the convolutional layer and where it fits in and everything. We've taken a look at images. So we're going to focus more on the convolution layer, since this is a convolutional neural network. A convolution layer has a number of filters and perform convolution operation. Every image is considered as a matrix of pixel values. Consider the following 5x5 image whose pixel values are only 0 and 1. Now obviously when we're dealing with color, there's all kinds of things that come in on color processing, but we want to keep it simple and just keep it black and white. And so we have our image pixels, so we're sliding the filter matrix over the image and computing the dot product to detect the patterns. And right here, you're going to ask, where does this filter come from? This is a bit confusing because the filter is going to be derived later on. We build the filters when we program or train our model. So you don't need to worry what the filter actually is, but you do need to understand how a convolution layer works, is what is the filter doing. Filter, and you'll have many filters. You don't have just one filter. You'll have lots of filters that are going to look for different aspects. And so the filter might be looking for just edges, it might be looking for different parts. We'll cover that in a little bit more detail in a minute. Right now we're just focusing on how the filter works as a matrix. Remember earlier we talked about multiplying matrices together? And here we have our two-dimensional matrix. And you can see we take the filter and we multiply it in the upper left image, and you can see right here 1 times 1, 1 times 0, 1 times 1. We multiply those all together, then sum them, and we end up with a convolved feature of 4. We're going to take that and sliding the filter matrix over the image and computing the dot product to detect patterns. So we're just going to slide this over. We're going to predict the first one and slide it over 1 notch, predict the second one, and so on all the way through until we have a new matrix. And this matrix, which is the same size as the filter, has reduced the image, and whatever that's filtering out is going to be looking at just those features reduced down to a smaller matrix. So once the feature maps are extracted, the next step is to move them to the ReLU layer. So the ReLU layer, the next step, first is going to perform an element-wise operation. So each of those maps coming in, if there's negative pixels, so it sets all the negative pixels to 0. And you can see this nice graph where it just zeroes out the negatives, and then you have a value that goes from 0 up to whatever value is coming out of the matrix. This introduces nonlinearity to the network. So up until now, when we say linearity, we're talking about the fact that the feature has a value. So it's a linear feature. This feature came up and it has, let's say the feature is the edge of the beak. It's like, or the backslash that we saw. You'll look at that and say, okay, this feature has a value from -10 to 10 in this case. If it was 1, it'd say, yeah, this might be a beak. It might not. It might be an edge right there. A -5 means, no, we're not even going to look at it. It's a 0. And so we end up with an output, and the output takes all these filtered features. Remember, we're not just running one filter on this, we're running a number of filters on this image. And so we end up with a rectified feature map that is looking at just the features coming through and how they weigh in from our filters. So here we have an input of it looks like a toucan bird. Very exotic looking. Real image is scanned in multiple convolution and the ReLU layers for locating features. And you can see up here is turn it into a black and white image. And in this case, we're looking in the upper right-hand corner for a feature, and that box scans over. A lot of times it doesn't scan 1 pixel at a time. A lot of times it will skip by 2 or 3 or 4 pixels to speed up the process. That's one of the ways you can compensate if you don't have enough resources on your computation for large images. And it's not just one filter that slowly goes across the image. You have multiple filters that have been programmed in there. So you're looking at a lot of different filters going over the different aspects of the image and just sliding across there and forming a new matrix. One more aspect to note about the ReLU layer is we're not just having one ReLU coming in. So not only do we have multiple features going through, but we're generating multiple ReLU layers for locating the features. That's very important to note. So we have quite a bundle. We have multiple filters, multiple ReLU, which brings us to the next step, forward propagation. Now we're going to look at the pooling layer. The rectified feature map now goes through a pooling layer. Pooling is a downsampling operation that reduces the dimensionality of the feature map. That's all we're trying to do. We're trying to take a huge amount of information and reduce it down to a single answer. This is a specific kind of bird. This is an iris. This is a rose. So you have a rectified feature map. And you see here we have a rectified feature map coming in. We set the max pooling with a 2x2 filters and a stride of 2. And if you remember correctly, I talked about not going 1 pixel at a time. Well, that's where the stride comes in. We end up with a 2x2 pooled feature map, but instead of moving 1 over each time and looking at every possible combination, we skip a few there. We go by 2. We skip every other pixel. We just do every other one. And this reduces our rectified feature map, which as you can see over here, 16 by 16 to a 4 by 4. So we're continually trying to filter and reduce our data so that we can get to something we can manage. And over here you see that we have the max 3, 4, 1, and 2. And in the max pooling, we're looking for the max value. A little bit different than what we were looking at before. So coming from the rectified feature, we're now finding the max value and then we're pooling those features together. So instead of thinking of this as image of the map, think of this as how valuable is a feature in that area? How much of a feature value do we have? And we just want to find the best or the maximum feature for that area. They might have that one piece of the filter of the beak said, oh, I see a 1 in this beak in this image, and then it skips over and says, I see a 3 in this image, and it says, oh, this one is rated as a 4. We don't want to sum it together because then you might have like 5 ones and it'll say 5, but you might have 4 zeros and 1 10, and that 10 says, well, this is definitely a beak, where the ones will say probably not a beak. A little strange analogy since we're looking at a bird, but you can see how that pooled feature map comes down, and we're just looking for the max value in each one of those matrices. Pooling layer uses different filters to identify different parts of the image, like edges, corners, body, feathers, eyes, beak, etc. I know I focus mainly on the beak, but obviously each feature could be a different part of the bird coming in. So let's take a look at what that looks like. Structure of a convolution neural network so far. This is where we're at right now. We have our input image coming in, and then we use our filters, and there's multiple filters on there that are being developed to kind of twist and change that data. And so we multiply the matrices. We take that little filter, maybe it's a 2 by 2, we multiply it by each piece of the image. And if we step 2, then it's every other piece of the image. That generates multiple convolution layers. So we have a number of convolution layers we have set up in there that is looking at that data. We then take those convolution layers, we run them through the ReLU setup, and then once we've done through the ReLU setup, and we have multiple ReLUs going on, multiple layers that are ReLU, then we're going to take those multiple layers and we're going to be pooling them. So now we have the pooling layers, or multiple poolings going on. Up until this point, we're dealing with, sometimes it's multiple dimensions. You can have 3 dimensions. Some strange data setups that aren't doing images but looking at other things, they can have 4, 5, 6, 7 dimensions. So right now we're looking at 2D image dimensions coming into the pooling layer. So the next step is we want to reduce those dimensions, or flatten them. So flattening. Flattening is a process of converting all of the resultant 2-dimensional arrays from pooled feature map into a single long continuous linear vector. So over here you see where we have a pooled feature map. Maybe that's the bird wing, and it has values 6, 8, 4, 7. And we want to just flatten this out and turn it into 6, 8, 4, 7, or a single linear vector. And we find out that not only do we do each of the pooled feature maps, we do all of them into one long linear vector. So now we've gone through our convolutional neural network part, and we have the input layer into the next setup. All we've done is taken all those different pooling layers and we've flattened them out and combined them into a single linear vector going in. So after we've done the flattening, we have just a quick recap because we've covered so much, so it's important to go back and take a look at each of the steps we've gone through. The structure of the network so far is we have our convolution where we twist it and we filter it and multiply the matrices. We end up with our convolutional layer, which uses the ReLU to figure out the values going out into the pooling. As you have numerous convolution layers that then create numerous pooling layers, pooling that data together, which is the max value, which one we want to send forward. We want to send the best value. And then we're going to take all of that from each of the pooling layers and we're going to flatten it. And we're going to combine them into a single input going into the final layer. Once you get to that step, you might be looking at that going, boy, that looks like the normal input to most neural network. And you're correct, it is. So once we have the flattened matrix from the pooling layer, that becomes our input. So the pooling layer is fed as an input to the fully connected layer to classify the image. And so you can see as our flattened matrix comes in this case we have the pixels from the flattened matrix fed as an input back to our toucan, or whatever that kind of bird that is. I need one of these to identify what kind of bird that is. It comes into our forward propagation network. And that will then have the different weights coming down across. And then finally it selects that that's a bird and that it's not a dog or a cat in this case. Even though it's not labeled, the final layer there in red is our output layer, our final output layer that says bird, cat, or dog. So quick recap of everything we've covered so far. We have our input image, which is twisted and multiplied. The filters are multiplied times the two matrices multiplied all the filters to create our convolution layer. Our convolution layers, there's multiple layers in there because it's all building multiple layers off the different filters. Then goes through the ReLU as its activation, and that creates our pooling. And so once we get into the pooling layer, we then on the pooling look for who's the best, what's the max value coming in from our convolution. And then we take that layer and we flatten it, and then it goes into a fully connected layer, our fully connected neural network, and then to the output. And here we can see the entire process, how the CNN recognizes a bird. This is kind of nice because it's showing the little pixels and where they're going. You can see the filter is generating this convolution network, and that filter shows up in the bottom part of the convolution network. And then based on that, it uses the ReLU for the pooling. The pooling then find out which one's the best, and so on, all the way to the fully connected layer at the end, or the classification in the output layer. So that'd be a classification neural network at the end. So we covered a lot of theory up till now, and you can imagine each one of these steps has to be broken down in code. So putting that together can be a little complicated. Not that each step of the process is overly complicated, but because we have so many steps. We have 1, 2, 3, 4, 5 different steps going on here with sub-steps in there. We're going to break that down and walk through that in code. So in our use case implementation using the CNN, we'll be using the CFAR10 dataset from Canadian Institute for Advanced Research for classifying images across 10 categories. Unfortunately, they don't let me know whether it's going to be a toucan or some other kind of bird, but we do get to find out whether it can categorize between a ship, a frog, deer, bird, airplane, automobile, cat, dog, horse, truck. So that's a lot of fun. And if you're looking anything in the news at all of our automated cars and everything else, you can see where this kind of processing is so important in today's world and very cutting edge as far as what's coming out in the commercial deployment. I mean, this is really cool stuff. We're starting to see this just about everywhere in industry. So a great time to be playing with this and figuring it all out. Let's go ahead and dive into the code and see what that looks like when we're actually writing our script. Before we go on, let's do one more quick look at what we have here. Let's just take a look at data batch 1 keys. And remember, in Jupyter Notebook, I can get by with not doing the print statement. If I put a variable down there, it'll just display the variable. And you can see under data batch 1 for the keys, since this is a dictionary, we have the batch 1 label, data, and file names. So you can actually see how it's broken up in our data set. So for the next step, or step 4 as we're calling it, we want to display the image using matplotlib. There's many ways to display the images. You could even, well, there's other ways to drill into it, but matplotlib is really good for this. And we'll also look at our first reshape setup, or shaping the data, so you can have a little glimpse into what that means. So we're going to start by importing our matplot, and of course, since I am doing Jupyter Notebook, I need to do the matplot inline command so it shows up on my page. So here we go. We're going to import matplot library.pyplot as PLT. And if you remember matplot library, the pyplot is like a canvas that we paint stuff onto. And there's my %sign matplot library inline, so it's going to show up in my notebook. And then of course we're going to import numpy as np for our numbers Python array setup. And let's go ahead and set x equals to data batch 1. So this will pull in all the data going into the x value. And then because this is just a long stream of binary data, we need to go a little bit of reshaping. So in here we have to go ahead and reshape the data. We have 10,000 images. Okay, that looks correct. And this is kind of an interesting thing. It took me a little bit I had to go research this myself to figure out what's going on with this data. And what it is it's a 32 by 32 picture. And let me do this. Let me go ahead and do a drawing pad on here. So we have 32 bits by 32 bits, and it's in color. So there's 3 bits of color. Now, I don't know why the data is particularly like this. It probably has to do with how they originally encoded it. But most pictures put the 3 afterward. So what we're doing here is we're going to take the shape, we're going to take the data, which is just a long stream of information, and we're going to break it up into 10,000 pieces, and those 10,000 pieces then are broken into 3 pieces each, and those 3 pieces then are 32 by 32. You could look at this like an old-fashioned projector where they have the red screen, or the red projector, the blue projector, and the green projector, and they add them all together, and each one of those is a 32 by 32 bit. So that's probably how this was originally formatted, was in that kind of ideal. Things have changed, so we're going to transpose it, and we're going to take the 3, which was here, and we're going to put it at the end. So the first part is reshaping the data from a single line of bit data, or whatever format it is, into 10,000 by 3 by 32 by 32, and then we're going to transpose the color factor to the last place. So it's the image, then the 32 by 32 in the middle, that's this part right here, and then finally we're going to take this, which is 3 bits of data, and put it at the end. So it's more like we process images now. And then as type, this is really important that we're going to use an integer 8. You can come in here and you'll see a lot of these, they'll try to do this with a float or a float 64. What you got to remember though is a float uses a lot of memory. So once you switch this into something that's not integer 8, which goes up to 128, you are just going to, the amount of RAM, let me just put that in here, is going to go way up. The amount of RAM that it loads. So you want to go ahead and use this. You can try the other ones and see what happens if you have a lot of RAM on your computer. But for this exercise, this will work just fine. And let's go ahead and take that and run this. So now our X variable is all loaded and it has all the images in it from the batch 1, data batch 1. And just to show what we were talking about with the as type on there, if we go ahead and take X0 and just look for its max value, let me go ahead and run that. You'll see it doesn't, oops, I said 128, it's 255. You'll see it doesn't go over 255 because it's basically an ASCII character is what we're keeping that down to. We're keeping those values down. So they're only 255, 0 to 255 versus a float value, which would bring this up exponentially in size. And since we're using the matplot library, we can do, oops, that's not what I wanted. Since we're using the matplot library, we can take our canvas and just do a plt.im for image show, and let's just take a look at what X0 looks like. And it comes in, I'm not sure what that is, but you can see it's a very low grade image broken down to the minimal pixels on there. And if we did the same thing, let's see what 1 looks like. Hopefully it's a little easier to see. Run on there, not enter. Let's hit the run on that. And we can see this is probably a semi-truck. That's a good guess on there. And I can just go back up here instead of typing the same line in over and over. And we'll look at 3. That looks like a dump truck unloading, and so on. You can do any of the 10,000 images. We can just jump to 55. Looks like some kind of animal looking at us there, probably a dog. And just for fun, let's do just one more run on there, and we can see a nice car for our image number 4. So you can see we paste through all the different images, and it's very easy to look at them. And they've been reshaped to fit our view and what the matplotlib library uses for its format. So the next step is we're going to start creating some helper functions. We'll start by a one-hot encoder to help us when we're processing the data. Remember that your labels, they can't just be words. They have to switch it, and we use the one-hot encoder to do that. And then we'll also create a class CFAR helper, so it's going to have an init and a setup for the images. And then finally we'll go ahead and run that code so you can see what that looks like. And then we get into the fun part where we're actually going to start creating our model, our actual neural network model. So let's start by creating our one-hot encoder. We're going to create our own here, and it's going to return an out. And we'll have our vector coming in and our values equal 10. What this means is that we have the 10 values, the 10 possible labels. And remember, we don't look at the labels as a number, because a car isn't one more than a horse. That'd be just kind of bizarre to have horse equals 0, car equals 1, plane equals 2, cat equals 3. So a cat plus a car equals what? So instead, we create a numpy array of zeros. And there's going to be 10 values, so we have 10 different values in there. So you have 0 or 1. 1 means it's a cat, 0 means it's not a cat. In the next line it might be that 1 means it's a car, 0 means it's not a car. So instead of having one output with a value of 0 to 10, you have 10 outputs with the values of 0 to 1. That's what the one-hot encoder is doing here. And we're going to utilize this in code in just a minute. So let's go ahead and take a look at the next helpers. We have a few of these helper functions we're going to build. And when you're working with a very complicated Python project, dividing it up into separate definitions and classes is very important. Otherwise, it just becomes really ungainly to work with. So let's go ahead and put in our next helper, which is a class. And there's a lot in this class, so we'll break it down here. And let's just start, oops, we can put a space right in there. There we go. Now this is a little bit more readable. Add a second space. So we're going to create our class, the Cipher Helper. And we'll start by initializing it. Now, there's a lot going on in here. So let's start with the init part. Self.I equals 0. That'll come in a little bit. We'll come back to that in the lower part. We want to initialize our training batches. So when we went through this, there was like a meta batch. We don't need the meta batch, but we do need the data batch 1, 2, 3, 4, 5, and we do not want the testing batch in here. This is just the self-all train batches. So we're going to make an array of all those different images. And then, of course, we left the test batch out, so we have our self.test batch. We're going to initialize the training images and the training labels, and also the test images and the test labels. So this is just to initialize these variables in here. Then we create another definition down here, and this is going to set up the images. And let's just take a look and see what's going on in there. Now we could have all just put this as part of the init part, since this is all just helper stuff, but breaking it up again makes it easier to read. It also makes it easier when we start executing the different pieces to see what's going on. So that way we have a nice print statement to say, hey, we're now running this and this is what's going on in here. We're going to set up these self-training images at this point, and that's going to go to a numpy array vstack. And in there we're going to load up, in this case, the data for D and self all train batches. Again, that points right up to here. So we're going to go through each one of these files, or each one of these data sets, because they're not a file anymore. We've brought them in. Data batch 1 points to the actual data. And so our self-training images is going to stack them all into a numpy array. And then it's always nice to get the training length, and that's just a total number of self-training images in there. And then we're going to take the self-training images. And let me switch marker colors, because I am getting a little too much on the markers up here. Oops, there we go. Bring down our marker change so we can see it a little better. And at this point, this should look familiar. Where did we see this? Well, when we wanted to look at this above, and we wanted to look at the images in the matplotlib library, we had to reshape it. So we're doing the same thing here. We're taking our self-training images, and based on the training length, total number of images, because we stacked them all together, so now it's just one large file of images, we're going to take and look at it as our 3 video cameras that are each displaying 32 by 32, and we're going to switch that around so that now we have each of our images that stays the same place, and then we have our 32 by 32, and then by our 3. our three different values for the color. And of course, we want to go ahead and they run this where you say divide by 255. That was from earlier. It just brings all the data into 0 to 1. That's what this is doing. So we're turning this into a 0 to 1 array, which is all the pictures, 32 by 32 by 3. And then we're going to take the self-training labels, and we're going to pump those through our one-hot encoder we just made, and we're going to stack them together. And again, we're converting this into an array that goes from, instead of having horse equals 1, dog equals 2, and then horse plus dog would equal 3, which would be cat. No, it's going to be an array of 10 where each one is 0 to 1. Then we want to go ahead and set up our test images and labels. And when we're doing this, you're going to see it's the same thing we just did with the rest of them. We just changed colors right here. This is no different than what we were doing up here with our training set. We're going to stack the different images. We're going to get the length of them so we know how many images are in there. You certainly could add them by hand, but it's nice to let the computer do it, especially if it ever changes on the other end and you're using other data. And again, we reshape them and transpose them, and we also do the one-hot encoder. Same thing we just did on our training images. So now our test images are in the same format. So now we have a definition which sets up all our images in there. And then the next step is to go ahead and batch them, or next batch. And let's do another breakout here for batches, because this is really important to understand. It tends to throw me for a little loop when I'm working with TensorFlow or Keras or a lot of these. We have our data coming in. If you remember, we had like 10,000 photos. Let me just put 10,000 down here. We don't want to run all 10,000 at once, so we want to break this up into batch sizes. And you also remember that we had the number of photos, in this case length of test or whatever number is in there. We also have 32 by 32 by 3. So when we're looking at the batch size, we want to change this from 10,000 to a batch of, in this case I think we're going to do batches of 100. So we want to look at just 100, the first 100 of the photos. And if you remember, we set self-I equal to 0. So what we're looking at here is we're going to create X. We're going to get the next batch from the very initialized. We've already initialized it for 0. So we're going to look at X from 0 to batch size, which we set to 100. So just the first 100 images. And then we're going to reshape that into, and this is important to let the data know, that we're looking at 100 by 32 by 32 by 3. Now, we've already formatted it to the 32 by 32 by 3. This just sets everything up correctly so that X has the data in there in the correct order and the correct shape. And then the Y, just like the X, is our labels. So our training labels, again, they go from 0 to batch size. In this case, they do self-I plus batch size because the self-I is going to keep changing. And then finally, we increment the self-I because we have 0. So the next time we call it, we're going to get the next batch size. And so basically, we have X and Y. X being the photograph data coming in, and Y being the label. And that, of course, is labeled through one-hot encoder. So if you remember correctly, if it was, say, horse is equal to 0, it would be 1 for the 0 position, since this is the horse, and then everything else would be 0 in here. Let me just put lines through there. There we go. There's our array. Hard to see that array. So let's go ahead and take that, and we're going to finish loading it, since this is our class. And now we're armed with all this, our setup over here. Let's go ahead and load that up. And so we're going to create a variable ch with the CFAR helper in it. And then we're going to do ch.setupImages. Now we could have just put all of the setup images under the init, but by breaking this up into 2 parts, it makes it much more readable. And also, if you're doing other work, there's reasons to do that as far as the setup. Let's go ahead and run that. And you can see where it says setting up training images and labels, setting up test images. And that's one of the reasons we broke it up, is so that if you're testing this out, you can actually have print statements in there telling you what's going on, which is really nice. They did a good job with this setup. I like the way that it was broken up in the back. And then one quick note, you want to remember that batch, to set up the next batch, since we have to run batch equals ch next batch of 100, because we're going to use the 100 size. But we'll come back to that. We're going to use that. Just remember that that's part of our code we're going to be using in a minute from the definition we just made. So now we're ready to create our model. First thing we want to do is we want to import our TensorFlow as TF. I'll just go ahead and run that so it's loaded up. And you can see we got a warning here. That's because they're making some changes. It's always growing, and they're going to be depreciating one of the values from float 64 to float type, or is treated as an NP float 64. Nothing to really worry about, because this doesn't even affect what we're working on, because we've set all of our stuff to a 255 value, or 0 to 1. And do keep in mind that 0 to 1 value that we converted to 255 is still a float value, but it'll easily work with either the NumPy float 64 or the NumPy D-type float. It doesn't matter which one it goes through, so the depreciation would not affect our code as we have it. And in our TensorFlow, we'll go ahead, let me just increase the size in there just a moment so you can get a better view of the what we're typing in. We're going to set a couple placeholders here. And so we're going to set x equals tf placeholder tf float 32. We just talked about the float 64 versus the NumPy float. We're actually just going to keep this at float 32. More than significant number of decimals for what we're working with. And since it's a placeholder, we're going to set the shape equal to, and we've set it equal to none, because at this point we're just holding the place on there. We'll be setting up as we run the batches. That's what that first value is. And then 32 by 32 by 3, that's what we reshaped our data to fit in. And then we have our y true equals placeholder tf float 32, and the shape equals none, comma 10. 10 is the 10 different labels we have, so it's an array of 10. And then let's create one more placeholder. We'll call this hold prob, or hold probability. And we're going to use this, we don't have to have a shape or anything for this. This placeholder is for what we call dropout. If you remember from our theory before, we drop out so many nodes is looking at, or the different values going through, which helps decrease bias. So we need to go ahead and put a placeholder for that also. And we'll run this, so it's all loaded up in there. So we have our 3 different placeholders. And since we're in TensorFlow, when you use Keras, it does some of this automatically, but we're in TensorFlow direct. Keras sits on TensorFlow. We're going to go ahead and create some more helper functions. We're going to create something to help us initialize the weights, initialize our bias. If you remember that each layer has to have a bias going in. We're going to go ahead and work on our conversional 2D, our max pool, so we have our pooling layer, our convolutional layer, and then our normal full layer. So we're going to go ahead and put those all into definitions, and let's see what that looks like in code. And you can also grab some of these helper functions from the MNIST, the NIST setup. Let me just put that in there if you're under the TensorFlow. So a lot of these are already in there, but we're going to go ahead and do our own. And we're going to create our init weights. And one of the reasons we're doing this is so that you can actually start thinking about what's going on in the back end. So even though there's ways to do this with an automation, sometimes these have to be tweaked and you have to put in your own setup in here. Now we're not going to be doing that. We're just going to recreate them for our code. And let's take a look at this. We have our weights, and so what comes in is going to be the shape, and what comes out is going to be random numbers. So we're going to go ahead and just init some random numbers based on the shape with a standard deviation of 0.1. Kind of a fun way to do that. And then the TF variable, init random distribution. So we're just creating a random distribution on there. That's all that is for the weights. Now, you might change that. You might have a higher standard deviation. In some cases, you actually load preset weights. That's pretty rare. Usually you're testing that against another model or something like that, and you want to see how those weights configure with each other. Now remember, we have our bias, so we need to go ahead and initialize the bias with a constant. In this case, we're using 0.1. A lot of times the bias is just put in as 1, and then you have your weights to add on to that. But we're going to set this as 0.1. So we want to return a convolutional 2D, in this case a neural network. This is would be a layer on here. What's going on with the conv2D is we're taking our data coming in, we're going to filter it. Strides, if you remember correctly, strides came from, here's our image, and then we only look at this picture here, and then maybe we have a stride of 1, so we look at this picture here, and we continue to look at the different filters going on there. The other thing this does is that we have our data coming in as 32 by 32 by 3. And we want to change this so that it's just, this is 3 dimensions, and it's going to reformat this as just 2 dimensions. So it's going to take this number here and combine it with the 32 by 32. So this is a very important layer here because it's reducing our data down using different means. And it connects down, I'm just going to jump down one here. It goes with the convolutional layer. So you have your kind of your pre-formatting and the setup, and then you have your actual convolution layer that goes through on there. And you can see here we have init weights by the shape, init bias, shape of 3, because we have the 3 different, here's our 3 again, and then we return the TFNN ReLU with the convention 2D. So this convolutional has this feeding into it. Right there, it's using that as part of it, and of course the input is the XY plus B, the bias. So that's quite a mouthful, but these two are the keys here to creating the convolutional layers there. The convolutional 2D coming in, and then the convolutional layer, which then steps through and creates all those filters we saw. Then of course we have our pooling. So after each time we run it through the conventional layer, we want to pool the data. If you remember correctly on the pool side, and let me just get rid of all my marks, it's getting a little crazy there. And in fact, let's go ahead and jump back to that slide. Let's just take a look at that slide over here. So we have our image coming in. We create our convolutional layer with all the filters. Remember, the filters go, the filters coming in here, and it looks at these 4 boxes. And then if it's a step, let's say step 2, it then goes to these 4 boxes, and then the next step, and so on. So we have our convolutional layer that we generate, or convolutional layers. They use the ReLU function. There's other functions out there. For this, though, the ReLU is the one that works the best, at least so far. I'm sure that will change. And then we have our pooling. Now, if you remember correctly, the pooling was max. So if we had the filter coming in, and they did the multiplication on there, and we have a 1, and maybe a 2 here, and another 1 here, and a 3 here, 3 is the max. And so out of all of these, you then create an array that would be 3, and if the max is over here 2, or whatever it is, that's what goes into the pooling, of what's going on in our pooling. So again, we're reducing that data down. We're reducing it down as small as we can, and then finally, we're going to flatten it out into a single array, and that goes into our fully connected layer. And you can see that here in the code. Right here, we're going to create our normal full layer. So at some point, we're going to take from our pooling layer, this will go into some kind of flattening process, and then that will be fed into the different layers going in down here. And so we have our input size. You'll see our input layer get shape, which is just going to get the shape for whatever's coming in. And then input size, initial weights is also based on the input layer coming in. And the input size down here is based on the input layer shape. So we're just going to already use the shape and already have our size coming in. And of course, you have to make sure you init the bias. Always put your bias on there. And we'll do that based on the size. So this will return tf.matmul input layer W plus B. This is just a normal full layer. That's what this means right down here. That's what we're going to return. So that was a lot of steps we went through. Let's go ahead and run that. So those are all loaded in there. And let's go ahead and create the layers. Let's see what that looks like. Now that we've done all the heavy lifting and everything, we get to do all the easy part. Let's go ahead and create our layers. We'll create a convolution layer 1 and 2 different convolutional layers, and then we'll take that and we'll flatten that out, create a reshape pooling in there for our reshape, and then we'll have our full layer at the end. So let's start by creating our first convolutional layer. Then we come in here, and let me just run that real quick. And I want you to notice on here the 3 and the 32. This is important because coming into this convolutional layer, we have 3 different channels and 32 pixels each. So that has to be in there. The 4 and 4 you can play with. This is your filter size. So if you remember, you have a filter and you have your image, and the filter slowly steps over and filters out this image depending on what your step is. For this particular setup, 4 is just fine. That should work pretty good for what we're doing and for the size of the image. And then of course at the end, once you have your convolutional layer set up, you also need to pool it, and you'll see that the pooling is automatically set up so that it would see the different shape based on what's coming in. So here we have max 2 by 2, and we put in the convolutional 1 that we just created. The convolutional layer we just created goes right back into it. And that right up here, as you can see, is the X. It's coming in from here, so notice to look at the first model and set the data accordingly. Set that up so it matches. And we went ahead and ran this already. I think I ran it. Let me go and run it again. And if we're going to do one layer, let's go ahead and do a second layer down here. And it's we'll call it Convo 2. It's also a convolutional layer on this. And you'll see that we're feeding convolutional 1 in, the pooling. So it goes from convolutional 1 into convolutional 1 pooling, from convolutional 1 pooling into convolutional 2, and then from convolutional 2 into convolutional 2 pooling. And we'll go ahead and take this and run this. So these variables are all loaded into memory. And for our flattened layer, let's go ahead and we'll do, since we have 64 coming out of here and we have 4 by 4 going in, let's do 8 by 8 by 64. So let's do 4096. This is going to be the flat layer. So that's how many bits are coming through on the flat layer. And we'll reshape this. So we'll reshape our Convo 2 pooling, and that will feed into here, the Convo 2 pooling, and then we're going to set it up as a single layer that's 4096 in size. That's what that means there. We'll go ahead and run this. So we've now created this variable, the Convo 2 flat, and then we have our first full layer. This is the final neural network where we have the flat layer going in. And we're going to again use the ReLU for our setup on there in a neural network for evaluation. And you'll notice that we're going to create our first full layer. Our normal full layer, that's our definition. So we created that. That's creating the normal full layer. And our input for the data comes right here from this goes right into it. The Convo 2 flat. So this tells it how big the data is. And we're going to have it come out. It's going to have 1024. That's how big the layer is coming out. We'll go ahead and run this. So now we have our full layer 1. And with the full layer 1, we want to also define the full 1 dropout to go with that. So our full layer 1 comes in, keep probability equals hold probability. Remember we created that earlier. And the full layer 1 is what's coming into it. And this is going backwards and training the data. We're not training every weight. We're only training a percentage of them each time, which helps get rid of the bias. So let me go ahead and run that. And finally, we'll go ahead and create a Y-predict, which is going to equal the normal full 1 dropout and 10, because we have 10 labels in there. Now, in this neural network, we could have added additional layers. That would be another option to play with. You can also play with, instead of 1024, you can use other numbers for the way that sets up on what's coming out and going into the next one. We're only going to do just the 1 layer and the 1 layer dropout. And you can see if we did another layer, it'd be real easy just to feed in the full 1 dropout into full layer 2. And then full layer 2 dropout would have full layer 2 feed into it. And then you'd switch that here for the Y prediction. For right now, this is great. This particular data set is tried and true, and we know that this will work on it. And if we just type in Y predict and we run that, we'll see that this is a tensor object, shape $10, D-type 32. A quick way to double check what we're working on. So now we've got all of our, we've done a setup all the way to the Y predict, which we just did. We want to go ahead and apply the loss function and make sure that's set up in there. Create the optimizer. And then train our optimizer and create a variable to initialize all the global TF variables. So before we dive into the loss function, let me point out one quick thing, or just kind of a rehab over a couple things. And that is, when we're playing with these setups, we pointed out up here we can change the 4-4 and use different numbers there. They change your outcome. So depending on what numbers you use here will have a huge impact on how well your model fits. And that's the same here with the 1024 also. This is also another number that if you continue to raise that number, you'll get possibly a better fit. You might overfit. And if you lower that number, you'll use less resources. And generally, you want to use this in the exponential growth. And exponential being 2, 4, 8, 16. And in this case, the next one down would be 5, 12. You can use any number there, but those would be the ideal numbers when you look at this data. So the next step in all this is we need to also create a way of tracking how good our model is. And we're going to call this a loss function. And so we're going to create a cross-entropy loss function. And so before we discuss exactly what that is, let's take a look and see what we're feeding it. We're going to feed it our labels, and we have our true labels and our prediction labels. So coming in here is where the two different variables we're sending in, or the two different probability distributions, is one that we know is true and what we think it's going to be. Now this function right here, when they talk about cross-entropy, in information theory, the cross-entropy between two probability distributions over the same underlying set of events measures the average number of bits needed to identify an event drawn from the set. That's a mouthful. Really, we're just looking at the amount of error in here. How many of these are correct and how many of these are incorrect? So how much of it matches? And we're going to look at that. We're just going to look at the average. That's what the mean, the reduced to the mean means here. So we're looking at the average error on this. And so the next step is we're going to take the error. We want to know our cross entropy or our loss function, how much loss we have. That's going to be part of how we train the model. So when you know what the loss is and we're training it, you feed that back into the back propagation setup. And so we want to go ahead and optimize that. Here's our optimizer. We're going to create the optimizer using an atom optimizer. Remember, there's a lot of different ways of optimizing the data. Atom's the most popular used. So our optimizer is going to equal the TF train atom optimizer. If you don't remember what the learning rate is, let me just pop this back into here. Here's our learning rate. When you have your weights, you have all your weights in your different nodes that are coming out. Here's our node coming out, and it has all its weights. And then the error is being sent back through in reverse on our neural network. So we take this error and we adjust these weights based on the different formulas. In this case, the atom formula is what we're using. We don't want to just adjust them completely. We don't want to change this weight so it exactly fits the data coming through. Because if we made that kind of adjustment, it's going to be biased to whatever the last data we sent through is. Instead, we're going to multiply that by 0.001 and make a very small shift in this weight. So our delta W is only 0.001 of the actual delta W of the full change we're going to compute from the atom. And then we want to go ahead and train it. So our training, or set up a training variable or function. And this is going to equal our optimizer minimize cross entropy. And we make sure we go ahead and run this. So it's loaded in there. And then we're almost ready to train our model. But before we do that, we need to create one more variable in here. And we're going to create a variable to initialize all the global TF variables. And when we look at this, the TF global variable initializer, this is a TensorFlow object. It goes through there and it looks at all our different setup that we have going under our TensorFlow and then initializes those variables. So it's kind of like a magic wand because it's all hidden in the back end of TensorFlow. All you need to know about this is that you have to have the initialization on there, which is an operation, and you have to run that once you have your setup going. So we'll go ahead and run this piece of code, and then we're going to go ahead and train our data. So let me run this so it's loaded up there. And so now we're going to go ahead and run the model by creating a graph session. Graph session is a TensorFlow term. So you'll see that coming up. It's one of the things that throws me because I always think of GraphX and Spark and graph as just general graphing. But they talk about a graph session. So we're going to go ahead and run the model. And let's go ahead and walk through this, what's going on here. And let's paste this data in here. And here we go. So we're going to start off with a TF session as ses. So that's our actual TF session that we've created. So we're right here with the TF session. Our session we're creating, we're going to run TF global variable initializer. So right off the bat, we're initializing our variables here. And then we have for I in range 500. So what's going on here, remember 500, we're going to break the data up and we're going to batch it in at 500 points each. We've created our session run. So we're going to do with TF session as session right here. We've created our variable session. And then we're going to run and we're going to go ahead and initialize it. So we have our TF global variables initializer that we created. That initializes our session in here. The next thing we're going to do is we're going to go for I in range of 500, batch equals ch.next batch. So if you remember correctly, this is loading up 100 pictures at a time. And this is going to loop through that 500 times. So we are literally doing, 500 times 100 is 50,000. So that's 50,000 pictures we're going to process right there. And the first process is we're going to do a session run. We're going to take our train. We created our train variable or our optimizer in there. We're going to feed it the dictionary. We had our feed dictionary that we created. And we have x equals batch 0 coming in, y true, batch 1, hold the probability, 0.5. And then just so that we can keep track of what's going on, we're going to, every 100 steps, we're going to run a print. So currently on step, format, accuracy is, and we're going to look at matches equals tf argument y prediction 1, tf.arg max y true, comma 1. So we're going to look at this as how many matches it has. And here our ACC, all we're doing here is we're going to take the matches, how many matches they have, it generates a chart. We're going to convert that to float. That's what the TF cast does. And then we just want to know the average. We just want to know the average of the accuracy. And then we'll go ahead and print that out, print session run accuracy feed dictionary. So it takes all this and it prints out our accuracy on there. So let's go ahead and take this. Oops, flip screens there. Let's go ahead and take this and let's run it. And this is going to take a little bit to run. So let's see what happens on my old laptop. And we'll see here that we have our we're currently on step 0. It takes a little bit to get through the accuracy. And this will take just a moment to run. We can see that on our step 0, it has an accuracy of 0.1 or 0.1028. And as it's running, we'll go ahead, you don't need to watch it run all the way, but this accuracy is going to change a little bit up and down. So we've actually lost some accuracy during our step 2. But we'll see how that comes out. Let's come back after we run it all the way through and see how the different steps come out. I was actually reading that backwards. The way this works is the closer we get to 1, the more accuracy we have. So you can see here we've gone from a 0.1 to a 0.39, and we'll go ahead and pause this and come back and see what happens when we're done with the full run. Alright, now that we've prepared the meal, got it in the oven, and pulled out my finished dish here, if you've ever watched any of the old cooking shows, let's discuss a little bit about this accuracy going on here, and how do you interpret that? We've done a couple things. First, we've defined accuracy. The reason I got it backwards before is you have loss or accuracy. And with loss, you'll get a graph that looks like this. It goes, oops, that's an S, by the way. There we go. You get a graph that curves down like this. And with accuracy, you get a graph that curves up. This is how good it's doing. Now, in this case, 1 is supposed to be really good accuracy. That means it gets close to 1, but it never crosses 1. So if you have an accuracy of 1, that is phenomenal. In fact, that's pretty much unheard of. And the same thing with loss. If you have a loss of 0, that's also unheard of. And the 0 is actually on this axis right here as we go in there. So how do we interpret that? Because, if I was looking at this and I go, oh, 0.51, that's 51%. You're doing 50-50. No, this is not percentage. Let me just put that in there. It is not percentage. This is logarithmic. What that means is that 0.2 is twice as good as 0.1. And when we see 0.4, that's twice as good as 0.2. Real way to convert this into a percentage. You really can't say this is a direct percentage conversion. What you can do, though, is in your head, if we were to give this a percentage, we might look at this as 50%, we're just guessing, equals 0.1. And if 50% roughly equals 0.1, that's where we started up here at the top. Remember at the top here, here's our 0.1028. The accuracy of 50%, then 75% is about 0.2, and so on and so on. Don't quote those numbers because that doesn't work that way. They say that if you have 0.95, that's pretty much saying 100%. And if you have anywhere between, you'd have to go look this up. Let me go ahead and remove all my drawings there. So the magic number is 0.5. We really want to be over a 0.5 in this whole thing. And we have both 0.5004. Remember, this is accuracy. If we were looking at loss, then we'd be looking the other way. But 0.0, instead of how high it is, we want how low it is. But with accuracy, being over a 0.5 is pretty valid. That means this is pretty solid. And if you get to a 0.95, then it's a direct correlation. That's what we're looking for here in these numbers. And you can see we finished with this model at 0.5135, so still good. And if we look at when they ran this in the other end, remember there's a lot of randomness that goes into it when we seed the weights. They got 0.5251, so a little better than ours. But that's fine. You'll find your own comes up a little bit better or worse depending on just that randomness. And so we've gone through the whole model. We've trained the model, and we've also gone through on every 100th run to test the model to see how accurate it is. Welcome to the RNN tutorial. That's the recurrent neural network. So we talk about a feed-forward neural network. In a feed-forward neural network, information flows only in the forward direction, from the input nodes through the hidden layers, if any, and to the output nodes. There are no cycles or loops in the network. And so you can see here we have our input layer. I was talking about how it just goes straight forward into the hidden layers. So each one of those connects and then connects to the next hidden layer, connects to the output layer. And of course we have a nice simplified version where it has a predicted output, and they refer to the input as X a lot of times and the output as Y. Decisions are based on current input, no memory about the past, no future scope. Why recurrent neural network? Issues in feed-forward neural network. So one of the biggest issues is because it doesn't have a scope of memory or time, a feed-forward neural network doesn't know how to handle sequential data. It only considers the current input. So if you have a series of things, and because 3 points back affects what's happening now, and what your output affects what's happening, that's very important. So whatever I put as an output is going to affect the next one. A feed forward doesn't look at any of that. It just looks at this is what's coming in. And it cannot memorize previous inputs. So it doesn't have that list of inputs coming in. Solution to feed forward neural network. You'll see here where it says recurrent neural network, and we have our X on the bottom going to H, going to Y. That's your feed forward. But right in the middle it has a value C, so there's a whole other process. So it's memorizing what's going on in the hidden layers, and the hidden layers, as they produce data, feed into the next one. So your hidden layer might have an output that goes off to Y, but that output goes back into the next prediction coming in. What this does is this allows it to handle sequential data. It considers the current input and also the previously received inputs. And if we're going to look at general drawings and solutions, we should also look at applications of the RNN. Image captioning. RNN is used to caption an image by analyzing the activities present in it. A dog catching a ball in midair. That's very tough. I mean, we have a lot of stuff that analyzes images of a dog and the image of a ball, but it's able to add one more feature in there that's actually catching the ball in midair. Time series prediction. Any time series problem like predicting the prices of stocks in a particular month can be solved using RNN. And we'll dive into that in our use case and actually take a look at some stock. One of the things you should know about analyzing stock today is that it is very difficult. And if you're analyzing the whole stock, the stock market at the New York Stock Exchange in the U.S. produces somewhere in the neighborhood, if you count all the individual trades and fluctuations by the second, it's like 3 terabytes a day of data. So we're only going to look at one stock. Just analyzing one stock is really tricky. In here, we'll give you a little jump on that, so that's exciting, but don't expect to get rich off of it immediately. Another application of the RNN is natural language processing. Text mining and sentiment analysis can be carried out using RNN for natural language processing. And you can see right here the term natural language processing, when you stream those 3 words together, is very different than if I said processing language naturally. So the time series is very important when we're analyzing sentiments. It can change the whole value of a sentence just by switching the words around. Or if you're just counting the words, you might get one sentiment where if you actually look at the order they're in, you get a completely different sentiment. When it rains, look for rainbows. When it's dark, look for stars. Both of these are positive sentiments, and they're based upon the order of which the sentence is going in. Machine translation. Given an input in one language, RNN can be used to translate the input into a different languages as output. I myself am very linguistically challenged. But if you study languages and you're good with languages, you know right away that if you're speaking English, you would say big cat. And if you're speaking Spanish, you would say cat big. So that translation is really important to get the right order, to get, there's all kinds of parts of speech that are important to know by the order of the words. Here this person is speaking in English and getting translated. And you can see here a person is speaking in English in this little diagram. I guess that's denoted by the flags. I have a flag. I own it. No. But they're speaking in English and it's getting translated into Chinese, Italian, French, German, and Spanish languages. Some of the tools coming out are just so cool. So somebody like myself who's very linguistically challenged, I can now travel into worlds I would never think of, because I can have something translate my English back and forth readily, and I'm not stuck with a communication gap. So let's dive into what is a recurrent neural network. Recurrent neural network works on the principle of saving the output of a layer and feeding this back to the input in order to predict the output of the layer. Sounds a little confusing. When we start breaking it down, it'll make more sense. And usually we have a propagation forward neural network with the input layers, the hidden layers, the output layer. With the recurrent neural network, we turn that on its side. So here it is, and now our X comes up from the bottom into the hidden layers into Y, and they usually draw it very simplified, X to H with C as a loop, A to Y, where A, B, and C are the perimeters. A lot of times you'll see this kind of drawing in here, digging closer and closer into the H and how it works. Going from left to right, you'll see that the C goes in, and then the X goes in. So the X is going upward bound, and C is going to the right. A is going out. And C is also going out. That's where it gets a little confusing. So here we have X in, C in, and then we have Y out and C out. And C is based on HT minus 1. So our value is based on the y and the h value are connected to each other. They're not necessarily the same value because h can be its own thing. And usually we draw this, or we represent it as a function. H of t equals a function of c, where h of t minus 1, that's the last h output, and x of t going in. So it's the last output of h combined with the new input of x, where ht is the new state, fc is a function with the parameters c, that's a common way of denoting it, ht minus 1 is the old state coming out, and then x of t is an input vector at time of step t. Well, we need to cover types of recurrent neural networks. And so the first one is the most common one, which is a one-to-one single output. One-to-one neural network is usually known as a vanilla neural network, used for regular machine learning problems. Why? Because vanilla is usually considered kind of just a real basic flavor. But because it's very basic, a lot of times they'll call it the vanilla neural network, which is not the common term, but it is, like kind of a slang term. People will know what you're talking about usually if you say that. Then we run one to many, so you have a single input, and you might have multiple outputs. In this case, image captioning, as we looked at earlier, where we have not just looking at it as a dog, but a dog catching a ball in the air. And then you have many-to-one network, takes in a sequence of inputs. Examples, sentiment analysis, where a given sentence can be classified as expressing positive or negative sentiments. And we looked at that as we were discussing, if it rains, look for a rainbow. So positive sentiment, where rain might be a negative sentiment if you were just adding up the words in there. And then, of course, if you're going to do a one-to-one, many-to-one, one-to-many, there's many-to-many networks, takes in a sequence of inputs and generates a sequence of outputs. Example, machine translation. So we have a lengthy sentence coming in English and then going out in all the different languages. Just a wonderful tool. Very complicated set of computations. If you're a translator, you realize just how difficult it is to translate into different languages. One of the biggest things you need to understand when we're working with this neural network is what's called the vanishing gradient problem. While training an RNN, your slope can be either too small or very large, and this makes training difficult. When the slope is too small, the problem is known as vanishing gradient. And you'll see here they have a nice image, loss of information through time. So if you're pushing not enough information forward, that information is lost, and then when you go to train it, you start losing the third word in the sentence or something like that, or it doesn't quite follow the full logic of what you're working on. Exploding gradient problem. Oh, this is one that runs into everybody. When you're working with this particular neural network, when the slope tends to grow exponentially instead of decaying, this problem is called exploding gradient. Issues in gradient problem, long training time, poor performance, bad accuracy. And I'll add one more in there. Your computer, if you're on a lower end computer testing out a model, will lock up and give you the memory error. Explaining gradient problem. Consider the following two examples to understand what should be the next word in the sequence. The person who took my bike and blank, a thief. The students who got into engineering with blank from Asia. And you can see in here we have our x value going in, we have the previous value going forward, and then you back propagate the error like you do with any neural network. And as we're looking for that missing word, maybe we'll have the person took my bike and blank was a thief. And the student who got into engineering with a blank were from Asia. Consider the following example, the person who took the bike. So we'll go back to the person who took the bike was blank a thief. In order to understand what would be the next word in the sequence, the RNN must memorize the previous context, whether the subject was singular noun or a plural noun. So was a thief is singular. The student who got into engineering, well, in order to understand what would be the next word in the sequence, the RNN must memorize the previous context, whether the subject was singular noun or a plural noun. And so you can see here the students who got into engineering with blank were from Asia. It might be sometimes difficult for the error to back propagate to the beginning of the sequence to predict what should be the output. So when you run into the gradient problem, we need a solution, the solution to the gradient problem. First, we're going to look at exploding gradient, where we have three different solutions depending on what's going on. One is identity initialization. So the first thing we want to do is see if we can find a way to minimize the identities coming in instead of having it identify everything, just the important information we're looking at. Next is to truncate the back propagation. So instead of having whatever information it's sending to the next series, we can truncate what it's sending. We can lower that particular set of layers, make those smaller. And finally is the gradient clipping. So when we're training it, we can clip what that gradient looks like and narrow the training model that we're using. When you have a vanishing gradient, the option problem, we can take a look at weight initialization, very similar to the identity, but we're going to add more weights in there so it can identify different aspects of what's coming in better. Choosing the right activation function. That's huge. So we might be activating based on one thing and we need to limit that. We haven't talked too much about activation functions, so we'll look at that just minimally. There's a lot of choices out there. And then finally there's long short-term memory networks, the LSTMs. And we can make adjustments to that. So just like we can clip the gradient as it comes out, we can also expand on that. We can increase the memory network, the size of it, so it handles more information. And one of the most common problems in today's setup is what they call long-term dependencies. Suppose we try to predict the last word in the text. The clouds are in the, and you probably said sky. Here we do not need any further context. It's pretty clear that the last word is going to be sky. Suppose we try to predict the last word in the text. I have been staying in Spain for the last 10 years. I can speak fluent. Maybe you said Portuguese or French. No, you probably said Spanish. The word we predict will depend on the previous few words in context. Here we need the context of Spain to predict the last word in the text. It's possible that the gap between the relevant information and the point where it is needed to become very large. LSTMs help us solve this problem. So the LSTMs are a special kind of recurrent neural network capable of learning long-term dependencies. Remembering information for long periods of time is their default behavior. All recurrent neural networks have the form of a chain of repeating modules of neural network connections. In standard RNNs, this repeating module will have a very simple structure such as a single tangent H layer. LSTMs also have a chain-like structure, but the repeating module has a different structure. Instead of having a single neural network layer, there are 4 interacting layers communicating in a very special way. LSTMs are a special kind of recurrent neural network, capable of learning long-term dependencies. Remembering information for long periods of time is their default behavior. LSTMs also have a chain-like structure, but the repeating module has a different structure. Instead of having a single neural network layer, there are 4 interacting layers communicating in a very special way. As you can see, the deeper we dig into this, the more complicated the graphs get. In here, I want you to note that you have x at t minus 1 coming in, you have x at t coming in, and you have x at t plus 1. And you have h at t minus 1, and h at t coming in, and h at t plus 1 going out. And of course, on the other side is the output A. In the middle, we have our tangent H, but it occurs in 2 different places. So not only when we're computing the x at t plus 1 are we getting the tangent H from x at t, but we're also getting that value coming in from the x at t minus 1. So the short of it is as you look at these layers, not only does the propagate through the first layer, goes into the second layer, back into itself, but it's also going into the third layer. So now we're kind of stacking those up. And this can get very complicated as you grow that in size. It also grows in memory too, and in the amount of resources it takes. But it's a very powerful tool to help us address the problem of complicated, long sequential information coming in, like we were just looking at in the sentence. And when we're looking at our long short-term memory network, there's 3 steps of processing in the LSTMs that we look at. The first one is we want to forget irrelevant parts of the previous state. A lot of times, like, is, as, in, a, unless we're trying to look at whether it's a plural noun or not, they don't really play a huge part in the language, so we want to get rid of them. Then selectively update cell state values. So we only want to update the cell state values that reflect what we're working on. And finally, we want to only output certain parts of the cell state. So whatever's coming out, we want to limit what's going out too. And let's dig a little deeper into this. Let's just see what this really looks like. So step 1 decides how much of the past it should remember. First step in the LSTM is to decide which information to be omitted from the cell in that particular time step. It is decided by the sigmoid function. It looks at the previous state, h at t minus 1, and the current input, x at t, and computes the function. So you can see over here we have a function of t equals the sigmoid function of the weight of f, the h at t minus 1, and then x at t, plus, of course, you have a bias in there with any of your neural networks, so we have a bias function. So f at t equals forget gate, decides which information to delete that is not important from the previous time step. Considering an LSTM is fed with the following inputs from the previous and present time step. Alice is good in physics. John, on the other hand, is good in chemistry. So, previous output. John plays football well. He told me yesterday over the phone that he had served as a captain of his college football team. That's our current input. So as we look at this, the first step is the forget gate realizes there might be a change in context after encountering the first full stop. Compares with the current input sentence of x at t. So we're looking at that full stop and then compares it with the input of the new sentence. The next sentence talks about John, so the information on Alice is deleted. Okay, that's important to know. So we have this input coming in, and if we're going to continue on with John, then that's going to be the primary information we're looking at. The position of the subject is vacated and is assigned to John. And so in this one, we've seen that we've weeded out a whole bunch of information, and we're only passing information on John, since that's now the new topic. So step 2 is then to decide how much should this unit add to the current state. In the second layer, there are two parts. One is the sigmoid function, and the other is the tangent h. In the sigmoid function, it decides which values to let through, 0 or 1. Tangent h function gives the weightage to the values which are passed, deciding their level of importance, -1 to 1. And you can see the two formulas that come up. The I of t equals the sigmoid of the weight of I, h of t minus 1, x of t plus the bias of I. And the c of t equals the tangent of h of the weight of c of h of t minus 1, x of t plus the bias of c. So our I of t equals the input gate, determines which information to let through based on its significance in the current time step. If this seems a little complicated, don't worry, because a lot of the programming is already done when we get to the case study. Understanding, though, that this is part of the program is important when you're trying to figure out what to set your settings at. You should also note when you're looking at this, it should have some semblance to your forward propagation neural networks, where we have a value assigned to a weight plus a bias. Very important steps in any of the neural network layers, whether we're propagating into the information from one to the next, or we're just doing a straightforward neural network propagation. Let's take a quick look at this, what it looks like from the human standpoint, as I step out of my suit again. Consider the current input at x of t. John plays football well. He told me yesterday over the phone that he had served as a captain of his college football team. That's our input. Input gate analyzes the important information. John plays football and he was a captain of his college team is important. He told me over the phone yesterday is less important, hence it is forgotten. This process of adding some new information can be done via the input gate. Now this example is as a human form, and we'll look at training this stuff in just a minute. But as a human being, if I wanted to get this information from a conversation, maybe it's a Google Voice listening in on you or something like that, how do we weed out the information that he was talking to me on the phone yesterday? Well, I don't want to memorize that he talked to me on the phone yesterday, or maybe that is important. But in this case, it's not. I want to know that he was the captain of the football team. I want to know that he served. I want to know that John plays football and he was the captain of the college football team. Those are the two things that I want to take away as a human being. Again, we measure a lot of this from the human viewpoint, and that's also how we try to train them so we can understand these neural networks. Finally, we get to step 3, decides what part of the current cell state makes it to the output. The third step is to decide what will be our output. First, we run a sigmoid layer, which decides what parts of the cell state make it to the output. Then we put the cell state through the tangent h to push the values to be between -1 and 1, and multiply it by the output of the sigmoid gate. So when we talk about the output of t, we set that equal to the sigmoid of the weight of 0 of the h of t minus 1, back one step in time, by the x of t, plus of course the bias. The h of t equals the out of t times the tangent h of c of t. So our O of t equals the output gate, allows the passed in information to impact the output in the current time step. Let's consider the example to predicting the next word in the sentence. John played tremendously well against the opponent and won for his team. For his contributions, Brave blank was awarded player of the match. There could be a lot of choices for the empty space. Current input, Brave, is an adjective. Adjectives describe a noun. John could be the best output after Brave. Thumbs up for John. awarded player of the match. And if you were to pull just the nouns out of the sentence, team doesn't look right because that's not really the subject we're talking about. Contributions, brave contributions, or brave team, brave player, brave match. So you look at this and you can start to train this neural network. So it starts looking at it and goes, oh no, John is what we're talking about. So brave is an adjective. John's going to be the best output. And we give John a big thumbs up. And then of course we jump into my favorite part, a case study. Use case implementation of LSTM. Let's predict the prices of stocks using the LSTM network based on the stock price data between 2012 2016. We're going to try to predict the stock prices of 2017. And this will be a narrow set of data. We're not going to do the whole stock market. It turns out that the New York Stock Exchange generates roughly 3 terabytes of data per day. That's all the different trades up and down of all the different stocks going on. And each individual one second to second or nanosecond to nanosecond. But we're going to limit that to just some very basic fundamental information. So don't think you're going to get rich off this today. But at least you can give a step forward in how to start processing something like stock prices, a very valid use for machine learning in today's markets. Use case implementation of LSTM. Let's dive in. We're going to import our libraries. We're going to import the training set and get the scaling going. Now, if you watch any of our other tutorials, a lot of these pieces just start to look very familiar because it's a very similar setup. But let's take a look at that. And just a reminder, we're going to be using Anaconda, the Jupyter Notebook. So here I have my Anaconda navigator. When we go under environments, I've actually set up a Keras Python 3.6. I'm in Python 3.6. And nice thing about Anaconda, especially the newer version, I remember a year ago messing with Anaconda in different versions of Python in different environments. Anaconda now has a nice interface. And I have this installed both on a Ubuntu Linux machine and on Windows, so it works fine on there. You can go in here and open a terminal window. And then in here, once you're in the terminal window, this is where you're going to start installing using pip to install your different modules and everything. Now we've already pre-installed them, so we don't need to do that in here. But if you don't have them installed in your particular environment, you'll need to do that. And of course, you don't need to use the Anaconda or the Jupyter. You can use whatever favorite Python IDE you like. I'm just a big fan of this because it keeps all my stuff separate. You can see on this machine I have specifically installed one for Keras, since we're going to be working with Keras under TensorFlow. When we go back to home, I've gone up here to application, and that's the environment I've loaded on here, and then we'll click on the Launch Jupyter Notebook. Now I've already, in my Jupyter Notebook, have set up a lot of stuff so that we're ready to go. Kind of like Martha Stewart's in the old cooking shows. We want to make sure we have all our tools for you so you're not waiting for them to load. And if we go up here to where it says New, you can see where you can create a new Python 3. That's what we did here underneath the setup, so it already has all the modules installed on it. And I'm actually renamed this. If you go under File, you can rename it. I'm calling it RNN Stock. And let's just take a look at start diving into the code. Let's get into the exciting part. Now we've looked at the tool, and of course you might be using a different tool, which is fine. Let's start putting that code in there and seeing what those imports and uploading everything looks like. Now, the first half is kind of boring when we hit the Run button, because we're going to be importing NumPy as NP. That's the number Python, which is your NumPy array, and the matplot library, because we're going to do some plotting at the end, and our pandas for our data set. Our pandas as PD. And when I hit Run, it really doesn't do anything except for load those modules. Just a quick note, let me just do a quick draw here. Oops, Shift-Alt, there we go. You'll notice when we're doing this setup, if I was to divide this up, oops, I'm going to actually, let's overlap these, here we go. This first part that we're going to do is our data prep. A lot of prepping involved. In fact, depending on what your system is, since we're using Keras, I put an overlap here, but you'll find that almost maybe even half of the code we do is all about the data prep. And the reason I overlap this with Keras, let me just put that down because that's what we're working in, is because Keras has like their own preset stuff, so it's already pre-built in, which is really nice. So there's a couple steps a lot of times that are in the Keras setup. We'll take a look at that to see what comes up in our code as we go through and look at stock. And then the last part is to evaluate. And if you're working with shareholders or classroom, whatever it is you're working with, the evaluate is the next biggest piece. So the actual code here, crossed is a little bit more, but when you're working with some of the other packages, you might have like 3 lines. That might be it. All your stuff is in your pre-processing in your data. Since Keras is cutting edge and you load the individual layers, you'll see that there's a few more lines here, and Keras is a little bit more robust. And then you spend a lot of times, like I said, with the evaluate, you want to have something you present to everybody else to say, hey, this is what I did, this is what it looks like. So let's go through those steps. This is like a kind of just general overview. And let's just take a look and see what the next set of code looks like. And in here we have a dataset train, and it's going to be read using the PD, or pandas.readCSV, and it's the Google stock price train.csv. And so under this we have training set equals dataset train.iLocation, and we've kind of sorted out part of that. So what's going on here? Let's just take a look at let's look at the actual file and see what's going on there. Now if we look at this, ignore all the extra files on this, I already have a train and a test set where it's sorted out. This is important to notice because a lot of times we do that as part of the pre-processing of the data. We take 20% of the data out so we can test it, and then we train the rest of it. That's what we use to create our neural network. That way we can find out how good it is. But let's go ahead and just take a look and see what that looks like as far as the file itself. And I went ahead and just opened this up in a basic WordPad and text editor just so we can take a look at it. Certainly you can open up in Excel or any other kind of spreadsheet. And we note that this is a comma-separated variables. We have a date, open, high, low, close, volume. This is the standard stuff that we import into our stock, and one of the most basic set of information you can look at in stock. It's all free to download. In this case, we downloaded it from Google. That's why we call it the Google stock price. And it specifically is Google. This is the Google stock values from, as you can see here, we started off at 1/3/2012. So when we look at this first setup up here, we have a dataset train equals PD_CSV. And if you noticed on the original frame, let me just go back there, they had it set to home Ubuntu downloads Google stock price train. I went ahead and changed that because we're in the same file where I'm running the code. So I've saved this particular Python code, and I don't need to go through any special paths or have the full path on there. And then of course we want to take out certain values in here. And you're going to notice that we're using our data set, and we're now in pandas. So pandas, basically it looks like a spreadsheet. And in this case we're going to do iLocation, which is going to get specific locations. The first value is going to show us that we're pulling all the rows in the data. And the second one is we're only going to look at columns 1 and 2. And if you remember here from our data, as we switch back on over, columns, we always start with 0, which is the date. And we're going to be looking at open and high, which would be 1 and 2. We'll just label that right there so you can see. Now, when you go back and do this, you certainly can extrapolate and do this on all the columns. But for the example, let's just limit a little bit here so that we can focus on just some key aspects of stock. And then we'll go up here and run the code. And again, I said the first half is very boring. Whenever you hit the run button, it doesn't do anything because we're still just loading the data and setting it up. Now that we've loaded our data, we want to go ahead and scale it. We want to do what they call feature scaling. And in here we're going to pull it up from the sklearn or the skKit pre-processing import min-max scaler. And when you look at this, you got to remember that biases in our data, we want to get rid of that. So if you have something that's like a really high value, let's just draw a quick graph. And I have something here like maybe the stock has a value, one stock has a value of 100 and another stock has a value of 5. You start to get a bias between different stocks. And so when we do this, we go ahead and say, okay, 100 is going to be the max, and 5 is going to be the min, and then everything else goes, and then we change this, so we just squish it down. I like the word squish. So it's between 1 and 0. So 100 equals 1, or 1 equals 100, and 0 equals 5. And you can just multiply. It's usually just a simple multiplication we're using. Multiplication. So it's going to be minus 5 and then 100 divided, or 95 divided by 1. So, or whatever value is divided by 95. And once we've actually created our scale, we've telling us going to be from 0 to 1. We want to take our training set and we're going to create a training set scaled. And we're going to use our scalar, SC, and we're going to fit. We're going to fit and transform the training set. So we can now use the SC, this particular object. We'll use it later on our testing set. Because remember, we have to also scale that when we go to test our model and see how it works. And we'll go ahead and click on the run. Again, it's not going to have any output yet because we're just setting up all the variables. Okay, so we paste the data in here, and we're going to create the data structure with the 60 time steps and output. First note, we're running 60 time steps, and that is where this value here also comes in. So the first thing we do is we create our xtrain and ytrain variables, and we set them to an empty Python array. Very important to remember what kind of array we're in and what we're working with. And then we're going to come in here, we're going to go for I in range 60 to 1258. There's our 60 time steps. And the reason we want to do this is as we're adding the data in, there's nothing below the 60. So if we're going to use 60 time steps, we have to start at point 60 because it includes everything underneath of it. Otherwise, you'll get a pointer error. And then we're going to take our xtrain and we're going to append training set scaled. This is the scaled value between 0 and 1. And then as I is equal to 60, this value is going to be 60 minus 60 is 0. So this actually is 0 to I. So it's going to be 0 to 60, 1 to 61. Let me just circle this part right here. 1 to 61, 2 to 62, and so on and so on. And if you remember, I said 0 to 60. That's incorrect because it does not count. Remember, it starts at 0, so this is a count of 60. So it's actually 59. Important to remember that as we're looking at this. And then the second part of this that we're looking at, so if you remember correctly, here we go. We go from 0 to 59 of I, and then we have a comma, a 0 right here. And so finally, we're just going to look at the open value. Now, I know we did put it in there for 1 to 2. If you remember correctly, it doesn't count the second one, so it's just the open value we're looking at, just open. And then finally, we have ytrain.append training set I to 0. And if you remember correctly, I to, or I comma 0. If you remember correctly, this is 0 to 59, so there's 60 values in it. So when we do I down here, this is number 60. So we're going to do this is we're creating an array, and we have 0 to 59. And over here we have number 60, which is going into the ytrain. It's being appended on there. And then this just goes all the way up. So this is down here is 0 to 59, and we'll call it 60, since that's the value over here. And it goes all the way up to 1258. That's where this value here comes in. That's the length of the data we're loading. So we've loaded 2 arrays. We've loaded one array that has, which is filled with arrays from 0 to 59, and we loaded one array which is just the value. And what we're looking at, you want to think about this as a time sequence. Here's my open, 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 open. What's the next one in the series? So we're looking at the Google stock, and each time it opens, we want to know what the next one, 0 through 59, what's 60? 1 through 60, what's 61? 2 through 62, what's 62? And so on going up. And then once we've loaded those in our for loop, we go ahead and take xtrain and ytrain equals np.array xtrain.nparray ytrain. We're just converting this back into a numpy array. That way we can use all the cool tools that we get with numpy array, including reshaping. So if we take a look and see what's going on here, we're going to take our xtrain, we're going to reshape it. Wow, what the heck does reshape mean? That means we have an array, if you remember correctly, so many numbers by 60. That's how wide it is. And so when you do xtrain.shape, that gets one of the shapes. And you get xtrain.shape of 1 gets the other shape. And we're just making sure the data is formatted correctly. And so you use this to pull the fact that it's 60 by, in this case, where's that value? 60 by 1199, 1258 minus 60, 1199, and we're making sure that that is shaped correctly. So the data is grouped into 1199 by 60 different arrays. And then the 1 on the end just means at the end, because when you're dealing with shapes and NumPy, they look at this as layers. And so the end layer needs to be 1 value. That's like the leaf of a tree, where this is the branch, and then it branches out some more, and then you get the leaf. np.reshape comes from and using the existing shapes to form it. We'll go ahead and run this piece of code. Again, there's no real output. And then we'll import our different Keras modules that we need. So from Keras models, we're going to import the sequential model. We're dealing with sequential data. We have our dense layers. We have actually 3 layers we're going to bring in. Our dense, our LSTM, which is what we're focusing on, and our dropout. And we'll discuss these 3 layers more in just a moment. But you do need with the LSTM, you do need the dropout, and then the final layer will be the dense. But let's go ahead and run this, and that'll import our modules. And you'll see we get an error on here. And if you read it closer, it's not actually an error, it's a warning. What does this warning mean? These things come up all the time when you're working with such cutting-edge modules that are completely being updated all the time. We're not going to worry too much about the warning. All it's saying is that the H5PY module, which is part of Keras, is going to be updated at some point. And if you're running new stuff on Keras and you start updating your Keras system, you better make sure that your H5Pi is updated too, otherwise you're going to have an error later on. And you can actually just run an update on the H5Pi now if you wanted to. Not a big deal, we're not going to worry about that today. And I said we were going to jump in and start looking at what those layers mean. I meant that. And we're going to start off with initializing the RNN, and then we'll start adding those layers in. And you'll see that we have the LSTM and then the dropout. LSTM, then dropout. LSTM, then dropout. What the heck is that doing? So let's explore that. We'll start by initializing the RNN, regressor equals sequential, because we're using the sequential model. And we'll run that and load that up. And then we're going to start adding our LSTM layer and some dropout regularization. And right there should be the Q, dropout regularization. And if we go back here and remember our exploding gradient, well, that's what we're talking about. The dropout drops out unnecessary data, so we're not just shifting huge amounts of data through the network. So we go in here, let's just go ahead and add this in. I'll go ahead and run this. And we had 3 of them, so let me go ahead and put all 3 of them in, and then we can go back over them. Here's the second one, and let's put 1 more in. Oops, put that in, and we'll go ahead and put 2 more in. I said 1 more in, but it's actually 2 more in, and then let's add 1 more after that. And as you can see, each time I run these, they don't actually have an output. So let's take a closer look and see what's going on here. So we're going to add our first LSTM layer in here. We're going to have units 50. The units is the positive integer, and it's the dimensionality of the output space. This is what's going out into the next layer. So we might have 60 coming in, but we have 50 going out. We have a return sequence, because it is a sequence data, so we want to keep that true. And then you have to tell it what shape it's in. Well, we already know the shape by just going in here and looking at xtrain shape. So input shape equals the xtrain shape of 1, 1. It makes it real easy. You don't have to remember all the numbers that put in 60 or whatever else is in there. You just let it tell the regressor what model to use. And so we follow our STM with a dropout layer. Now, understanding the dropout layer is kind of exciting because one of the things that happens is we can overtrain our network. That means that our neural network will memorize such specific data that it has trouble predicting anything that's not in that specific realm. To fix for that, each time we run through the training mode, we're going to take 0.2 or 20% of our neurons and just turn them off. So we're only going to train on the other ones. And it's going to be random. That way, each time we pass through this, we don't overtrain. These nodes come back in the next training cycle. We randomly pick a different 20. And finally, I see a big difference as we go from the first to the second and third and fourth. The first thing is we don't have to input the shape. Because the shape's already, the output units is 50 here, the next step automatically knows this layer is putting out 50, and because it's the next layer, it automatically sets that and says, oh, 50 is coming out from our last layer. It's coming out, goes into the regressor, and of course we have our dropout. And that's what's coming into this one, and so on, and so on. And so the next 3 layers, we don't have to let it know what the shape is. It automatically understands that. And we're going to keep the units the same. We're still going to do 50 units. It's still a sequence coming through, 50 units and a sequence. Now, the next piece of code is what brings it all together. Let's go ahead and take a look at that. And we come in here, we put the output layer. the dense layer. And if you remember up here, we had the 3 layers. We had LSTM, dropout, and dense. Dense just says we're going to bring this all down into one output. Instead of putting out a sequence, we just want to know the answer at this point. And let's go ahead and run that. And so in here, you notice all we're doing is setting things up, one step at a time. So far, we've brought in our, way up here, we brought in our data, we brought in our different modules, we formatted the data for training it, we set it up, we have our X train and our Y train, we have our source of data and the answers we know so far that we're going to put in there. We've reshaped that, we've come in and built our Keras, we've imported our different layers, and we have in here, if you look, we have 5 total layers. Now, Keras is a little different than a lot of other systems because a lot of other systems put this all in one line and do it automatic, but they don't give you the options of how those layers interface, and they don't give you the options of how the data comes in. Keras is cutting edge for this reason. So even though there's a lot of extra steps in building the model, this has a huge impact on the output and what we can do with these new models from Keras. So we brought in our dense, we have our full model put together, our regressor. So we need to go ahead and compile it, and then we're going to go ahead and fit the data. We're going to compile the pieces so they all come together, and then we're going to run our training data on there and actually recreate our regressor so it's ready to be used. So let's go ahead and compile that, and I can go ahead and run that. And if you've been looking at any of our other tutorials on neural networks, you'll see we're going to use the optimizer Atom. Atom is optimized for big data. There's a couple other optimizers out there beyond the scope of this tutorial, but certainly Atom will work pretty good for this. And loss equals mean squared value. So when we're training it, this is what we want to base the loss on. How bad is our error? Well, we're going to use the mean squared value for our error and the Atom optimizer for its differential equations. You don't have to know the math behind them, but certainly it helps to know what they're doing and where they fit into the bigger models. And then finally we're going to do our fitting the RN into the training set. We have the regressor.fit, X-train, Y-train, epochs, and batch size. So we know where this is. This is our data coming in for the X-train. Our Y-train is the answer we're looking for of our data, our sequential input. Epochs is how many times we're going to go over the whole data set. We created a whole data set of X-train. So this is each of those rows, which includes a time sequence of 60. And batch size, another one of those things where Keras really shines is if you were pulling this, say, from a large file, instead of trying to load it all into RAM, it can now pick smaller batches up and load those indirectly. We're not worried about pulling them off a file today because this isn't big enough to cause the computer too much of a problem to run, not too straining on the resources. But as we run this, you can imagine what would happen if I was doing a lot more than just one column in one set of stock, in this case Google stock. Imagine if I was doing this across all the stocks and I had, instead of just the open, I had open, close, high, low, and you can actually find yourself with about 13 different variables times 60 because there's a time sequence. Suddenly you find yourself with a gig of memory you're loading into your RAM, which will just completely, if you're not on multiple computers or cluster, you're going to start running into resource problems. But for this, we don't have to worry about that. So let's go ahead and run this, and this will actually take a little bit on my computer because it's an older laptop. And give it a second to kick in there. There we go. Alright, so we have epoch. So this is going to tell me it's running the first run through all the data. And as it's going through, it's batching them in 32 pieces. So 32 lines each time. And there's 1198. I think I said 1199 earlier, but it's 1198. I was off by 1. And each one of these is 13 seconds. So you can imagine this is roughly 20 to 30 minutes runtime on this computer. Like I said, it's an older laptop running at 0.9 gigahertz on a dual processor. And that's fine. What we'll do is I'll go ahead and stop, go get a drink of coffee, and come back, and let's see what happens at the end and where this takes us. And like any good cooking show, I've gotten my latte. I also had some other stuff running in the background, so you'll see these numbers jumped up to like 19 seconds, 15 seconds. But you can scroll through, and you can see we've run it through 100 steps, or 100 epochs. So the question is, what does all this mean? One of the first things you'll notice is that our loss is over here. It kind of stopped at 0.0014, but you can see it kind of goes down until we hit about 0.014 3 times in a row. So we guessed our epoch pretty close since our loss has remained the same on there. So to find out what we're looking at, we're going to go ahead and load up our test data, the test data that we didn't process yet. And a real stock price, dataset test allocation. This is the same thing we did when we prepped the data in the first place. So let's go ahead and go through this code. And we can see we've labeled it Part 3, Making the Predictions and Visualizing the Results. So the first thing we need to do is go ahead and read the data in from our test CSV. You see I've changed the path on it for my computer. And then we'll call it the real stock price. And again, we're doing just the one column here and the values from iLocation. So it's all the rows and just the values from that one location. That's the open. Stock open. And let's go ahead and run that. So that's loaded in there. And then let's go ahead and we have our inputs. We're going to create inputs here. And this should all look familiar because this is the same thing we did before. We're going to take our data set total. We're going to do a little pandas concat from the data set train. Now remember, the end of the data set train is part of the data going in. And let's just visualize that just a little bit. Here's our train data. Let me just put TR for train. And it went up to this value here. But each one of these values generated a bunch of columns. So it was 60 across, and this value here equals this one, and this value here equals this one, and this value here equals this one. And so we need these top 60 to go into our new data. So to find out what we're looking at, we're going to go ahead and load up our test data, the test data that we didn't process yet. And a real stock price, data set, test iLocation. This is the same thing we did when we prepped the data in the first place. So let's go ahead and go through this code. And we can see we've labeled it Part 3, Making the Predictions and Visualizing the Results. So the first thing we need to do is go ahead and read the data in from our test CSV. You see I've changed the path on it for my computer. And then we'll call it the real stock price. And again, we're doing just the one column here and the values from iLocation. So it's all the rows and just the values from that one location. That's the open. Stock open. And let's go ahead and run that. So that's loaded in there. And then let's go ahead and we have our inputs. We're going to create inputs here. And this should all look familiar because this is the same thing we did before. We're going to take our data set total. We're going to do a little pandas concat from the data set train. Now remember, the end of the data set train is part of the data going in. And let's just visualize that just a little bit. Here's our train data. Let me just put TR for train. And it went up to this value here. But each one of these values generated a bunch of columns. So it was 60 across, and this value here equals this one, and this value here equals this one, and this value here equals this one. And so we need these top 60 to go into our new data because that's part of the next data, or it's actually the top 59. So that's what this first setup is over here, is where we're going in, we're doing the real stock price, and we're going to just take the data set test and we're going to load that in. And then the real stock price is our data test location. So we're just looking at that first column, the open price. And then our data set total, we're going to take pandas and we're going to concat. And we're going to take our data set train for the open and our data set test open. And this is one way you can reference these columns. We've referenced them a couple different ways. We've referenced them up here with the 1, 2. But we know it's labeled as a panda set as open. So pandas is great that way. Lots of versatility there. And we'll go ahead and go back up here and run this. There we go. And you'll notice this is the same as what we did before. We have our open data set. We concatenated our two data sets together. We have our inputs equals data set total length minus length of data set minus test minus 60 values. So we're going to run this over all of them. And you'll see why this works. Because normally when you're running your test set versus your training set, you run them completely separate. But when we graph this, you'll see that we'll be looking at the part that we didn't train it with to see how well it graphs. And we have our inputs equals inputs dot reshape, so reshaping like we did before. We're transforming our inputs. So if you remember from the transform between 0 and 1. And finally we want to go ahead and take our X test, and we're going to create that X test, and for I in range 60 to 80. So here's our X test, and we're appending our inputs I to 60, which remember is 0 to 59, and I comma 0 on the other side. So it's just the first column, which is our open column. And once again, we take our X test, we convert it to a numpy array. We do the same reshape we did before, and then we get down to the final 2 lines, and here we have something new. Right here on these last 2 lines, let me just highlight those or mark them. Predicted stock price equals regressor.predicts X test. So we're predicting all the stock, including both the training and the testing model here. And then we want to take this prediction and we want to inverse the transform. So remember, we put them between 0 and 1, well, that's not going to mean very much to me to look at a float number between 0 and 1. I want the dollar amounts. I want to know what the cash value is. And we'll go ahead and run this, and you'll see it runs much quicker than the training. That's what's so wonderful about these neural networks. Once you put them together, it takes just a second to run the same neural network that took us, what, a half hour to train? Head and plot the data. We're going to plot what we think it's going to be, and we're going to plot it against the real data, what the Google stock actually did. So let's go ahead and take a look at that in code. And let's pull this code up. So we have our PLT. That's our, if you remember from the very beginning, let me just go back up to the top. We have our matplotlibary.pyplot as PLT. That's where that comes in. And we come down here, we're going to plot, and let me get my drawing thing out again. We're going to go ahead, and PLT is basically kind of like an object. It's one of the things that always threw me when I'm doing graphs in Python, because I always think you have to create an object, and then it loads that class in there. Well, in this case, PLT is like a canvas you're putting stuff on. So if you've done HTML5, you'll have the canvas object. This is the canvas. So we're going to plot the real stock price. That's what it actually is. And we're going to give that color red, so it's going to be in bright red. We're going to label it real Google stock price. And then we're going to do our predicted stock, and we're going to do it in blue, and it's going to be labeled predicted. And we'll give it a title, because it's always nice to give a title to your graph, especially if you're going to present this to somebody, to your shareholders in the office. And the X label is going to be time, because it's a time series. And we didn't actually put the actual date and times on here, but that's fine. We just know they're incremented by time. And then, of course, the Y label is the actual stock price. PLT.legend tells us to build the legend on here so that the color red and real Google stock price show up on there. And then the plot shows us that actual graph. So let's go ahead and run this and see what that looks like. And you can see here we have a nice graph, and let's talk just a little bit about this graph before we wrap it up. Here's our legend I was telling you about. That's why we have the legend to show the prices. We have our title and everything. And you'll notice on the bottom we have a time sequence. We didn't put the actual time in here. Now we could have. We could have gone ahead and plotted the X, since we know what the dates are, and plotted this to dates. But we also know that it's only the last piece of data that we're looking at. So last piece of data, which ends somewhere probably around here on the graph, I think it's like about 20% of the data, probably less than that. We have the Google price, and the Google price has this little up jump and then down, and you'll see that the actual Google, instead of a turn down here, just didn't go up as high and didn't go down. So our prediction has the same pattern, but the overall value is pretty far off as far as stock. But then again, we're only looking at one column. We're only looking at the open price. We're not looking at how many volumes were traded. And like I was pointing out earlier, when we talk about stock, just right off the bat, there's 6 columns. There's open, high, low, close, volume. Then there's whether how many volume shares. Then there's the adjusted open, adjusted high, adjusted low, adjusted close. They have a special formula to predict exactly what it would really be worth based on the value of the stock. And then from there, there's all kinds of other stuff you can put in here. So we're only looking at one small aspect, the opening price of the stock. And as you can see here, we did a pretty good job. This curve follows the curve pretty well. It has like little jumps on it, bends. They don't quite match up. So this bend here does not quite match up with that bend there, but it's pretty darn close. We have the basic shape of it, and the prediction isn't too far off. And you can imagine that as we add more data in and look at different aspects in the specific domain of stock, we should be able to get a better representation each time we drill in deeper. Of course, this took a half hour for my computer to train, so you can imagine that if I was running it across all those different variables, it might take a little bit longer to train the data. Not so good for doing a quick tutorial like this. So we're going to dive right into what is Keras. We'll also go all the way through this into a couple of tutorials, because that's where you really learn a lot, is when you roll up your sleeves. So we talk about what is Keras. Keras is a high-level deep learning API written in Python for easy implementation of neural networks. It uses deep learning frameworks such as TensorFlow, PyTorch, etc. as backend to make computation faster. And this is really nice because as a programmer, there is so much stuff out there and it's evolving so fast, it can get confusing. And having some kind of high-level order in there, we can actually view it and easily program these different neural networks is really powerful. It's really powerful to have something out really quick and also be able to start testing your models and seeing where you're going. So Keras works by using complex deep learning frameworks such as TensorFlow, PyTorch, MLFull, etc. as a backend for fast computation, while providing a user-friendly and easy-to-learn front-end. And you can see here we have the Keras API specifications, and under that you'd have like TF Keras for TensorFlow, Thano Keras, and so on. And then you have your TensorFlow workflow that this is all sitting on top of. And this is, like I said, it organizes everything. The heavy lifting is still done by TensorFlow or whatever underlying package you put in there. And this is really nice because you don't have to dig as deeply into the heavy end stuff while still having a very robust package you can get up and running rather quickly. And it doesn't distract from the processing time because all the heavy lifting is done by packages like TensorFlow. This is the organization on top of it. So the working principle of Keras. The working principle of Keras is Keras uses computational graphs to express and evaluate mathematical expressions. And you can see here we put them in blue. They have the expression expressing complex problems as a combination of simple mathematical operators, where we have like the percentage, or in this case in Python that's usually your remainder, or multiplication. You might have the operator of x to the power of 0.3. And it is useful for calculating derivatives by using back propagation. So if we're doing with neural networks, when we send the error back up to figure out how to change it, this makes it really easy to do that without really not banging your head and having to hand write everything. It's easier to implement distributed computation, and for solving complex problems, specify input and outputs and make sure all nodes are connected. And so this is really nice as you come in through, is that as your layers are going in there, you can get some very complicated different setups nowadays, which we'll look at in just a second. And this just makes it really easy to start spinning this stuff up and trying out the different models. So when we look at Keras models, Keras model, we have a sequential model. Sequential model is a linear stack of layers where the previous layer leads into the next layer. And this, if you've done anything else, even like the sklearn with their neural networks and propagation and any of these setups, this should look familiar. You should have your input layer, it goes into your layer 1, layer 2, and then to the output layer. And it's useful for simple classifier or decoder models. And you can see down here we have the model equals a Keras sequential, and this is the actual code. You can see how easy it is. We have a layer that's dense, your layer 1. As an activation, they're using the ReLU in this particular example. And then you have your name layer 1, layer dense ReLU, name layer 2, and so forth. And they just feed right into each other. So it's really easy just to stack them, as you can see here, and it automatically takes care of everything else for you. And then there's a functional model. And this is really where things are at. This is new. Make sure you update your Keras, or you'll find yourself running this, doing the functional model. You'll run into an error code because this is a fairly new release. And it uses multi-input and multi-output model. The complex model which forks into 2 or more branches. And you can see here we have our image inputs equals your Keras input shape equals 32 by 32 by 3. You have your dense layers, dense 64 activation ReLU. And this should look similar to what you already saw before, but if you look at the graph on the right, it's going to be a lot easier to see what's going on. You have 2 different inputs. And one way you could think of this is maybe one of those is a small image and one of those is a full-sized image. And that feedback goes into, you might feed both of them into one node because it's looking for one thing, and then only into one node for the other one. And so you can start to get kind of an idea that there's a lot of use for this kind of split and this kind of setup. Where you have multiple information coming in, but the information's very different even though it overlaps. And you don't want it to send it through the same neural network. And they're finding that this trains faster and also has a better result depending on how you split the data up and how you fork the models coming down. And so in here we do have the 2 complex models coming in. We have our image inputs, which is a 32 by 32 by 3, or 3 channels, or 4 if you're having an alpha channel. You have your dense, your layers, dense is 64 activation using the ReLU, very common. X equals dense inputs, X layers dense X64 activation equals ReLU, X outputs equals layers dense 10X, model equals cross model inputs equals inputs, outputs equals outputs, name equals minced model. So we add a little name on there. And again, this is this kind of split here. This is setting us up to have the input go into different areas. So if you're already looking at Keras, you probably already have this answer. What are neural networks? But it's always good to get on the same page, and for those people who don't fully understand neural networks, to dive into them a little bit or do a quick overview. Neural networks are deep learning algorithms modeled after the human brain. They use multiple neurons, which are mathematical operations, to break down and solve complex mathematical problems. And so just like the neuron, one neuron fires in and it fires out to all these other neurons, or nodes as we call them, and eventually they all come down to your output layer. And you can see here we have the really standard graph input layer, a hidden layer, and an output layer. One of the biggest parts of any data processing is your data pre-processing. So we always have to touch base on that. With a neural network, like many of these models, they're kind of, when you first start using them, they're like a black box. You put your data in, you train it, and you test it and see how good it was. And you have to pre-process that data, because bad data in is bad outputs. So in data pre-processing, we will create our own data examples set with Keras. The data consists of a clinical trial conducted on 2,100 patients, ranging from ages 13 to 100, with the patients under 65 and the other half over 65 years of age. We want to find the possibility of a patient experiencing side effects due to their age. And you can think of this in today's world with COVID.
So guys, let's start first with a beginner level project. And the first project that we are going to encounter, that is home value prediction. So guys, this project aims to develop a predictive model to estimate the value of residential properties. The model will analyze various features such as location, square, footage, number of bedrooms and bathrooms, age of the property, and other relevant factors. By leveraging historical property data, the model will be able to provide accurate home value predictions, which can be useful for real estate agents, buyers, and sellers. So guys, the programming language that we are going to use all over here will be Python, and machine learning libraries that we will be using will be Scikit-learn, TensorFlow, Keras, and for data handling libraries we have Pandas, NumPy, and for visualization we have to use Matplotlib and Seaborn. Now what will be the approach for this one, guys? So guys, the first one that we have a data collection. So here what is going to happen, guys? So first you have to collect the historical property data from the sources like Zillow, retailer.com. You can also get database from the public real estate databases like Kaggle datasets, where you have Zillow home value prediction. Ensure that the dataset include features like location, where you have latitude, longitude, square footage, number of rooms, year built, property type, and previous sales. The next step that comes is data cleaning. You have to handle the missing values by using imputation techniques or removing incomplete records, removing outliers that may skew the model's prediction, normalize or standardize the data to ensure consistency. The third one that we have is feature engineering. You have to create new features such as proximity to schools, crime rates, and access to the public transportation. Encode categorical variables, example property type, location, using techniques like one-hot encoding. Generate interaction features that capture relationship between existing features. The fourth one that we have is model selection. Use regression models like linear regression, random forest, gradient boosting, neural networks. Experiment with different models to identify the best performing one. Now, in the next phase, all you have to do, guys, is model training and evaluation. Split the data set into training and test sets. Train the model on the training set and evaluate their performance on the testing set using metrics like RSME, which means root mean squared error. You can use cross-validation to ensure the model's robustness and avoid overfitting. The sixth one that we have all over here is hyperparameter tuning. You can optimize the model's hyperparameter using techniques such as grid search or random search to improve accuracy. And if you're looking forward to deploy your model, then you can develop a web interface using Flask or Django to allow users to input property features and get predictions. You can deploy the model on the cloud platform like AWS for scalability. Now, if we talk about the complexity level of this, we all know that it is a beginner level project. Now let us move on to the one more set, that is music genre classification and generation. So guys, this is also one of the most beginner level project. This project aims to develop a system that can classify music tracks into different genres and generate new music composition within specified genre. The goal is to build a model that analyzes audio features to categorize music and uses deep learning techniques to create new music. This project introduces advanced concept of audio processing, deep learning, and generative models. So guys, what will be used in this? So we'll have programming language, that will be Python. For audio processing, we'll be using Librosa. For machine learning libraries, we'll be using TensorFlow, Keras, PyTorch. For data handling libraries, we'll be using Pandas, NumPy. For visualization, we'll be using Matplotlib, Seaborn. For the dataset, guys, you can use GTZan music genre dataset, or you can get it from Free Music Archive. So guys, in the first phase, we are going to have data collection. You can obtain datasets containing music tracks and their corresponding genre from the sources, from GTZan music genre dataset and the Free Music Archive. Ensure that a dataset includes diverse genre and substantial number of tracks per genre. Next, we'll go for data preprocessing. Use library Librosa to load and preprocess audio files, including feature extractions such as mil frequency, cepstral coefficients, chroma features, and spectral contrast. You can normalize the extracted features to ensure consistent input for the given models. Now, if we talk about feature engineering, guys, you can extract additional features from the audio files such as tempo, beat, zero crossing rate, etc. Create a feature matrix that represents the extracted audio features. Then go for the model selection. Use convolutional neural network or recurrent neural networks for the music genre classification. Split the dataset into training and testing dataset. Now, if we talk about model training and evaluation, guys, then you can train the selected classification model on the training set. Evaluate the model's performance on the testing set using metrics like accuracy, precision, recall, and F1 score. Use confusion matrices to understand the classification performance across different genres. Now, if we talk about model selection and training for the music generation, what you will do, guys, you can use the generative adversarial networks or recurrent neural networks such as LSTM, long short-term memory for music generation. Train the generative model on the dataset to create new music sequences. Next, we have model training and evaluation. You can train the generative model on sequences of audio features. You can evaluate the generated music by listening tests and by objective metrics like inception score or Friese audio distance. If I talk about hyperparameter tuning, guys, you can optimize the model. You can use the hyperparameters using techniques like grid search or random search to improve performance. If I talk about deployment, guys, you can deploy these models on cloud platforms like AWS. Now, let us move on to our next project. So guys, the complexity of this project is at the beginner level. Now, let us move to the intermediate level projects. Next project that we have all over here is sentiment analysis of Twitter data. This project aims to develop a sentiment analysis model that can classify tweets as positive, negative, or neutral. The goal is to analyze public sentiment on various topics or events using natural language techniques. So guys, what will be used all over here? So in this, we will have programming language like Python, okay, NLP libraries, NLTK Spacey. For machine learning libraries, you can use scikit-learn, TensorFlow, Keras. For data handling libraries, we have Pandas, NumPy. For visualization, we have Matplotlib, Seaborn, and we can use the API Twitter for data collection. Now, how you're going to work on it, guys? So guys, if I talk about the data collection, use a Twitter API to collect tweets based on specific hashtags like keywords or topics. Extract relevant fields like tweet text, user information, timestamp, etc. Then if I talk about data preprocessing, guys, clean the tweet text by removing special characters, links, mentions, hashtags, and stop words. Tokenize the text and perform lemmaization or stemming to reduce the words to their base form. Next, if we talk about feature engineering, guys, you convert the clean text data into numerical representation using TF-IDF, bag of words, or word embedding. Now, if I talk about model selection, guys, you can choose the classification algorithms such as logistic regression, Naive Bayes, or LSTM. Split the data set into training and testing data set. Now, if I talk about model training and evaluation, then you can train the selected model on the training set. Evaluate the model's performance on the testing set using metrics like accuracy, precision, recall, and F1 score. Use cross-validation to ensure the model's robustness. If I talk about hyperparameter tuning, guys, you can optimize the model's hyperparameters using grid search or random search to improve the performance. For deployment, which can be optional, You can deploy your model on AWS for real-time sentiment analysis. So if I talk about the complexity level, guys, its complexity is intermediate. So guys, our next project is customer segmentation using k-means clustering. This project aims to segment customers into distinct groups based on their purchasing behavior and demographic information. The objective is to understand customer segments and tailor marketing strategies accordingly. So guys, what programming languages we'll be using? So basically, we'll be using Python. For machine learning libraries, we'll have scikit-learn. For data handling libraries, we'll have pandas, numpy. For visualization libraries, we'll have matplotlib, seaborn. And the dataset source will be e-commerce transaction data. How we are going to work on this one? For data collection, we can obtain a dataset of e-commerce transactions that include customer demographics, purchase history, and product information. Next, we'll have data pre-processing. For data pre-processing, we are going to do the cleaning of the data by handling the missing values and outliers. Then, for feature engineering, we are going to create features like total purchase amount, purchase frequency, and recency of the purchases. Then we are going to proceed for the model selection. You can use k-means clustering to segment the customers into distinct groups. You can determine the optimal number of clusters using methods like elbow methods or Silhouette score. Now, if I talk about model training and evaluation, you can train the k-means model on the processed dataset. You can evaluate the quality of clusters by analyzing intra-cluster and inter-cluster distances. Next, we have the evaluation. You can visualize the clusters using techniques like PCA, principal component analysis, TSNE, etc. Next, we have the hyperparameter tuning. Now you can tune this model and interpret the characteristic of each segment. You can develop a target marketing strategies for each segment based on unique behavior and preferences. Now, deployment is optional. You can develop a dashboard using Flask or Django to visualize customer segments and track marketing campaigns. So guys, if I talk about the complexity of this project, so this is an intermediate level project. So guys, for dataset, you can use the Kaggle's customer segmentation dataset, which is available at the Kaggle's platform. Now, the third intermediate level project that we have all over here is building a chatbot with RASA. This project aims to build an intelligent chatbot using RASA framework. The chatbot will be capable of understanding user queries and providing appropriate responses, making it useful for customer support, personal assistance, or information retrieval. What languages we are going to use? So it will be Python based. We'll have the NLP libraries like RASA, NLTK, Spacy. For machine learning libraries, we are going to have scikit-learn, TensorFlow, Keras, etc. For data handling libraries, we are going to use pandas, numpy. So guys, this was what we are going to do it. And how you can work on this one? By collecting the data, collect the conversation data and FAQs from the target domain. Annotate the data to create training examples for the chatbot. Next comes is data pre-processing. Clean the text data by removing special characters and normalizing the text. You can tokenize and limitize the text to prepare for a training. The third one, we have the models training. You can use RASA's NLU's component to train a model for intent recognition and entity extraction. You can define the dialogue management policies to handle different conversation flows. Next guys, you can perform the feature engineering and integration. You can integrate the RASA's NLU and core components to build complete chatbot. You can connect the chatbot to messaging platform like Facebook, Messenger, etc. For model selection and testing, what you can do guys, you can test this chatbot with various inputs to ensure that it handles the scenarios appropriately. And you can also select the right model using this. Now, if I talk about model training guys, what do you have to do? You have to collect the user feedback and conversational logs to continuously work on training the model. Next, similarly, you have to retrain the model periodically with the new data to see how it is working. So that will be your evaluation. Now, for the hyperparameter tuning, what are you going to do guys? You have to check in those scenarios where it is able to tune up with those scenarios where it can handle the input appropriately. And next is deployment. So guys, for deploying it, you can use AWS. So guys, for a data set, you can use RASA's open source. So that's a very good data set for you to proceed. So guys, if you talk about difficulty of this project, this is an intermediate level project. Now let us move on to the advanced level projects. For advanced level projects, the first one that comes up to my mind is movie similarity from plot summaries. Now, this project aims to develop a system that can find out recommended movies similar to a given movie based on their plot summaries. By analyzing the textual content of the movie, plot summaries, the model will identify similarities and suggest movies with similar themes, storylines, or genres. This project introduces beginners to natural language processing, text similarly measures, and recommendation systems. What languages we are going to use, guys? We'll be using Python, NLP libraries like NLTK, Spacey, machine learning libraries like scikit-learn, data handling libraries like pandas, numpy, visualization, we can use numpy, and dataset source will be IMDb or Kaggle. So guys, this process is also involving the data collection. Then you have to go for data cleaning, then feature engineering, next model selection. So similar process as I have discussed in other projects, so you have to also go through the same one. Next, what do you have to do, guys? Similarly, what do you have to do? You have to train the model, then evaluate the model, then hypertune it, and finally proceed for the deployment. So this is overall process of this project. Try to research on the website a lot, like how you can extract it. So guys, you can use Kaggle or Towards Data Science to research more about this project. Now guys, if I talk about the difficulty of this project, then this is an advanced level project. Now, let us move on to the next one that we have all over here. That is image segmentation project for brain tumor prognosis. This is a very amazing project and definitely you can put up on your portfolio. Basically guys, this project aims to develop an image segmentation model to identify and delineate brain tumors from MRI scans. The goal is to accurately segment the tumor regions which can aid in prognosis, treatment planning, surgical interventions. This project introduces intermediate level concepts of computer vision, deep learning and medical image analysis. So guys, what we'll be using all over here? For programming languages, we can use Python. For deep learning libraries, we can use TensorFlow, Keras, PyTorch. For image processing libraries, we can use OpenCV, scikit-image. For data handling libraries, we can use Pandas, NumPy. For visualization, we can use Matplotlib, Seaborn. Now, if I talk about what is the process of developing this project, the first step will be the same, data collection. So next step, you have to go for data pre-processing. Third step, you have to do the model selection where you can use CNN models for image segmentation task. Then you go for model selection. Moving ahead, you're going to have the model training and evaluation. You have to split the data set into training and validation and testing data sets. Next, proceed for the evaluation phase. Okay, evaluate the model with certain metrics. So here I can give you certain idea, like you can use dice coefficient, intersection over union, or accuracy. Then go for hyperparameter tuning, where you have to optimize the model's hyperparameters. You can use grid search or random search as we have discussed. And finally, you can deploy this model on AWS. Now guys, we have come to the final project. This is also a very amazing project, guys. So guys, the complexity level of this project is advanced level. Now, let us move on to our final project. That is the impact of climate change on birds. This is a very amazing project and definitely you can add it on your resume. This project aims to analyze the impact of climate change on the bird population and migration patterns. By examining various climatic factors and their correlation with bird species data, the project seeks to predict how climate change might affect bird behavior and distribution. This project will introduce you some advanced level concepts like time series analysis, environmental data modeling, etc. So guys, what programming languages we'll be using? For data analysis, you can see we'll have Pandas, NumPy. For machine learning libraries, we are going to have scikit-learn, TensorFlow. For visualization, we are going to have Matplotlib, Plotly. For geospatial, we are going to have GeoPandas, Folium. For data source, we're going to have public data sets on bird observation and climate data sources from eBird. Now, what will the process flow for this one, guys? First, you have to proceed for data collection. Gather bird observation from the data like eBird, which provides extensive record of bird sightings. Okay, and for climate data, you can collect it from NOAA, including temperature, precipitation, and other relevant climatic factors over the time. And similar next process will be the data pre-processing. Then you have to proceed for feature engineering. Then you have to go for model selection. Okay, moving ahead, you have to go for model training, then evaluation, then hyperparameter tuning, and finally, you have to deploy the model. So research about this project, see what models you are going to use. Suppose I can give you a hint about this. You can use time series analysis models like ARIMA, or ML models. You can also use random forest or gradient boosting for predicting impact on the bird population. So guys, use Google exhaustively to research about this project. This is also a very amazing project and it's going to give you a lot of idea. Now, if I talk about the complexity level of this, it is an advanced level project.
Today we are talking about must-have Python AI projects and how to build them so that can really help you sharpen your skills and stand out in the growing field of artificial intelligence. So let's quickly see what is Python. Python is one of the most popular programming languages for AI because its simplicity and the powerful libraries it offers, like TensorFlow, Keras, and PyTorch. Building projects using Python is a great way to get started if you want to break into the AI industry. Whereas artificial intelligence is transforming industries like healthcare, finance, and even entertainment. Companies are now looking for experts who know how to apply AI to real-world problems. In this video, we will explore beginner level to advanced level projects. So these projects are designed to give you hands-on experience in building intelligent systems, analyzing data, and even automating tasks. So without any further ado, let's get started. So let's start with beginner level projects. So number one, we have fake news detection using machine learning. So in today's world, fake news is a major concern, causing misinformation to spread rapidly across social media and news platforms. Detecting fake news is crucial to maintaining the integrity of the information we consume. So these projects aim to build a machine learning model that can identify fake news articles by analyzing their textual content, by learning from existing datasets of real and fake news. The model will be able to classify articles into these two categories, thus assisting media outlets and social media platforms in reducing the spread of misinformation. This project is perfect introduction to natural language processing, NLP, as it involves text data manipulation, feature extraction, and supervised learning. It can also be adapted for real-time use on website or social media platforms to flag suspicious articles and provide more reliable information to users. So now let's see how to build this. In this, first step is data collection. Use dataset like LIAR or fake news net that can contain label, real, and fake news articles. You can find dataset from the Kaggle. The second step is pre-processing. Clean the text by removing stop words, punctuation, and special characters. Tokenize and stem words using NLTK or spacing. The third step is feature extraction. Use TF, IDF, or bag of words to convert the text into numerical data for machine learning models. The fourth step is model training. Train a classifier like logistic regression, naive Bayes, or random forest on the dataset. The fifth step is evaluation. Evaluate the model using accuracy, precision, recall, and F1 score metrics to determine how well it classifies fake and real news. Tools you can use is NLTK, Scikit-learn, and Pandas. Skills you will gain from this are text preprocessing, NLP, classification models. And if you want to make us video on this project, please comment down below. In number two, we have image recognition using CNN. Image recognition is one of the core applications of deep learning and computer vision, used in a variety of industries ranging from healthcare to autonomous vehicles. This project will guide you through building an image classifier using CNNs, a deep learning architecture designed specifically for image recognition tasks. The goal is to create a model that can accurately classify images, such as differentiating between cats and dogs. By working on this project, you will gain a solid understanding of the fundamental concepts of CNNs, such as convolutional layers, pooling, and activation functions. This project not only introduces you to the basics of CNNs, but also teaches essential skills like image preprocessing, dataset handling, and model evaluation, which can be applied to more advanced computer vision projects in the future. So now let's see how to build this project. In this project, first you have to import dataset. So use a dataset like CIFR10 or Kaggle cats versus dogs with labeled images. The second step is pre-processing. Resize, normalize, and augmented images using libraries like OpenCV or PIL to prepare the dataset. The third step is model architecture. Design a basic CNN model with convolutional, pooling, and fully connected layers using Keras or TensorFlow. The fourth step is training. Split the dataset into training and validation sets and train the CNN model to classify images. The fifth step is model evaluation. Use accuracy, precision, and confusion metrics to evaluate how well the model predicts the correct class label. Tools you will use in this project are Keras, TensorFlow, OpenCV, Pandas. Skills you will gain after doing these projects are image preprocessing, CNN architecture, model evaluation. And if you want to make us video on image recognition using CNN, please comment down below. Second, we have intermediate level projects. In this first, we have AI-based recipe recommendation system. Recommendation systems have become an integral part of modern digital platforms. From e-commerce website suggesting product to users to streamlined services recommending shows and movies. So in this project, you will build a recipe recommendation system that suggests dishes based on the ingredients a user has on hand. This project demonstrates how recommendation algorithms such as content-based filtering and collaborative filtering can be used to provide personalized suggestions. You will also learn how to pre-process data and clean textual data, such as ingredient lists, and implement a machine learning algorithm to match user inputs with recipe databases. This is an excellent project for understanding how recommendation systems work and how they can be applied in various industries, from food tech to personalized content recommendations. So now let's see how to build this. In this project, first step is data collection. Use web scraping tools like Beautiful Soup to scrape recipes from websites, or use datasets like Recipe 1M. The second step is pre-processing. Normalize and clean ingredient data by standardizing ingredient names and handling missing values. The third step is recommendation algorithms. Implement content-based filtering and collaborative filtering to recommend recipes. Content-based filtering matches ingredient list, while collaborative filtering uses user preferences model. Fourth step is model training. Use cosine similarity to match user-provided ingredients with recipe ingredient in the dataset. And the next step is interface and tools. So create a simple web interface using Flask where users can input ingredients and receive recipe recommendation. Tools you will use: Beautiful Soup, Pandas, Scikit-learn, and Flask. So you will gain skills like web scraping, data cleaning, recommendation systems using this project, by doing this project. And if you want to make us video on this project, please comment down below. Number 4, we have chatbot with sentiment analysis. Chatbots have transformed how businesses and services interact with users, providing 24/7 support and personalized responses. In this project, you will build a conversational chatbot that can analyze the sentiment behind user inputs and respond accordingly. By incorporating sentiment analysis, the chatbot will not only understand the content of the user's messages, but also the emotional tone, such as whether the user is happy, frustrated, or neutral. This allows the chatbot to adjust its tone and responses to improve user satisfaction. For example, a chatbot could offer a more empathetic response if it detects a negative sentiment. This project will give you hands-on experience in building a conversational AI system while learning how to integrate machine learning techniques like sentiment analysis. The skills you develop in this project can be applied to customer service, healthcare, education, and more. So now let's see how to build this project. So before jumping to advanced level projects, here is a quick info for you. Dive into the future of AI with our generative AI and machine learning course in collaboration with and ICT Academy, IIT Guwahati. Learn tools like ChatGPT, OpenAI, Hugging Face, Python, and more. Join masterclass led by IITG faculty, engage in hands-on projects, and earn executive alumni status. This generative AI and machine learning course enriches your career journey with comprehensive coverage of machine learning, deep learning, NLP, generative AI, reinforcement learning, computer vision, and more. Combining theory with hands-on practice, it offers live virtual sessions, projects with integrated labs, and masterclasses by IIT Guwahati faculty. So find the course link from the description box below and the pinned comment. In this project, the first step is chatbot framework. Use tools like Dialogflow or Rasa to build a conversational chatbot capable of handling various user intents. The second step is sentiment analysis. Integrate a sentiment analysis model using pre-trained models like Veda or BERT. The third step is conversational flow. Adjust the chatbot's responses based on the sentiment, positive, negative, or neutral, detected in the user's input. The fourth step is integration and deployment. So build an interface, website, or messaging platform where users can interact with the chatbot in real time, and deploy the chatbot on a website or app, allowing user to engage with it and receive sentiment-aware responses. So you will use tools in this are Dialogflow, Rasa, Vader, Transformers, Flask, and you will gain skills like sentiment analysis, chatbot deployment, conversational AI. And if you want to make us video on this project, please comment down below. So now let's see some advanced level projects. In this we have AI-powered image colorization. Image colorization is a fascinating application of deep learning that transforms black and white images into color by predicting and applying realistic colors to grayscale images. This project explores how CNN and GANs can be used to learn mapping between grayscale and colored images. You will gather a dataset of colored images, convert them into grayscale, and train the model generate color version. This project is especially useful in areas such as film restoration, photography, and artistic creation, where colorization can breathe new life into old black and white images. Moreover, it highlights the power of deep learning in understanding and generating complex visual data, giving you insight into how these models work for tasks like image generation, video prediction, and beyond. The skills you learn in this project will also be useful for other creative AI applications like style transfer and image synthesis. So now let's see how to build this project. So in this project, first step is data collection. Use dataset of colored image, convert them into grayscale, and use the grayscale images as inputs while training the model to output colorized version. The second step is pre-processing. Normalize images pixel values and resize them for training. The third step is model architecture. Implement a unit model or generative adversarial network (GANs) which are well suited for image generation tasks like colorization. Fourth step is training and evaluation. Train the model on grayscale images as input and colored images as output using mean squared error method for guidance. Evaluate with visual inspection and peak signal to noise ratio. The last step is deployment. So create a web interface where user can upload black and white images and get them colorized. So you will use tools like TensorFlow, Keras, OpenCV, and Flask. So we'll gain skills like deep learning, CNNs, JNs, and image preprocessing. And if you want to make a video on AI-powered image colorization project, so please comment down below. And the last we have object detection using YOLO. You only look once. Object detection is one of the most popular computer vision applications, allowing machine to recognize and locate multiple objects within an image or video stream in real time. YOLO is a state-of-the-art object detection algorithm known for its speed and accuracy. This project involves building a real-time object detection system capable of identifying multiple objects in images or videos feeds by drawing bounding boxes around them. Object detection has widespread use in fields such as security surveillance, autonomous driving, and augmented reality, where systems need to understand and interact with their surroundings in real time. By working on this project, you will learn how to pre-process image data, format bounding box labels, and train a YOLO model using a dataset like Coco or Pascal. You will also gain a valuable experience in deploying object detection systems that process video streams, giving you the skills to build application in dynamic environment, from traffic monitoring to industrial robotics. So now let's see how to build this project. So in this project, we will first import dataset. So use a dataset like Coco or Pascal VOC, which contains label objects in images with bounding boxes. The second step is pre-processing. Resize image and normalize pixel values, ensuring bounding box labels are appropriately formatted. The third step is model architecture. Use the YOLO, you only look once architecture, which splits images into a grid and predicts bounding boxes and class probabilities for each object. The fourth step is training and evaluation. Train the YOLO model on label data using a framework like Darknet. Evaluate the model using metrics like intersection over union and mean average precision. The last step is deployment. Develop a system that can process video streams in real time, detecting objects and drawing bounding boxes around them. Tool you will use OpenCV, TensorFlow, and Darknet. You will gain skills like object detection, YOLO architecture, real-time video processing. And if you want to make videos on this project, please comment down below. So in conclusion, these Python AI projects not only help you build hands-on skills, but also provide a solid foundation for advancing your career in artificial intelligence. Whether you are working on fake news detection, image recognition, or developing advanced tools like chatbots and object detection systems, these projects offer real-world applications that companies are looking for. Start small, keep learning, and as you complete each project, you will get better prepared to take on the challenges in the growing AI field.
So without any further ado, let's begin with top AI, ML, and deep learning interview questions for 2023. Over to our experts.
We'll start with a very general concept of what is deep learning. This is where we take large volumes of data, in this case on cats and dogs or whatever. A lot of times you use a training setup to train your model. Remember, it's kind of like a magic black box going on there. And then we use that to extract features or extract information, and in this case classify the image of a cat and a dog. So the primary takeaway when we're talking about deep learning is it learns from large volumes of structured and even unstructured data and uses complex algorithms to train neural network. It also performs complex operations to extract hidden patterns and features. And if we're going to discuss deep learning in this very simplified overview, then we also have to go over what is a neural network. This is a common image you'll see of a drawing of a forward propagation neural network. And it's a human brain inspired system which replicate the way humans learn. So this is inspired how our own neurons in our brain fire, but at a much simplified level. Obviously it's not ready to take over the human population and be our leader yet, not for many years. It's very much in its infant stage. But it's inspired by how our brains work. And they use a lot of other inspirations. You can study brains of moths and other animals that they've used to figure out how to improve these neural networks. The most common one consists of 3 layers of network, and this is generally how you view these networks, is you have an input, you have a hidden layer, and an output. And the neural network is broken up into many pieces, but when we focus just on the neural network, it's always on the hidden layers that we're making all the adjustments and figuring out how to best set up those hidden layers for their functions to both train faster and to function better. When we look at this, of course, we have our input, hidden, and output. Each layer contains neurons called as nodes that perform various operations. And you can see here we have the list of the nodes. We have both our input nodes and our output nodes, and then our hidden layer nodes. And it's used in deep learning algorithm like CNN, RNN, GAN, etc. We'll address some of these models a little closer, at least the most common models, as we go down the list and we study the deep learning and the neural network framework. Let's start with what is a multi-layer perceptron, or MLP, a lot of time is referred to. And you'll see these abbreviations. I'll be honest, I have to write them down on a piece of paper and go through them because I never remember what they all mean, even though I play with them all the time. What is a multi-layer perceptron? Well, if you look at the image on the right, it's very similar to what we just looked at. You have your input layer, your hidden layer, and your output layer. And that's exactly what this is. It has the same structure of a single layer perceptron with one or more hidden layers, except the input layer. Each node in the other layers uses a nonlinear activation function. What that means is your input layer is your data coming in, and then your activation function is based upon all those nodes and weights being added together, and then it has the output. MLP uses supervised learning method called backpropagation for training the model. Very key word there is backpropagation. Single layer perceptron can classify only linear separable classes with binary output, 0, 1, but the MLP can classify nonlinear classes. So let's break this down just a little bit. The multi-layer perceptron with an input layer and a hidden layer and an output layer. As you see that it comes in there, it adds up all the numbers and weights depending on how your setup is, that then goes to the next layer, that then goes to the next hidden layer if you have multiple hidden layers, and finally to the output layer. The backpropagation takes the error that it sees. So whatever the output is, it says, hey, this has an error to it, it's wrong. And then sends that error backwards from where it came from. And there's a lot of different functions used to train this based on that error and how that error goes backwards in the nodes. So forward is you get your answers, backward is for training. You see this every day. Even my Google Pixel phone has this. They train the neural network, which takes a lot more data to train than it does to use. And then they load up that neural network into, in this case I have a Pixel 2, which actually has a built-in neural network for processing pictures. And so it's just the forward propagation I use when it processes my photos. But when they were training it, it used the back propagation to train it with the errors they had. We'll be coming back to different models that are used. For right now, though, multi-layer perceptron, MLP. Put that down as your vocabulary word. And, of course, back propagation. What is data normalization and why do we need it? This is so important. We spend so much time in normalizing our data and getting our data clean and setting it up. So when we talk about data, there's a pre-processing step to standardize the data. So whatever we have coming in, we don't want it to be a 1 gigabyte file here, a 2 gigabyte picture here, and a 3 kilobyte text there. Even as a human, I can't process those all in the same group. I have to reformat them in some way that loops them together so that it's standardized format. We use this data normalization in pre-processing to reduce it and eliminate data redundancy. A lot of times the data comes in and you end up with 2 of the same images or the same information in different formats. Then we want to rescale values to fit into a particular range for achieving better convergence. What this means is with most neural networks, they form a bias. We've seen this recently in attacks on neural networks where they light up one pixel or one piece of the view and it skews the whole answer. So suddenly, because one pixel is really bright, it doesn't know what to do. Well, when we start rescaling it, we put all the values between, say, -1 and 1, and we change them and refit them to those values. It helps get rid of that bias, helps fix for some of those problems. And then finally, we restructure the data and improve the integrity. We want to make sure that we're not missing values or we don't have partial data coming in. One way to look at this is bad data in, bad data out. So you want clean data in and you want good answers coming out. One of the most basic models used is a Boltzmann machine. So let's address what is a Boltzmann machine. And if you know, we just did the MLP, multi-layer perceptron. So now we're going to come into almost a simplified version of that. And in this we have our visible input layer and we have our hidden layer. The Boltzmann machines are almost always shallow. They're usually just two-layer neural nets that make stochastic decisions whether a neuron should be on or off, true, false, yes, no. First layer is the visible layer, and second layer is the hidden layer. Nodes are connected to each other across layers, but no two nodes of the same layer are connected. Hence it is also known as restricted Boltzmann machine. Now that we've covered a basic MLP or multi-layer perceptron, and we've gone over the Boltzmann machine, also known as the restricted Boltzmann machine, let's talk a little bit about activation formulas. And this is a huge topic that can get really complicated, but it also is automated, so it's very simple. So you have both a complicated and a simple at the same time. So what is the role of activation functions in a neural network? Activation function decides whether a neuron should be fired or not. That's the most basic one. And that actually changes a little bit because it's either whether it's fired or not, in this case activation function, or what value should come out when it's fired. But in these models we're looking at just the Boltzmann restricted layers. So this is what causes them to fire. Either they don't or they do. It's a yes or no, true, false, all or nothing. It accepts the weighted sum of the inputs, the bias, as input to any activation function. So whatever our activation function is, it needs to have the sum of the weights times the input. So each input, if you remember on that model, and let's just go back to that model real quick. And then you always have to add a bias. And you can look at the bias if you remember from your Euclidean geometry. You draw a straight line. The formula for that line has a y coordinate at the end. It's always cx plus m or something like that, where m is where it crosses the y coordinates if you're doing a straight line. With these weights, it's very similar, but a lot of times we just add it in as its own weight. We take it as a node of a one value coming in, and then we compute its new weight, and that's how we compute that bias, just like we compute all the other weights coming in. The node which gets fired depends on the y value, and then we have a step function. And the step function, this is where, remember I said it's going to get complicated and simple all at the same time? We have a lot of different step functions. We have the sigmoid function, we have just a standard step function, we have the ReLU, it's pronounced like ray, the ray from the sun, and lu, like a name, so ReLU function. And we have the tangent h function. And if you look at these, they all have something similar. They all either force it to be one value or the other. They force it to be, in the case of the first three, a 0 or a 1, and in the last one, it's either a -1 or a 1. And you can easily convert that to a 0, 1, yes, no, true, false. And on this, one of the most common ones is the step function itself, because there is no middle value. There is no discrepancy that says, well, I'm not quite sure. But as you get into different models, probably the most commonly used, it used to be the sigmoid was most commonly used, but I see the ReLU used more often. Really, depending on what you're doing, you just have to play with these and find out which one works best, depending on the data in your output. The reason to have a non-0-1 answer or something kind of in the middle is when you're looking at this and it's coming out, you can actually process that middle ground as part of the answer into another neural network. So it might be that the ReLU function says, hey, this is only a 0.6, not a 1. And even though the 1 is what's going into the next neural network or the next hidden layer as an input, the 0.6 value might also be going in there to let you know, hey, this is not a straight up 1 or a straight up 0, it's someplace in the middle. This is a little uncertain what's coming out here. So it's a very powerful tool. But in the basic neural network, you usually just use the step function. It's yes or no. Let's take a big step back and take a kind of an overview. The next function is what is a cost function that we're going to cover. This is so important because this is your end result that you're going to do over and over again and use to decide whether the model is working or not, whether you need to try a different step function, whether you need to try a different activation, whether you need to try a fully different model used. So what is the cost function? Cost function is a measure to evaluate how good your model's performance is. It is also referred as loss or error, used to compute the error of the output layer during backpropagation. There's our backpropagation where we're training our model. That's one of our key words. Mean squared error is an example of a popular cost function. And so here we have the cost function C equals half of y minus y predicted, and then you square that. So the first thing is, real quick, if you haven't done statistics, this is not a percentage. It's not a percentage of how accurate it is. It's just a measurement of the error. And we take that error if we're training it, and we push that error backwards through the neural network, and we use that through the different training functions, depending on what model you're using, to train the neural network. So when you deploy the network, you're usually done training it, because it takes a lot of computational force to train it. This is a very simple model. And so you deploy the trained one, but we want to know how your error is. And so how do we do that? Well, you split your data. Part of your data is for training, and part of your data is for testing, and then we can also test the error on there. So that's very important. And then we're going to go one more step on this. We got to look at both the local and the global setup. It might work great to test your data on what you have on your computer, but that's different than in the field. So when we're talking about all these different tests in the error test, as far as your loss, you want to make sure that you're in a closed environment when you do your initial testing, but you also want to open that up and make sure you follow up with the testing on the larger scale of data, because it will change. It might not fit the larger scale. There might be something in there in the way you brought the data in specifically, or the data group you used, or any of those could cause an error. So it's very important to remember that we're looking at both the local and the global context of our error. And just one other side note on a lot of the newer models of neural networks, by comparing the error we get on the data, our training data, with a portion of the test data, we can actually figure out how good the model is, whether it's overfitted or not. We'll go into that a little bit more as we go into some of the different models. So we have our output. We're able to figure out the error on it based on the square means usually, although there's other functions used. So we want to talk about what is gradient descent, another vocabulary word. Gradient descent is an optimization algorithm to minimize the cost function or to minimize the error. Aim is to find the local or global minima of a function. Determine the direction the model should take to reduce the error. So, as we're looking at this, we have our squared error that we just figured out based on the cost function. It says, how bad is my model fitting the data I just put through it? And then we want to reduce that error. So how do you figure out what direction to do that in? Well, it could be that you're looking at just that line of data coming in, so that would be a local minima. We want to know the error of that particular setup coming in. And then you have your global minima. We want to minimize it based on the overall data we're putting through it. And with this, we can figure out the global minimum cost. We want to take all those local minimum costs of each piece of data coming in and figure out the global one. How are we going to adjust this model to fit all the data? We don't want it to be biased just on 3 or 4 lines of data coming in. We want it to kind of extrapolate a general answer for all the data coming in. And this, of course, we mentioned it briefly about back propagation. This is where it really comes in handy, is training our model. Neural network technique to minimize the cost function helps to improve the performance of the network, back propagates the error, and updates the weights to reduce the error. So as you can see here is a very nice depiction of a back propagation. We have our predicted y coming out, and then we have, since it's a training set, we already know the answer, and the answer comes back, and based on, in case of the square means was one of the functions we looked at, one of the activation functions based on cost function. That cost function then, depending on what you choose for your back propagation method, and there's a number of them, will change the weights. It will change the weight going to each of one of those nodes in the hidden layer, and then based upon the error that's still being carried back, it'll change the weights going to the next hidden layer. And then it computes an error level on that and sends that back up. And you're going to say, well, if it computes the error into the first hidden layer and fixes it, why would it stop there? Well, remember, we don't want to create a biased neural network. So we only make small adjustments on these weights. We don't make a big adjustment that changes everything right off the bat. So no matter how far back you go, you're always going to have a small amount of error, and that's still going to continue to go all the way back up the hidden layers. For right now, focus on the back propagation, is taking that error and moving it backwards on the neural network to change the weights and help program it so that it'll have the correct answers. So far, we've been talking about forward propagation neural networks. Everything goes forwards, goes left to right. But let's take a little detour and let's see what is the difference between a feed-forward neural network and a recurrent neural network. Now this is in the function, not when we're training it using the back propagation. So you've got new information coming in and you want to get the answer. And there's a couple different networks out there, and we want to know, we have a feed-forward neural network and we have a new vocabulary term, recurrent neural network. A feed-forward neural network. Signals travel in one direction from input to output. No feedback loops. Considers only the current input. Cannot memorize previous inputs. One example of one of these feed-forward neural networks, and we've covered a number of them, but one of the ones that has a big highlight nowadays is the CNN, a convolutional neural network. TensorFlow, the one put out by Google, is probably most known for their CNN, where the information goes forward. It first takes a picture, splits it apart, goes through the individual pixels on the picture so it picks up a different reading, then calculates based on that, goes into a regular feed-forward neural network, and then gives your categorization on there. Now, we're not covering the CNN today, but we do have a video out that you can look up on YouTube, put out by Simplilearn, the convolutional neural network. Wonderful tutorial. Check that out and learn a lot more about the convolutional neural network. But you do need to know that the CNN is a forward propagation neural network only. So it's only moving in one direction. So we want to look at a recurrent neural network. Signals travel in both directions, making it a looped network. Considers the current input along with the previous received inputs for generating the output of a layer. Has the ability to memorize past data due to its internal memory. And you can see they have a nice image here. We have our input, and for some reason they always do the recurrent neural network in reverse from bottom up in the images. Kind of a standard, although I'm not sure why. Your X goes into your hidden layer, and your hidden layer, the answer for part of the answer from that it generates feeds back into the hidden layer. So now you have an input of both X and part of the hidden layer, and then that feeds into your output. Now if we go back to the forward, let me just go back a slide, and we're looking at our forward propagation network. One of the tricks you can do to use just a forward propagation network is if you're in a what they call a time sequence. That's a good term to remember, or a time series, meaning that it's sequential data. Each term comes after the other. You can trick this by creating your input nodes as with the history. So if you know that you have values 1, 5, and 7 going in, and you know what the output is from what those outputs are, you can expand the input to include the history input. That's one of the ways to trick a forward propagation network into looking at that. But when you do it with a recurrent neural network, you let the hidden layer do that for you. It sends that data and reprocesses it back into itself. What are some of the applications of recurrent neural network? The RNN can be used for sentiment analysis and text mining. Getting up early in the morning is good for health. And it's a positive sentiment. One of the catches you really want to look at this when you're looking at the language is that I could switch this around and totally negate the meaning of what I'm doing, so it would no longer be positive. So when you're looking at a sentence, knowing the order of the words is as important as the meaning of the words. You can't just count how many good words there are versus bad words to get a positive sentiment. You now have to know what they're addressing. And there's lots of other different uses. Kids are playing football, or soccer as we call it in the US. RN can help you caption an image. So based on previous information coming in, it refeeds that back in and you have a image setter. And then time series problems like predicting the prices of stocks in a month or quarter or sale of products can be solved using an RNN. And this is a really good example. You have whatever your stocks were doing earlier this month will have a huge effect on what they're doing today if you're investing. So having an RNN model, a recurrent neural network, feeding into itself what was happening previously allows it to take that model and program in that whole series without having to put in the whole a month at a time of data. You can only put in one day at a time, but if you keep them in order, it will look back and say, oh, this is because of what happened yesterday. I need some information from that, and I'm going to use that to help predict today's, and so on and so on. We're going to go back to our activation functions. Remember I told you ReLU is one of the most common functions used? So let's talk a little bit more about ReLU and also softmax. Softmax is an activation function that generates the output between 0 and 1. It divides each output such that the total sum of the outputs is equal to 1. It is often used in the output layers. Softmax L of the n equals e to L of the n over the absolute value of e to the L. So what does this function mean? I mean, what is actually going on here? So we have our output nodes, and our output nodes are giving us, let's say they give us 1.2, 0.9, and 0.4. As a human being, I look at that and I say, well, the greatest value is 1.2, so whatever category that is, if you have 3 different categories, maybe you're not just doing if it's a cat or it's a dog or, let's say it's a cow. Remember we had cats and dogs earlier. Why the cats and dogs are hanging out with a cow, I don't know. But we have a value, and it might say 1.2 is a cat, 0.9 is the dog, and 0.4 is a cow. For some reason it thinks that there's a chance of it being any one of these 3 items, and that's how it comes out of the output layer. Well, as a human, I can look at 1.2 and say this is definitely what it is. It's definitely a cat or whatever it is. Maybe it's looking at different kinds of cars. Might be a better, whether it's a car, truck, or a motorcycle. Maybe that'd be a better example. Well, from a computer standpoint, that might be a little confusing because they're just numbers waving at us. And so with the softmax, we want all those numbers to always add up to 1. So when I add 3 numbers together, I want the final output to be 1 on there. And so it goes through this formula, changes each of these numbers. In this case, it changes them to 0.46, 0.34, and 0.20. They all add up to 1. And that's a lot easier to register because it's very set. It's a set output. It's never going to be more than 1. It's never going to be less than 0. And so you can see here that there's probably a pretty high chance that it's the first one. So as a human being, we have no problem knowing that. But this output can then also go into, say, another input. So it might be an automated car that's picking up images, and it says that image in front of us is probably a big truck. We should deal with it like it's a big truck. It's probably not a motorcycle, or whatever those categories are. That's the softmax part of it. But now we have the ReLU. Well, where's the ReLU coming from? Well, the ReLU is what's generating the 1.2 and the 0.9 and the 0.4. And so if you remember, our ReLU stands for Rectified Linear Unit and is the most widely used activation function. We looked at a number of different activation functions, including tangent H, the step function. I remember I said the step function is really used if that's what your actual output is, because then you know it's a 0 or 1. But the ReLU, if you have that as your output, you now have a discrepancy in there, and if that's going into another neural network or another process, having that discrepancy is really important. And it gives an output of x if x is positive and 0 otherwise. So it says my x value is going to be somewhere between 0 or 1. And then the usually, unless it's really uncertain, the output's usually a 1 or 0. And then you have that little piece of uncertainty there that you can send forward to another network, or you can look at to know that there's uncertainty involved. And is often used in the hidden layers. This is what's coming out of the hidden layers into the output layer usually. Or as we referenced the convolution neural network, the CNN, which you'd have to go to another video to review, the ReLU is the most common used for convolutional part of that network. It has a bunch of little pieces that are very simplified, looking at all the different images or different sections of the map, and the ReLU works really good for that. And like I said, there's other formulas used, but this is the most common one, and you'll see that in the hidden layers going maybe between one layer and the next layer. So just a quick recap, we have our softmax, which means that if you have numerous categories, only one of them is going to be picked, but you also want to have some value attached to it, how well it picked it. And you put that between 0 and 1, so it's very standardized. So we have our softmax. We looked at that. Let's go back one. We looked at that here where it transforms the numbers. And then we have our ReLU function, which takes the information and the summation and puts it between a 0 and a 1, where it's either clearly a 0 or, depending on how confident our model is, it'll go between the 0 and 1 value. What are hyperparameters? Oh, this is a great interview question. Hyperparameters. When you are doing neural networks, this is what you're playing with most of the time once you've gotten the data formatted correctly. A hyperparameter is a parameter whose value is set before the learning process begins, determines how a network is trained and the structure of the network. This includes things like the number of hidden units. How many hidden layers are you going to have, and how many nodes in each layer? Learning rate. Learning rate is usually multiplied once you've figured out the error and how much you want to change the weights. We talked about, or I mentioned it early just briefly, you don't want to just make a huge change, otherwise you're going to have a biased model. So you only take some little incremental changes, and that's what the learning rate is those small incremental changes. Epochs. How many times are you going to go through all the data in your training set? So one epoch is one trip through all the data. And there's a lot of other things depending on which model you're working with and which programming script you're working with. Like the Python sklearn package will have it slightly different than, say, Google's TensorFlow package, which will be a little bit different than the Spark machine learning package. So these are just some examples of the hyperparameters. And so you see in here we have a nice image of our data coming in, and we train our model, then we do a comparison to see how good our model is, and then we go back and we say, hey, this model's pretty good, but it's biased. So then we send it back and we change our hyperparameters to see if we can get an unbiased model, or we can have a better prediction on it that matches our data closer. What will happen if learning rate is set too low or too high? We have a nice couple graphs here. We have one over here that says the learning rate set too low, and you can see that it slowly works its way down the curve. And on the right, you can see a learning rate set too high. It's just bouncing back and forth. When your learning rate is too low, that's what we studied at 2 slides ago, that's what the learning rate was, training of the model will progress very slowly as we are making very tiny updates to the weights. We'll take many updates before reaching the minimum point. So I just mentioned epoch, going through all the data. You might have to go through all the data 1,000 times instead of 500 times for it to train. Learning rate too high causes undesirable divergent behavior to the loss function due to drastic updates in weights. At times it may fail to converge or even diverge. So if you have your learning rate set too high and it's training too quickly, maybe you'll get lucky and it trains after one epoch run, but a lot of times it might never be able to train because the weights are changing too fast. They flip back and forth too easy. And you see down here we've introduced 2 new terms, converge and diverge. Converge means that our model has reached a point where it's able to give a fairly good answer for all the data we put in. All those weights have adjusted and it's minimized the error. Diverge means that the data is so chaotic that it can never manage to train to that data. The data is just too chaotic for it to train. So we have 2 new words there, converge and diverge are important to know also. What is dropout and batch normalization? Dropout is a technique of dropping out hidden and visible units of a network randomly to prevent overfitting of data. It doubles the number of iterations needed to converge the network. So here we have our standard neural network, and then after applying dropout. Now it doesn't mean we actually delete the node. The node is still there, and we're still going to use that node. What it means is that we're only going to work with a few of the nodes. A lot of times, I think the most common one right now used is 20%. So you'll drop out 20% of the nodes when you do your training. You reverse propagate your data, and then you'll randomly pick another 20 nodes the next time you go through an epoch data training. So each time you go through one epoch, you will randomly pick 20 of those nodes not to mess with. And this allows for less overfitting of the data. So by randomly doing this, you create some, I guess it just kind of pulls some nodes off to the sides and says we're going to handle the data later on so we don't overfit. Batch normalization is a technique to improve the performance and stability of neural network. The idea is to normalize the inputs in every layer so that they have mean output and activation of 0 and standard deviation of 1. This question covers a lot of different things, which is great. It's a great interview question because it pulls in that you have to understand what the mean value is. So a mean output activation of 0, that means our average activation is 0. So when you normalize it, remember usually we're going between -1 and 1 on a lot of these. It's a very standard setup. So you have to be very aware that this is your mean output activation of 0. And then we have our standard deviation of 1. So we want to keep our error down to just a 1 value. The benefits of this doing a batch normalization is it provides regularization, it trains faster, higher learning rates, and weights are easier to initialize. What is the difference between batch gradient descent and stochastic gradient descent? Batch gradient descent. Batch gradient computes the gradient using the entire data set. It takes time to converge because the volume of data is huge and weights update slowly. So you can look at the batch as, a lot of times if you're using big data, batch the data in, but you still go through a full epoch. You still go through all the data on there. So batch gradient descent means you're going to use it to fit all the data and look for a convergence there. Stochastic gradient descent. Stochastic gradient computes the gradient using a single sample. It converges much faster than batch gradient because it updates weight more frequently. Explain overfitting and underfitting and how to combat them. Overfitting happens when a model learns the details and noise in the training data to the degree that it adversely impacts the execution of the model on the new information. It is more likely to occur with nonlinear models that have more flexibility when learning a target function. An example of this would be if you're looking at, say, cars and trucks and motorcycles, it might only recognize trucks that have a certain box-like shape. It might not be able to notice a flatbed truck unless it's only a specific kind of flatbed truck, or only Ford trucks, because that's what it saw on the training set. This means that your model performs great on your trained data and great on maybe a small test amount of data, but when you go to use it in the real world, it leaves out a lot and is not very functional outside of your small area, your small laboratory data coming in. Underfitting, doing the opposite when you underfit your data. Underfitting alludes to a model that is neither well trained on training data nor can generalize to new information. Usually happens when there is less and improper data to train a model, has a poor performance and accuracy. So if you're using underfitted data and you generate a model and you distribute that in a commercial zone, you'll have a lot of people unhappy with you because it's not going to give them very good answers. So we've explained overfitting and underfitting, so now we want to ask how to combat them. Combating overfitting and underfitting. Resampling the data to estimate the model accuracy, k-fold cross-validation. Having a validation data set to validate the model. So when we do the resampling, we're randomly going to be picking out data, and we'll run it a few times to see how that works, depending on our random data and how we sample the data to generate our model. And then we want to go ahead and validate the data set by having our training data and then keeping some data on the side, testing data to validate it. How are weights initialized in a network? Initializing all weights to 0. All the weights are set to 0. This makes your model similar to a linear model. So if you have linear data coming in, doing a basic setup like that might work. All the neurons in every layer perform the same operation given the same output and making the deep net useless. Right there is a key word. It's going to be useless if you initialize everything to 0. At that point, be looking into some other machine learning tools. Initializing all weights randomly. Here the weights are assigned randomly by initializing them very close to 0. It gives better accuracy to the model since every neuron performs different computations. And here we have the weights are set randomly. We have our input layer, the hidden layers, and the output layer. And W equals NP random, random N. Layer size L minus 1. This is the most commonly used, is to randomly generate your weights. What are the different layers in CNN, convolutional neural network? First is the convolutional layer that performs a convolutional operation. We have our other video out if you want to explore that more, so you can go into detail exactly how the convolutional layer works in the CNN as far as creating a number of smaller picture windows that go over the data. The second step is as a ReLU layer. ReLU brings nonlinearity to the network and converts all the negative pixels to 0. Output is rectified feature map. So it goes into a mapping feature there. Pooling layer. Pooling is a downsampling operation that reduces the dimensionality of the feature map. So we have all our ReLU layer, which is pulling all these little maps out of our convolutional layer. It's taking that picture and creating little tiny neural networks to look at different parts of the picture. Then we need to pool it together. And then finally, the fully connected layer. So we flatten our pooling layer out, and we have a fully connected layer recognizes and classifies the objects in the image. And that's actually your forward propagation, reverse propagation training model, usually. I mean, there's a number of different models out there, of course. What is pooling in CNN and how does it work? Pooling, used to reduce the spatial dimensions of a CNN, performs downsampling operation to reduce the dimensionality, creates a pooled feature map by sliding a filter matrix over the input matrix. I mentioned that briefly on the previous slide. It's important to know that you have, if you can see here, they have a rectified feature map. And so each one of those colors, like the yellow color, that might be one of a smaller little neural network using the ReLU. It'll just kind of go over the main picture and look at all the different areas on the main picture. So you might step 1, 2, 3, 4 spaces. And then you have another one that's also looking at features. And it has a 2, 7, 8, 5. Each one of those is a map. So it might be, the first one might be a map looking for cat ears, and the second one looking for human eyes. When it does this, you then have this rectified feature map looking at these different features. And the max pooling with a 2x2 filters and a stride of 2. Stride means instead of skipping every pixel, you're going to go every 2 pixels. You take the maximum values. And you can see over here, when we look at a pooled feature map, one of the features says, hey, I had a max value of 8, so somewhere in here we saw a human eye labeled as 8, pretty high label. And maybe 7 was a human hand, and maybe 4 was cat whiskers, or something that we thought might be cat whiskers. 4 is kind of a low number in this particular case compared to the other ones. So you have your full pooled feature map. You can see the process here as we have our stepping. We look for the max value, and then we create a pooled feature map of the maxed values. How does a LSTM network work? That's long short-term memory. So the first thing to know is that an LSTMs are a special kind of recurrent neural network capable of learning long-term dependencies. Remembering information for long periods of time is their default behavior. We did look at the RNN briefly, talked about how the hidden layer feeds back into itself. With the LSTM, it has a much more complicated feedback, and you can see here we have the hidden layer of t-1, and the hidden layer, that's what the H stands for, hidden layer of t, and the formula is going in. As we can see here, we have the hidden layers. We have t-1 and then h of t, where t stands for time. So this is a series. Remember, we're working with series, and we want to remember the past. And you can see you have your input of t, and that might be a frame in a video. As a frame comes in, they usually use in this one the tangent H activation formula, but you also see that it goes through a couple other formulas, the omega formula. And so when it combines these, that then goes into the next layer, your next hidden layer. That then goes into the data that's submitted to the next input. So you have your x of t plus 1. So when you have that coming in, then you have your h value that's coming forward from the last process. And depending on how many of these omega structures you put in there, depends on how long-term the memory gets. So it's important to remember this is more for your long-term recurrent neural networks. The 3 steps in an LSTM. Step 1 decides what to forget and what to remember. Step 2 selectively updates cell state values. So based on what we want to remember and forget, we want to update those cell values. And then decides what part of the current state make it to the output. So now we have to also have an output on there. What are vanishing and exploding gradients? This is a great question that affects all our neural networks. While training an RNN, your slope can become either too small or too large, and this makes the training difficult. When the slope is too small, the problem is known as vanishing gradient. So our slope, we have our change in x and our change in y. When the slope decreases gradually to a very small value, sometimes negative, and makes training difficult. When the slope tends to grow exponentially instead of decaying, this problem is called exploding gradient. The slope grows exponentially. You can see a nice graph of that here. Issues in gradient problem: long training time, poor performance, and low accuracy. What is the difference between epoch, batch, and iteration in deep learning? Epoch. An epoch represents one iteration over the entire data set. So that's everything you're going to go ahead and put into that training model. Batch. We cannot pass the entire data set into the neural network at once, so we divide the data set into a number of batches. And then iteration. If we have 10,000 images as data and a batch size of 200, then the epoch should run 10,000 times over 200. So that means we have our total number over the 200 equals 50 iterations. So in each epoch, we're running over all the data set, we're going to have 50 iterations. And each of those iterations includes a batch of 200 images in this case. Why TensorFlow is the most preferred library in deep learning? Well, first, TensorFlow provides both C++ and Python APIs that makes it easier to work on. Has a faster compilation time than other deep learning libraries like Keras and Torch. TensorFlow supports both CPUs and GPUs computing devices. So right now TensorFlow is at the top of the market because it's so easy to use for both programmer side and for hardware side and for the speed of getting something up and running. What do you mean by tensor in TensorFlow? Tensor is a mathematical object represented as arrays of higher dimension. These arrays of data with different dimensions and ranks that are fed as input to the neural network are called tensors. And you can see here we have a tensor of dimensions 5, 4. So it's a two-dimensional tensor coming in. You can look at an image like this, that each one of those pixels is a different value if it's a black and white. So it might be 0 and 1s, and then each one represents a black and white image. In a color photo, you might either find a different value system, or you might have a tensor value that has the XY coordinates as we see here, plus the colors. So you might have 3 more different dimensions for the 3 different images, the red, the blue, and the yellow coming in. And even as you go from one layer or one tensor to the next, these layers might change. We might flatten them, might bring in numerous, in the case of the convergence, neural network, we have all those smaller different mappings of features that come in. So each one of those layers coming through is a tensor if it has multiple dimensions coming in and weights attached to it. What are the programming elements in TensorFlow? Well, we have our constants. Constants are parameters whose value does not change. To define a constant, we use tf.constant command. Example, a equals tf.constant 2.0 tf_float 32. So it's a tensor float value of 32. B equals tf_constant 3.0. Print AB. If we did a print of AB, we'd have tf.constant, and then of course B is that instance of it. Variables. Variables allow us to add new trainable parameters to graph. To define a variable, we use tf.variable command and initialize them before running the graph in session. Example, w equals tf variable 0.3 dtype tf_float 32, or b equals the tf variable -3, dtype float 32. Placeholders. Placeholders allow us to feed data to a TensorFlow model from outside a model. It permits a value to be assigned later. To define a placeholder, we use tf_placeholder command. Example, a equals tf placeholder, b equals a times 2. With the tf session as SESS, result equals session run b, feed dictionary equals a 3.0, print result. So we have a nice example there of a placeholder. Session. A session is run to evaluate the nodes. This is called as the TensorFlow runtime. So for example, you have a equals tf constant 2.0, b equals tf constant 4.0, c equals a plus b. And at this point, you'd go ahead and create a session equals tf session, and then you could evaluate the tensor c, print session run c. That would input C as an input into your session. What do you understand by a computational graph? Everything in TensorFlow is based on creating a computational graph. It has a network of nodes where each node performs an operation. Nodes represent mathematical operation and edges represent tensors. Since data flows in a form of a graph, it is also called a data flow graph. And we have a nice visual of this graph, or graphic image of a computational graph. And you can see here we have our input nodes, our add, multiply nodes, and our multiply node at the end. And then we have the edges where the data flows. So we have from A going to C, A going to D. You can see we have a 2 flowing, 4 flowing. Explain generative adversarial network along with an example. Suppose there is a wine shop that purchases wine from dealers, which they will resell later. So we have our dealer going to the wine, our shop owner that then sells it for a profit. But there are some malefactor dealers who sell fake wine. In this case, the shop owner should be able to distinguish between fake and authentic wine. The forger will try different techniques to sell fake wine and make sure certain techniques go past the shop owner's check. So here's our forger, fake wine, shop owner. The shop owner would probably get some feedback from the wine experts that some of the wine is not original. The owner would have to improve how he determines whether a wine is fake or authentic. Goal of forger, to create wines that are indistinguishable from the authentic ones. Goal of shop owner, to accurately tell if the wine is real or not. There are two main components of generative adversarial network. And we'll refer to it as a noise vector coming in, where we have our forger who's going to generate fake wine, and then we have our real authentic wine, and of course our shop owner who has to figure out whether it's real or fake. The generator is a CNN that keeps producing images that are closer in appearance to the real images, while the discriminator tries to determine the difference between real and fake images. The ultimate aim is to make the discriminator learn to identify real and fake images. What is an autoencoder? The network is trained to reconstruct its inputs. It is a neural network that has 3 layers. Here the input neurons are equal to the output neuron. The network's target outside is same as the input. It uses dimensionality reduction to restructure the input. Input image comes in, we have our Latin space representation, and then it goes back out reconstructing the image. It works by compressing the input to a Latin space representation and then reconstructing the output from this representation. What is bagging and boosting? Bagging and boosting are ensemble techniques where the idea is to train multiple models using the same learning algorithm and then take a call. So we have in here where we're bagging, we take a data set and we split it. We're going to have our training data and our test data. Very standard thing to do. Then we're going to randomly select data into the bags and train your model separately. So we might have bag 1, model 1, bag 2, model 2, bag 3, model 3, and so on. In boosting, the emphasis is to select the data points which give wrong output in order to improve the accuracy. So in boosting, we have our data set. Again, we split it to test data and train data. And we'll take bag 1 and we'll train the model. Data points with wrong predictions then go into bag 2, and we then train that model and repeat.
So if you are looking to try your hand hands on this field, then do check Simplilearn's postgraduate program in AI and machine learning. So hurry up and enroll now. Find the course link in the description box.
So one of the first questions that you may face is, what are the different types of machine learning? Now, what is the best way to respond to this? There are three types of machine learning. If you read any material, you will always be told there are three types of machine learning. But what is important is you would probably be better off emphasizing that there are actually two main types of machine learning, which is supervised and unsupervised. And then there is a third type, which is reinforcement learning. So supervised learning is where you have some historical data and then you feed that data to your model to learn. Now, you need to be aware of a keyword that they will be looking for, which is labeled data. Right? So if you just say past data or historical data, the impact may not be so much. You need to emphasize on labeled data. So what is labeled data? Basically, let's say if you're trying to train your model for classification, you need to be aware of, for your existing data, which class each of the observations belong to, right? So that is what is labeling. So it is nothing but a fancy name, you must be already aware, but just make it a point to throw in that keyword labeled, so that will have the right impact. Okay, so that is what is supervised learning, when you have existing labeled data which you then use to train your model. That is known as supervised learning. And unsupervised learning is when you don't have this labeled data. So you have data, it is not labeled. So the system has to figure out a way to do some analysis on this. Okay, so that is unsupervised learning. And you can then add a few things like what are the ways of performing supervised learning and unsupervised learning, or what are some of the techniques. So supervised learning, we perform, or we do regression and classification, and unsupervised learning, we do clustering. Okay? And clustering can be of different types. Similarly, regression can be of different types, but you don't have to probably elaborate so much. If they are asking for just the different types, you can just mention these and just at a very high level. But if they want you to elaborate, give examples, then of course, I think there is a different question for that. We will see that later. Then the third, so we have supervised, then we have unsupervised, and then reinforcement. You need to provide a little bit of information around that as well, because it is sometimes a little difficult to come up with a good definition for reinforcement learning. So you may have to a little bit elaborate on how reinforcement learning works. Right? So reinforcement learning works in such a way that it basically has two parts to it. One is the agent and the environment. And the agent basically is working inside of this environment, and it is given a target that it has to achieve. And every time it is moving in the direction of the target, so the agent basically has to take some action. And every time it takes an action which is moving the agent towards the target, right, towards a goal. A target is nothing but a goal. Okay, then it is rewarded, and every time it is going in a direction where it is away from the goal, then it is punished. So that is the way you can a little bit explain. And this is used primarily, or very, very impactful for teaching the system to learn games and so on. Examples of this are basically used in AlphaGo. You can throw that as an example where AlphaGo used reinforcement learning to actually learn to play the game of Go, and finally it defeated the Go world champion. Right? This much of information that would be good enough. Okay. Then there could be a question on overfitting. So the question could be, what is overfitting and how can you avoid it? So what is overfitting? So let's first try to understand the concept, because sometimes overfitting may be a little difficult to understand. Overfitting is a situation where the model has kind of memorized the data. So this is an equivalent of memorizing the data. So we can draw an analogy so that it becomes easy to explain this. Now let's say you're teaching a child about recognizing some fruits or something like that. Okay, and you're teaching this child about recognizing, let's say, 3 fruits: apples, oranges, and pineapples. Okay, so this is a small child, and for the first time you're teaching the child to recognize fruits. Then, so what will happen? So this is very much like, that is your training data set. So what you will do is you will take a basket of fruits which consists of apples, oranges, and pineapples. Okay, and you take this basket to this child, and there may be, let's say, hundreds of these fruits. So you take this basket to this child and keep showing each of this fruit, and then first time obviously the child will not know what it is. So you show an apple and you say, hey, this is apple. Then you show maybe an orange and say this is orange, and so on and so forth. And then again you keep repeating that, right? So till that basket is over. This is basically how training works in machine learning. Also, that's how training works. So till the basket is completed, maybe 100 fruits, you keep showing this child. And in the process, what has happened, the child has pretty much memorized these. So even before you finish that basket, right, by the time you are halfway through, the child has learnt about recognizing the apple, orange and pineapple. Now what will happen after halfway through? Initially you remember it made mistakes in recognizing, but halfway through now it has learned. So every time you show a fruit, it will exactly 100% accurately, it will identify. It will say, the child will say this is an apple, this is an orange, and if you show a pineapple, it will say this is a pineapple, right? So that means it has kind of memorized this data. Now let's say you bring another basket of fruits, and it will have a mix of maybe apples, which were already there in the previous set, but it will also have, in addition to apple, it will probably have a banana or maybe another fruit like a jackfruit. Right? So this is an equivalent of your test data set, which the child has not seen before. Some parts of it probably has seen, like the apples it has seen, but this banana and jackfruit it has not seen. So then what will happen? In the first round, which is an equivalent of your training data set, towards the end, it has 100% it was telling you what the fruits are, right? Apple was accurately recognized, orange was accurately recognized, and pineapples were accurately recognized, right? So that is like 100% accuracy. But now when you get a fresh set which were not a part of the original one, what will happen? All the apples maybe it will be able to recognize correctly, but all the others like the jackfruit or the banana will not be recognized by the child. Right? So this is an analogy, this is an equivalent of overfitting. So what has happened during the training process, it is able to recognize or reach 100% accuracy, maybe very high accuracy, okay, and we call that as very low loss, right? So that is the technical term. So the loss is pretty much 0 and accuracy is pretty much 100%. Whereas when you use testing, there will be a huge error, which means the loss will be pretty high and therefore the accuracy will be also low. Okay, this is known as overfitting. This is basically a process where training is done. Training process it goes very well, almost reaching 100% accuracy, but while testing, it really drops down. Now, how can you avoid it? So that is the extension of this question. There are multiple ways of avoiding overfitting. There are techniques like what you call regularization. That is the most common technique that is used for avoiding overfitting. And within regularization, there can be a few other subtypes like dropout in case of neural networks and a few other examples. But I think if you give example or if you give regularization as the technique, probably that should be sufficient. So there will be some questions where the interviewer will try to test your fundamentals and your knowledge and depth of knowledge and so on and so forth. And then there will be some questions which are more like trick questions that will be more to stump you. Okay, then the next question is around the methodology. So when we are performing machine learning training, we split the data into training and test, right? So this question is around that. So the question is, what is training set and test set in machine learning model, and how is the split done? So the question can be like that. So in machine learning, when we are trying to train the model, so we have a 3-step process. We train the model and then we test the model, and then once we are satisfied with the test, only then we deploy the model. So what happens in the train and test is that you remember the labeled data. So let's say you have 1,000 records with labeling information. Now, one way of doing it is you use all the 1,000 records for training, and then maybe, right, which means that you have exposed all these 1,000 records during the training process, and then you take a small set of the same data and then you say, okay, I will test it with this. Okay, and then you probably, what will happen, you may get some good results. Right? But there is a flaw there. What is the flaw? This is very similar to human beings. It is like you are showing this model the entire data as a part of training. Okay, so obviously it has become familiar with the entire data. So when you're taking a part of that again and you're saying that I want to test it, obviously you will get good results. So that is not a very accurate way of testing. So that is the reason what we do is we have the label data of this 1,000 records or whatever. We set aside, before starting the training process, we set aside a portion of that data and we call that test set, and the remaining we call as training set, and we use only this for training our model. Now, the training process, remember, is not just about passing one round of this data set. So let's say now your training set has 800 records. It is not just one time you pass this 800 records. What you normally do is you actually, as a part of the training, you may pass this data through the model multiple times. So this 1,000 records may go through the model maybe 10, 15, 20 times till the training is perfect, till the accuracy is high, till the errors are minimized. Okay, now, so which is fine, which means that that is what is known as the model has seen your data and gets familiar with your data. And now when you bring your test data, what will happen is this is like some new data, because that is where the real test is. Now you have trained the model and now you are testing the model with some data which is kind of new. That is like a situation, like a realistic situation, because when the model is deployed, that is what will happen. It will receive some new data, not the data that it has already seen, right? So this is a realistic test. So you put some new data. So this data which you have set aside is for the model, it is new. And if it is able to accurately predict the values, that means your training has worked. Okay, the model got trained properly. But let's say while you're testing this with this test data, you're getting a lot of errors. That means you need to probably either change your model or retrain with more data and things like that. Now, coming back to the question of how do you split this, what should be the ratio? There is no fixed number. Again, this is like individual preferences. Some people split it into 50-50, 50% test and 50% training. Some people prefer to have a larger amount for training and a smaller amount for test. So they can go by either 60-40 or 70-30, or some people even go with some odd numbers like 65-35 or 63.33 and 33, which is like 1/3 and 2/3. So there is no fixed rule that it has to be something, the ratio has to be this. You can go by your individual preferences. All right, then you may have questions around data handling, data manipulation, or what do you call data management or preparation. So these are all some questions around that area. There is again no one answer, one single good answer to this. It really varies from situation to situation, and depending on what exactly is the problem, what kind of data it is, how critical it is, what kind of data is missing, and what is the type of corruption. So there are a whole lot of things. This is a very generic question, and therefore you need to be a little careful about responding to this as well. So probably have to illustrate this again. If you have experience in doing this kind of work in handling data, you can illustrate with examples saying that I was on one project where I received this kind of data. These were the columns where data was not filled, or these were this many rows where the data was missing. That would be, in fact, a perfect way to respond to this question. But if you don't have that, obviously, you have to provide some good answer. I think it really depends on what exactly the situation is. And there are multiple ways of handling the missing data or corrupt data. Now, let's take a few examples. Now, let's say you have data where some values in some of the columns are missing, and you have pretty much half of your data having these missing values in terms of number of rows. Okay, that could be one situation. Another situation could be that you have records or data missing, but when you do some initial calculation, how many records are corrupt or how many rows or observations, as we call it, has this missing data. Let's assume it is very minimal, like 10%. Okay. Now, between these two cases, how do we? So let's assume that this is not a mission critical situation, and in order to fix this 10% of the data, the effort that is required is much higher, and obviously effort means also time and money, right? So it is not so mission critical, and it is okay to, let's say, get rid of these records. So obviously one of the easiest ways of handling the data part or missing data is remove those records or remove those observations from your analysis. So that is the easiest easiest way to do. But then the downside is, as I said as in the first case, if let's say 50% of your data is like that, because some column or the other is missing. So it is not like in every place, in every row, the same column is missing, but you have in maybe 10% of the records, column 1 is missing, and another 10% column 2 is missing, another 10% column 3 is missing, and so on and so forth. So it adds up to maybe half of your data set. So you cannot completely remove half of your data set, then the whole purpose is lost. Okay, so then how do you handle? Then you need to come up with ways of filling up this data with some meaningful value, right? That is one way of handling. So when we say meaningful value, what is that meaningful value? Let's say for a particular column, you might want to take a mean value for that column and fill wherever the data is missing, fill up with that mean value, so that when you're doing the calculations, your analysis is not completely way off. So you have values which are not missing, first of all, so your system will work. Number two, these values are not so completely out of whack that your whole analysis goes for a toss. Right? There may be situations where if the missing values, instead of putting mean, maybe a good idea to fill it up with the minimum value or with a 0. So, or with a maximum value. Again, as I said, there are so many possibilities. So there is no like one correct answer for this. You need to basically talk around this and illustrate with your experience. As I said, that would be the best. Otherwise, this is how you need to handle this question. Okay, so then the next question can be, how can you choose a classifier based on a training set data size? So again, this is one of those questions where you probably do not have like a one size fits all answer. First of all, you may not, let's say, decide your classifier based on the training set size. Maybe not the best way to decide the type of the classifier. And even if you have to, there are probably some thumb rules which we can use. But then again, every time, so in my opinion, the best way to respond to this question is you need to try out few classifiers irrespective of the size of the data, and you need to then decide on your particular situation which of these classifiers are the right ones. This is a very generic issue, so you will never be able to just by, if somebody defines a problem to you and somebody, even if they show the data to you or tell you what is the data or even the size of the data, I don't think there is a way to really say that yes, this is the classifier that will work here. No, that's not the right way. So you need to still, test it out, get the data, try out a couple of classifiers, and then only you will be in a position to decide which classifier to use. You try out multiple classifiers, see which one gives the best accuracy, and only then you can decide. Then you can have a question around confusion matrix. So the question can be, explain confusion matrix. Right? So confusion matrix, I think the best way to explain it is by taking an example and drawing like a small diagram. Otherwise, it can really become tricky. So my suggestion is to take a piece of pen and paper and explain it by drawing a small matrix. And confusion matrix is about to find out, this is used especially in classification learning process, and when you get the results, when our model predicts the results, you compare it with the actual value and try to find out what is the accuracy. Okay, so in this case, let's say this is an example of a confusion matrix, and it is a binary matrix. So you have the actual values, which is the labeled data, right? And which is, so you have how many yes and how many no. So you have that information, and you have the predicted values, how many yes and how many no, right? So the total actual values, the total yes is 12 plus 1, 13, and they are shown here. And the actual value no's are 9 plus 3, 12. Okay, so that is what this information here is. So this is about the actual and this is about the predicted. Similarly, the predicted values, there are yes are 12 plus 3, 15 yeses, and no are 1 plus 9, 10 no's. Okay, so this is the way to look at this confusion matrix. Okay, and out of this, what is the meaning conveyed here? So there are 2 or 3 things that needs to be explained outright. The first thing is, for a model to be accurate, the values across the diagonal should be high, like in this case, right? That is one. Number 2, the total sum of these values is equal to the total observations in the test data set. So in this case, for example, you have 12 plus 3, 15 plus 10, 25. So that means we have 25 observations in our test data set. Okay, so these are the two things you need to first explain, that the total sum in this matrix, the numbers, is equal to the size of the test data set, and the diagonal values indicate the accuracy. So by looking at it, you can probably have an idea about, is this an accurate model? Is the model being accurate? If they're all spread out equally in all these 4 boxes, that means probably the accuracy is not very good. Okay. Now, how do you calculate the accuracy itself, right? How do you calculate the accuracy itself? So it is a very simple mathematical calculation. You take sum of the diagonals, right? So in this case, it is 9 plus 12, 21, and divide it by the total. So in this case, what will it be? Let me take a pen. So your diagonal values is equal to, if I say D is equal to 12 plus 9, so that is 21, right? And the total data set is equal to, right, we just calculated, it is 25. So what is your accuracy? It is 21 by, so your accuracy is equal to 21 by 25, and this turns out to be about 85%. Right? So this is 85%. So that is our accuracy. Okay. So this is the way you need to explain, draw a diagram, give an example, and maybe it may be a good idea to be prepared with an example so that it becomes easy for you. You don't have to calculate those numbers on the fly, right? So a couple of hints are that you take some numbers which add up to 100. That is always a good idea, so you don't have to really do this complex calculations. So the total value will be 100, and then diagonal values you divide. Once you find the diagonal values, that is equal to your percentage. Okay. All right. So the next question can be a related question about false positive and false negative. So what is false positive and what is false negative? Now, once again, the best way to explain this is using piece of paper and pen. Otherwise, it will be pretty difficult to explain this. So we use the same example of the confusion matrix, and we can explain that. So a confusion matrix looks somewhat like this, and when we just take it looks somewhat like this, and we continue with the previous example where this is the actual value, this is the predicted value, and in the actual value we have 12 plus 1 13 yeses and 3 plus 9 12 no's, and the predicted values, there are 12 plus 3 15 yeses and 1 plus 9 10 no's. Okay. Now, in this particular case, which is the false positive? What is a false positive? First of all, the second word, which is positive, okay, is referring to the predicted value. So that means the system has predicted it as a positive, but the real value, so this is what the false comes from, but the real value is not positive. Okay, that is the way you should understand this term, false positive or even false negative. So false positive, so positive is what your system has predicted. So where is that system predicted? This is the one. Positive is what? Yes. So you basically consider this row. Okay. Now if you consider this row, so this is all positive values. This entire row is positive values. Okay. Now the false positive is the one where the actual value is negative. Predicted value is positive, but the actual value is negative. So this is a false positive, right? And here is a true positive. So the predicted value is positive and the actual value is also positive. Okay, I hope this is making sense. Now let's take a look at what is false negative. False negative. So negative is the second term. That means that is the predicted value that we need to look for. So which are the predicted negative values? This row corresponds to predicted negative values. All right. So this row corresponds to predicted negative values. And what they are asking for? False. So this is the row for predicted negative values, and the actual value is this one, right? This is predicted negative and the actual value is also negative. Therefore, this is a true negative. So the false negative is this one. Predicted is negative, but actual is positive, right? So this is the false negative. So this is the way to explain, and this is the way to look at false positive and false negative. Same way, there can be true positive and true negative as well. So again, positive, the second term you will need to use to identify the predicted row, right? So if we say true positive, we need to take for the predicted part. So predicted positive is here. Okay, and then the first term is for the actual. So true positive. So true in case of
Actual is yes, right? So true positive is this one. Okay. And then in case of actual, the negative. Now we are talking about, let's say, true negative. True negative. Negative is this one, and the true comes from here. So this is true negative, right? 9 is true negative. The actual value is also negative, and the predicted value is also negative. Okay, so that is the way you need to explain this, the terms false positive, false negative, and true positive, true negative. Then you might have a question like, what are the steps involved in the machine learning process, or what are the 3 steps in the process of developing a machine learning model, right? So it is around the methodology that is applied. So basically, the way you can probably answer in your own words, but the way the model development of the machine learning model happens is like this. So first of all, you try to understand the problem and try to figure out whether it is a classification problem or a regression problem. Based on that, you select a few algorithms, and then you start the process of training these models. Okay, so you can either do that, or you can, after due diligence, you can probably decide that there is one particular algorithm which is most suitable. Usually it happens through trial and error process, but at some point you will decide that, okay, this is the model we are going to use. Okay, so in that case, we have the model, algorithm, and the model decided, and then you need to do the process of training the model and testing the model. And this is where, if it is supervised learning, you split your data, the labeled data, into training data set and test data set. And you use the training data set to train your model. And then you use the test data set to check the accuracy, whether it is working fine or not. So you test the model before you actually put it into production, right? So once you test the model, you're satisfied it's working fine, then you go to the next level, which is putting it for production. And then in production, obviously new data will come and the inference happens. So the model is readily available, and only thing that happens is new data comes and the model predicts the values, whether it is regression or classification. Now, so this can be an iterative process. So it is not a straightforward process where you do the training, do the testing, and then you move it to production. Now, so during the training and test process, there may be a situation where, because of either overfitting or things like that, the test doesn't go through, which means that you need to put that back into the training process. So that can be an iterative process. Not only that, even if the training and test goes through properly and you deploy the model in production, there can be a situation that the data that actually comes, the real data that comes, with that, this model is failing. So in which case you may have to once again go back to the drawing board. Or initially it will be working fine, but over a period of time, maybe due to the change in the nature of the data, once again the accuracy will deteriorate. So that is again a recursive process. So once in a while, you need to keep checking whether the model is working fine or not. And if required, you need to tweak it and modify it, and so on and so forth. So net, this is a continuous process of tweaking the model and testing it and making sure it is up to date. Then you might have question around deep learning. So because deep learning is now associated with AI, artificial intelligence, and so on. So it can be as simple as, what is deep learning? So I think the best way to respond to this could be, deep learning is a part of machine learning. And then obviously the question would be, then what is the difference, right? So deep learning, you need to mention there are 2 key parts that interviewer will be looking for when you are defining deep learning. So first is, of course, deep learning is a subset of machine learning. So machine learning is still the bigger, let's say, scope, and deep learning is one part of it. So then what exactly is the difference? Deep learning is primarily when we are implementing these our algorithms, or when we are using neural networks for doing our training and classification and regression and all that, right? So when we use neural network, then it is considered as deep learning. And the term deep comes from the fact that you can have several layers of neural networks, and these are called deep neural networks, and therefore the term deep, deep learning. The other difference between machine learning and deep learning, which the interviewer may be wanting to hear, is that in case of machine learning, the feature engineering is done manually. What do we mean by feature engineering? Basically, when we are trying to train our model, we have our training data, right? So we have our training labeled data, and this data has several, let's say if it is a regular table, it has several columns. Now each of these columns actually has information about a feature. right? So if we are trying to predict height, weight, and so on and so forth, so these are all features of human beings. Let's say we have census data and we have all this. So those are the features. Now there may be probably 50 or 100, in some cases there may be 100 such features. Now all of them do not contribute to our model, right? So we as a data scientist, we have to decide whether we should take all of them, all the features, or we should throw away some of them, because again, if we take all of them, number one, of course, your accuracy will probably get affected, but also there is a computational part. So if you have so many features and then you have so much data, it becomes very tricky. So in case of machine learning, we manually take care of identifying the features that do not contribute to the learning process, and thereby we eliminate those features and so on. Right? So this is known as feature engineering, and in machine learning we do that manually. Whereas in deep learning, where we use neural networks, the model will automatically determine which features to use and which to not use, and therefore feature engineering is also done automatically. So this is an explanation. These are two key things probably will add value to your response. All right, so the next question is, what is the difference between, or what are the differences between machine learning and deep learning? So here, this is a quick comparison table between machine learning and deep learning. And in machine learning enables machines to take decisions on their own based on past data. So here we are talking primarily of supervised learning. And it needs only a small amount of data for training, and then works well on low-end systems, so you don't need large machines. And most features need to be identified in advance and manually coded. So basically the feature engineering part is done manually, and the problem is divided into parts and solved individually and then combined. So that is about the machine learning part. In deep learning basically enables machines to take decisions with the help of artificial neural networks. So here in deep learning we use neural nets. So that is the key differentiator between machine learning and deep learning. And usually deep learning involves a large amount of data, and therefore the training also requires, usually the training process requires high-end machines because it needs a lot of computing power. And the machine learning features the feature engineering is done automatically. So the neural networks takes care of doing the feature engineering as well. And in case of deep learning, therefore, it is said that the problem is handled end to end. So this is a quick comparison between machine learning and deep learning in case you have that kind of a question. Then you might get a question around the uses of machine learning or some real life applications of machine learning in modern business. The question may be worded in different ways, but the meaning is how exactly is machine learning used, or actually supervised machine learning. It could be a very specific question around supervised machine learning. So this is like give examples of supervised machine learning, use of supervised machine learning in modern business. So that could be the next question. So there are quite a few examples or quite a few use cases, if you will, for supervised machine learning. The very common one is email spam detection. So you want to train your application or your system to detect between spam and non-spam. So this is a very common business application of supervised machine learning. So how does this work? The way it works is that you obviously have historical data of your emails, and they are categorized as spam and not spam. So that is what is the labeled information. And then you feed this information or all these emails as an input to your model, right? And the model will then get trained to detect which of the emails are to detect which is spam and which is not spam. So that is the training process. And this is supervised machine learning because you have labeled data. You already have emails which are tagged as spam or not spam. And then you use that to train your model, right? So this is one example. Now, there are a few industry-specific applications for supervised machine learning. One of the very common ones is in healthcare diagnostics. In healthcare diagnostics, you have these images and you want to train models to detect whether from a particular image, whether it can find out if the person is sick or not, whether a person has cancer or not. right? So this is a very good example of supervised machine learning. Here, the way it works is that existing images, it could be X-ray images, it could be MRI or any of these images are available and they are tagged saying that, okay, this X-ray image is defective or the person has an illness, or it could be cancer, whichever illness, right? So it is tagged as defective or clear or good image and defective image, something like that. So we come up with a binary, or it could be multi-class as well, saying that this is defective to 10%, this is 25%, and so on. But let's keep it simple. You can give an example of just a binary classification, that would be good enough. So you can say that in healthcare diagnostics, using image, we need to detect whether a person is ill or whether a person is having cancer or not. So here, the way it works is you feed labeled images and you allow the model to learn from that, so that when new image is fed, it will be able to predict whether this person is having that illness or not, having cancer or not, right? So I think this would be a very good example for supervised machine learning in modern business. All right, then we can have a question like, so we've been talking about supervised and unsupervised, and so there can be a question around semi-supervised machine learning. So what is semi-supervised machine learning? Now, semi-supervised learning, as the name suggests, it falls between supervised learning and unsupervised learning, but for all practical purposes, it is considered as a part of supervised learning. And the reason this has come into existence is that in supervised learning, you need labeled data. So all your data for training your model has to be labeled. Now, this is a big problem in many industries or under many situations. Getting the labeled data is not that easy because there's a lot of effort in labeling this data. Let's take an example of the diagnostic images. We can just let's say take X-ray images. Now there are actually millions of X-ray images available all over the world, but the problem is they are not labeled. So the images are there, but whether it is defective or whether it is good, that information is not available along with it, right, in a form that it can be used by a machine, which means that somebody has to take a look at these images, and usually it should be like a doctor, and then say that, okay, yes, this image is clean and this image is cancerous and so on and so forth. Now that is a huge effort by itself. So this is where semi-supervised learning comes into play. So what happens is there is a large amount of data, maybe a part of it is labeled. Then we try some techniques to label the remaining part of the data so that we get completely labeled data, and then we train our model. So I know this is a little long winding explanation, but unfortunately there is no quick and easy definition for semi-supervised machine learning. This is the only way probably to explain this concept. We may have another question as what are unsupervised machine learning techniques, or what are some of the techniques used for performing unsupervised machine learning? So it can be worded in different ways. So how do we answer this question? So unsupervised learning, you can say that there are two types, clustering and association. And clustering is a technique where similar objects are put together. And there are different ways of finding similar objects. So their characteristics can be measured, and if they have, in most of the characteristics, if they are similar, then they can be put together. This is clustering. Then association, I think the best way to explain association is with an example. In case of association, you try to find out how the items are linked to each other. So for example, if somebody bought maybe a laptop, the person has also purchased a mouse. So this is more in an e-commerce scenario, for example. So you can give this as an example. So people who are buying laptops are also buying a mouse. So that means there is an association between laptops and mouse. Or maybe people who are buying bread are also buying butter. So that is a association that can be created. So this is unsupervised learning, one of the techniques. Okay. All right, then we have very fundamental question. What is the difference between supervised and unsupervised machine learning? So machine learning, these are the two main types of machine learning, supervised and unsupervised. And in case of supervised, and again here, probably the keyword that the person may be wanting to hear is labeled data. Now, very often people say, yeah, we have historical data, and if we run it, it is supervised, and if we don't have historical data, yes, but you may have historical data, but if it is not labeled, then you cannot use it for supervised learning. So it's very key to understand that we put in that keyword labeled. Okay, so when we have labeled data for training our model, then we can use supervised learning. And if we do not have labeled data, then we use unsupervised learning. And there are different algorithms available to perform both of these types of trainings. So there can be another question, a little bit more theoretical and conceptual in nature. This is about inductive machine learning and deductive machine learning. So the question can be, what is the difference between inductive machine learning and deductive machine learning, or somewhat in that manner, so that the exact phrase or exact question can vary. They can ask for examples and things like that, but that could be the question. So let's first understand what is inductive and deductive training. Inductive training is induced by somebody, and you can illustrate that with a small example. I think that always helps. So whenever you're doing some explanation, try as much as possible, as I said, to give examples from your work experience or give some analogies, and that will also help a lot in explaining as well, and for the interviewer also to understand. So here we'll take an example, or rather we will use an analogy. So inductive training is when we induce some knowledge or the learning process into a person without the person actually experiencing it. Okay, what can be an example? So we can probably tell the person or show a person a video that fire can burn his finger, or fire can cause damage. So what is happening here? This person has never probably seen a fire or never seen anything getting damaged by fire. But just because he has seen this video, he knows that, okay, fire is dangerous, and if fire can cause damage, right? So this is inductive learning. Compared to that, what is deductive learning? So here you draw conclusion, or the person draws conclusion out of experience. So we will stick to the analogy. So compared to the showing a video, let's assume a person is allowed to play with fire. Right? And then he figures out that if he puts his finger, it's burning, or if he throws something into the fire, it burns. So he is learning through experience. So this is known as deductive learning. Okay, so you can have applications or models that can be trained using inductive learning or deductive learning. All right, I think probably that explanation will be sufficient. The next question is, are KNN and K-means clustering similar to one another, or are they same? Right, because the letter K is kind of common between them. Okay, so let us take a little while to understand what these two are. One is KNN, another is K-means. KNN stands for K nearest neighbors, and K means, of course, is the clustering mechanism. Now, these two are completely different, except for the letter K being common between them. KNN is completely different. K means clustering is completely different. KNN is a classification process, and therefore it comes under supervised learning, whereas K-means clustering is actually unsupervised. Okay, when you have KNN, when you want to implement KNN, which is basically K nearest neighbors, the value of K is a number. So you can say K is equal to 3. You want to implement KNN with K is equal to 3. So which means that it performs the classification in such a way that, how does it perform the classification? So it will take 3 nearest objects, and that's why it's called nearest neighbor. So basically, based on the distance, it will try to find out its nearest objects that are, let's say, 3 of the nearest objects, and then it will check whether the class they belong to which class, right? So if all 3 belong to one particular class, obviously this new object is also classified as that particular class. But it is possible that they may be from 2 or 3 different classes. Okay, so let's say they are from 2 classes. And then if they are from 2 classes, now usually you take an odd number, you assign an odd number to. So if there are 3 of them and 2 of them belong to one class and then 1 belongs to another class, so this new object is assigned to the class to which the 2 of them belong. Now, the value of K is sometimes tricky, whether should you use 3, should you use 5, should you use 7? That can be tricky because the ultimate classification can also vary. So it's possible that if you're taking K as 3, the object is probably in one particular class, but if you take K is equal to 5, maybe the object will belong to a different class, because when you're taking 3 of them, probably 2 of them belong to class 1 and 1 belong to class 2. Whereas when you take 5 of them, it is possible that only 2 of them belong to class 1 and 3 of them belong to class 2. So which means that this object will belong to class 2, right? So you see that? So the class allocation can vary depending on the value of K. Now, K-means on the other hand is a clustering process, and it is unsupervised, where what it does is the system will basically identify how the objects are, how close the objects are with respect to some of their features. Okay, but the similarity, of course, is the letter K, and in case of K means also we specify its value, and it could be 3 or 5 or 7. There is no technical limit as such, but it can be any number of clusters that you can create. Okay, so based on the value that you provide, the system will create that many clusters of similar objects. So there is a similarity to that extent that K is a number in both the cases, but actually these two are completely different processes. We have what is known as naive Bayes classifier, and people often get confused thinking that naive Bayes is the name of the person who found this classifier or who developed this classifier, which is not 100% true. Bayes is the name of the person, Bayes is the name of the person, but naive is not the name of the person, right? So naive is basically an English word, and that has been added here because of the nature of this particular classifier. Naive Bayes classifier is a probability based classifier, and it makes some assumptions that presence of one feature of a class is not related to the presence of any other feature of maybe other classes, right? So which is not a very strong or not a very accurate assumption, because these features can be related and so on. But even if we go with this assumption, this whole algorithm works very well even with this assumption, and that is the good side of it. But the term comes from there, so that is the explanation that you can give. Then there can be question around reinforcement learning. It can be paraphrased in multiple ways. One could be, can you explain how a system can play a game of chess using reinforcement learning? Or it can be any game. So the best way to explain this is again to talk a little bit about what reinforcement learning is about, and then elaborate on that to explain the process. So first of all, reinforcement learning has an environment and an agent, and the agent is basically performing some actions in order to achieve a certain goal. And these goals can be anything, either if it is related to game, then the goal could be that you have to score very high, score a high value, high number. Or it could be that your number of lives should be as high as possible. Don't lose lives. So these could be some of them. More advanced examples could be for driving. In the automotive industry, self-driving cars, they actually also make use of reinforcement learning to teach the car how to navigate through the roads and so on and so forth. That is also another example. Now, how does it work? So if the system is basically there is an agent and environment, and every time the agent takes a step or performs a task which is taking it towards the goal, the final goal, let's say to maximize the score or to minimize the number of lives and so on, or minimize the deaths, for example, it is rewarded. And every time it takes a step which goes against that goal, right, contrary or in the reverse direction, it is penalized. Okay, so it is like a carrot and stick system. Now, how do you use this to create a game of chess, or to create a system to play a game of chess? Now, the way this works is, and this could probably go back to this AlphaGo example where AlphaGo defeated a human champion. So the way it works is in reinforcement learning, the system is allowed, for example, if in this case we are talking about chess, so we allow the system to first of all watch playing a game of chess. So it could be with a human being, or it could be the system itself. There are computer games of chess, right? So either this new learning system has to watch that game or watch a human being play the game, because this is reinforcement learning is pretty much all visual. So when you're teaching the system to play a game, the system will not actually go behind the scenes to understand the logic of your software, of this game or anything like that. It is just visually watching the screen and then it learns. Okay, so reinforcement learning to a large extent works on that. So you need to create a mechanism whereby your model will be able to watch somebody playing the game, and then you allow the system also to start playing the game. So it pretty much starts from scratch. Okay, and as it moves forward, it's right at the beginning, the system really knows nothing about the game of chess. Okay, so initially it is a clean slate. It just starts by observing how you're playing. So it will make some random moves and keep losing badly. But then what happens is, over a period of time, so you need to now allow the system, or you need to play with the system, not just 1, 2, 3, 4 or 5 times, but hundreds of times, thousands of times, maybe even hundreds of thousands of times. And that's exactly how AlphaGo has done. It played millions of games between itself and the system, right? So for the game of chess also, you need to do something like that. You need to allow the system to play chess and then learn on its own over a period of repetition. So I think you can probably explain it to this much, to this extent, and it should be sufficient. Now, this is another question which is again somewhat similar, but here the size is not coming into picture. So the question is, how will you know which machine learning algorithm to choose for your classification problem? Now, this is not only classification problem, it could be a regression problem. I would like to generalize this question. So if somebody asks you, how will you choose? How will you know which algorithm to use? The simple answer is, there is no way you can decide exactly saying that this is the algorithm I'm going to use. In a variety of situations, there are some guidelines. Like for example, you will obviously, depending on the problem, you can say whether it is a classification problem or a regression problem. And then in that sense, you are kind of restricting yourself to, if it is a classification problem, you can only apply a classification algorithm, right? To that extent, you can probably, let's say, limit the number of algorithms. But now within the classification algorithms, you have decision trees, you have SVM, you have logistic regression. Is it possible to outright say, yes, so for this particular problem, since you have explained this, now this is the exact algorithm that you can use? That is not possible. Okay, so we have to try out a bunch of algorithms, see which one gives us the best performance and best accuracy, and then decide to go with that particular algorithm. So in machine learning, a lot of it happens through trial and error. There is no real possibility that anybody can, just by looking at the problem or understanding the problem, tell you that, okay, in this particular situation, this is exactly the algorithm that you should use. Then the questions may be around application of machine learning. And this question is specifically around how Amazon is able to recommend other things to buy. So this is around recommendation engine. How does it work? How does the recommendation engine work? So this is basically the question is all about. So the recommendation engine again works based on various inputs that are provided. Obviously something like Amazon, a website or e-commerce site like Amazon collects a lot of data around the customer behavior, who is purchasing what. And if somebody is buying a particular thing, they're also buying something else. So this kind of association, right? So this is the unsupervised learning we talked about. They use this to associate and link or relate items. And that is one part of it. So they kind of build association between items, saying that somebody buying this is also buying this. That is one part of it. Then they also profile the users, right? Based on their age, their gender, their geographic location. They will do some profiling. And then when somebody is logging in and when somebody is shopping, kind of the mapping of these two things are done. They try to identify, obviously if you have logged in, then they know who you are and your information is available. Like for example, your age maybe, your gender, and where you're located, what you purchased earlier. Right? So all this is taken, and the recommendation engine basically uses all this information and comes up with recommendations for a particular user. So that is how the recommendation engine works. All right, then the question can be something very basic like, when will you go for classification? versus regression, right? When do you do classification instead of regression, or when do you use classification instead of regression? Now, yes, so this is basically going back to the understanding of the basics of classification and regression. So classification is used when you have to identify or categorize things into discrete classes. So the best way to respond to this question is to take up some examples and use it. Otherwise, it can become a little tricky. The question may sound very simple, but explaining it can sometimes be very tricky. In case of regression, we use, of course, there will be some keywords that they will be looking for. So just you need to make sure you use those keywords. One is the discrete values, another is the continuous values. So for regression, if we are trying to find some continuous values, you use regression. Whereas if you're trying to find some discrete values, you use classification. And then you need to illustrate. What are some of the examples? So classification is like, let's say there are images and you need to put them into classes like cat, dog, elephant, tiger, something like that. So that is a classification problem. Or it can be, that is a multi-class classification problem. It could be binary classification problem, like for example, whether a customer will buy or he will not buy. That is a classification, binary classification. It can be in the weather forecast area. Now, weather forecast is again combination of regression and classification, because on the one hand, you want to predict whether it's going to rain or not. That's a classification problem. That's a binary classification, right? Whether it's going to rain or not rain. However, you also have to predict what is going to be the temperature tomorrow, right? Now, temperature is a continuous value. You can't answer the temperature in a yes or no kind of a response, right? So what will be the temperature tomorrow? So you need to give a number, which can be like 20 degrees, 30 degrees or whatever. Right? So that is where you use regression. One more example is stock price prediction. So that is where again you will use regression. So these are the various examples. So you need to illustrate with examples and make sure you include those keywords like discrete and continuous. So the next question is more about a little bit of a design related question to understand your concepts and things like that. So it is, how will you design a spam filter? So how do you basically design or develop a spam filter? So I think the main thing here is he is looking at probably understanding your concepts in terms of what is the algorithm you will use, or what is your understanding about difference between classification and regression and things like that, right? And the process, of course, the methodology and the process. So the best way to go about responding to this is we say that, okay, this is a classification problem because we want to find out whether an email is a spam or not spam, so that we can apply the filter accordingly. So first thing is to identify what type of a problem it is. So we have identified that it is a classification. Then the second step may be to find out what kind of algorithm to use. Now, since this is a binary classification problem, logistic regression is a very common algorithm. But however, right, as I said earlier also, we can never say that, okay, for this particular problem, this is exactly the algorithm that we can use. So we can also probably try decision trees or even support vector machines, for example, SVM. So we will kind of list down a few of these algorithms and we will say, okay, we would like to try out these algorithms. And then we go about taking your historical data, which is the labeled data, which are marked. So you will have a bunch of emails, and then you split that into training and test data sets. You use your training data set to train your model or your algorithm that you have used, or rather the model actually. So, and you actually will have three models. Let's say you are trying to test out three algorithms, so you will obviously have three models. So you need to try all three models and test them out as well. See which one gives the best accuracy, and then you decide that you will go with that model. Okay, so training and test will be done, and then you zero in on one particular model, and then you say, okay, this is the model we will use, and then go ahead and implement that or put that in production. So that is the way you design a spam filter. The next question is about random forest. So what is random forest? So this is a very straightforward question. However, the response, you need to be again a little careful. While we all know what is random forest, explaining this can sometimes be tricky. So one thing is, random forest is kind of, in one way, it is an extension of decision trees, because it is basically nothing but you have multiple decision trees, and trees will basically we will use for doing, if it is classification, mostly it is classification, you will use the trees for classification, and then you use voting for finding the final class. So that is the underlines. But how will you explain this? How will you respond to this? So first thing, obviously we will say that random forest is one of the algorithms, and the more important thing that you need to, probably the interviewer is waiting to hear, is ensemble learner, right? So this is one type of ensemble learner. What is ensemble learner? Ensemble learner is like a combination of algorithms. So it is a learner which consists of more than one algorithm or more than one maybe models. Okay, so in case of random forest, the algorithm is the same, but instead of using one instance of it, we use multiple instances of it, and we use. So in a way, that is a random forest is an ensemble learner. There are other types of ensemble learners where we have, like, we use different algorithms itself. So you have one maybe logistic regression and a decision tree combined together, and so on and so forth. Or there are other ways, like for example, splitting the data in a certain way and so on. So that's all about ensemble. We will not go into that, but random forest itself, I think the interviewer will be happy to hear this word ensemble learner. And so then you go and explain how the random forest works. So if the random forest is used for classification, then we use what is known as a voting mechanism. So basically, how does it work? Let's say your random forest consists of 100 trees, okay, and each observation you pass through this forest, and each observation, let's say it is a classification problem, binary classification 0 or 1, and you have 100 trees. Now if 90 trees say that it is a 0 and 10 of the trees say it is a 1, you take the majority, you may take a vote, and since 90 of them are saying 0, you classify this as 0. Then you take the next observation and so on. So that is the way random forest works for classification. If it is a regression problem, it's somewhat similar, but only thing is, instead of vote, what we will do is, so in regression, remember what happens, you actually calculate a value, right? So for example, you're using regression to predict the temperature, and you have 100 trees, and each tree obviously will probably predict a different value of the temperature. They may be close to each other, but they may not be exactly the same value. So these 100 trees. So how do you now find the actual value, the output for the entire forest, right? So you have outputs of individual trees which are a part of this forest, but then you need to find the final output of the forest itself. So how do you do that? So in case of regression, you take like an average or the mean of all the 100 trees, right? So this is also a way of reducing the error. So maybe if you have only one tree, and if that one tree makes an error, it is basically 100% wrong or 100% right? But if you have, on the other hand, if you have a bunch of trees, you are basically mitigating that error, reducing that error. Okay, so that is the way random forest works. So the next question is, considering the long list of machine learning algorithms, how will you decide on which one to use? So once again, here there is no way to outright say that this is the algorithm that we will use for a given data set. This is a very good question, but then the response has to be like, again, there will not be a one size fits all. So we need to, first of all, you can probably shorten the list in terms of by saying, okay, whether it is a classification problem or it is a regression problem. To that extent, you can probably shorten the list, because you don't have to use all of them. If it is a classification problem, you only can pick from the classification algorithms, right? So for example, if it is a classification, you cannot use linear regression algorithm there. Or if it is a regression problem, you cannot use SVM, or maybe no, you can use SVM, but maybe a logistic regression, right? So to that extent, you can probably shorten the list, but still you will not be able to 100% decide on saying that this is the exact algorithm that I'm going to use. So the way to go about is, you choose a few algorithms based on what the problem is. You try out your data, you train some models of these algorithms, check which one gives you the lowest error or the highest accuracy, and based on that, you choose that particular algorithm. Okay. All right. Then there can be questions around bias and variance. So the question can be, what is bias and variance in machine learning? So you just need to give out a definition for each of these. For example, bias in machine learning, it occurs when the predicted values are far away from the actual value. So that is a bias. Okay. And whereas they are all the values are probably they are far off, but they are very near to each other though. The predicted values are close to each other, right? While they are far off from the actual value, but they are close to each other. You see the difference? So that is bias. And then the other part is your variance. Now, variance is when the predicted values are all over the place, right? So if the variance is high, that means it may be close to the target, but it is kind of very scattered. So the predicted values are not close to each other, right? In case of bias, the predicted values are close to each other, but they are not close to the target. But here they may be close to the target, but they may not be close to each other. So they are a little bit more scattered. So that is what in case of a variance. Okay, then the next question is about, again, related to bias and variance. What is the trade-off between bias and variance? Yes, I think this is an interesting question because these two are heading in different directions. So for example, if you try to minimize the bias, variance will keep going high. And if you try to minimize the variance, bias will keep going high. And there is no way you can minimize both of them. So you need to have a trade-off saying that, okay, this is the level at which I will have my bias and this is the level at which I will have variance. So the trade-off is that pretty much that you decide what is the level you will tolerate for your bias and what is the level you will tolerate for variance, and a combination of these two in such a way that your final results are not way off. And having a trade-off will ensure that the results are consistent, right? So that is basically the output is consistent, and which means that they are close to each other and they are also accurate. That means they are as close to the target as possible, right? So if either of these is high, then one of them will go off the track. Define precision and recall. Now, again, here I think it would be best to draw a diagram and take the confusion matrix. And it is very simple. The definition is like a formula. Your precision is true positive by true positive plus false positive. And your recall is true positive by true positive plus false negative. Okay, so that's, you can just show it in a mathematical way. That's pretty much that can be shown. That's the easiest way to define. So the next question can be about decision tree. What is decision tree pruning and why is it? So basically, decision trees are really simple to implement and understand, but one of the drawbacks of decision trees is that it can become highly complicated as it grows, right? And the rules and the conditions can become very complicated, and this can also lead to overfitting, which is basically that during training you will get 100% accuracy, but when you're doing testing you will get a lot of errors. So that is the reason pruning needs to be done. So the purpose or the reason for doing decision tree pruning is to reduce overfitting or to cut down on overfitting. And what is decision tree pruning? It is basically that you reduce the number of branches, because as you may be aware, a tree consists of the root node and then there are several internal nodes and then you have the leaf nodes. Now, if there are too many of these internal nodes, that is when you face the problem of overfitting, and pruning is the process of reducing those internal nodes. Alright, so the next question can be, what is logistic regression? So basically, logistic regression is one of the techniques used for performing classification, especially binary classification. Now, there is something special about logistic regression, and there are a couple of things you need to be careful about. First of all, the name is a little confusing. It is called logistic regression, but it is used for classification. So this can be sometimes confusing. So you need to probably clarify that to the interviewer if it's really, if it is required. And they can also ask this like a trick question, right? So that is one part. Second thing is, the term logistic has nothing to do with the usual logistics that we talk about, but it is derived from log. So that the mathematical derivation involves log, and therefore the name logistic regression. So what is logistic regression and how is it used? So logistic regression is used for binary classification, and the output of a logistic regression is either a 0 or a 1, and it varies. So it's basically, it calculates a probability between 0 and 1, and we can set a threshold that can vary. Typically it is 0.5. So any value above 0.5 is considered as 1, and if the probability is below 0.5, it is considered as 0. So that is the way we calculate the probability, or the system calculates the probability, and based on the threshold it sets a value of 0 or 1, which is like a binary classification, 0 or 1. Okay, then we have a question around k nearest neighbor algorithm. So explain k nearest neighbor algorithm. So first of all, what is a k nearest neighbor algorithm? This is a classification algorithm. So that is the first thing we need to mention. And we also need to mention that the k is a number. It is an integer. And this is variable, and we can define what the value of k should be. It can be 2, 3, 5, 7, and usually it is an odd number. So that is something we need to mention. Technically, it can be even number also, but then typically it would be odd number, and we will see why that is. Okay. So based on that, we need to classify objects. Okay, we need to classify objects. So again, it will be very helpful to draw a diagram. If you're explaining, I think that will be the best way. So draw some diagram like this, and let's say we have 3 clusters or 3 classes existing, and now you want to find for a new item that has come, you want to find out which class this belongs to, right? So you go about, as the name suggests, you go about finding the nearest neighbors, right? The points which are closest to this, and how many of them you will find, that is what is defined by k. Now let's say our initial value of k was 5. Okay? So you will find the 5 nearest data points. So in this case, as it is illustrated, these are the 5 nearest data points. But then all 5 do not belong to the same class or cluster. So there are one belonging to this cluster 1, the second one belonging to this cluster 2, 3 of them belonging to this third cluster. Okay. So how do you decide? That's exactly the reason we should, as much as possible, try to assign an odd number so that it becomes easier to assign this. So in this case, you see that the majority, actually, if there are multiple classes, then you go with the majority. So since 3 of these items belong to this class, we assign, which is basically the, in this case, the green or the tennis or the third cluster, as I was talking about. Right, so we assign it to this third class. So in this case, it is that's how it is decided. Okay, so k nearest neighbor. So first thing is to identify the number of neighbors that are mentioned as k. So in this case, it is k is equal to 5. So we find the 5 nearest points, and then find out of these 5 which class has the maximum number in that. Okay, and then the new data point is assigned to that class. Okay, so that's pretty much how k nearest neighbors work.
Today we are diving into an exciting topic: how to make money using ChatGPT, an AI-powered tool that can help you generate passive income. If you are eager to start earning effortlessly, keep watching. Are you looking for ways to generate passive income with minimal effort? Thanks to the advancement in artificial intelligence and chatbot, you can now earn money using these technologies. So in this video, we will explore some of the most effective methods to generate passive income with ChatGPT. ChatGPT, known as the world's smartest generative AI, is changing how people make money online. With this incredible free tool, you can start earning with the little skill and no initial investment required. So we are in an exciting new era of artificial intelligence, and now is the perfect time to get involved and seize this opportunity. People are using ChatGPT for YouTube, blogging, freelancing, and many other ways to make money. So now let's dive in and discover how you can leverage ChatGPT to generate various streams of passive income. So there are numerous ways to monetize ChatGPT's capability. So in this video, we will explore some few effective strategies, or you can say categories, by giving prompts. So this is my ChatGPT 4o. I'm using the premium version, right? So the first category is get businesses idea from ChatGPT. So you can discover how ChatGPT can generate personalized business ideas by understanding your interests, talents, and challenges. So now let's ask ChatGPT for business ideas tailored to a computer science engineer with experience in digital marketing and sales. Okay, or not even computer science engineer, you can ask as a graphic designer or as a sales marketer, anything, right? So I'm giving here a prompt. I am a graphic designer with a knack for digital marketing. Okay, so I will write what side hustle can I start to generate. Okay, I will give here $500 income per day with minimal investment, dedicating 6 to 8 hours, or you can write 9 to 10 hours or 1 to 2 hours, 6 to 8 hours daily. Okay, so now let's see what ChatGPT says. So here, given your skills in a graphic designer and digital marketing, here are some side hustle ideas that you can potentially generate $500 per day. See, first is freelance graphic designer. Second is print on demand. Third is social media management, sell digital product online coach consultation, affiliate marketing you can do, content creation for YouTube and social media you can do. So I'm not saying you can earn like in next day itself, but it will take time. But you can take ideas for your business, okay, as per your need, as per your skills. You can just write the prompt and ChatGPT will tell you the answer, or it will give you some ideas. Okay, so once you have some great ideas, so dive deeper with ChatGPT to develop a plan and consider important factors. Okay, you can ask to brief freelance graphic designer or print on demand, social media management, like this. Okay, so our second category is freelancing itself. Okay, so and you can enhance your freelancing career with ChatGPT. So this advanced AI tool ChatGPT help professionals earn extra income by producing high quality content that impresses clients. Like you can write blog or website content, you can translate languages, you can provide email writing services, you can craft compelling headlines and calls to action, you can create social media content, you can write captivating short stories, or you can conduct hashtag research. Okay, so let me give you a small prompt. Okay, so write me a blog on Great Wall of China in 1,000 words. Or you can write in mutual funds, you can write in stocks, whatever you want. Okay, so as you can see, the Great Wall of China, a marvel of ancient engineering. So this is your title. Okay, so the Great Wall of China, this is the historical overview, the architectural marvel, everything it will give you. Okay, so the third category is build software. Okay, so you can use ChatGPT to develop software solution for common problems faced by the online businesses. Okay, create software tools using the codes provided by ChatGPT and sell them to make money. Okay, so first what you can do, you can create your portfolio, online portfolio website. Okay, so there you can mention services as a software developer. Okay, or you build software. Okay, so the first thing is identify common issues in your niche. Okay, so you can use ChatGPT to list the most common problems in e-commerce business face, such as inventory management, customer support, or cart abandonment. Okay, the second thing is use ChatGPT to generate code and develop software solution. Okay, let me give you an example. So here you can write generate a Python script for an inventory management system for an spelling mistake, system for an e-commerce store. Okay, so it will generate you a Python script. Okay, see, it's very easy to earn money using ChatGPT. You have to just give a prompt, okay, with your perfect thought. What do you want? What your client wants, right? This is how you have to give the prompt. Okay, so this is Python code for the inventory management, right? See, its feature, its usage, everything is here. You have to just give your prompt. And the third thing is in this build software category. And the third thing is market your software to the target audience. Like you can use ChatGPT to create a marketing strategy, including promotional content, social media posts, and email campaigns. Right. So here I will write one prompt for this. So write a marketing plan to promote an inventory management software for small e-commerce business or businesses, right? So as here you can see market plan for promoting inventory management software for e-commerce business. Okay, see, market is the target audience, small e-commerce owners with annual revenue, this competitor analysis you can do. So this is your marketing plan, how you can market your product or your service. Okay, so I repeat, so by following these steps and utilizing ChatGPT's capabilities, you can create valuable software tools and successfully market them to your target audience, and you can earn a hefty of money. Okay. So our next category is email marketing with ChatGPT. How you can do cold emailing, how you can do a perfect email to your client, so he or she can impress with your services or your mail. Okay, so you can boost your affiliate marketing efforts with ChatGPT email expertise. Okay, so the first step is choose an affiliate program that aligns with your niche. The second is build an email list of potential customer. Okay, the third thing is use ChatGPT to craft engaging email that drive conversion. Okay, so I will give you example. See, I am a digital marketer looking to promote a new project management software. So can you write a compelling email that will attract potential customers and persuade them to make a purchase? Okay. See, first subject, transform your project with a cutting edge project management software. So dear this, I hope this email found you well. I'm thrilled to announce key features of particular benefits, and don't just take our word for it. Here is what our satisfied clients. See, these are the testimonials you can write. Okay, and the fun fact is, if you don't like this email, you can ask for the next email. Okay, I want something different. It will give you again with a different concept. Okay, with a different thought, right? The next thing is you can leverage ChatGPT for blogging success, right? So already I have wrote one blog. Okay, again let's dive into it. So ChatGPT can elevate your blogging journey by assisting in content generation, editing, proofreading, and SEO optimization. The first thing is you can generate ideas from ChatGPT, outlines and drafts. The second thing is enhance readability and reduce errors. The third thing is optimize for search engines with keyword suggested and SEO tips. The fourth thing is engage with your audience through personalized content. Okay, so let me give you example. Write a blog post on the US economy. Okay, and optimize it. See, understanding the current state of the US economy and in-depth analysis. You can write anything. Okay, this is just an example, right? So the next thing is affiliate marketing with ChatGPT. So what you can do, you can just select a medium to build your audience. Ask ChatGPT to help you decide whether to focus on articles, audio content like podcasts, or videos based on your strength and target audience. So let me give you an example. So you can write, what are the pros and cons of using articles, comma, audio, audio content and video for affiliate marketing. Okay, so which medium would be best for promoting tech products? You can ask this. See, so it will give you the pros and cons for the articles, okay, then audio content like podcast, then the video. So now you can, after reading this, now you can decide what do you want, what are your skills, right? And the second thing is you can use ChatGPT to craft engaging content that promotes your affiliate products. Let's suppose you chose video, so you can target video skills, okay? Or let's suppose you chose articles, so you can write a small prompt like create a compelling article outline for promoting an affiliate product like a fitness tracker or a bottle or a watch, anything. And the third thing is implement a consistent affiliate marketing strategies, like use ChatGPT to develop comprehensive marketing strategy that includes content schedules, promoting tactics, and tracking metrics. Like you can write, help me create a consistent, I will write here, help me create a consistent affiliate marketing strategy, including a content calendar and promotional tactics for social media. Okay, so it will give you marketing strategies. See, for the select product, content creation, build a website or blog, email writing, content creator. Week 1 you can do this, week 2 you can do, and you can ask for the like day wise also, no issues. So by following these steps and utilizing ChatGPT capabilities, you can like effectively build your audience, create engaging promotional content, and implement a successful affiliate marketing strategy. Okay, so now let's suppose you have a YouTube channel. So what you can do, you can ask ChatGPT to generate video ideas and a script, making content creation easier. Okay, you have to just write, I want to create a video on what is machine learning. So give me, so write a script for me in 1,000 words. Okay, so it will write into 1,000. See, you can see opening scene, background music starts softly, text on the screen, this. So it makes content creation easier, ChatGPT, right? So you can use AI powered platform like Pictory.ai, InVideo.io to convert your script into professional video. So even we have multiple GPTs here. Okay, see, for writing you can use these GPTs. Okay, I guess these GPTs are free only with the premium version. I don't know about the 3.5 which is free. Okay, so for the productivity you can use Canva. Okay, you can use the diagram thing, and you can generate the images. See, video GPT by Weed, it's very easy. let me show you something. Okay, see, generate text to video maker. Let's try this. Okay, start a chat. Create a video on what is machine learning. Target audience is college students, and I am aiming for the engagement. So you can just fill these details. So later on it will give you the script and the video itself. Okay, so this is how you can use ChatGPT to earn money. ChatGPT can help you express your ideas creatively, making your video, articles, anything relatable to it. Okay, so these prompts and strategies illustrate how versatile ChatGPT is in helping you to make money across various fields. Okay, and to earn money using ChatGPT is very simple. It will take time, but it is very simple. Okay, it is less time consuming, right? So with this, we have come to end of this video. If you have any question or any doubt, please ask in the comment section below. Our team of experts will help you as soon as possible.
Thank you for joining us on this journey. If you enjoyed this course, please share it with others and don't forget to subscribe for more courses on AI and other cool technologies. Keep learning and we'll see you in the next course.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.